Hey all of you, hope you guys are great and welcome back to Complete Salty course. This course is going to be entirely based on project. We're going to learn everything about Salty, all the syntax, and then we're going to cover some important interview questions which you have to know, because if you apply for a job they're going to ask you these important concepts about Salty. Then we're going to see a couple of more example on each and every topic. Then we're going to build project on that particular concept. There are a few things you have to know as a blockchain developer and a smart contract developer, because when you will apply for an interview, in that they're going to ask you this basic terminology, that what are the other alternative languages you have besides Solidity to build the smart contract, what are the performance rate, why Solidity is more preferable than the other programming languages. So that's all I'm going to cover in this video. So hope you will have a better understanding so you can easily able to answer this important question in your interview. So before we do that, let's talk about what are the other alternative we have to build the smart contract besides Solidity, and what are their performance ratio. So let's start with Rust. According to the Stack Overflow, Rust is one of the most popular and beloved programming language. You can not only write smart contract, but you can build applications, computer program using Rust. In short, Rust is a low-level static type programming language, and because of that, it's fast and memory efficient in an industry where scalability and performance is everything. This is the simple smart contract written in Rust. We have state variable and we have functions. So if you know that how the Rust works, then you can easily able to understand this smart contract. So the disadvantages we have with Rust for writing the smart contract, that it's fast, no doubt in that, but it's fairly a new language. You won't find communities which can help you. So if you are starting up creating a smart contract using Rust, and if you will stuck somewhere, you won't find the community which can help you to figure out the problem. And on the other hand, you won't find library support. So if you're writing your smart contract in Salty, you will have bunch of libraries which you can utilize it. But in Rust, there is no library which you can use to build your smart contract. And the second alternative we have for writing the smart contract is Viper, contract oriented Python. This programming language was introduced to target the Ethereum virtual machine, and it has some core features like such as event, notifier, listener, custom global variables, and global contents. So there are a couple of good things is there in the Viper which you can use to build a smart contract. Viper was never introduced to replace Salty as a smart contract programming language. The developer of the Viper, they built this Viper programming language to provide support in terms of security. So there are a couple of loopholes we have in Salty, and the developer who find out and they provided this particular language to fix those security loopholes. And the core feature Viper provide, and that's what make the smart contract even more secure, like modifier, inheritance, inline assembly, function and operator overloading, recurring function, infinite loop, and binary fixed point. So these are a couple of features come with a Viper which you can use it in your smart contract to make it more secure. So this is the simple smart contract which is written in Viper. You can have a look. It has a similar structure, but there is a difference in the syntax and the way you point out the comma and bracket, okay? But this is a simple smart contract written in Viper. I'll provide you a couple of examples in the description in the link so you can check from your end. And the third alternative you have for writing the smart contract is Go programming language, and this language was introduced by Google to build application on Ethereum blockchain, and you can easily able to build any kind of computer programs. It's quite similar to Rust, okay? So all the functionality you find in Rust, that same features you're going to find in Go language. And the fourth alternative you have for writing the smart contract is Yell. So it's just like a Viper. It was introduced to build support to the Salty programming language in terms of security. And now let's come to the star of the show, Salty programming itself. Salty is a contract-oriented high-level programming language, and this language was highly influenced by C++, Python, and JavaScript. It was designed to target Ethereum virtual machine. Salty is a static type programming language, which means all the variables you're going to define in the smart contract, you have to be very specific. It cannot be changed once you deploy the smart contract. That's why it's called static type programming language, not dynamic type. It supports inheritance, it supports libraries, it supports complex user defined data and other beautiful feature which you can utilize to write your smart contract. And the best part of writing smart contract in Salty that it contains multiple contract, but all the contract within a file share a single namespace, and that's give the power. In 2014, when Gavin Wood proposed the Solidity programming language for writing the smart contract which can run on Ethereum blockchains, so the main funda was for creating this language so it can build a token which can run on the Ethereum blockchains. And you can see that we are in so early stage of this language that we haven't reached the release one. We are still using the 0.8 version of Solidity. And now let's talk about some of the important components of Solidity. So let's start with the keyword first. So in Solidity, there are some special keywords in there. So you cannot be used as a variable name like keywords like contract, library, interface, pragma, and modifier. So these are the reserved keyword which is there in the Solidity. So you can use as a variable name in your contract. And the second one we have is identifier. So you can define any variables, any function in your smart contract as a name. So that could be the unique identifier for that particular function, for the particular variable. Okay, so that's the two terminology we have called the keywords and identifier. And now let's come to the third one, which is a literal. So literal is actually a data type which you define in your smart contract, like number, string, and boolean. So these are the important things comes in your interview. Okay, so the interviewer will ask you that what is literal in terms of Solidity programming, what is identifier, what is keyword. Okay, so that's the thing you have to keep in mind. And the last one we have is punctuation. So it just represent the symbols which you use in Solidity programming. So if you have done coding in JavaScript, then you will find the exact same structure, exact same column, semicolons, bracket which you will use in Solidity smart contract. Okay, so these are the 4 points you have to keep in mind: keyword, identifier, literals, and pronunciations. So you have to keep these technical terms because this is the term I'm going to use while going through this course. And now let's talk about some of the important feature of Solidity, that why we should use Solidity, how it's going to help us, what kind of program we can build. Okay, so let's start with the syntax. If you have code in JavaScript, you will have the same infrastructure, same pattern, same syntax to write the Solidity smart contract. Okay, so that's the first point we have here. And the second point is file extension. So every programming language had its own extension. So for Python, for JavaScript, for C++, so they all have their own extension. In the same way, Solidity does have its own extension .sol. And the third one is application. Solidity can be used to create contract for various purposes such as voting, crowdfunding, building auction, multi-signature wallet, NFT marketplace, or some kind of financial product. Okay, so when you will go to the interview definitely going to ask you, because I was asked once I gave the interview for the very first time. So they asked me this question, that what kind of application you can build using the smart contract. Okay, so you have to be creative. Okay, you don't give this generic name that voting, crowdfunding, auctions, multi-signature wallet, because everyone knows this. You can say about that you can build a Uniswap application which can do the trading, or you can create a trading board which can look at the price of the ethers, and on the base of the price chain they're going to do the transaction. Okay, so you can talk about those things, don't give this generic name. So there is a lot of things you can do. Whatever application you see in the real world, you can create a smart contract, and that smart contract can control the entire functionality of that particular applications. In case of Instagram, in case of a Facebook, you can build an application like that. And the fourth point is contract. So the Solidity program which you're going to write, it will follow object oriented programming language. So if you have follow the classes in JavaScript, it's going to follow the same structure, but in that we have a couple of variables access, like we have access of variable, we have access of modifier, we have access of function. Okay, so it will follow the same classes structure which you followed in the JavaScript. So that's the basic thing you have to know. So when someone will ask you that what kind of structure it's going to follow, you can say object oriented structure is going to follow for writing the smart contract. And the fifth point we have is data type. Every single programming language has its own data type: array, boolean, number. In the same way, Solidity does have its own data types, like unt stand for unsigned integer, int stand for signed integer, boolean we have fixed array or dynamic array. Okay, we have enum, we have struct, we have different type of data type which you can use in Solidity. And the sixth point we have is contract deployment. So whatever contract you're going to write in the Solidity program, you have an option to deploy on the Ethereum blockchain. You can use it Polygon blockchain, because all of these blockchain can accept the smart contract, and it's follow the same protocol like EVM, Ethereum virtual machine. Okay, that's the only thing you have to keep in mind. And the seventh point we have is Solidity compiler. And definitely when you will sit for an interview, they're going to ask you this simple question, that what is Solidity compiler. So Solidity compiler is nothing but the Solidity version which you are using in your smart contract. Okay, so right now you have seen that we have a lot of version. We have started from 0.4 and right now we are using 8. So there is a lot of changes came into the programming language in the Solidity, and whenever you can pick any specific compiler to write your smart contract. Okay, so make sure you have to be very specific. Whenever you write your smart contract, you have to pick the 8 because that one is latest, and because in the earlier contract we had a lot of bugs which can create a overflow and underflow problem. So make sure to use that 8 compiler. So this is the answer you can get, that we should prefer to use compiler 8. And number 8 is easy to learn. Solidity is a fairly easy language which you can start learning. If you be focused for the 3 month, you can be a master on Solidity programming language, because this entire language is influenced by existing language. So if you have little bit knowledge about any previous language like JavaScript, Python or C++, you can easily able to learn this language very fast. Okay, so before you start learning this language, you have to focus on at least JavaScript. Okay, at least JavaScript. And now let's talk about the contracts which you can build using Solidity smart contract. So right now in the real world, you will find that most of the exchange have their token, ERC20 token, ERC21 token, ERC1715 token. So you can create contract and you can have your own token which can get regulated and you can make money out of it. Okay, so that's the one funda we have. You can build an application using the smart contract which can entirely control by the smart contract. Okay, you can build contract which can be run when a certain condition fulfilled. Okay, so you can use for many things. Whatever you can see right now you're doing on web 2 platform, that's all you can do on a web 3 using smart contract. And the most common uses you will find right now in 2022 when it's come to the smart contract, like you can able to build your decentralized exchange where user can buy coin, trade coins, and that contract will communicate straight away to the Ethereum blockchains. Nobody is involved in that. It will allow user to facilitate all the transaction exchange. The second option you have is you can launch your own ICO. So okay, if you have your own company, if you have your proposal, and if you want that the user should contribute in your project, so you can launch your own ICO, which stand for initial coin offering, and you can raise fund from that. Okay, it's just like a stock market. And the third one we have is DAO. Okay, you can create a decentralized autonomous organizations. You will define the proposal in that contract will control every single thing. Those who will be a part of the DAO, they have the right to give vote, and on the basis of their vote the contract will decide that what action need to be taken. Okay, so you can do bunch of things. Don't need to worry, we're going to do all of these things. We're going to build application on each of this topic. We'll launch our ICO, we'll build our DAO, we'll build a decentralized exchange, we'll build all different kind of application. Okay, and that's the only thing I want to cover about the Solidity, that what are the competitive language you have, what are the things you have to keep in mind, how it's going to help you when you will write your smart contract in Solidity and when you will not write in Solidity and write in other programming language, and what are the problems you will face. So hope you will have the complete understanding and you are taking note. Okay, so whatever I have covered, make sure to take note of this, because these are the questions we'll definitely going to ask when you will sit for the interview. Okay, from the next video I'll give you a complete overview of Remix ID, that how you can utilize that online tool which is so powerful for building a smart contract. Every single functionality and every single features Remix ID offers you, we're going to have a complete overview of that. And after that, we're going to see a sample Solidity smart contract for housing. Okay, so after that, we're going to cover that. So hope you guys have liked it. If you are new to my channel, hit like and subscribe. That will motivate me a lot. And do leave your like and thought. What do you think about this course? What topics you want me to cover and what project we should build? So see you in the next video. In this video, you will learn that how you can use Remix ID to test your smart contract, to write your smart contract, to deploy your smart contract. What are the Web3 provider Remix ID provide you, which you can use to connect with different blockchains, whether you want to use injected provider, whether you want to use MetaMask, Ganache, Hardhat, localhost, all the providers you will find in this Remix ID so you can test your smart contract. In this video, I'm going to give you a complete overview and what are the setups you have to do to be on my footstep to continue in this course. Okay, so make sure you open your Remix ID in your browser. So here I've opened the Remix ID in my browser, and the very first thing you have noticed this scam alert. Okay, so don't need to share any important credential with anyone else. Don't get into trap of liquidity and pulls. So they have given some tips which you can follow to make it secure your account. Okay, and here you will find some feature plugin which you can use to write your smart contract. So we have Solidity, we have StakeNet, and bunch of plugin we have. We're going to explore each one of that. From here you can easily able to create a new file, new folder, and you can connect to localhost. Okay, so if want to use your localhost browser to create a test your account track, you can do that. And if you have any confusion about Remix ID or any particular feature which Remix ID provide, you can simply visit their documentation. You can easily able to visit the channel and some feature website if you want to take the reference of that. Okay, and from here you can easily able to import any file or any libraries. So we have GitHub, IPFS, HTTP, RPC, URL. Okay, so they have bunch of options. We're going to explore this. Okay, and here we have our terminal. So all the contract will deploy, all the transactions logs, that's all we can able to find right up here. Okay, so we're going to see this in basic overview of this home page. Now on the right hand side you will find that we have our workspace. Okay, so if you click on this, here you will find different workspace. So if you want to create a new workspace, you can create. If you want to connect with the local host, you can do that. If you want to go with the default, you can do that. So make sure you go with the new, create new one. Okay, and here you have to give the name. You can pick that what you want blank, open zipling, ERC21, ERC 7021, ERC 5050. So okay, here you will have bunch of options which comes with supportive template which you can use it. Okay, and here you can give the name whatever you want. Okay, so I'll say solidity solidity course. Okay, because all the codes we're going to write in this. Okay, so here you can see we got our project workspace ready. This is the name we have given. Let me close all this open folder, and that's the script. So if you want to test the contract, you can do it right up here, which we're going to do. From here you can do the editing from delete, and if you want to import any file from the workspace, you can do that. From deployment you can do that, and you can simply copy it. Okay, you can simply copy a URL from the GitHub and you can paste and you can import the entire file here. Okay, so that's how you can create your basic workspace. Okay, so if you click here, you will come back to your workspace. If you click on this, from here you can do the basic settings like file extension and what are the things you need to exclude. Okay, here you will have important. So this is the very important thing. Here you will find all the Solidity compiler version. Okay, and that's very important. Make sure you should always use the latest Solidity compiler version. And but if you have any previous code, suppose you have got any smart contract which is written in previous version, so make sure to come and simply change the compiler version as well, because by default it will select this. But if you using different compiler version and you have in different in your smart contract, and if you're using this, that will throw an error. Okay, so make sure you can easily able to change your compiler version from here. We're going to do time to time. Okay, and make sure to make it on auto compile, so whenever you will write, it will automatically compile and save, and you don't need to do anything here. Okay, from here you can easily able to do the important setups. Okay, so let me expand this and let me show you what we have here. So here the environment we're going to use is this Remix VM London. You can use this Berlin, and here you will have all the providers. So we have injected provider, we have harded provider, we have Ganache, we have boundary provided, connect wallet. So we have all these provider. We can use it to test our smart contract. Okay, so if you want to use harded, which I have used a lot in my previous NFT marketplace project, so if you haven't watched that, I'll link the complete tutorial so you can follow that. Okay, so we're going to use each of these provider in detail, but we'll start with this normal Remix ID provider London one. Okay, and from here you will have to pick your account. So Remix ID provide you close to 10 account, and each account contain 100 fake ether. So we're going to use each of this account to switch between the accounts and do the testing of our contract. From here you can easily able to set the limits in your contract. Okay, so whenever you want to have a limit in a function, like this much gas fee you're going to pay for calling the function, so you can set the limit for that as well. From here you have multiple currency, which is in ether. This is way is the lowest, GUI is the uppest, and then Finny, and then we have the ether. Okay, so we're going to do all the transaction in terms of ether, so make sure you select this ether, and from here we can easily able to take it up and down. Okay, and here we're going to have a contract. So when we're going to compile it, we're going to use it at out, and here you will find all the transaction log. You don't need to worry about this, and here you will find the deployed contract. Okay, and from here you can easily able to do the debugging. Okay, and that's the very important feature, because this tool will allow you to see that what data you have in which function at the time of deployment and when you are calling the function. So you can easily step by step navigate to the entire function and you can check the value. Okay, and the same thing we have done when we are building the empty marketplace API, and that I have explained that how you can check the every single value in the API and the data is flowing. Okay, so this is a very important tool which we're going to use a lot, and you don't need to worry about this. Here you can stop and run the code, which we're going to do exactly, and here you will find all the libraries. So we're going to use a couple of libraries to make our work very easy, and this is the general setup. Okay, don't need to worry about it. And that's the only thing I wanted to cover about this Remix ID, because it's really powerful. if you do all the same thing in the code, we can do it very easily, but it's more time consuming. And we have this powerful tool which we can use right in the browser and test and deploy in one go. Okay, so that's the tool we're going to use a lot. When we done with the entire course with all the syntax, then we'll move to the project, and that we're going to use our code editor and do all the thing. Okay, so hope you guys have found this video valuable. You have understood that what are the things we have. If you want to find plugins, where you have to go, how to create a workspace, how to import different resources from different places like IPFS, GitHub, we're going to do that all. So hope you guys have found this video valuable. If you have still any question, down, do leave in the comment section. And that's the only thing I want to cover in this video. In the next video, I'm going to show you the sample smart contract which I have built for the hotel industry. So we're going to have a look at that contract, that how we can write contract in the real world. So before we actually move to the syntax part, we have to have an understanding that what are the things goes into that for writing a smart contract. Okay, what are the syntax we are using? Okay, so I'm going to give you a complete overview of the contract which I have built for a hotel industry. So let's move to the next video. This is the simple smart contract we have written for a hotel industry, and this contract keep the track of entire activities happening in that particular hotel. So it will keep the track of the hotel tenant with an address, it will keep the track of hotel landlord with an address, it will contain the information about the number of rooms are there in the hotel, number of agreement, number of tenants. So it will keep all the track of this important information. And here you can see, here we have this struct which has this multiple data type. Okay, so we're going to talk about all these data type which you can see in detail. In this video, I just want to give you a complete overview that how contract look like and how you have to build the contract in Solidity. Okay, so this is the struct for room. Okay, so every single room will have a unique ID number, unique agreement number, unique address. So all the data we're going to define inside this struct, and who is the tenant, who is the landlord, whether the room is vacant or not, when the time of booking, then security deposit, payment per month, address, name, agreement, room ID. Okay, so all these data will define to every single room whenever we add into our hotel. Okay, and mapping is huge addition to the Solidity smart contract. It is just act like an array. Okay, so every single room will have this unique properties. Okay, so if we want to find out the entire details of this particular room, all we have to do is to pass the room ID into this mapping, and we can easily able to access all the data you can see here. We're going to do this in practical. Okay, so this is the room we have struct for the room, this is the mapping for the room we have. Now we have another struct for the agreement. Okay, so whenever any user will have an agreement, they book an hotel room, all this property will assign. So it will have a unique ID, agreement number, room name, address, monthly payment, deposit, all the thing will assign automatically. Okay, and we have a mapping for that. Okay, so if you have an ID and you wanted to find out the information about the agreement, so you can pass the ID of this and you will have the information. So mapping generally act like an array. Okay, we have nested mapping which we're going to talk about. Okay, just follow along with me what is happening here. And we have another struct which is a rent. So whenever any tenant will pay the rent, all the property would be assigned to that particular payment. So it will have a unique ID, unique agreement, and all the information. So if we want to find out the information about that particular payment, we can simply pass the ID here and we'll get all the information. And here on the top you can see, here we are keeping the track of the total number of rent we are receiving into this contract. Okay, so we can easily able to access from here as well. So this is the agreement this is the agreement, and here we have the rent. Let me close all this and close this one as well. And we have a mapping for the rent as well. And this modifier is a huge addition into the Solidity programming language. It allows you to write more secure code because your contract will contain a lot of sensitive data, money. So it's always very good that you have to write more secure code, and in that scenario modifier plays a very important role. So what it does, it will keep the abstraction. For example, you have a condition which you want that user should fulfill, and then you want to execute the code further. Okay, so in such scenario what do, you can take the abstraction of that condition and convert into a modifier, and all you have to do is to call this modifier wherever you want, no matter in how many functions. Okay, so this will save a lot of bug in your code, and you can easily able to write less code, and you can check multiple condition with the same function. Okay, we're going to have a complete detail on this. We're going to find out that what are the ways we can write the modifier. You can see this is the simple way I have written, and what are the places you can add modifier, okay, in your smart contract. So here I've created multiple modifier. First one is for the landlord. So I have to check certain function should be called by the landlord, not by the tenant. Okay, we have a not landlord functions, we have a not only while vacant modifier, we have this enough rent modifier, we have this agreement fee modifier, we have the same tenant modifier, we have this agreement time left modifier, we have the agreement times of modifier, we have the rent times of modifier. You can write your smart contract without using this modifier, but it's always great that you should use it because it's allow you to write more secure code. Okay, and here we have the very first function which allow us to add room into a smart contract. In that we have to pass couple of data. We have to pass the name, address, rent cost, security deposit, and we can simply changing all the data here. You can see here we are calling this struct we have created for the room on top here. So here we have the room, this room struct, and we are updating all this data whenever any room get added into our contract. Okay, and that's all you can able to find here. Okay, so we are increasing the room number, we are making to vacant to true, and we are updating all this data. Okay, so we're going to talk about each of these data type, each of this function, and how we can call the struct, everything in detail. I just want to give you a complete overview that how the smart contract look and what are the function exactly there and how this contract is happening. Okay, so this is for the add room. We have the same, we have another function for the sign agreement. So if anybody wants to book a room into this contract, so this is the function they're going to call. All they have to do is to pass the room ID, and they have to follow this couple of modifier which we have to added here. Okay, so this function cannot be called by the landlord, the one who created this contract, and the one who tried to book the hotel room, they have to have enough money, and this booking can only be happen when the particular room is empty. Okay, so these are the couple of conditions we are checking which we have extracted as a modifier here. Okay, so you can see how life saving it is, and here once we are passing all these things, we are simply updating all this data. Okay, so we are updating all this agreement data here, which is very simple. Okay, right now I believe that it makes complicated, but this is very simple. We're going to cover in detail, don't need to worry about it. Okay, so this is a sign agreement function we have, and now we have another function called pay rent. So if a tenant want to pay the rent, so all they have to do is to call this room ID number, and it will do all this check, and then they can simply update the make their payment. Okay, here we are changing all the state. We have another function for agreement completed. Okay, so whenever any agreement will happen, it will happen for a specific time period, so that's why we have the timestamp in our stock. Okay, so on the base of that, we are checking that whether the agreement still exists. If it exists, then let it be like that, but if it exceeds then the normal agreement time, then they're going to simply transfer the entire deposit. Okay, so here we are simply tenant transfer to the security deposit. So they are transferring some money which the tenant has provided as security deposit, and they are taking from there. Okay, so that's what we are doing here. Here we have the last function which is called agreement tenant. So if a user don't want to be in the hotel and they want to cancel the agreement, all they have to do is to simply make this call. Okay, they have to pass an ID, it will fulfill all this condition, and it will come true. Okay, so that's the simple smart contract for a hotel industry. You can add hell lot of things, you can add a lot of security. Right, this is a very simple smart contract we have built for the hotel industry. Okay, so this is how the smart contract looks like in the real world, and don't need to worry, again we're going to have a detailed discussion on each of these topics, each of this address, unit, struct, variables type, how we have to write more secure code in details. Okay, we're going to take one step at a time because I want you to understand everything in detail. Okay, because when you will go to the interview, right now Solidity and blockchain is in the early stage. Okay, so nobody has the deep understanding in terms of security, in terms of language, so you have to know every little thing about the Solidity smart contract so you can easily able to answer, because they're going to ask you more in the technical side. Okay, so you have to know that how to use struct, how to retrieve data from the struct, how to update the struct data, how to use mapping, how to use nested mapping. So all lot of things we have to do. Okay, so you can see this is the Pragma Solidity version I have used in my contract, and the moment I will come in the deploying section, you can see that here where it is. Here you can see that it will automatically discharge that I'm using this Pragma Solidity version, and it will pick this here. Okay, so here you will find all the Solidity version which you can use to write your smart contract, but I would recommend you to go with the latest one, which is 0.8.70. It's a recent delete, but this is the program we have written in the call say 5. It's a 5.16. Okay, so this is the one we have used. So make sure no matter what Solidity version you use, make sure to check it from here and try to use the latest one, because that will come with a lot of security and good stuff. Okay, so that's the only thing I want to cover. I hope you will have a complete understanding that how the smart contract exactly work in the real world and how you can create, what are the conditions you have to fill. Okay, so when you write your smart contract, the very first thing you have to do is you have to picture the entire contract, that what you exactly want to do with that smart contract. In case of hotel industry, you have seen that we have keep the important information in consideration, like tenant, landlord, number of room, agreement, rent, and according to that we have built all the functionality, that there should be an agreement struct, there should be a room struct, there should be a payment system. Okay, so you have to always write down that what are the functionality you want to have in your smart contract, and then you can build on top of it. Okay, and that's the strategy we're going to follow, because from the very beginning I want you to think that how you have to write, and how you have to write the smart contract, not only just writing, how you have to make it more secure, because that's the most important thing. So I don't want to extend this video too long. That's the only thing I want to cover in this video. In the next video, we're going to write the first function in our Solidity smart contract and how you can write your own function. Okay, with that said, I'm ending this video. Let's move to the next one, where we're going to write the first application in our Solidity smart contract. So let's meet there. Hey all of you, hope you guys are great. So in this video, you're going to write the very first smart contract in this Solidity course. Every single video will be divided in 4 parts. In the first part, we'll talk about the theoretical part of the syntax. In the second part, we're going to do the practicals around the syntax. In the third part, we're going to see some real world smart contract examples which have used those syntax. And at the end, we're going to cover a couple of interview questions related to this particular topic. So this is how I'm going to plan every single video right from here. Okay, so here I have opened my Remix ID. Make sure to do that. Enable to code along with me. So first thing we have to do is to provide the license identifier, and this is the general convention which you have to follow. Okay, it's going to be MIT. Okay, so to know what this MIT is, come here, and here you can able to find all the details that what this MIT stand for. Okay, it's actually a copyright and it's free to use. You can easily able to use this software to write smart contract. You can modify as per your contract. So I will provide the link of this GitHub repo in the description so you guys can check. And you have to keep in one thing in mind, that the compiler version you use in the Solidity smart contract, it should be equal to 8.13 and less than 9. Okay, so and this is the updated one, so make sure to always use the latest compiler version. And here we're going to take this pragma Solidity, and then we're going to define the compiler version which we want to use. And as you can see, this arrow up means that take this version, and whatever version above this we can use that as well. Okay, so this arrow up means that take all the version above this 8.18. okay, so that's what it is. Okay, so I want to take 13, not 18. So this is the Solidity version we have here. Now we'll come here, and now we have to create the contract. So to create the contract, there is a keyword in Solidity by the name contract, and then you have to define the name of your contract. Okay, so make sure you should always give your contract name in capital letter. Okay, so I'll say my first contract, and this is the dynamic block. So if you have coded in JavaScript classes, then you will find the similar structure here as well. Okay, and now I'm going to define a couple of state variable here. We're going to talk about each of these variables, each of this data type in detail in the further videos. Okay, I just want to show you that how you can build the simple smart contract and build your first smart contract. Okay, so I'm going to take this string, and it will have no data. And here if I come here and if I deploy this, click on this account, I'm going to choose this one, like Remix VM London, and now I'm going to deploy this contract. Okay, pick the contract and deploy. Here I will get the transaction, and you can see right now I have nothing here. And because to access this data, all I have to do is I can simply come here in the ABI. If I copy, you can see this is completely empty. I don't have anything. Whenever you will compile your code, it will generate the ABI of the smart contract which we have written. In that you will have all the data. Okay, I believe that this sounds complicated right now, but I want to explain everything from the beginning. Okay, we're going to have a detailed discussion on each of these ABI and bytecode and how we can utilize it. Okay, so right now we don't have anything here. We're going to remove it, and if we look at the bytecode, you can see this is the bytecode got generated. So we have the function debugger, it's entirely empty. We don't have any data because we haven't written any functionality, anything like that. Okay, so it's completely empty we have here. So okay, so this is our bytecode, source map, everything we have here. Now delete this one, and now what we can do is let's come here, and right now you can see the balance in this contract is 0 because we haven't have any ether into this contract. So now what I can do, I want to see the value of this string hey. Okay, so for that I can use this public keyword, okay, and it's an inbuilt keyword in Solidity smart contract which allow you to create a getter function. Okay, we can easily able to access this data by creating a separate function which allow us to fetch the information. But if you use this public keyword in your variables, it will automatically create the getter function. Okay, so we have a detailed discussion on this, don't need to worry about it. Okay, just follow along with me. So now if I deploy the contract, if I delete and deploy the contract one more time, and here you can see right now I got this hey because of this public keyword. Okay, and this public keyword will generate a getter function for me. So if I click on this, I can see the data type I'm getting, and there is no value in that. Okay, there is no value in that. So now we have to assign a value. So you can simply assign a value like this. You have an option to assign the value right in the state variable sections. Okay, so you can define the value here, hey, dollar, and that's okay. Okay, save it, delete it, and deploy the contract one more time. And if you click on this hey, you can see I got the value. Okay, so this is how you can easily able to access the data of the state variable and how you can define state variable. Okay, so this is one way. And now what I want to do, I want to take this unt, because there are multiple data types. We have boolean, unt, array. Okay, we're going to have a detailed discussion on this. Just follow along with me and understand that what are the things we can do in the simple contract. Okay, so I'll take this unt, and this time I have to change this value to 4, and make sure to change the name. So we have to change this name to something like num. Okay, so let's make it num, and sorry. And now we can deploy the contract, and you can see here we have the contract. If we click on the header lot number, okay, so this is the data we can easily able to access with the help of this public. So I believe you guys have understood that how you can easily able to access the data without calling any function using the public keyword. We're going to talk about each and everything in detail later in the video. Just follow along with me. So this is the one way to get the data, and let's comment out this. In the above example, you have seen that the data is predefined, but I want to add the data based on the function or on the contractor. Okay, so what I can do, I can simply comment this, and I'm going to remove this value. Okay, value. So if I come here, and now I'm going to update this data with the help of constructor. Okay, so constructor is a keyword in Solidity which will run every time you will deploy the contract. Okay, again we're going to have a detailed discussion on this, so just follow along with me. In this we have to pass this data. Okay, so what I'm going to do, I'm going to pass the string. Okay, string memory, and we're going to pass this hey. Okay, so we're going to receive data in this constructor, and we're going to assign this to our variable. Okay, and now we have to receive the number as well, and now we have to update the data. So hey, and we have to update the number as well. And this is the another way which you can use to update your state variable. Okay, right now we don't have anything in our state variable, but when we run the contract, when we deploy the contract, our state variable will get updated. Okay, so this is the constructor we have, and now everything is looking fine. Now what we can do, let's come back and let's try to deploy the contract. So here make sure to select the contract, and here we have to pass this data inside this. Okay, because in the constructor we have to pass this hey and number. First one is string, second one is unt. Okay, so this is the data we have to pass. I'll type something like dollar, and the number I want to give 23. Hit on transaction, and if I open the logs, here you can able to find the transaction wait successful. And if I open the details, you will find the entire details of this transaction which you have done when you deploy the contract. So you will have the address, you will have the name of the contract, the gas amount you have paid, all the things you can able to find in the logs. Okay, and here you can see this is the data we have passed, a string and number. Okay, deported. Okay, and if I come back here, and you can see if we call this function hey, you will see dollar, and if we call this no, here we have the number. Okay, I believe this makes sense to all of you. Okay, so this is another way to update your state variable with the help of constructor. And now let me show you one more example. So we have updated the state variable with the help of constructor at the time of deployment, but now what we're going to do is we're going to update that state variable with the help of function. Okay, we have a dedicated videos for every single topic, every single syntax we are using in this contract. Okay, so here I will create a function. I will call say add info, because this function will allow me to add the information in our state variable, those variable we have created. Okay, and inside this we're going to simply pass the same data. We have to pass memory, we have to pass the number. It's going to be a public, and we can simply call this and update the data. Okay, so we'll say hey, we have to pass the number as well, and that's it. Now this function will simply update the data of the state variable. Okay, So come here, let's remove this and let's deploy the contract. So right now you can see we don't need to deploy, simply close this one, hit on the close this one, and right now you can see we don't need to pass any data at the time of deployment because we are not going to update the data with the help of constructor. Okay, we are going to do with the function. Okay, so click on this deploy, and here we have the function, and here you can see we have this hey is empty and number is empty, but in add information we have to pass the data. Okay, so let's come here, pass the string. I'll say $, and here I'm going to pass number transaction. You can see transaction went successful if you click $, and if you click number. So this is how you can easily able to add the data and update the state variable with the help of function. Okay, so that's pretty much very simple things we are doing here. Hope these all things are making sense to all of you guys. Okay, this is a basic examples I have given that how you can use the write a simple smart contract, create a variable, update the variable at the time of deployment, at the time of function calls. Okay, so you have bunch of things which is coming on your way in this course. Okay, so these things looking good. So hope this makes sense to all of you, and that's the only thing I want to cover about this sample smart contract which we have built in this video. We're going to have a detailed discussion on each of these syntax we have used here. Don't need to worry about it. We're going to cover a lot of things about every single concept which exists in Solidity. So that's the only thing I want to cover. With that said, let's move to the next video. In this video, we're going to build a simple smart contract which will count the number of NFT. Okay, so let me show you what we're going to do here. So let's come here, and I'm going to take this contract and I'm going to give the name to this contract is count NFT count. Okay, so that's the name I'm going to give. I will take a state variable, I will make it public so I can easily able to see the value, and I will take number of NFT. Okay, so this is the state variable I have taken, and now I will create this function. This function will increment the NFT number. Okay, so I will create this function and I will call add NFT. In that, we're not going to pass anything, we just want to increase the NFT count. Okay, so it will become public because anybody can call this function. Okay, and we want to simply update this NF plus 1. So here what we are doing, we are taking the number of NFTs and we are adding 1 to that. Okay, so whenever someone will call this function, it will keep increasing that NFT count. Okay, so that's the add NFT function we have. Now let's write one more function. This will allow us to decrease, okay, delete the NFT count by 1. Okay, so it will say delete NFT. Again, it become public so anybody can call it, and -1. So right now we are making public so anybody can call, but in the real world application you should always check for condition that the one who created the NFT, they have the rights to delete the NFT only, or maybe the moderator or maybe the owner of the smart contract have the authority to delete any kind of information from the smart contract. Okay, but right now I'm just giving you this simple example. We're going to build certain logics around this in the later videos. Okay, so this is for the deleting, and now let's write one more function which allow us to see the number of NFT we have created. Okay, to fetch the data of this number of NFT. Okay, you can do it by this using the public keyword, but it's never a good idea that you should make it public, this sensitive information. You should always try to retrieve data from with the help of function. Okay, and allow certain condition on that, so only certain people, a certain authority individual can have the access of this information. Okay, so let's write the functionality for that. So I'll say check total number of NFT. Okay, we'll write the function, we'll say check total NFT public view. And the reason why we have used view here, because we want to see the state variable. Okay, we have a detailed discussion on this view keyword, that why we use view keyword and what kind of operation we can do with the help of view. Okay, so make sure to use view, and then we have to return this because we want to see the data. Okay, and here we're going to pass the data type, that what we want to exactly return, and here we're going to use this return keyword. Okay, return keyword, and we're going to pass this number of NFT. Okay, so these are the 3 functions we have written which allow us to check the NFT count, which allow us to add NFT and delete NFT. Okay, hope things making sense to all of you. That's why I have included this one more small sample smart contract project so you guys can understand that how things are taking place. Okay, so that's looking pretty good, and now we can start testing this one. Come here and let's try to delete the old deployment, and this is the account I'm going to take, and I'm going to take this account number 3rd. Okay, and now let's deploy the contract. You can see this is the deployed contract. If we open it, here we have all the functionality. So if we click on this, right now we have this 0 balance. If you click on this check total, we have 0, we have nothing in there. If we click on this, still we get the 0 because here we have used the public keyword, so it's create a getter function. So that's what it is. Now if you click on this, If you come here, you can see the transaction event successful, and if you click on this check total, here we have one. If you click on this, here we have one. If you click one more, one, two, no matter how many times you will click, it will keep increasing the number. Okay, and click in number. Okay, and deleting, increasing, deleting. And this one is a very important functions in smart contract, because sometimes what you have to do is you have to keep a track of certain IDs. You have to delete IDs, or you have to add IDs. So these kind of function plays a very important role, which allow you to create new ID for every single logic which you want to build, or every single condition you want to build. Okay, so that looks pretty fine. You can see we can delete, we can add, and this contract is absolutely working fine. Okay, so check, add NFT, so all these looking fine. We're going to have detailed discussion of this UNT data type function, pure public return, so we'll have a detailed discussion on these. Okay, I just want to give you a more practical example so you guys can understand that what are the possible things you can do. Okay, and that's the only thing I want to cover in this video. Hope you guys have found this video valuable. If you are still any confusion and doubt, do leave in the comment section so we can discuss on that. So let's move to the next video. Like every programming language has its native data type, in the same way Solidity has its data type. So there are generally two types of data types in Solidity. One is value data type. In that you will have boolean, integer, fixed point number, address, byte and string, enum. Okay, so these are the value data type. And the other data type we have, it's called reference data type, and in that we have array, struct and mapping. Okay, so we're going to cover each of these in detail, that how you can create array, how you can create boolean. So the first data type we have is boolean. Okay, this is how you write bool, and we are making public so we can able to see the data value. Okay, so we'll type hey. Initially I'm not going to change the data type because the default value of this boolean is false always. Okay, and the second one I'm going to take is boolean and I will make it public, but here I'm going to change this data type to true. Okay, so this is boolean, but this time it's true, not false. So this is the way you can define boolean in your smart contract. Okay, let's come down. Now we're going to talk about the other data type, which is uint, and uint stand for, let's say, unsigned integer, meaning no negative integer, only positive. Okay, to write the unt variable, this is how we can do it. We'll take this unt 8. Okay, so we have couple of range. We have unt 8 is the lowest one, then we have unt 16, unt 24, and it will go all the way to unt 256. Okay, so let me show you what I mean by that. So the unt 8 will range from, let's say 0 to and 2 multiplied by 8 and minus 1. So okay, so whatever value you will get, that's the range of this unt 8. Okay, so hope this makes sense. So this is the range of unt 5 and the range is 255. Okay, so if you do the calculation, you will find that it's 255 is the range of unt 8. Okay, and this one becomes 16 and I will make it 16. If you come here and if I paste here, so this is the range I got it. Simply copy and I'm going to paste it back here. So this is the range of the unt 16. Okay, which is very important because we're going to use the same things, because we have to define explicitly about the data variables, and that will help us to save gas fee. Okay, so this is the thing which you have to keep in mind, because sometime what happen that the problem will come in terms of underflow, overflow. Okay, so we have to deal with that as well. So this is the unt 6 we have. Now let's take another one. We'll take this, let's say unt 256 is the highest one. Okay, and the range lies between, let's say, we'll take this one, 256 minus 1, and same thing, we have to copy this and let's find out the value. So paste and simply copy this one. It's a huge number. Okay, so this is the range of unt 256. So hope this thing's making sense to all of you. Okay, and the reason why we take different ranges, because it will allow us to save gas fee when we deploy the smart contract. So that's the only thing you have to keep in mind, but it's always better that you should go with this unt 256. So this is how we can define unt 256. And now let me show you that what data we have exactly in this. So let's make it public, unt 8, and I'm going to assign this the value to 8, and this will become, let's say, 244, and let's make it to 8. Okay, and by default it will take 256. Okay, so whether you define unt 256 or not, if you write only unt, it will take 256. So that's you have to keep in mind. It will always take this 256. So let's simply comment out this portion and let's try to find out the data. Okay, simply come here and deploy the contract. Let's deploy it. Here we have the contract, and here you can see we have hey. We have hey is false, because that's by default the boolean value is false. Okay, false. If we click on no, we have this true, because we have assigned hard-coded value. And if we click on u, we have this data, you can see 1 2 3, we have this unt, and this is the value we have, and if we click on this, and this is one we have it. So hope this thing's making sense to all of you, that how you can define the boolean, how you can take this unt, and unt only stand for positive number, no negative, and that's the important point you have to keep in mind. Okay, now let's come here, and the second data type we're going to take is, it's also a number, but in case of negative. Okay, so because sometimes we need a negative number in our smart contract to do certain calculation. Okay, so for that we have int number. So we have, let's say, negative number are allowed from int type. Okay, so this is the type we're going to use if we want to add a negative number. Okay, and let's talk about the range, that what are the range we have in this as well. So again, it will have the same range. You can define 256, and the range lies between -2, and it will go to 255, and you have to do this -1. Okay, so this is the range you will have from the negative to the plus. Okay, so if you want to do the calculations, simply remove this one and copy and come back here and paste here. So this is the positive, and the same way this is the negative. All you have to do is to add the minus negative sign. So you can go in the negative till here, and you can go positive till here. Okay, in this 256. So that's the important point you have to keep in mind, because this is the question, 1 marks question you will get in your exam. Okay, so that's what we have here. That's the range. Now that's the one type. Let's replicate this, and if we make it to 128, so same thing we have to do here. We have to make the changes to 128, and the range will automatically lie in between that range. Okay, so this is how you can define multiple range, whether in negative and positive. And now let's take this real application. So we'll take an example. We'll say -1, and we'll say this value, and again we'll take another one. Okay, so this is the 3 int variable level we have taken, minus and plus. Okay, and we have to make it this I. Okay, I, otherwise it will throw an error. So this looks pretty fine. Now let's come here, deploy the contract one more time, and if you can see here, we have a lot of things. So if I click on this UA8, so this is what I have here. We have I. You can see I can easily able to go back in negative because of this int. But if I do the same thing with the UNT, I'll get an error. Okay, if I click on this, I can go into a negative. If I click on this, I go into positive as well. Okay, so that's how we can use negative and positive number with the help of int and UNT. So that's how we can define. Let's come here. Now let's talk about min and max value in number. Okay, so there is a simple way which you can use to find out the minimum and maximum value of a number. Okay, so that's, we have operator for that. So let's come here. We're going to take this variable int public min int, and here we have to define the type. So the type we're going to take int, and we'll call this min. Okay, so this will give the minimum number of a integer, and this will give us the maximum number. All you have to do max, and here we have to change max. Okay, and sometimes this becomes very helpful, because if we want to do certain calculations and we want to prevent the condition of overflow and underflow, in such scenario we can explicitly define that we don't want a number which can exceed this limit. Okay, so in such scenario you can take this one. Okay, so this is the why we have simply deploy the contract one more time, and let's have a look. If we come here, you can see here we have the 4 functions. Hey, let's call this max, and you can see this is the max number you can take in this 256. Okay, if you define only in, that will take this 256 range. Okay, so this is the range. If you do this minimum, you will have the minus signs, but the rest is same. Okay, so this is how you will get the maximum and minimum number in Solidity smart contract with the help of this function. Okay, so hope this makes sense. Comment this out to all of you guys. And now let's talk about a couple of more examples. So the second data type we have is the array. Okay, and just like other programming language like C, Python and JavaScript, we have array. We also have array in Solidity smart contract. So let me give this command. In Solidity, the data types bytes represent an sequence of bytes, and generally they are 2 types. Okay, so there is no difference between a byte and a string. Okay, byte is more gas efficiency, so when you will use byte instead of string, it will save you gas at the time of deployment. Okay, so you can take a array as a byte, or you can take a array as a string or as a number. Okay, it's totally up to you. Okay, so now let's come here. Here we have this fixed size bytes array. Okay, and the other one we have is dynamic size byte array. Okay, so these are the two types of array we have. One is the fixed size, which you will define explicitly that you want only 5 arrays in that particular array. Okay, or it could be a dynamic based on the function. Okay, so these are the two types of data type array we have. So that's the array. Now let me do this command. So when you define byte, okay, in smart contract, it's represent dynamic bytes. Okay, so that's the only thing you have to keep in mind. That, but if you want to explicitly define that you want only fixed size array, then you have to set the number. Okay, we're going to cover everything about this array as well in the later video. Okay, so I'll take byte 1, and by default I will don't add anything, and this will become byte B. Okay, simply deploy the contract, and let's try to have a look. Here you have these two functions. Okay, so let's simply comment this one, and I make it public so I can able to access the data. So let's make it public. I'll say public, and this will become also public, and let's try to have a look what we have inside this. Let's deploy the contract, and here we have that calling this function, and you can see this is how the byte data will represent. Okay, it will start with 0x, and then it will have the data. Okay, if you call this, it will have this data. So this is the default value. Now what if I want to add value into my byte data? You can do it very easily. Okay, so simply comment this out, and I'm going to replicate it, and I'm going to assign predefined value. So I'll take this. Okay, because this is the data, this is how I have to add the data. Start with 0x, which represent the byte. Okay, and then you can add the data whatever you want. Okay, so let's define this as well, and simply comment this portion, and now let's simply deploy the contract and make the call. If you call it, you can see here we got the data. Okay, and this one is more memory efficient. Okay, so instead of string, we're going to use this byte a lot in our future smart contract. Okay, you all know that computer can understand only binary code. Okay, so this is how this code will represent. Okay, so we'll start with 1010, and this is so on and on. Okay, and if you want to know about this binary code, you can simply do Google, and you can easily able to find and learn more about it. Okay, so this is how it will represent in the Ethereum virtual machine. Okay, so that's the byte code we have, looking fine. And now let's have a look to the other data type we have. So the other we have is address. Okay, so we'll come here and we'll take this address public, hey, and we'll take this address public, and we'll assign the address. Okay, so I'll come here and I'll go back to this. Here I have the address, so I can simply copy, and I want to show you the difference that when you have an address and when you don't have the address. So I will go to simply pass it without code. Okay, so it's a Solidity programming language, in that you don't need to pass this address into a string. You just pass it like this. Okay, so that's the addresses we have. Now what we can do is simply deploy the contract, deploy on, and here we have the transaction. If I click on this adder, you will see that this is the address which we have defined here in the contract, but by default we don't have anything here. Okay, so this is how the address will represent when there is no address. Okay, so this is how it will look. Hope things are making sense to all of you guys, understand that what we are doing exactly. I'm just going a little faster because these are the basic things, and we're going to get into more detail when we have a dedicated session on each of these data type and when we use in the function. Okay, so simply comment this out, and what I can do, and now let's check the default value of each of this data type, because in Solidity there is no concept of null and undefined. Okay, so what are the predefined data we'll get when we'll use any one of these data types? So let's have a look on that. So I'll say default value, I'll first take with boolean, and the default value is going to be false. Okay, let's say false. We'll take another unt, and its default value is going to be, let's say, 0. Okay, this will default value 0, and we'll take the int, it will also become 0, because this is the default value we have for the number. There is no concept of null and undefined. Okay, if you don't provide anything, you will have 0. And let's take the address. So this is what we'll get, 0000 with this. Okay, that these are the default value we have for each of these data type. Same goes for the array, byte size, same goes for that. Okay, but these are the most common used data types, and that's why I'm covering this one as well. Now let's come here, upload this, and let's look at this. If I click on this false, here we have the false. If we click on this unt 0, we have 0. If we click on hey, here this is the address. By default address we get this 00, and the last one we have this number is a 0. Okay, so hope these things make sense to all of you guys. Whatever we have covered, you have to keep all this thing in mind, because these are the things going to be asked in your interview session, that what type of arrays we have, what is the difference between bytes, and what is the difference between string, which one will save more gas fee. If you want to take a number into a negative, then what data type you're going to use. what are the range of certain units, int or unt. So these are the important things you have to keep in mind, that what it does and how you can utilize it in your smart contract. Right now we have covered about this data type, and we have talked about the unt and int variable. So you must know that why these ranges are important and what kind of problem it will create in our smart contract if we don't use that particular way. If you want to optimize our smart contract for paying the less gas fee, then how we can utilize it in a more efficient way, this in variable. Okay, so these are the things you have to keep in mind to write a well optimized smart contract. Okay, so that's the only thing I want to cover. Hope you guys have found this video valuable about this data type. Let's move to the next video. So when you will ask in an interview that what is the role of the function in the Solidity smart contract, so this is how you have to answer this question. Okay, a function is basically a group of code that can be reused anywhere in the program, which generally save the excessive use of memory and decrease the runtime of the program. So creating a function reduces the need of writing the same code over and over again. With the help of the function, a program can be divided into a small piece of code for a better understanding. Okay, so this is the explanation you can provide to your interviewer, the person who's taking your interview. Now they might be asking you that what kind of function we have in Solidity smart contract. So there is one function, declarative function, and there is a non-declarative function. So this is the code snippet for the function we have. So we have the function keyword, then we have the name of the function, and inside that we can easily able to pass multiple parameters. It's totally up to you that what you want to do with the function. Then we have the scope, that whether you want to make it public, external, internal. Then we have a return keyword, and if you can add multiple parameters like this here. Okay, and there are a couple of more function we have in Solidity programming, like we have modifying state variable. Okay, we have events, we have creating other contract, we are using self-destruct, sending ether wire calls, calling function with mark pure and view. Okay, so these are the couple of function you can create, and there is a lot of things you can do with a function. Okay, so that's the general overview I want to give you about the function in Solidity, and let's try to have a look in practical way. Okay, so here we are back into a remix ID. So let's create a contract. So I'll call it learn function. Okay, right now I'm just giving you basic examples of function, but we're going to have a detailed discussion when we write actual real world smart contract. You will see that how life-saving it is. Okay, so here we'll take a variable called unt, and I'll say public, and I will say hey. So initially I don't want to assign any value to this, but I want to do it with the help of function. Okay, so get data with the help of function. Okay, so I want to check the function. So right now I'm using this function to check the data of this unt. Okay, so I'll take get info and public, view, and return. Okay, so the reason why I have used this view keyword, because I want to look at the state variable, and the return, you can pass multiple parameter in the function, and I want to return this unt 256. Okay, and now I want to simply return this data. Okay, hey. So this is the simple function which allow me to see the data of the state variable. Okay, that's the simple function we have. And this function can be more complex. You can have function inside another function which can check certain condition. Okay, we're going to do all that, but just have a look that how you can write a simple function which can do a simple thing. Okay, so let's delete this one. Let's try to deploy the contract, and let's try to have a look. So here we have this hey and get info. Okay, so if I click on this get, so before I do that, click on this get info, I can see 0 we have here. If I call this simple get info, I'll get this 0. Okay, so this is how we can retrieve the data. Now simply come here and let's replicate this, and let's delete this, and this time I don't want to make it public. Okay, deploy this one, and you can see right now we have this get info. If I click, I can easily able to see the data of this. Okay, so it's looking fine. So hope this making sense. This is how you can retrieve the data of the state variable with the help of function. Now let's write a one more function which allow us to update the data. Okay, so we'll say update data. In that we're going to pass the data which we want to update, public. Okay, so this time we try to change the data, change the state variable. That's why we haven't added this any view or return statement. You can return that statement, but I'm not going to return it, because why should we should do that? Okay, because I just want to focus one thing at a time. Okay, so let's update the data. So that's what we have. We can take hey, and we're going to update it. Okay, so this is how we can update the data with the help of function. So let's come here, click on this, and let's try to deploy the contract. Okay, and here I have to check the data. So right now we have 0, and now we have to update the data. So in this we go to pass the value. So let's pass 6. Click on this transaction, hit enter. You can see here we got 6. No matter what value you will add, it will keep adding and updating the data. Okay, so that looks pretty fine. Let's keep updating the data. Okay, so that's how you can use a function to update the data. You can see keep updating, keep updating. So this is the updating we have, and let's write one more function which we'll call get unt a plus b because we want to do some operations. Okay, so we're going to take a two number and we're going to sum it together and we're going to add to the state variable, and we can do that as well with the function. Okay, so we'll have this view return unt. Okay, so what I will do, I will take this two number, so new number, and this will come a plus b, and I want to simply return this number, new number. Okay, so what I'm doing, I'm taking this two number from the users and I'm summing up together and I'm returning back. Okay, so that's what I'm doing. Simply comment this, and now let's deploy the contract. Hit enter, open up this. Here you can see here I have to pass this two number, so the number I want to pass is 5 and 6. Call this transaction. Here you can see here I got the output to 11 because of the return keyword I have used. So you can perform this kind of mathematical calculations, a lot of things you can do. Okay, it will keep updating. Okay, so this is the one example for simple using function to do some calculation within the function. Okay, so hope this makes sense to all of you, that how things are happening. Now what I want to do is, let's come here. We're going to take this hey, because that's the state variable we have, and I want to update that data as well. So, okay, so we're going to say new number. Okay, and I don't want to return this, I want to return this hey. But as you can see here, I'm getting this error because I have used view keyword, and view keyword is not allowed when you are changing the state variable. Okay, we have a detailed discussion on this view keyword, okay, as well. So what I will do, I will simply come here, I'm going to remove this view, and now the error is gone, and now we can easily able to change the data. Okay, let's hit on deploy, go back to the transactions, and you can see if we pass this two data, let's 4 7, hit enter, and if I open up the terminal, you can see the logs there. So let's come here and simply come here and make it this public, so we can easily able to see, have a getter function, so we can check the value as well. So let's bring this terminal down and let's redeploy the contract. Okay, delete this one, deploy the contract one more time, and we have to pass this. Here you can see right this moment we have hey is to 0, and if we pass this two number, hit enter, and here you can see we got, right now you can see this is the log we got. So this is the two number we have put, and the output we got is 8. Okay, so this is the output we got 8. Okay, this is the function we have called. If you click on this hey, you will get the 8 as well. Okay, so this is how you can perform operations in the functions and update the state variables. Okay, so hope this makes sense to all of you, that how you can create function in the smart contract. Again, I'm telling you, we're going to have a detailed discussion on each of these topics. Okay, and now let me show you that how the ABI would look like of this function. Okay, because whenever you will deploy the contract, it will generate the ABI based on the variables, based on the data types function you have defined. Okay, and that ABI is very important because that's the ABI is going to be run on the Ethereum blockchain. Okay, so let's copy that ABI and let's simply paste here, and here you can see we have all this data. We have all this abstraction in terms of ABI of the smart contract. Okay, so we have this input, in that we have this data type, and the name of the name is A. So this is the one we are passing, A. We have the another one which is a UNT type. We have B. You can see we have B, and here we have the call the get function. Okay, so we have the name of the function. You can see here we have the portion we want to return as an output, so we want to return the UNT, so the result. Okay, that's what we want to result, and here you can see we have this, that's UNT. Okay, and here you can see we have this non-payable because this smart contract is not receiving any kind of fund, so that's why the state is changed to non-payable. Okay, and we have the type function. Okay, and here you can able to find the state variable we have defined hey, and we have all this calculation. Okay, so this is how ABI will get generated whenever you deploy a smart contract, and this is what exactly run on the blockchain. Hope this thing's making sense to all of you guys. You guys understand that what we are doing exactly. Okay, so let's close this one and simply remove this one because we don't need that one. So that's, if I copy this bytecode, you will find the same bytecodes. Okay, so this is the bytecode we have, all the data. So this is what we have. You can easily able to decode this, simply remove this one, and that's the only thing I want to cover about the function. Okay, so I hope you guys have understood the basic concept, that what are the things you can do with the help of the functions. There's a lot of things you can do. You can build condition, build logic, which can automatically do certain of things for getting the data, for calling certain function, for transferring. You can do a lot of things. Okay, and we're going to do that in a practical way when we build the real world application using smart contract. Okay, so hope you guys have found this video valuable. If you have still any question and doubt, do leave in the comment section. I'll try to help you in that. And if you're new to my channel, hit like and subscribe. That will motivate me a lot. So but that's it, I'm ending this video. Let's move to the next video. In the last video we learned about the functions in Solidity, and we have discussed a couple of important concepts which you have to keep in mind when you write your smart contract. In this video we're going to learn about the state variable in Solidity, that how we can create, what are the way to update the state variable data. Okay, so that's all we're going to do in this video. So here I've opened my remix ID. Make sure to do that. So the very first thing I want to do is I want to create a contract, and I'll call it state variable. Okay, and here I'm going to leave a couple of comments, so you guys have to keep few things in mind about the state variable. Okay, so that's the comments I have given. Now I'm going to define a couple of state variables to show you. So first thing, I'm going to take a string public, and I'll call it my state. I will take another one, this will become my num, and I will take another one. String is going to be, let's say, default text, and I'll say hey the default text, and I will take a number public, and this will say default num, and I will assign initial value is going to be 5, and I have to change this one to num. Okay, unt 256. Here I have taken 4 state variable. The first 2 state variable doesn't have their value, but the second they do have. Okay, so let me save it and let me try to compile it, and let me show you what we get. So if I deploy, and if I open this my deploy contract, here you can see currently I have 0 ether into this contract. Okay, so that's why you can see the balance is 0, and here I have all these function, and the reason I got this function because I have used the public keyword, which I have already explained in the previous video. Okay, so right now you can see I have 5 in this, and that because of this default value I have assigned, I have my default text as well. You can see if I click, I got this default text, but if I click on this I get 0, and if I click on this I get empty string. Okay, I don't have anything in that. So that's how you can define your state variable in your smart contract, and the state variable will always come on top. Okay, so you have given the name of your contract, and below that whatever you define, that's your state variable. Okay, so right now we have taken 2 data types. One is number and the second one is a string, but we have other data type as well. So let's take a byte. Okay, and this byte is similar to a string. Okay, so when you use byte in your contract, it will allow you to save gas fee. Okay, it will allow you to save gas fee. So I'll make it public, and I will say default byte, and if I pass anything in here, you will see the output I will get. You will see the output. Okay, so the output I will get, let me deploy the contract and let me show you what I want to highlight here. So here you can see, here I have the function. If I call on this, if I call this default byte, you can see this is the number, this is the exactly output I'm getting, because this string is converted into a byte because we have used the data type to byte, and because of this it's more memory efficient. We have to pay less gas fee for this. Okay, so that's the thing you have to keep in mind. So whenever you pass whether hardcode data or whether you take from the user as an input, the data will represent in something like this in a byte. Okay, the data we have here. Okay, so let's simply replicate it, and let's try to have a look on the default value. If we don't assign anything, what we'll get as an output. Okay, so let me redeploy the contract and let's try to have a look. Okay, so let's change the name to num, and let's try to deploy the contract one more time. And if I come here, if I call this, right now you can see we don't have any data assigned to this default byte. Okay, number. So this is how it will represent. It will start with 0x, and then the number of alphabet you will have, it will take that binary code. Okay, so hope this makes sense to all of you guys. So this is how the byte data represent as a state variable. So these are the things you have to keep in mind. So this is the way you can define your state variable. You can keep as many data as you want. You can take array, you can take boolean, you can take unt array. So there are tons of things you can do. Now let's come here, and now what I want to do is I'm going to take another variable array. Okay, so as I told you that you can take an array as well. So this is commented this out. If I come here and try to redeploy the contract, and the output I will get, you can see I'll get nothing. Okay, because I haven't made public, so I have to make it public so I can access this. Let's replicate this and let's make it public, and let's redeploy the contract, and boom, and here you can see that I got this my number. So currently we don't have any data into this array. Okay, so if we do have any data into this array, we can easily pass the index and we can easily able to have the output. Okay, so that's how you can define array. If you call this, nothing will happen. Okay, so this is how you can define array as well. So this is all the state variable, and this is how you define in your contract. And now I want to update the state variable data. So right now you can see this is the 2 state variable we have, string string and number, but we haven't assigned any value to that. But we're going to do it right now with the help of constructor. Okay, we have a detailed discussion on this constructor keyword. Okay, constructor keyword, sorry. Okay, so just focus for the time being that there are multiple ways you can update the data of your state variable. Okay, so currently it's empty. Here I'm going to take this constructor, and in that I'm going to pass this two data. Okay, so I have to pass the string, I have to pass the number, so I can assign that number to my state variable, and this is how we can do it. Okay, so I'll copy here and I will pass that, because first thing is a string, so I have to give the name of that data type string, and in Solidity you have to define the data type explicitly. Okay, you have to say that what data type you want to take, and here I'm going to use it memory. Again, this memory keyword has a detailed discussion, it has its own topic. Okay, so that's why I'm not covering it, just use it. And then I'm going to call this anything. Okay, and this is a general convention in the smart contract. So whenever you take any data from the user or as an input, this is how you denote slash and whatever name you can give to that. Okay, so I'll call it text, and I would call the number as well num. Okay, so this is our constructor. Whatever data we'll get from the constructor, we're going to assign the data to our state variable. Okay, that's pretty simple. So this is how you can update the data with the help of constructor, and this is what we follow when you will create a ERC20 token. So at that point of time, you're going to define your name of the token, and you're going to define that how many token supply you want, and this is how you're going to do it. Okay, so let's try to update that. So let's come here. So this is the data we have. Let's come here and let's try to deploy the contract, and here we have to pass the text, and we have to pass the number. So I'll call it, let's say, hey dollar, and here I want to say 6. Hit on transaction, and if I come here I have my logs. Okay, if I click on my number, you can see I got 6, and if I call my state, I got this hey dollar. So this is the another way which you can use to update your state variable. Okay, so let me comment this out, and now let's talk about the third way which you can use to update your state variable. Okay, with the help of function. Okay, so let's come here, let's create a function. So I'll create a function, I'll call it update, and the same thing I have to do is I have to pass the same data type. Okay, same convention I have to follow here. I will make it public, and again there is a detailed discussion about this public keyword, that why we use, and we have a detailed discussion about this public keyword, what is public, what is external, what is internal. Okay, just follow along with me. So what I will do now, I will simply take the data, my state, and I'm going to update it. Same logic I have to follow here, simply copy and paste here. So our function is ready to update our state variable. Okay, so now let's deploy the contract. So let's come here, and I'm going to select the contract, and I'm going to click on this deploy, and here we have the deployed contract. Right now you can see we have nothing in this two, my num and my state, and here I have to update the data. So I'll call here inside the function, and now I'm going to pass the data which I want to update. So I'll say is and 2. Okay, hit enter. Now you can see the data is updated. So this is another way you can use to update your state variable, and that's the only thing you have to know about the state variable, that how you can define the state variable in your contract, what are the ways you can use to update the data of your state variable. Okay, we're going to get into more details when we'll build the actual project ahead. I just want to have you a basic graph idea that how state variable work and what are the way you can act with. Okay, so we are done with this entirely. Okay, hope this entire thing makes sense to all of you guys. You have understood that what are this. So with that, I'm ending this video. Let's move to the next video where we're going to talk about the local variables in Solidity. In the last video we learned about the state variable. In this video we're going to talk about the local variables in Solidity smart contract. Okay, so I have opened my Remix ID, make sure to do that, and let me give this comment local variables, and let's create a contract by the name locals variable. Okay, we are following the general convention. Okay, not a big deal, and here we're going to define couple of variable as a state variable. Okay, so when you define variable here after the contract, it's called state variable, and that's the thing you have to keep in mind. Okay, so it will become public, and I will call it number. Okay, right now I'm not assigning any value to this state variable. Okay, so we have our state variable, and now I'm going to create a function. So I'll call it function for local variable, and now here I'm going to define the function. I'll call it local public. Here you have to keep few things in mind. Whatever variables you will define inside a function, they are called local variables. You can define as many as you want, and you can use them to build different logic, to perform different calculations. So those variables can only execute when the function is get called, and they're not going to store on the blockchain. It's used locally in a memory. Okay, so all the variables which you will define as a state variable, those are the variables going to store on the blockchain, and those will keep the actual data. But those variables you will define inside the function, they're going to use in the function and act as a memory. Okay, it will not store on the blockchain, but it will store in the memory. So that's the few thing, that's the thing you have to keep in mind. So I'll say not stored on the blockchain. So you guys can understood that the variables we'll define here, it will not store on the blockchain. And here I'm going to define a variable. I'll take a unt. I'll define a variable unt I, and I'll say I is equal to 345. Okay, that's the simple one. And here I'm getting some sort of notification. Okay, so let's come here, let's delete this one, let's try to deploy the contract. Click on this, and here the contract is got deployed. Here I have my number. If I click on this, currently I have 0 because nothing in there. But if I have this function, I click on this function, and here you can see nothing is happening. I want to return this. Okay, so I have to make it this view. I'll simply call it pure because we have a detailed discussion about this view and pure. Okay, so I'm not explaining right now this because I don't want to make things complicated to all of you guys. Okay, so just use pure, and here I'm going to use return. And what I want to return, I want to return number. Okay, so I will take this unt, and this is how you define return. Okay, and here what I will say, here I will come and I will simply say return, and I'm going to call this I. Okay, so in this way I can easily able to have the output from this function. So let's save it, and let's try to deploy the contract one more time. And if I click on deploy, if I click on this, here you can see I have 0. If I click on local, and I have the output. Okay, so this is how I can easily able to use the local variable to perform certain tasks. Okay, so this is the one way to define your local variables, but I want to do something. Okay, so right now you can see this is the state, this is the local variable I have, and I have my state variable which is an empty. So what if I want to make certain calculation, and the output I get, I want to assign that value to my state variable? Okay, we can do that. Definitely we can do that with the help of our local variables. Okay, so what I can do, I want to update that. So let's come here. Here I'm going to call that my number, and I want to update it to I, and here I want to have the output as my number. So here you can see, here I'm making the change in my state variable. Okay, because the previously the state variable is 0, empty, but here I'm, with the help of this function, I'm changing the state variable data. Okay, so I have to remove this from view. Okay, actually we don't need to use view because we are making change. View is only used to read the data from the state variable. Okay, so we have to remove this view because we are not reading, we are making change in our state variable. Now save it, and let's try to redeploy the contract. Click on this deploy, and here we have the contract. Okay, so if I click on this local, you can see right now I have this 0, but I have to call this function. If I call this function, if I call this, here you can see this is how we can update the data. So let me repeat what we have done, because this is the very important thing which you have to know, because when you will work on an actual smart contract, this is the thing goes over and over again. Okay, so inside the function we have created a variable by the name I, and that variable I, we are assigning that local variable, we are assigning to our state variable. That's the only thing we are doing here, and because of that everything's working fine. Okay, so that's working fine. So I hope you guys have understood that how you can use this function. And if you come to the logs, if I call this function, and if I come here, you can see this is the entire log I have got for this transaction. So this is the account which I have to do it, and the function I have called, and you can see this is the output I have got from this function. Okay, if I call it one more time, open it, this is the output I have got. Okay, so this is pretty simple. Hope you guys have understood that how you can define local variables, how you can use it, local variable, to perform certain calculation to update this state variable. Okay, so that's our local variable. Let's have a couple of more examples. So I'll say I plus plus. Okay, so what I'm doing inside that, I have defined the I value is 345, but further I'm trying to update that as well. Okay, so I'm adding 45 to that, and I will take this address, and I want to take the address one. Okay, so this is what I'm doing. So let's come here, let's define the address data type here, and now I have to make the output. Okay, so I'll say address, I want to take the number, and I want this I remove this one, and here I have to define that what are the data I'm just returning. So here I have to come, and here I have to define everything. So I will address, and I want this number. Okay, so that's the 3 thing we are returning. So we have to define explicitly that these are the 3 data type we are returning. Okay, and now we can click on this, click on deploy, and here we have, if we click on my number, still we have 0. If we click on this local, and here you can see we got the output. Okay, so this is the one we have right now. We have seen this is looking good, and here you can see in the log, you can see we got the address account 1, we got the unt 45, and we got the 390. Okay, it's coming in the form of object, so we can easily able to fetch this data and display on our application. Okay, So that's how things are looking fine. Okay, let's bring this down. So that's all about the functions and how you can create local variables and perform different tasks. Okay, and how you can use local variables to update the state variable. Okay, with that I'm ending this video. Let's move to the next video. In the last video we learned about the local variables. In this video we're going to talk about the global variables, that what are the global variables we have access in our smart contract so we can utilize it. Okay, so the same thing we have to do. Let me give this comment, local variable. We're going to build a contract, we'll call it local variable, and here I'm going to define all the variables which we have access as a global variable. Okay, so let's start with the first one. I'll say address, public, and honor. Okay, so let's start with the honor first. So here I'm going to build the constructor, and this honor will get updated. So I'll say honor equal to message.sender. So what I'm doing here, message.sender is a global variable, and how it's work, whoever will deploy this contract became the message.sender. So we are saying that whoever is deploying the contract take the account address and assign it to the honor. That's what we are doing. Okay, so let me show you practically. Let's come here and let me remove this one. Simply click on this deploy and let's call it honor. So this is the account which I have used to deploy the contract. Simply copy and simply paste here. Okay, and let's come up here. Here I have my first account which I'm connected with, and I'm going to paste it here. Okay, you will find both the accounts are same. Okay, so in this way you can easily able to access the message.sender, means the one who deployed the contract. Okay, so this is the one global variable we have. Now let's talk about all the other global variable we have in our smart contract in Solidity. Okay, so we have this block hash, we have difficulty, we have gas limit, number, timestamp, value, now on, and we have this origin, gas price, call data, first for. Okay, so these are the couple of variables I have taken, so I can show you that what are the global variables we have access to. Okay, so these are the variables I have taken. Now let's try to access. Okay, so here we're going to do in the contract. You can use it in the functions, but here I want to get it in the contract. Okay, let's deploy the contract and let's try to have a look. So if we deploy the contract, you can see here we got that, and here you can see we have empty, nothing in there. Okay, all of these fields have empty. Okay, nothing in there, and now we have to simply update all this data in our constructor. Okay, so let's do it very quickly. So here we have the block coin base. Okay, we have difficulty, we have gas limit, timestamp, gas price, origin, data, sign, value, and we now. Okay, so all the data is available in this block. So whenever any transaction will happen, it will contain all this metadata. Okay, so we can easily able to access the origin, the data, sign, timestamp, number, gas limit, difficulty, coin base. Okay, so now what I can do, let's try to deploy the contract. Okay, you can see we have all this, and you're going to use a lot whenever you want to build any logic about the smart contract. Okay, just imagine that you have to build a contract which can take a token from the user and it will keep it for a week or for 2 weeks, and then it will send back to the user with some extra reward. Okay, so if you want to build that kind of smart contract, then these are the property you need a lot. Okay, so we have this. Now let's try to deploy the contract. Click on this deploy, and here we got it. And now if you click on any one of these, you will have access to the data. So this is the call data. Okay, right now we don't have any data, that's why it says this way. Okay, if we click on this difficulty, this is the difficulty, we got it. If we call this first 4, okay, it will give you the first 4 of the buy data. Okay, so that's why you can see in that way. If you click on this gas limit, gas price, block, now 0, number. Okay, so this is number 21 number block. Okay, origin, this is the honor. Both origin and honor has the same address. Okay, timestamp we have, and we have value to 0. Okay, so hope things are making sense to all of you, and you guys know that how many data, how many global variables do we have access in our contract and how we can utilize it. Okay, so these are the important things you have to keep in mind when you build your smart contract. So hope you guys have found this video valuable. If you have still any question and doubt, do leave in the comment section. And that's the only thing I want to cover about this global variable, that how you can access in your smart contract. With that said, let's move to the next video. In the last video, we have learned about the global variable in Solidity, that what type of global variable we have, how we can update it, and how we can access in constructor and in function. So if you haven't watched, I'll link in the I button or in the description so you guys can follow that. In this video, we'll learn about the view keyword in Solidity, that why you should use view keyword. You guys have already seen a couple of examples in the previous video, but in this video we'll try to understand even in deeper level. Okay, so here I've opened my remix ID, make sure to do that. And here I'm going to provide this comment view, okay, and I will create a contract. I will call, let's say, view, and here I'm going to define a couple of state variables. So I'll take a unt and I will define 2 predefined value and number 2. Okay, so they have taken 2 state variable and I have assigned value to that. Okay, so now let's write a function so we can check the state variable value. Okay, so let me give this comment using view to check the state variable. Okay, let's write the function and I call get result. I'll make it public, and again we have a detailed discussion about this public keyword, and this is how you define view keyword. Okay, view keyword, okay, view and result, and here we have to provide the data type which we want to return. That's the general convention. So we want to return unt, okay, unt, because we want to return 2 unt. Okay, and with this function what we are trying to do is we are trying to access the state variable which we have defined and to see that what value we have here. Okay, so here what we're going to do, we're going to return this, and we want to return this num1 and num2. Okay, so that's the simple function we have written, and we have used this view keyword. I will show you that when you will not use the view keyword, what error message you will get. Okay, so we have this function, just simply save it and we have compile it. Okay, and let's make it capital and make it capital. That looks pretty good. And now let's come here and simply delete this one and redeploy the contract, and here we got the contract, and you can see we got this function and we have used this view keyword to access the data of the state variable. So let's click on this, and here you can see we got the data of the state variable. Okay, UA2 and 7. Okay, so that's how you can see the data of the state variable using the keyword view. Okay, now if I comment this and if I create another function, I'll say what if I want to calculate. So this function will allow me to do a certain calculation, and I'm going to use that calculation to have an output, and final output I'm going to assign to my state variable. Okay, so let's follow along with me. So I'll create this get result, and I'll say public view return, and I want to return this unt and product, okay, and unt and total. So this is the one way you can define whatever data you want to return. Okay, so here I'm defining at the function level that this is the product and total I want to return from this function. Okay, so you have multiple way to return unt, and I call num1 20 and num2 30, and I want to sum them. Okay, so I want to return this product, so I will simply say product, and I'm going to multiply 1 and 2. Okay, 1 and 2, and the same thing I'm going to do for the total. I will simply add them. Okay, so that's the simple. I have taken this local variable, okay, and that's what I'm returning from here. Okay, so that looks pretty good. Now if I come here, deploy the contract, and if I click on this deploy, you can see if I call this function here, you can see I got this data. Okay, I got this data. It's looking absolutely fine. Okay, so we can perform internal calculation as well with the use of view keyword. Okay, and this function will not create any impact on the state variable. Okay, you will see in later. Okay, so right now what I want to do, I want to simply use those 2 variables here. So if you can see here I'm getting this error message. Okay, did you mean num1 num2, because we have comment out this one, that's why we are getting it. Now I want to use this 2 variable and I want to update that. So I will say num1 num2, and this one is n, capital N, this one is capital N. So this time what we are trying to do, we are trying to use the state variable. Okay, we want to use that state variable to do certain calculation so we can use it. Okay, this time we are using state variable, and because of this view keyword we can easily able to access. If we don't provide the view keyword, we can't able to access that state variable. So we have the state variable there, and now if we deploy that, we can easily able to have that output. Okay, you can see now we can easily able to use that state variable. Okay, and that's happening because of this view keyword, and that's such a lifesaver you have. Okay, such a lifesaver you have. Now what I want, if I come here and if I want to update the data further, so the state variable I want to update that with the help of this function. Okay, so I'll take num1, and if I say +5 and num2 +7, and here you can see I'm getting an error message, because now what I'm doing with this function, that I'm trying to change my state variable. So I have predefined state variables, but with this function I'm trying to update that, and I will get an error. Okay, because I have used view keyword, and view keyword you can only use to see the data of the state variable. you can't do any changes. Okay, you can do the changes in the locally, but you can't do the changes in state variables. Okay, so these are the two variables I have, and here we are trying to update it, you can see, but we are using, if we remove this view keyword, okay, so we'll get an error. Okay, if we simply remove this, and now we'll not get any error. Okay, everything's looking fine. And if you call this function, you can see here we call this function and get a result. You won't get anything here, but you can see in the logs, you can see this is what we got as an output. So we have product 98, we have total 21. Okay, so this is the output we got, and we have successfully updated our state variable as well. Okay, so if I make it public, let's make this public as well, and let's redeploy the contract. If I open it, if I call this function, you can see I have 2 and I have 7, but the moment I will call this function, you can see I have this 7 and I have 14. So I have updated that, so things are looking fine. Okay, the main thing you have to understand here, that if you want to do any changes in the state variable, you can't use the view keyword, you have to write a normal function. But if you want to see the state variable data, you can use the view keyword. Okay, so that's the funda you have to use. If you type view, you will still get an error, so you can simply comment, and everything is okay now. Everything is okay now. So that's the state variable, and let's simply copy and let's make it this, remove this one, the one I want to have a normal return. And if I want to return this product and total, I'll get an error. You can see I'm getting this error because I have to define the data type as well, because earlier I was saying that the data type is product unt and it is product, so I don't need to do define the data type one more type here. Okay, so here I have to define the data type, it's unt and it's unt here, and now I can easily able to return the data from here. Open, call it. If you call this one, this is the data what I get, and things are looking good. I hope these things are making sense to all of you guys, that how you can use the view keyword. The only thing you have to focus, that if you use view keyword to see the value of the state variable, okay, you can't, when you want to do any changes in the state variable, you can't use the view keywords. So that's the important things you have to make for this view keyword. Okay, things are looking good, perfect. So that's the only thing I want to cover in this short video, because I don't want to extend this video too long, because this is a very simple concept which you have to keep in mind while developing your contract. Okay, so with that, I'm ending this video. Let's move to the next video. In the last video, we have learned about the view keyword in Solidity. We have seen a couple of examples that where we can use, how we can use. In this video, we're going to learn about the pure keyword in Solidity, that why we should use pure keyword and in what way we can utilize it. Okay, so here I have opened my remix ID. Make sure to do that to be on my footstep. Okay, so I'll come here, I'll give this comment pure, and I will take a contract pure, and I'm going to define a couple of variables. So I'll say unt num4, unt num2 10. Okay, so these are the two state variable we have. Now let's create a function. I'll say function get data public pure and return, and define the data types, and I want to simply return the num1 num2 which I have defined as a state variable, and it will throw an error. You can see I'm getting this error that I cannot use this function to access the data of the state variable. So to access the data, I have to use this pure view keyword. Okay, so this pure keyword will not work for me. So you can see I'm getting this error, and if I remove this, if I type this view, everything's fine, because view will allow to access the both the state variable and local variable, but pure is only restricted to the local variable, not access to state variable. So that looks pretty good. Now if we deploy the contract, here you can see we getting the data. Okay, if we type pure, we are still getting an error, so you can't access that. Okay, let's take a variable. I'll say num1 30, num2 50, and I want to perform certain calculations. So let's simply have an output, and this will work absolutely fine. Okay, we have taken two variables and we are simply returning from this function. Okay, and this time we are not calling any state variable, but we are using the simple function. Okay, so let's provide this comma, and now things are looking good. If we deploy the contract, and everything's fine, we can easily able to access the data, because this time the data we have defined and try to have an output, those are the local variable, not state variable. Okay, so that's the thing you have to keep in mind. Okay, now we can come down, we can take another product variable num plus, and we have to perform certain calculations. Okay, you can do anything as long as you are using as a view and using a local variables. So, and this time here you can see we try to access the state variable, and again we have used pure, but we can't do that. If we want to access, we can use view keyword, and now everything's fine. Okay, we can use the state variable to perform certain calculation and get an output from the local variables. Okay, that's what you can do. If you type hit enter, get the data, you can see we are getting the data. Things are looking pretty good. If you provide this product and if you provide this total, we'll get an output here. Okay, let's redeploy the contract, and boom, here you can see we got the data, calculated data 500 and 120. So that's the entire logic you have to know about the pure keyword. If I use the pure, I can't able to access, it will throw an error. It will throw an error. Okay, you can see we can't able to access that. So the only thing you have to keep in mind that you can use pure when you not accessing any state variable, but when you accessing state variable and both local variable, in such scenario you can use view keyword. Okay, so that's the only thing I want to cover about this pure keyword in Salty, and I believe that you guys have got a complete understanding that how to use, where to use, and what are the things operation you can perform using this pure keyword. Okay, so let's move to the next video. In the last video we have learned about the pure keyword in Salty. In this video we're going to build a smart contract for event organization. Okay, so let's start doing that. So I'll call this event ticket, and I will take the contract called event tickets, and I'm going to define couple of state variable here because our ticket will have couple of data. Okay, so I will take a unt public number of ticket. I will have another one, we'll say ticket price, we'll have a ticket amount, we'll have a ticket start time, so when the event will start, and we have to provide the end time as well. We have to provide the tickets timestamp. Okay, so we can easily able to find that when the time is got booked and when to end the event, when to start the event. Okay, so that's why we need to have this timestamp. Now we have to take a one more variable, and here we're going to define a pre-data. Okay, the by your first event ticket. Okay, so these are the couple of state variable we're going to define for our event ticket. Okay, we are writing a very simple, okay, very simple one, and here we have to provide the name. Okay, message. So that is the event state variables. Now we have to build our constructor. We'll take the, let's come here and let's try to deploy this one. If I deploy here, we get the entire instead of the contract. Okay, if you call all of these function, you will get this 0, and we have this pre-data. Okay, nothing in there, and now we have to update this. So we'll use this constructor, and in that we have to pass couple of things. So we have to take this unt, and we have to pass the ticket price, that what price we want to charge for those who want to buy their ticket. Okay, and we'll make this. Now we have to get the ticket price, and we have to update, and we can take the start time, which we'll have in this block timestamp. Okay, at the time of deployment we get the timestamp, we'll get the end time, so we'll simply take this block timestamp and we're going to add the 7 day. Okay, so it will have a 7 days period in which the users can buy the ticket. Okay, it has 7 days period. So whatever we have learned so far in Salty, we are only using those concepts. Okay, here we can add hell lot of things and optimize this contract even into the next level. Okay, because we have to do couple of condition checking, we have to do the condition checking that who can call, who to make the honor. Okay, so we are not doing anything like that because we haven't covered those topic in the Salty course. So whatever we have covered so far, we are building the smart contract on top of that only. Okay, so we have to make a 7 days period. Now what we're going to do, we'll take this timestamp, and so here we have the timestamp. Let's rename this to time range. Okay, and we have this start end. We'll take this end time minus start time, and we have to convert that into seconds. Okay, so this is the timestamp we have, time range, and this one is called time range, not timestamp. So that's the constructor we have. Now simply deploy the contract, and here in the contract we have to pass the price of the ticket. So we'll say 5, click on deployed, and here you can see if you click on this total amount, we have 0 because no one have bought any ticket, so we have 0 amount. Okay, we have this 5 rupees, we have this time range is 7 days. You can see we have given 7 days time range, 7 days periods, and that's what we got here. If we call this start, we call this number, message, and this is the end date. Okay, things are looking pretty good, And now we have to write the functions so other can buy the ticket. Okay, so let's write the function buy ticket, and it will receive the price, public, anybody can call it, and we have to return something. We have to return the ticket ID number. Okay, and here I'm explicitly saying that I want to return ID, ticket ID. Okay, now I want to simply call this number of ticket, because every time someone will call this function, we have a number of ticket that will get increased. Okay, and every ticket will have a unique ID, and we'll say a total. We have to take the price and we have to add that to the total amount. Now we have to take the ticket ID and we have to call the number of ticket. So that's the simple function we have here, which allow us to take the amount and create a ticket ID and add that amount to our contract total amount. Okay, so that's the simple function. Here we can do a hell lot of things. We can check for the conditions like honor, we can check for the price. Okay, so but those things we are not doing here because that's the topic for the later part, because we haven't learned about the condition checking. Okay, so whatever we have learned so far, we are building the contract on the base of that. Now that's what we have here. Now let's redeploy the contract, and we have to price the price 5 rupees, 5 ether, sorry. Hit enter, and that's what we have here. You can see here we got all the functionality which you can check. Right now we haven't bought any ticket, so you can see number of ticket is 0, but now we can buy it. We can pass the price 5, and if we click call this claw, here you can see we got an output. If you open this one, you can see we got the ticket ID 1. Okay, if you call this now, you will have 1. It's working fine. You can see 5 we got. If we click on this 5, this become 10, so the amount is also increasing in the contract. Okay, and the problem I was telling you, that if someone pass the less than 5, it will also generate the ticket. So you can see it will add the amount here as well. Okay, so we're going to learn about the condition checking as well later, not now, because we are building whatever we have learned so far, we are building on top of that only. So price is this, but we are passing 1. So that's how we can generate a ticket for those who want to attend the event. Okay, so that's the simple contract we have. Now let's write another function, get amount. Okay, so we want to access the total amount which we have in the contract and how many ticket we have bought. Okay, so we can do it. In the last video, in the last video, we have learned about the concept of view keyword. Okay, so you can see how everything is coming together, and we want to return the amount, total amount, and provide another bracket here, and now it's looking good. And now if you deploy, you have to pass just remove all this, because these are the sensitive data which you don't want to make it public. Okay, so let's remove all of this. Things looking good. Now we're going to provide the price, hit enter, and here we can see if you call right now we have this 0, if we call 5, 10. Okay, so this is the very simple event taken contract which we have created on the base of whatever we have learned so far in this Solidity course. Okay, so hope you guys can see that how things are getting together. Okay, we have learned about the global variables and how we can utilizing it. We have learned about the functions, we have learned about the view keywords. You can see everything we are using in this contract. So things are looking pretty impressive. So that's the only thing I want to cover about the small smart contract of ticket event. Hope you guys have learned something new and you are making progress in every single lecture. With that said, I'm ending this video. Let's move to the next video. In the last video, we have built a simple smart contract for an event organization for selling tickets and collecting money. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about the constant keyword in Solidity. And this is very important concept which you have to know, because if you're in a smart contract development, this will save you a lot of money when you will deploy the contract. Okay, so I'll give this comment constants, and I will take a contract and I'll call it constants, and I'm going to define couple of state variable. Okay, so let's take a stay address first. I'll make it public and say my address, and this is the address of my first account, so I'm simply pasting here. Okay, if I come here, if I simply deploy this, and if I open my console, you can see here this is the entire transaction log, the hash generation. Okay, this is the execution cost I paid for deploying the contract on the base of this variable, the state variable I have defined. So okay, so what I will do is simply copy this and I will paste here. Okay, I will show you the difference, that why you should use constant for certain variables. So I just want to make it clear one thing, that when you use constant, where the value is constant, it's not going to change. in the context of this contract, you can see this is the address I have defined in the contract, and this address is not going to be changed. All the funds I will receive in this address. Okay, so whenever you have any variables in your smart contract, that's going to be permanent. You can't change those variables. You should define constant. Okay, so this is the amount I'm paying without defining constant, but you will see that when I will define the constant, I'll pay less. So this is how you can define constants. Literally you spell it right, and this is the general convention you follow to define the constant variable in uppercase. So my dash address. Okay, so this is the general convention to define the variables. Now I will simply deploy the contract, and I will show you something. If I deploy it, come back to the logs, and let me have a look to the execution cost, and this time I pay way less. You can see, simply copy and paste it here. You can see there is a lot of difference in the gas which we are paying with constant and without constant. Okay, so that's why you should use constant for those variables which are constant, which are not going to change in the contract. Okay, so that's the simple funda we have here. And now let's write a function to see that what we get. So we'll say get constant public return, and we want to return the address. So we want to simply return this my address. Okay, so the address we have defined with a constant value. Okay, let's come and we'll make it view so we can easily able to see that. Let's deploy the contract, and this is the amount we got. Okay, so we are calling the constant variable with the function. So this is the amount we are paying, 215,450. Now let's comment this one without constant and simply replace this one and deploy and call this function. And here you can see here the amount we are paying, 23,586. Still we are paying high. Okay, so you can see we are saving money when we are calling the function as well. Okay, so it's always good to use constant when you define any variable which not going to change. You can see you are saving a lot of money for your company, and that's the only thing you have to know about the constant. In short, those variable is going to be permanent, not going to change. You should define those variable constant to save money. Okay, and those variables going to be changed, you should just use normal expression. Okay, so that's the only thing I want to say. Hope you guys have learned something new. With that, let's move to the next video. In the last video, we have learned about constant keyword in Solidity, that how we can define to save gas fee. In this video, we're going to learn about if-else statement in Solidity, that how we can write nested if statement and the entire concept. Okay, so here I have opened my remix ID. Make sure to do that. Let me give this comment if else, and I'm going to create a contract. I'll call it if else, and that I'm going to define a couple of state variables. So I'll take a unt my 5, and string is going to be, let's say, no. And here I will write a simple function, get public return, and I want to return the string memory. And again, we have a detailed discussion on this memory keyword, don't need to worry about it. And make it, let's say, if. Okay, so here what I want to do is I want to update my state variable with the help of this function using this if else statement. Okay, so here I will receive a number from the user. So I'll say num equal to 5. If it's 5, then I want to update the string to, let's say, hey, the value of num is 5. Okay, else I say not 5. This is a very simple function we have built. What we are doing here, we are taking an input from the user. On the base of that input, we are defining the value, okay, of that string. Okay, simply deploy the contract, and here you can see we have this 3 function. Num is 5 and string is empty. But if I provide this 5, hit enter and call the string, you can see, hey, the value of num is 5. It's got updated. If I type any other number, I'll say not 5. Okay, so this is how if and else statement works in Solidity. It's just like a JavaScript and other programming language. In the same way, you can define if and else statement here as well. Now we can add as many as we want. The third parameter we can also add, and we'll say num is equal to 4 if. Okay, so that's the third argument we can add. We can hit down deploy, and you can simply able to check the data and update it. So 5 to this, call this one. If we provide 4, we'll get this value. If we type 6, we'll get this value. Okay, hey dollop. Okay, things are looking pretty good. Hope these things are making sense to all of you guys. Let me comment this out. Let's write down the function shorthand. Okay, so the method I have shown you above, that's a longhand of writing the if and statement, but we have a shorthand method as well called ternary operator. Okay, so we can write that huge code in a smart way as well. Okay, same logic we have to follow here. Memory will say if number is equal to 5, then dollar. Okay, else this. So this is the long way of writing the if and else statement. Now let's write the shorthand. So I'll say num if that is equal to 5. I have to give this question mark because we are using ternary operator. If it's right, then we have to give this string to string, and I can say dollar. Else we can say this nobody. Okay, simple. You can see it's just like a one liner. You have just simply reduced that 7 to 8 lines of code into one line, and that's called ternary operator. It's just like the way you write in JavaScript, the same way we are doing here. If I deploy the contract, it will work in the same way. Simply pass the number and you get the updates of the data. Okay, so hope these things are making sense to all of you guys. This is the way you can define if and else statement in the contract. Okay, these are the simple if statement we have written. We're going to build more complex as per the contract itself. And that's the only thing I want to cover about this if else statement in Solidity, that how you can define longhand, shorthand, and it's just like a JavaScript. The way you write if else statement in JavaScript, the same thing you do here as well. Okay, so hope you guys have understood that how you can define if else statement in Solidity. With that, I'm ending this video. Let's move to the next one. Hey all of you, hope you guys are great. In this video, we'll learn that how we can create while loop in our Solidity smart contract. As we all know that all the programming language has their own loop. In the same way, we have loop in Solidity programming language. Okay, so we're going to cover one of the loops, which is a while loop in this video. Okay, so here I've opened my Remix ID. Make sure to do that to continue where I am right now. So I'm going to give this command Solidity while loop. I'll create a contract, I'll play while loop, and here I'm going to define the syntax that how it will look. So let me type the syntax, and this is the condition you have to. First you define the while and then conditions, and inside that you have to write the block and the piece of code which you want to execute and check. Okay, so I'm making this comment so you guys can have a reference. Okay, so let me comment this out. So this is the syntax part. Now let's check this in private. So I'm going to create a couple of variables. So first is going to be, let's say, uint array. Okay, so what I will do, I'm going to create a function, and with the help of while loop I'm going to add the number into this array. Okay, so that's what I'm going to do with the help of while loop. I'll take another uint. This will call uint 8, and initial value is going to be 0. Okay, now let's create a function. I'll call it loop public return, and I want to return an array, so memory. Okay, here I'm going to create the while loop. Okay, so I will define the keyword while, and here I'm going to check for the condition. So I'll say if j is less than 5. Okay, because I want to add only 5 elements into my array. Okay, so I will increment the j, and then I'm going to push that j into my array. Okay, that's a very simple logic, and then I'm going to return it. I believe that you guys are familiar with JavaScript, the same structure we have to follow here to push the data into array with the help of while loop. Okay, so here I'm getting an error. It's not a j, it's a k. So let me replace this one, k, and k. So that's the simple while loop we have written. Okay, I believe that you guys have got the idea that how you can use it. And now let's test this out. Okay, so let's deploy the contract. Click deploy, and here you can see the transaction went successful. If you see the logs, it's always very important that whenever you define any loops in your contract, there is a high probability that it will exhaust your gas fee. Okay, so adding loop in your contract, it's never a good idea. Okay, you should always try to avoid loops in your contract. Okay, and you should always compare the gas fees which you are paying when you are running the loop. Okay, so this is the entire execution cost, transaction cost which I have paid. Let's open it and let's try to call this function. Okay, if I call this function, you can see the transaction went successful, and if I open the transaction log, you can see I got 5 arrays into my data. Okay, 1 2 3 4 5. Okay, so right now I have 5 array. Okay, so you have to look at the execution code. You can see it's pretty high, so we should not include loops in our contract. Okay, let's bring this down, and that's the basic example. I don't want to extend this video because that's the only thing you have to know about the loops, that how you can create in your smart contract, and you can check for any conditions Okay, you can check for any condition in your smart contract. So that's how it will look. Hope you guys have got an idea that how the loops work in a smart contract and how you can create your own loop in Solidity programming language. Okay, so that's the only thing I want to cover. Hope you guys have found this video valuable. If you are still question, doubt, to leave in the comment section. With that said, let's move to the next video. Hey all of you, hope you guys are great. So in the last video we learned about the while loop in Solidity smart contract. In this video we're going to learn about do while loop in Solidity. Okay, so I have opened the project in my remix ID. Make sure to do that. Okay, so I'll give this command Solidity do while loop. Okay, let me create the contract and we'll call do while loop, and let me give this command. Let me show you that syntax of this do while loop, that how it will look on a Solidity smart contract. Okay, so first we define the do, and then we have this block, and here we check for the condition. Okay, you can check for any piece of code which you want to execute into this do while loop, and then you define the while, and here you check for the conditions. So that's the structure for creating a do while loop in Solidity smart contract. Okay, so let me simply comment this out, and now let's create a couple of let me type this command syntax, and now let's create the couple of variables. So let me create the unt data array, and we'll create another data type is this. Okay, so I'm going to follow the same logic here which we have covered in the last video, okay, about the while loop. So I'm going to take the same example here. I'll create a function called loop, and we'll say public return, I want to return an array memory, and now I'm going to use this do while loop. Okay, j++ data.push, and I want to simply return that. Okay, here I'm going to check for the condition. If it's j is less than 5, then we have to execute this code, and then we have to return the data. Okay, that's the very simple loop which you can create. Okay, so now it will work fine. So let's come here, let's deploy the contract, and simply open up the terminal and hit on deploy the transaction. When successful, open this, and you can see this is the execution cost we have paid as a gas, pretty high because we have loops in our contract. Okay, we have transactions, we have execution costs, they're pretty high. So now you will see that how much amount we are paying, or if you click on the loop, this is the transaction we done it, and here you can see still the transaction is really very high. That's why I tell you never include loops in your. So here you can see that we have this execution cost, we have this unt, and that's the simple. Okay, so it's pretty simple with the while loop, and this is the do while loop. Okay, so I hope this makes sense to all of you. Okay, so that's the only thing I want to cover about the do while loop, about the syntax. Okay, so that's why I don't want to extend this video too long, because this is a very simple which I want to highlight the syntax only. Okay, let's move to the next video. So in the last video we have learned about the do while loop in Solidity smart contract. In this video we learn about the for while loop. Okay, so I have opened the project in my remix ID. Make sure to do that. Okay, so let me give this command Solidity for loop. Okay, let me create a contract for loop, and I'm going to type the syntax so you guys can prefer. So first we type the for, and then we have to give the initialize value. Okay, then we have to provide the tester conditions, and then we have to simply add the iteration statement and then we have to add the statement, and that's it. Okay, here you can add the block of codes to check. So that's the general conditions which you have to follow if you really want to create loops in your contract. Okay, so let's come here, let's have a practically look. So I'm going to create a variable, same example I'm going to take here as well. Okay, so I have this data type array, I have this function public return, and I want to return simply an array. Okay, so what I will do, I'm going to create the loop. I'll use this for, and here I will provide my initialize value, which is going to be a unt type. So I'll say I is equal to 0. If I is less than, I'll take for any arbitrary number. Okay, so I'll say if I is less than 5, then I want to increment the I, and I'm going to simply push that I into my data array. Okay, so that's the simple loop, for loop, which you can use to create loops in a smart contract. Okay, so there is so many loops we have here. So that looks pretty fine, and then we have to simply return the entire data. Okay, so that's the simple examples we have here. Let's remove this extra and let's try to have a practical. Okay, let's deploy the contract and let's see the logs. Hit on deploy, and boom, you can see here we have the entire transaction logs, and the gas is always really very high. If you call this loops, you can see it went successful, and you can see still we are paying very high amount of gas fee. We have all this data. It started with 0, 1, 2, 3, and 4. So we have 5 array into our data. So that's how you can create array I believe that you guys know how to create loops in Solidity smart contract. Last video about the loops in Solidity, because we have covered all the 3 loops. The one thing I want to highlight about the loops is that you should try to avoid any type of loop in your smart contract, okay? Because when you include loops in the contract, it increases the possibility of exhausting your gas fee, okay? If you want to use it, the loops in your contract, you can, but you should never add the dynamic data, okay? You should define the definite value, that this is the value which I want to execute, and this range it will follow. Only the loop will follow for this range, okay? It should never be in dynamic. So that's the only thing you have to keep in mind about the loops in Solidity smart contract, okay? So that's pretty good, and that's the only thing I want to cover about the loops. Hope this makes sense to all of you guys, and if you have still any confusion, any doubt, we have covered all the 3 loops, okay? With that said, I'm ending this video. Let's move to the next one. In this video, we're going to learn about the required keyword in Solidity smart contract, that when you have to use, how you have to use, and what are the conditions you have to follow if you really want to handle error in your smart contract, okay? So let me give this command. I'll call it Solidity error handling, and we're going to use this require statement, okay? All the way we have 3 methods to handle error in our smart contract, okay? But in this we are focusing on the required. In the next video we're going to focus on other keywords, other ways to handle error in our smart contract, okay? So let's create a contract, and we're going to call it required. Inside that we're going to create a function, and we'll say check input, okay? It will take a unt number from the user, and we have to validate that number. So public view return, and we want to return a string, okay? And here we have to build the condition, okay? We have to use this required statement to check for a condition. So we use the required keyword, and in that we pass condition and message, both thing. So let's build the condition. So whatever input we are getting, if that's greater or equal to 0, then this is the error message we have to display, invalid unt8. And the second check we are doing, that if input is less or equal to 255, then we have to simply throw this error message, okay? And that's the very important thing which you have to keep in mind, that require statement need 2 arguments. One the condition, and the other one is the result, that message you want to display, okay? So let's provide this bracket. So I'm getting an error, so let's provide this bracket, and that's the check we are doing. If someone provide the valid number, then we want to simply return the string, okay? Input is unt8, okay? So that's the simple function we have written. We are taking a number, we are doing a couple of check, and then we are passing the string, okay? So let's come here, let's try to deploy this contract, and let's try to have a look what output we get. So here you can see the contract is deployed, and here we have the function check input, and in that we have to pass the number, okay? So let's bring the terminal a little up here. Things looking fine to me. Now let's provide the number, let's call it 5, and here you can see the transaction went successful, and here you can see the input is given 5, and here we got the output string unt is unt8, okay? Input is unt8. So but if I provide something higher number, I'll get the error message. You can see invalid unt8, okay? And that's the power of the require statement. But you always find the cost you are paying, because your transaction will get reverted back if the condition fail, and you can able to see that how much gas cost you are paying. So here you will find the execution cost. So whenever you write your smart contract, you should always compare with all the statement of error handling, that which one is costing you higher amount, okay? In that you will find the require is the best option to go with, okay? So you can see here we have that entire logic. This is the entire error, the codes you have got. So hope this makes sense to all of you guys. Now let's come here, and let's delete this contract and bring this terminal down, and this is what we have here. And what I can do, so we are doing this check. Let's try to create one more function. We'll say odd, okay? We're going to take the number, value, returns, and we want to return boolean this time. We're going to do a comparison, so we'll take the condition. So the input we are getting, if we are doing this remainder, if it's 0, and if we do this, okay? So if this statement is true, then we have to throw this true, okay? So that's the simple logic we have, and that looks pretty good to me. No more problem we have. Let's simply deploy the contract, and here we have it. Simply let's come here, let's try to provide the number. So this time I want to have a remainder, so let's provide 5, and you can see here we got this call to require odd, okay? We have called the function. If you open, you can see this is the input we have given and the return we have got is true. Okay, because we got a remainder. So that looks pretty fine to me. If you type 2, you can see this will give us false because the condition is failed. Okay, the transaction is reverted. You can see it's false. So you can do hell lot of things. You can do multiple things. Okay, here we are checking for a conditions and simply executing the functions. So that's the simple thing you have to keep in mind, that you can do calculations, you can pass argument, you can pass conditions and check the data which you are receiving from the smart contract and any kind of validation you want to do. Okay, so hope this entire things makes sense to all of you, that how you can use the required keyword in your Solidity smart contract to capture the error. Okay, so let's move to the next video, and that we're going to see a couple of more keywords to handle error in our Solidity smart contract. So let's move to that. In the last video we have learned about the required keyword in Solidity, that how we can handle error in our Solidity smart contract. In this video we're going to learn about the one more keyword to handle error. Okay, so let me give this comment assert. Okay, because we're going to use assert. Last time we used the required, but this time we're going to use assert. So let me create a contract. We'll say assert statement. In that I'm going to take a couple of variables, state variable, boolean, result, and I want to create a function. We'll say check overflow. It will have a number. Take two numbers, public. Okay, so we're going to take a 2 input from the user and we're going to perform certain calculation. Okay, so we'll say num1 plus num2, and we want to simply check for the condition. I want to simply say result is true. Okay, so what I'm doing here, I'm taking 2 number, I'm performing the sum, and I'm saying that if sum is less or equal to 255, then result is going to be true. Okay, that's a simple logic we have built here. Let's bring this up and let's try to deploy the contract. And here you can see the contract is deployed. You can see you can easily able to find all the execution cost which you have paid for deploying the contract. Okay, so again I'm telling you, it's very important that you should always compare all the variables which you use, that how much gas it's costing you. Okay, so that looks fine to me, no more problem we have here. Let's open this one, and this is the function we have, and here we have to pass 2 numbers. So I'll say 45 78. Okay, if I save, and you can see this is the 2 number which I have provided, 45 and 78, and the result I got back is where it is. Okay, I'm not returning anything from this function, that's why you can, but you can see the, let's make it public. Okay, let's make it public so we can see. You have the boast option, you can simply return from this function, but I'm not returning. I'll make it public. So let's deploy the contract and let's try to have a look. You can see right now the result is false. Let me provide the number. So I'll say 34 and 67. If I make a request, you can see the result is true now. Okay, so it's working fine because the sum is less than 255. So that looks pretty fine. So I believe that you guys have understood that how you can use this assert in your smart contract for checking for a condition. But here you have noticed one thing, in the required statement we have used the condition and the message, but here in the assert we are using only condition, no message. Okay, so that's the key point you have to keep in mind. Let's bring the terminal down. So that's the simple function we have written. Let's come here, let's create one more function, get result, public view return, and we want to return simply string. We'll say if result is deeply equal to true, then we want to say that return no overflow, else return overflow exist. Okay, so that's the simple logic we have. Simply remove this one, and now let's try to deploy the contract. And contract is deployed, and simply bring it up. Here we have this get result. Click on this get result, and here you can see overflow exist. Okay, if we provide the number, so 45 56, hit a request, and you can see right now the result is above. Okay, so say no overflow. Okay, that looks pretty fine. You can see on the base of that we can easily able to check the data. So believe that things are looking good to all of you guys. Now you guys can understand that how you can use this required statement or a asserted statement to handle error, how you can use in different functions and check condition. Okay, so that's the pretty simple thing. That's the only thing you have to know about this assert keyword in Solidity smart contract to handle error. Okay, there's no rocket science there. Okay, it's a simple keyword. You have to know the rules that how you can utilize it, and you can straight away apply. Okay, so with that I'm ending this video. Let's move to the next video. In that we're going to use one more keyword to handle our error. Okay. This is where we left in the last video. In the last video, we have learned about the assert keyword to handle error in our smart contract. So in this video, we're going to see one more keyword which is there, which allow you to handle error, okay? And this one is the final one. So let's start working on it. So let me give this command. I'll call it revert handler, okay? I'll create a contract by the name revert statement, because revert is the keyword which allow us to handle error, okay? So we have three error handle keyword like required, assert, and revert, okay? And this one is the least used keyword method, okay? So here what I'm going to do is I'm going to simply create a function. We'll say check overflow, and it will take the unt, two unt types, and we'll say public view return, and we want to return this string, okay? Simple. Now I want to take a variable called sum num1 plus num2. If sum is less than 0 or sum is greater than 255, then I want to simply, let's say, revert this, and I can say overflow exist, okay? Else I want to return this, and I want to say overflow and the exact value. I hope this makes sense. So what I'm doing here, I'm checking for a condition. If the sum is less than 0 or sum is greater than 255, means it's not between this range, okay? Then in such scenario, it's only throw this error message overflow exist, okay? But if the sum is in between the range, then we are sending this message, okay? Simple logic. In this revert keyword, we don't look for any condition, okay? We only pass the error message. So that looks good to me. Now these are the checks we are doing, revert, and we have the error. Let's deploy the contract, bring the terminal up, hit the deploy, and just look at this function. And here we have to pass the two number 34 and 56, and here you can see we got this. You can see no overflow because the range is lies between these, okay? And we get this unt, okay? So everything's looking fine, looks great to me. So that's the simple logic, simple thing. It's pretty simple, but you will notice one thing, that in most of the contract which already out there in the different blockchains, they don't use this revert keywords, okay? Because in that it's limited. You can't able to check for the conditions, okay? Because when you use this revert keyword, in such scenario you have to check the condition based on the if else statement, okay? And that's the unnecessary lot of code you have to add if you go with the revert keyword, okay? So if you use the required keyword in your statement for checking the condition, it make your work very easy, because you have to type the condition and you have to throw the error message, okay? So that's why you will not find in most of the smart contract, they not prefer to use this revert keyword. So that's how it looks. Hope this makes sense. That's the only thing I want to cover. I don't want to extend this video, because this is the concept you have to understand. Don't try to use revert, don't try to use assert, just try to use the required, because in that you can easily able to check for the condition and send the message, or you can simply check the message only or check the condition only, okay? So hope you have found this video valuable. If you have still any question and doubt, do leave in the comment section. With that, let's move to the next video. In this video, you will learn about modifier in Solidity programming language, that how you can define and what kind of benefit it's provide, okay? So here I have opened my remix ID, make sure to do that. So let's come here and let me give this command function modifier, and here I'm going to give couple of notes to all of you guys, so you guys can have that in mind, okay? Modifier are code that can be run before and after function calls, okay? Generally used for three reasons. The first one we have is the restrictions, okay? So if you want to keep a restriction for anything, for that, validations, and the third one we have is the guard for reentrancy, okay? So this is the three important concept which you have to know for the smart contract developer, okay? That it's help you to restrict any functions, it help you to validate data, it help you to prevent any reentrancy attack, okay? So these are the couple of things you have to keep in mind. Let's come here, let's create a contract. We'll call it function modifier, and here we're going to define a couple of variables. Public honor, we'll say unt public x is equal to 10, okay? So I have taken two state variable. Let's take the third one, public locked, okay? So what I have done, I have taken three state variable. One is honor, the second one is unt type x is 10, and the third one is a boolean type, okay? Three different data types. Let's create a constructor, and in that what I have to do is I have to set the owner message.sender, because I'm going to deploy the contract, so I will be the message.sender. And here I have to create a modifier. Okay, so what I say, modifier only owner. Okay, so what this modifier will do, that wherever you will attach this modifier, only owner of the smart contract can call that function. Okay, so let me show you what I mean by that. So I'll say required message.owner, sorry, sender, and I have to pass this owner. So if message.sender, the person who's calling the function, if his owner, then only execute, but if it's not the owner, then you have to throw the error message, not owner. Okay, so this is the simple modifier we have created, and this is how we have to denote. Okay, so if this statement get true, that dash notation will mean that continue the function further. Okay, execute the other function. So this is the simple modifier we have built. Hope this makes sense to all of you guys. Now let's come here, let's create the second modifier, which is for validating data. Okay, so I have to validate this address, and I'll say that address not equal to the 0 address, and if that's, then I have to throw this error message. Okay, that's the second modifier I have. So we got this 2 modifier, and now we have to continue the function. Okay, now let's create a function. We'll say check owner, we have to pass the address, and I'll say new owner. Okay, so what this function will do, that it will change the ownership of the contract. Okay, and public, I'll say owner only, and validate data. Okay, so here what I'm doing, that I'm calling the 2 modifier I have created as a function. Okay, so I have created this only owner, means only owner of the smart contract can call the function. Okay, so that's the first modifier we have. The second modifier is validate data. Okay, so first only owner will execute. If it's get true, okay, then this function will true execute, then the change owner function will execute. Okay, so this function, okay. Hope this makes sense to all of you. If it does, then we have to simply get this on new owner, and we'll set the owner to new owner. Okay, hope this makes sense. Try to understand that what's going on. You can use this modifier as an abstraction. Just imagine that you have a statement, and the same statement you have to utilize in multiple functions. So you can abstract that as a modifier, and all you have to do is to attach that modifier in every single function wherever you want to do the check. And that's so powerful. This will save you from critical bugs. Okay, it will save you from typing lengthy long smart contract, like too many codes. Okay, so it will save you a lot of time and sort of lot of bugs. So that looks fine to me. No more error we have. Now what we can do it, so we have the modifiers, we have the change owner functions, and both the modifiers working fine. Now let's come here, let's try to deploy the contract and deploy. And this is the, you can see I got this logged variable is false, honor this, and X is this. Okay, so now what I want, I can come here, I can simply go to the account number 2, and because I want to set him an honor. Okay, so if I copy that, his address, and if I come here and simply, this is the honor, if I paste his, and currently I'm on account number 2, that's the thing you have to keep in mind. So currently I'm on account number 2, so if I call this change owner function, I'll get an error. Okay, because I'm not the owner, account 2 is not the owner, account 1 is the owner. Okay, so our modifier is working fine. I got this error message. So okay, so if I come here, you can see I got this error message from here. If I copy that account address, if I paste and make the change, I can still get that error. Okay, I'm not the owner, so to change I have to come back to my first account, and now I can make an owner. And this time what I'm doing, that I'm making honor my contract. Okay, I'm making the contract honor to itself. Okay, so if I paste and if I hit a request, you can see the transaction went successful, everything's looking good. So this is the address, which is the contract address. So right now nobody can do anything because this contract is the owner of itself. Okay, so this is how you can transfer the ownership of the contract. Okay, if you click on the owner, you can see the owner variable is changed. If you go to no matter what accounts, and if you try to call these functions, you will get an error. Okay, you will get an error that not owner. Okay, because the owner is the contract. What function, no matter what account you call, you will get that error. So hope these things are making sense to all of you guys. You guys have understood that how you can use the modifier as an abstraction, and you can check for a condition, check for the data validations, and you can do a hell lot of things. Okay, so that's the first check. Let's come down, let's create another modifier, and I'll say no reentrancy. And you guys have already are familiar with this famous attack which happened in most of the smart contract, reentrancy attack. Okay, and in such scenario, modifiers play a great role. It's a great role. In such scenario, modifiers plays such a great role because it will totally prevent any kind of reentrancy attack if you use modifier. Okay, there is no chance of having reentrancy. So let's create a function for that. So here what I want to do is I have to check for a condition. If lock is true, okay, initial value of lock is false. Okay, if it's true, then I have to say that no reentrancy. This is the error message I want to send, and I want to simply execute the function false. Okay, but if it's not true, then I have to set the true. Okay, then I have to simply continue and I have to say false. So in that way, I'm simply strictly saying that if that's happened, then change the variables and update the data. Okay, so that's the modifier I have here. Now I can use this in my function. So I'll say decrement, it will take a number. Public reentrancy, you can see I have called the modifier, and now I have to do simple calculation. I want to simply subtract this x by -1. Okay, every time I call. Okay, so that looks fine. And here I have to check for condition. If I is greater than 1, then I want to simply decrement I plus 1. Okay, simple logic. I hope these things are not making any complicated. Okay, these are the simple JavaScript we are doing, because JavaScript and Solidity both are same. You will find everything is same. So that's the simple smart contract. We are using the modifier, no reentrancy modifier, to check these conditions. Okay, subtracting, checking for the if statement. Let's come here and let's try to deploy the contract. And here you can see, let's come here, and here you can see we get all the functions. Right now x is 10 and all these variables we have. This looks good. Now let's provide this. So if I provide 5, I'll get an error because the value is above 1, and that's why it's throwing this error. Okay, no reentrancy. But if I provide 0, it went successful because it's less than, because 0 is less than 1. Okay, and that's the condition we are checking here. You can see this is the value we have provided, which is less than 1. If I provide 1, if I hit a request, it will went through because 1 equal to 1. You can see this is the value I had. If I provide 2, it will throw me an error. You can see our reentrancy attack is working fine. Sorry, a modifier is working fine. So that's how you can create. The possibilities are endless. You can create many logic around these simple, powerful functions. Okay, so that's the only thing you have to know about this modifier, that this is how you can create an abstraction of the condition which you want to check in every function. Okay, so just imagine that you have a couple of function in your smart contract and you want that owner only if owner can call that functions. So you can add this kind of modifier, so only owner of the contract can have the calling power of the functions. Okay, so hope these things make sense to all of you guys. If you have still any confusion, rewatch the video and leave your comments down below so I can help you. So with that, let's move to the next video. In this video, we're going to learn about constructor in Solidity, that how you can initialize constructor, what is the role of the constructor, and how you can define into the smart contract. So construction is basically an optional function which can only be executed at the time of contract creation. So here I'm using Visual Code Studio to write the example, and later we're going to test this code in the remix ID. So let's see that. So let me give the license identifier. We have to provide this. Now we have to provide the Solidity version, and here we're going to define the constructor name. So let's create a basic constructor. So we'll have a basic constructor X, and we'll say X, and that I'm going to define a string variable. Then I'm going to define the constructor, and this constructor will take the variables at the time of deployment, so it's memory, and that's how we're going to update our string variable. So this is the very first contract, the X contract. We'll create couple of contract because we want to test that how we can inherit one contract into the another, the properties. So this is the first contract. Let's create the second contract, and this will call contract Y, and again we're going to have a string. It will call text, and we'll define our constructor, and it will take this text, and here we're going to update that text, and we're going to simply close that. So this is the second contract. So we have two contracts, X and Y. So let's write the third contract. There are two ways to initialize parent contract with the parameter. So right now we have two contract and we want to use these contract variables like this text and the string into different contracts. So generally there are two way. So let's have a look on the first way. So here we can come, we'll give this comment pass parameter here in the inheritance list. And the order is very important. The order is very important when you inherit any parent contract into your subcontract. So let's define the contract and it will call B. And here how we initializing. So we are taking the parent contract X and we'll pass the value. So input to X, and the same thing we have to do with the Y. And here we have to simply execute that. That's the only thing you have to do if you really want to inherit the parent contract into the other contract in the children contract. Let's create another contract, and the second way we have is to define in this way. So this is what you have to do: pass the parameter here in the constructor. So we'll say similar to the function modifier we have. So we're going to define the constructor, and it's going to be take this memory string and memory, and this will be our X and Y. And the second way to inherit the parent contract into the subcontract. So the first one is initializing with the value, and the second way we inherit. So make sure there is one important things you have to keep in mind, that order is very important. So first we have defined X, the second contract we have Y, and the same order we are following here. If you build any modifier, which I have already covered in previous videos, so you have seen that this is how we define the modifiers on the constructor, and the same thing we are doing. So this is the C contract, and that's how we can inherit the parent contract. Let's give me this comment. Parent constructors are always called in the order of inheritance. So that's the only thing you have to keep in mind, that it's called in the inheritance way. The second we have to say regardless of the order of the parent contract list in constructor of this child contract. So this is how the order is going to be like. So first we'll have the first contract, which is X. This is we'll have the second contract, which is Y, and the third contract is D, because we are inheriting X and Y in our D contract, and this is going to be our third contract. So what I'm doing here, this is the D contract we're going to create right now, and in that we're going to inherit X and Y. So let's define X and Y, and here we're going to build our constructor. We'll pass the value both for the X and Y, and that's it. Let's do the same thing for the other method. So here we're going to create X, Y, and this is going to be E. So let's create another contract. This will become E, and this is how we can inherit as a way of inheritance. We'll define our constructor, we'll define the values, and we're going to, and that's the only thing you have to know about the constructor. There are a couple of ways which you have to initialize constructor. There are ways that you can inherit the property of the previous contract into the main contract. So that's the things we have to keep in mind. You can see this is the first, second, and this is the two methods to update the contracts, and that's it. So now let's take this code to the remix ID and let's test this out, that is it really working. So here I've pasted all the code for the constructor, and let's deploy this contract. So if I come here you can see, here you will find the list of all the contract which you have created: B, C, D, E, F, and X and Y. So these two contracts are the parent contract, and these contracts are subcontracts. So let's first deploy the parent contract, and in this I'm going to pass DAULAT. That's the one I'm going to pass. And here you can see we have this one, and if I call this, you will have this dollar, and right now we don't have any balance into this contract, so you can see it's empty. Now let's come here, go to this Y contract, and in that I'm going to type SHOAIB Schwab my little angel, and I will click on deploy. And here we have the second contract which is got deployed, and this is the contract we have, the first one. If I call this, it's dollar, not this one, and this is the one we have. If I call, you can see I got this two contract. Now what I want to do is, so these two contracts we have deployed, and now we have to inherit these property into this X, so B contract only. So let's come here and we're going to deploy this contract B, and what I can do is I'll simply close this out and let's deploy the contract. So here I have deployed the contract, and this is the B contract. If I open this, here you can see I got this two name. One I've got text, and this one is M name. So if I click on this, I'll get this X, because that's the variables I have defined. And this contract is totally this contract which you have taken. Like here we are trying to inherit this contract in the B. You can easily able to modify the data. You can see we are modifying the data by passing the values like this. do the same thing for the Y. You can see that we have initialized that. So that's the B contract. Now let's deploy this contract C1. Let's click on this and we'll deploy that. So here we have to pass this values. So if you open this one, here you have to pass the name. So I'll say hey buddy, buddy, and I'll simply click on this deploy, and the transaction went successfully. If I click on this is the C contract, and here you can see if I click on name hey, and this one is the B buddy. That looks pretty fine to me. So we are continue using this contract to update the data. That's what we have here, and this is the final one. This is another constructor we have created. Now what we can do is, let's come here and we have to select the D. If you click on deploy, here you can have this D. If you click on this, you can easily able to have this value. So that's how you can update with the help of the constructor. This is also a way to update the value with the help of the constructor, and I hope this makes sense to all of you guys, that how you can update the value into a smart contract at the time of deployment. Because when you are deploying these contracts, only on that time you can initialize these value into these properties. So make sure these are the things you have to keep in mind, and that's the only thing I want to cover about this constructor, that how you can initialize, what are the way you have, and how you can deploy. So hope this makes sense to all of you. With that, let's move to the next video. Let's learn about mapping in Solidity. Mapping is a very important concept which allows us to track the data into the smart contract. So in this video, we're going to focus on the mapping, that how you can define the mapping, what are the value types, what are the data types, what is the string type, how you can inherit a contract into the mapping. So to create a mapping, this is the exact sentence. You have to define the keyword mapping, then you have to define the key type and the value type. So the key type can be built in any types, like it could be a byte, it could be a string, it could be any other contract, and the value type can be include only mapping or array. So these are the two things you have to keep in mind. Now let's see the examples. So let's define the license identifier, MIT, define the Solidity versions. Now let's write the first contract, and this contract we're going to call mapping because we are learning mapping. So let's call it mapping, and in this I'm going to take a variable, okay, mapping from address to UNT. So we're going to create a mapping, and that we're going to provide the address and we'll get the UNT back. That's how we're going to create the mapping. So let's create it. So we're going to call mapping address to UNT. It's going to be public and mapping. So this my mapping will contain all the addresses, all the data. It's just like a big basket, and that we have all the users, all the addresses. With this ID, we can identify that which user we want to take from that basket. So that's how the mapping works. So that's mapping we have. Let's come down. We're going to create a function, and this will call get, and this mapping will allow us to get that particular individual from the big basket. So we'll take this address, we'll take the public view, and it will return the UNT because it will return the ID of that particular user. And here we're going to define mapping always returns a value. It will always return a value, whether you define or not. But if you don't define that, it will return a default value. So what is the default value of a number? Default value of a number, default value for address, default value of a boolean. So everything is covered. Make sure to follow the previous video, okay? So that's the default value. Let's come here, and here we're going to return the address. So my mapping is the entire basket, and that we are passing the address. So when we do that, we can easily able to get that ID. So that's the very first function which allows us to get the ID of that particular user. Now let's come down. We have to create another function. We'll say set user. So we want to set the user into that mapping. So for that we need two data. We need an address and we need the ID. So we're going to create an ID. We'll say public because we are doing the changes in the state variable. Mapping is a state variable. So here we're going to create a comment. So update the value at this address. We're going to target our mapping, and we're going to pass the address into that, and we're going to assign an ID, and that ID is coming in the form of I. So that ID is totally up to you, that what ID you want to assign. You can do it programmatically. Whenever someone will click or create the account, ID get generated, and that's what we have done in our NFT marketplace. So if you haven't followed that project, make sure to watch, and that you will have a complete idea that how we are assigning an ID to every single NFT or every single user. So you have these two options. One, you can add it programmatically, or you can take from the user that what ID they want. But when you take the ID from the user, it's create a problem, because what will happen on that time, same user, like two different user can provide the same ID, and that can create the problem. So that's the thing you have to keep in mind. But here I want to teach you the concept of mapping. That's why I'm going in this way. So it looks fine. Now let's simply close this. So this is this two function we have. We have the get mapping and a set mapping. Now let's create another function. This will say remove mapping. So we have a data. We have a huge list of users into our mapping. But sometimes what happened that we want to remove certain data from there, and we can use it. So for that we need the address that whom we want to remove. So it's gonna be a public, and we have to simply call the our mapping. So we have to reset the value of the default. And how we can do that? This is how we can do it. So we'll say delete my map, and in that we have to pass the address, and that's the pretty only thing you have to do. We have this special keyword in Solidity which allow us to delete the element, and it is what it is. So that's the function we have. Hope you guys have understood that how you can get, how you can set, and how you can remove in the mapping the data. Nested mapping. And nested mapping is a very important concept which you have to know, that how you can get the data from the nested mapping and set the data there. So what we can do, let's come here. We're going to create another contract and we'll call nested mapping. And in that I'm going to create a nested mapping. So this is how the general structure of the nested mapping look like. So this time what we're going to do is we're going to create a mapping from address to another mapping. So if we provide an address of a user, and that will return a particular mapping related to that user. Every single user will have a mapping. So that's what we are doing here. So that looks pretty fine. Let's create a mapping address, and this will call mapping, and in that we'll have this unt. It will return the boolean public, and this is the call. We're going to call it nested. Hope this makes sense. So this is the syntax which you have to follow if you want to create a nested mapping. So we have mapping, we are passing the address of the user, and with the help of that address we are getting another mapping which contain all the informations of that particular user. That's how it's work, and that's the only thing you have to know. So that's the mapping we have. Let's create a function. We'll say get, and we have to get as it says. So we're going to pass the address, we're going to pass the ID, and it will return the boolean. So it will return the boolean. So we'll say you can get value from a nested mapping, and here what we can say, even when it is not initialized. So it will return me the nested, and we have to pass the ID and the address and the ID, and this will give you the data of that particular user, which is a true or false, because that's what we are returning. So with this function, what we are checking that the address we are providing, is it really there in our nested mapping or not? If it's there, then it's returned true. If it's not there, then it's returned false. Now let's create another function. This will allow us to set. So we want to set users into this nested mapping. So again, let me take a address one. It will take the unt ID, and it will take the boolean, and that's what we're going to provide. So if a user will get created, he will provide his address, he will provide his ID, he will provide the bool value, because initially boolean value is false. So at the time of setting, it's become true. So let's come here. We're going to call this nested address and bool, and that's the only thing you have to do. So this will set the user into a nested mapping. Let's create another function for removing. It will take the address and the ID, it will come public, and here we're going to simply delete that user from the nested mapping, and that's pretty much. So that looks pretty fine. You can see we have learned about all these functions. So we have created like single mapping, we have created nested mapping. So that's how you can see this is the nested and this is the single. Here we have all the contract which we have written about the nested mapping and a single mapping. So let's come here, let's deploy the contract. So here you can see, here we have two contracts. First one is mapping, and second one we have the nested mapping. So click on the first one and deploy the contract. The contract is got deploy. You can see the green tick, and if I come here, if I click in this, here we got four functions. So if I come here, the very first mapping contract have these four function, and the reason why we have this my mapping here as well, because we have assigned public. So when you assign public keyword, it will create a getter functions, and that's you can easily able to identify. So first thing what I want to do is I want to set a new user. So we're going to use this for function. So let's open it one, and this time I'm going to pass, let's come here, let's go copy this address, and that's the address I'm going to pass here, and the ID I want to assign is the 12. That's the one I want to do, and I will simply call transaction. So the transaction went successful, and I know the ID. So here I want to provide the address. So if I want to know the user, I can simply pass the address and I can call it. So if I pass the address, you can see I got this 12, and here what we are calling. So because of this, it will take the address and it will return you the EUNT. So I hope this makes sense to all of you. So that's the function we have checked. We have checked the set function. Now let's click on the get function, and in that get function we have to pass this, where it is, we have to pass the address. So to get the user, I have to click on paste the address and click on this, and here you can see we got the data. If you want to remove it, you can simply come here and you want to remove that person, and that we're going to simply pass the address. So if you click on this, and that's removed. And if I come here, if I click on this get, we don't have that user into this. So it's working pretty fine. So this is the very first function. You have seen all the methods: remove, set, get, and mapping. Now let's create on the nested mapping. So let's delete this one. Let's come here and let's deploy the contract. So if I deploy that, you can see here we have the contract, and here we got the 4 functions. So right now we don't have anything. So first thing we have to do is to set. So to set that, what I have to do is I can paste this address, I can paste the, let's say, ID, and I can paste this to, let's say, something true. If I click on this transaction, the transaction went successful, and that looks pretty good to me. Now what I want to do is I want to get that user. So to get that user, I have to paste the address of that user, and because we are doing with the nested mapping, so that's why we are providing this true data, and we're going to pass this 5. If I call this one, you can see the transaction got reverted, because I think I have what the ID we have given to this user. Okay, so this is the set method we are calling, and that we are passing the ID. Okay, so we are setting the user, and this ID is, okay, this one is the set one, and this one is the get one. In the get, we are passing the address only, my bad. So not this one, this is the function we have created. It will take the address and it will take the UNT. So in that, I'm going to pass the address and I'm going to pass the UNT. If I call this one, if I call this get, I get an error. Why it's happening? So let's come here, let's paste the address and paste this ID. What ID I have provided? Let's call the functions. I think I have provided the wrong ID. I forgot the ID. Let's click on this and let's try to create that one more time. So what I will do is, so this is first thing we have to do is to set the user. I'll come here, I'll simply paste that, and let's call this one to 3, and this will become hey. And if I click on this transaction, the transaction went successful. And if I want to get that user, first thing I have to pass this in this. Let's call the function, and you can see it's a UNT type. So this will take the address. My bad. So first thing we have to provide the address, and then we have to provide the 3. And if I call this one, here you can see I got it true. This user exists in our nested mapping. You can see this is true, we got with this function. Sorry, this function we have created nested mapping. Now I want to get the user. It will same thing I have to do here. If I come here, I'll paste the address and I'll paste this 3, and if I call this get the transaction, you can see here we got the boolean true. So it's working fine. So that's how you can retrieve the data and simply delete the data. The same thing you have to do. If you want to set, you can set it, you can remove it. Hope this makes sense to all of you guys. You guys have understood that how you can create the nested mapping with a single, and how to create a simple mapping, and how you can create a nested mapping. So that's the only thing I want to cover in this video. Hope you guys have found this video valuable, and if you have any confusion, make sure to watch the NFT marketplace after completing this course. Okay, so in that you will have a better understanding that how we have utilized this nested mapping for mapping the NFTs of the single user and a multiple user. So make sure to check that as well. So with that, I'm ending this video. Hope you have enjoyed this. With this, let's move to the next video. Array is a very important concept in Solidity or any programming language. So in Solidity, we have 2 types of array. One compile time fixed size array, and the other we have a dynamic size array. So let's take the example and let's see how we can easily able to update, delete, add into an array. So let's follow the general configurations. We have to provide the Solidity version, and here we're going to create a contract. We're going to call it array because that's what we're going to cover here. And inside that, we're going to create a couple of arrays. So several way to initialize your array in the contract. So let's do that. So first way is to this. This is the first way to initialize the array. So here we are creating an array which is a unt type, and we have used this public keyword so we can get a getter function, and this is the name we have given to our array, arr. So this is the first way to declare an array. Let's have a second way. So we'll again have a public and we'll pass this data, and this is the second way to declare your array. In that we are defining the value, predefining the value of the array. So that's the second way. Now let's do the third way. Let me give this comment: fixed size array, all element initialized to 0. And that's how you can do it. Here we have to declare 10 array, and we're going to call it fixed size array. In this fixed size array, we are declaring that we cannot have more than 10 element into our array, and that's what you have to follow in your smart contract, fixed size array. Now let's come here. Here we're going to create a function we'll call get. And with this function, we want to get the information from an array by particular ID, because every array will have a index. So it will start from 0, 1, 2, 3. So on the base of that index, we're going to get the data from the array. So here we're going to make it public. We'll call view returns unt, because that's what we want to return from the array, because it's a unt type. And here we're going to simply return the array, the entire array. In that we're going to pass the index, and that will give us the data. So this is the very first function we have. Let's create the second function. This will call Solidity can return the entire array, but this function should be avoided for array that can grow indefinitely in length. And that's very important, because in the smart contract, what happened that you're going to store informations, you're going to do the transaction, because this array is nothing but a state variable, and whenever you do any transaction, whenever you add any information into an array, what happened that you have to pay gas fee for every time. So that's why it's not a good idea that you should define an infinite array in your contract. You can go with the fixed size array, but you cannot go with the infinite. You can, but it's not recommended. So let's create a function. We'll call it get array, public view return, and we want to return the entire array. So not a particular data, but we want to return the entire array. So let's come here. We're going to define that. We'll say return, and we want to return the entire array, and that's how you can do it. So this is the array, and now let's create another function. We'll call it push public, and now we want to push the data. So you have seen that this is the normal array we have created, and we want to push the data into that, because we are not initializing any data at the time of deployment. It's just a state variable, an array, and we are pushing the data into that. So let's do that. We'll create this append to array, add to array, and here we're going to call this will increase the array length by 1. So every time you will add an array element into your array, it will increase that. So initially it will start from 0, 1, 2, 3, and will go on and on. So let's come here. Let's create an array dot push, the method we have. In that we're going to pass this I, the number. So this is the push method. Now let's come here. We have to take another function which is pop. So sometime what happened that we have an array and we want to remove something from that array, and that's how we can utilize it, by using the pop method. So we'll come here, we'll take the array, so removing the last element from array. So when you want to do that, when you want to remove the last element, you have to use the pop method. So we'll call our entire array. So this will decrease the array length by 1. So we'll call our pop method, and it will remove that last element in the array. So this is the function. Now let's create another function. This will call get length. So if you want to get the length of the array, that's how you can do it. So we'll say public view return. We want to return a number, obviously, because the length is going to be unt type. So that's why unt, and return the entire length. So just simply call the method dot length. It will give you the length of the entire array. Let's come here. Let's create another function we'll call remove. And now we want to remove an element. So just imagine that you have an array, 100 of array or 10 array, and that you want to remove a particular data, particular element from that. But what happened here that when you will remove that data into an array, so if the array length is 10, and if you remove that particular number 5 element, so when you remove that, what happened at that time, gets removed, but it will set the default value to the 0, and you will have the same 10 length. So there would be no changes in the length, but only in the value. It will reset the value to 0. So in that, we're going to pass this index public, and we're going to simply delete does not change the array length, but it reset the value at indication as a default. Hope this makes sense. And let's, in the case of 0, here we're going to call this delete method, and we're going to pass the array and the index, and this will become 0. So let's come here. We have to create another function. This will call example external. So let's test this out. So what I want to do is, into this function, let's create an array. In memory, fixed size can be created. So sometime what happened that you have an array as a state variable, and you want to create a copy of that array to execute certain functions. And that's what we have follow in our NFT marketplace. So you can check that smart contract. So in that scenario, whenever you want to create a function in a memory, that should be fixed size. It should be never dynamic size. It should be fixed. You have to define the length of that array, and that's what we're going to create here. So let's come here, and we're going to call this unt memory new memory, and here we have to define the lengths. So right now I'm going with a 5, and that's how you can define. You have to define the data types, then the array, memory, and you have to give the name of the array. So we have taken A, and you have to use the new keyword, then a data type, and you have to define the length. So that's how you can define array into your memory. So this is very important. You have to be very focused here. So that looks pretty good to me. Now close this one. So with this, we are done with this entire array section, and we have covered most of the topics. So you can see this is the entire contract, and now we can test this out. Here you can see we have the entire array contract we have written, and we have all these functions here. So let's come here, let's deploy the contract, and here you can see this is the only contract we have, which is an array. Click on this deploy, and here you will get the contract. Open it, and here you will find all the contracts, all the function which you have created right into this array contract. So what I can see right now, you can see we have this array 22. So let's test this out. So if I come here, you can see this is the one we have, and we don't have any function to add any error because we have defined all the element at the deployment. Initially we have defined all the values. So if I want to get the first value into this array, I can pass the 0 index, and I click on this, and here you can see I got the value 0. If I come here, if I pass the 3, because I don't have this 3 element, so I have to pass 2, because in array start with 0. So if I click on this, I will get the 3, and that's what I have in this. So this is how you can access the data on the base of the index into an array. And right now we have this array, and here we are using this array to update and delete and remove. So you can see this is the public we have used, and here we have it. And right now where it is, if I call this one array, you can see nothing I'll get here. You can see it's an empty array. And now what I want to do is I want to get this. So right now we don't have any array. We have to simply, first we have to set that array. So let's see where we have created that array. And this is the array. We're going to use this. So we're going to use this push function to add into our array. So where we have is, here we have that. So I want to add 5. If I click on push, the transaction went successful. And if I call this one get array, so this is the one we have, get array. If I click on this get array, here you can see I have this 5, which I have added. And if I want to find, let's add one more. So let's come here, let's remove this, let's type this 3, let's type this 7, 6, let's type this 8. So right now I have 4 arrays. If I click on this get array, I'll get this all 4 elements. So if I want to get with the help of this function, so I want to access this data number 3. So what I will do, I will type 1, I will click on this, I'll get this 3. Okay, if I want to get the 5, I can type 0, because array is start with 0, okay, index 0, so 5. If I want to get the length, right now we have 4. If I click on this, I'll get the length. We have 4 elements into our array. If I want to remove, so for removing, what I have to do, if I want to remove this, so right now we have this, I want to remove number 5 or number, let's say number 2, this is the 3 value. So for that I'm going to pass the 1 index, and I will click on remove. And it's remove. If I call this get array, you can see I have this 4, because when you remove, what happened, that it only remove the value, but the length will not change. It will set the value to 0. So hope this makes sense. And if I want to remove the last element, so this is the length I want to remove, so I can call this pop. If I call the transaction successful, if I call get, you can see the array is gone. So the pop method delete an element from last. That's the general overview of an array, that how you can add element, delete element. In the next two videos, we're going to have two more lessons on the arrays. In that, we're going to see the advanced use case of an array. So let's move to that. In this video, we'll learn one important concept in Solidity when it's come to array. How you can shift an element from right to left and remove. And that's what we're going to focus in this video. So let's see how we can do that. So let me provide this Solidity compiler. We have to provide the Solidity version. Let's create a contract and I'm going to call it array removed by shifting. And that's what we're going to do in this. So here I'm going to define an array. So this is how it will work. So this is the array we have 1, 2, 3, and I want to remove the one index array. So once I remove that, that's how it will become 1, 3, 3, and this is the final product would look like 1, 3, because I'm removing this. So what I'm going to do is, let's come here, we're going to remove 1, and that's how you can do, because 1 is going to be, we have a array in that we have one element which is a 1, and that's what I want to remove. So the index of that element is going to be 0. Once you remove that, what you will get? You will get nothing. So that's pretty simple thing. Let's create a array, and it's going to be a unt type and array. So let's come here, we'll create a function called remove, and this function I'm going to call inside another function. So in this function we're going to pass an index public, so anybody can call it, and thus we're going to write a do a if statement, because we want to remove the element on the base of the condition, not just like this. So here we'll say that if the index is less than array.length, the array we have, if we have an array, if we have any item into our array, then only remove index out of bound, because there is no array and the index we have provided, there is no way to remove those index into our array. So that's the first check, and here we're going to run a for loop. We'll say unt I is equal to I index, the index we are getting. If I is less than the array length, then we have to subtract, because we want to start from the backend side, and then we have to increment that. And here we're going to simply remove it, the index I plus 1. So hope this makes sense. It's a simple JavaScript. We are running a for loop and trying to delete the index. So just imagine that you have a 10 elements into an array and you want to delete the 5 from the last. And that's how you have to do. So if you want to have only 5 elements into 10 array, so what you can do, you will pass the index 5 and it will run the for loop and it will delete all the element from the last side till we have the 5 array left. And that's what this remove function is going to do, to help us to remove the array from the back into our array. So that's what we have, and now we're going to call this function. So we're going to create another function, and this will call test. It's going to be external, and here we have to do on the base of certain things. Okay, so we're going to take an array. It's going to be 1, 2, 3, 4, 5, 6. So this is the array which we are updating into a function. Okay, remember earlier we have no data into an array, but here we are updating that. We'll say that remove index 2. So that's how it will work. So you have passed this remove functions, so it will remove. This is the array we have defined 1, 2, 3, 4, 5, but we are passing the index 2. So can you guess that what array it will remove from that? So here let me do this. So this is what we're going to get it, because we are removing number 3, 0, 1, 2, 3. 0 is 1, 2 is 1, 0, 1 is 0, 2 is 1, and 3, because we are removing the 3 element. That's how it will look. Let's do the check. So if assert 0 index is 1, yes, that's the true. Then we have to do the second check. If the second element is 2, yes, it is true. Here we have to do the third check. If the first is 2, second is 4, yes, because after deleting that we got that. Now the last one is 5. So it's true statement. If this statement gets true, we have to simply call this assert. So if the array.length is 4, if that's the true condition, then we have to remove one more element. So we're going to check this one and we're going to say remove 0. So we want to remove the first array, and then we have to call this. So it will call assert.length is equal to 0. It will be our true statement. So hope this entire things make sense. So this is the entire shifting works. And let's test this out, the contract we have written. Here we have the entire arrays, which we have defined, and the two functions. So let's quickly deploy that. So here you can see this is the only functions, only contract I have. If I click on this deploy, here I got the contract back, and in this we have these three functions. So right now we have this test and we have this array. So here you can see right now we don't have anything into an array. So if you pass 0, you will get an empty array. You will get nothing into this because we don't have anything. Now what I'm going to do is, instead of calling this function get test, or you can call it from here. So if you have anything into an array, because that's what we are dealing here. So if I can pass 1, I can call it remove function. Nothing will happen because nothing is there. Nothing is there because this function is totally dependent on this test. So right now you can see if I call this get, if I call this test, so what will happen? The first, it will update this array, because this is the array we have taken and here we are updating that. So it will update that, then it will remove the first this element, it will remove this element and it will get this, and then we are doing this check that at the end finally we are checking for the length, and then we are checking we are again updating the array and making it 1. So at this point we have only one array, and here we are calling this remove function and passing this 0 means we want to remove this array as well, and we'll get this function. And here we are confirming that the entire array is length is 0. That's pretty simple function. Now let's test this out. So what I can do is I can click on this confirm, and here the transaction went successful, and you can see we got nothing. If I open the logs, this is the transaction we have done, and here you can see we have done all the logic. So this is the transaction has the function we have called, and you can see right now we don't have anything. This is absolutely empty. So what happened? First, when you call this test function, what it does, it update the array 5 element into our array, then remove the third, all the elements are there on their position based on the index, then check the length, then remove the last one. So hope this makes sense that how you can remove by shifting. So this is a pretty important thing which you have to know, because when you're going to create a nested mapping and in that you're going to map an array, so these things becomes very important. So that's the only thing I want to cover about the shifting and removing array by shifting. Let's move to the next video, and that we're going to have one more topic on array, then we'll move to the other topics. When it's come to removing an element into an array, there is one more method which you can use it. So generally what happened that you have an array, just imagine that you have 10 array, and when you call a delete method on that array to delete a specific index, a specific element, what happened at that time, the length is going to be the same. So if you have 10 element and you call the delete function and you deleted the first element or second element, the length is going to be the same, and that's not ideal because you want to change the length as well, because you have deleted one element. Once you call the delete function straight away, what happened at that time, it will set the value to 0 by default. So it's always a great idea that whichever element you want to delete, first you have to place that element at the end of the array, and from there you can call it pop method to delete the last element, and that way you will get the updated length after the delete. Okay, and that's what we're going to do it right now in this video. So first thing, we have to provide the Solidity license identifier MIT, then we have to define the Solidity versions. And here we're going to create a contract and we'll call it array replaced from end. Here we're going to define an array, and it's going to be a normal array. We have not defining any value, and here we're going to create a function. Okay, so let me give this command: deleting an element, create a gap in the array. This is what I have talked about. If you want to delete an array, if you have 10 array, if you want to delete the array number 5, and that it will reset the value, but you will have the same length. And that's the gap I'm talking about here. On trick to keep that array compact is to move that last element and place, and then call delete method. So let's call this, let's see in the function. So we'll call this remove, and in that we're going to pass the index, whichever index we want to delete into an array, and we're going to make it public so anybody can call it. So we have that one. Now what I'm going to do is I'm going to create this, move the last element into the place to delete. So just move it, and now we're going to create an array. We'll have an array, this entire array, in that we're going to identify by an index, and we're going to simply call this array.length -1. So it will give us the last length. So it will give us the right index and the exactly both the things will be together. Simple. Let's call remove the last element. So to remove that, we're going to call this pop method. So what we are doing here, we are just setting up the value and we are removing the last element. So that's how exactly it works, and that's how you can remove that. Let's come here, let's create another function, and we're going to call it test public, and here we're going to confirm that. So we have to update the array. So we're going to take this 4 array. In that, we're going to simply call this remove function. So what I'm doing here, I want to remove the element number 2 inside my array, the 2. So for that, I'm calling that, and this is what the result I will get. So first I'm doing that, I'm bringing that 4, the fourth one, bringing into the place of 2. So 1 4 3, and that's what I have talked about. So you have to replace the position of the index of the element which you want to delete from the to the last, and bring the last one to its own place. That's what the array, updated array, will get after calling this remove functions. And here we can make the change. So if the length is 3, so that's the first check we are doing, and here we are simply doing that second check, that in the first index we have 1, in the 0 index we have 1, and the first index we have 4, and the second index we have 3. And now we can simply call the remove function. So in this remove function, what I'm doing, I want to remove the last element, the last one. So this is what I will get, 1 and 4, because it's already last. We are not going to replace with anyone. So we're going to simply call this. And then we can check the length. Is it the length? If is that the length, then simply confirm that. It will work 100% fine. And that's the entire logic. Hope this makes sense, how you can replace an array and then you can simply remove that. This is the entire contract we have here. Let's deploy the contract very quickly. This is the only contract I have in this. Let's open this one, and here we have these 3 functions: remove, test, and array. So right now if I call 1, I have nothing into this because initially we have not assigned any value to this. So first let me click on this test. If I click on this test, it will do this. You can see first it will update the array, then it will remove this element, and it will give me the updated array. Then we are confirming this. Then again we are removing this array. So this is the third one, because this was 0, 1, and 2. So this one, and then we are checking for this. If you have a look here, we can see the transaction went successful, there is no error, and you can see everything looks fine. We don't have any error, means everything's look good. So that's how you can replace an array by shifting. In that way you always get the updated length. So 10 array, if you want to remove one and you want that the length of the array also get changed, and that's how is the way to go. So hope this makes sense to all of you, and that's the only thing I want to talk about the array. I hope I try to cover every single thing about the array which are there, by replacing and then shifting and deleting, then the normal. So everything we have discussed about the array in the Solidity smart contract or in the Solidity programming language. With that said, let's move to the next video. So in the last video, we have completed the array section in Solidity smart contract. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about enum, what it is, and how you can define into your smart contract, what is the structure, and how you can keep the track of the entire data which you want to specify in the contract. So that's going to be the topic of this video. And enum stand for innumerable. So this kind of question might be asked in the interview. So let's see the practically that how we can do it. We have to provide the general configuration. So Solidity license identifier, we have to provide the Solidity version, and let's create a contract, and we're going to call it enum. Inside that, we're going to define our exact enum. So let me give this command. Let's define the enum. So this is how you define. You give your name enum, and you can give this name of this enum whatever you want. It could be hey, okay, but here I'm going with status because I want to create an enum of a shipping. So just imagine that I'm creating contract, and that contract will keep the track of a shipping of a product. So there will have a multiple data. It will have a pending, cancel, arrive, accept, reject. So let's create that data. So we'll call it pending, shipped, accept, reject, and cancel. This is going to be our enum. And let's come here. So whenever you define enum, the default value is going to be the first element. So that's how exactly it's worked. So let's create a variable, status, public status, and that's how we refer our enum. And here what I'm going to do is, let me show you. Returns the UNTs. Pending is going to be the 0 because the default value of the enum is going to be 0, and it's just like an index. So we have array, in that we have this indexing system. In the same way we have indexing system in enum. So the second one will have this ship 1, accept 2, reject 3, and cancel is going to be 4. So looks fine. Now let's create a function. We'll call it get public view return, and in that we want to return the status. So what we have to do is let's create a return status. So that's the simple function. So this will give us the status. So can you guess what status we'll get when we'll call this function? Just think about it. Let's write the code. So let's come here. So now let's update the status, because the default value of the status is going to be obviously pending. So let's update that. So we'll create a function, we'll call it set status, and that we're going to take the status public, and in that we're going to call it status equal to status, and that's it. In that we have to pass the index, the status we want to confirm, because the pending we have 0, accept we have 1, so that's the index we have to provide. So this is so let's come here, let's create a function, we'll call it cancel, and this is how you can update the status. So we'll say status is going to this cancel. So if you want to cancel that entire order, you can call this cancel method, cancel enum, and this will change the state. So by default we have this pending, but when someone will call the cancel this function, it will update to cancel. And if you want to update to other like accept, reject, you can simply pass the index in the set function, and that will update the status. So that's the pretty simple thing here. Let's come here, let's create another function, and this is very important, because when you delete an enum, it will reset the value to 0. So let's see in the code. So we'll call it reset public, and in that we want to take this delete status. So when you do that, it will delete the status. So that's the simple smart contract we have written about the enum. Hope this makes sense to all of you, and how we are accessing different variables in each of these functions. So now let's test this contract in the Remix ID. Here you can see we have the entire smart contract for the enum, and we have all these 3 functions. So what we can do is let's come here, let's come to the deploy sections, and you can see this is the contract we have. Now click on this deploy, and here the contract is got deployed. If you click on this enum, here you will find these 5 functions. So first thing we have to do is, if you really want to access the set, so in the set, so let me do one thing. What I can do is, here we have made this public, so let's check the default value, that what default data we get from here. If we click on the status, we'll have this 0, because this is the indexing 0. This one is the first one pending. And now what I want, if I want to simply call this 1, because I want to target this shipped, if I call this set, the transaction went successful. If I click on this, I'll get this 1. So you can see we are updating based on the index. So it's just like an array. The way we have accessed the array into a big array by providing the index, in the same way we can access all this data by its index. So it's working absolutely fine. So now if I call this get method, I will get the status. So here I can call it get, and you can see this is 1. That means the shipped, and it's working fine. If you call this set, we have already used the set method. If we call this cancel, so let's do one thing, let's click on this cancel, and the transaction went successful. If we call on this status, it will be 0, and that's what we have provided here, 0. So we have checked this function. Now what we can do, let's do the reset. So if I want to reset the entire data by its default, I can do it very easily. Click on this reset, and the transaction went successful, and now you can click on the status, and you can see we have this default value. So hope this makes sense to all of you guys. Array act like an indexing. So if you want to access any variable into these data, you can provide this index. So this one is 0, 1, 2, 3, and 4, and on the base of this indexing, you can easily able to build the logic which you want to build. You can display the message that your transaction is got approved or rejected. A huge string you can display by taking this indexing value based on this enum. So hope this makes sense. If you have still any confusion, make sure to rewatch the video, and do leave in the comment that what is the problem you are having, what is the difficulty you are having. I'll try to solve in that. With that, let's move to the next video. Sometime what happened that your smart contract is huge, and in that you define multiple enums. The enum list is huge. So in such scenario, what you can do, you can create a separate contract, separate interface, and that you can define the entire enum. So that's also possible in the Solidity. So in this, we're going to do the example. We're going to create an enum into a different page, and we're going to import it and try to access that. So let's me provide this general convention Solidity version. Let's create a contract declaration. So here what I'm going to do right now, I will show you right here, but in the real world, what happened that you create a separate file, and although it's a very small enum which I'm going to create. So that's why I'm going in the same way, so you guys can get the notation that how you can import and how you can create. So let's declare the enum. So we'll call it status, and that we can define our enum. So the same example we are taking: pending, shipped, accept, reject, and cancel. So just imagine that we have created a separate enum declaration Solidity file. In that we have declared all the enums which we want to use into a smart contract. So this is the enum, and now I want to utilize this enum into different contract. So this is how you can do it. All you have to do is to create a new file. So right now I'm showing you in the same file, but what you can do, if you want to use this enum, the interface, enum interface, into a different contract, you can create a different file like whatever the name of the file, and this is how you can import. You can use the import and you can provide the file path. So that's what we have, and now you can simply create a contract. We'll call it enum, and in that you can easily able to inherit all the enum property, all the enum which you have defined into the file. Just close the contract, and that's the only thing we have to do. You can see we have defined the enum and we have imported that. How you can import and export the enum, and that's the only thing I want to talk about, the import of the enum in this video. So with that, let's move to the next video. Struct is a very important concept in Solidity smart contract development because it will allow you to create related data. And the best part of it is that you can define into separate file and you can import it into a smart contract. So in this, we're going to learn everything about struct, that how you can define, how you can update, and how you can delete. All those things we're going to discuss in this. Let's provide the general configuration. So we have the MIT Solidity version, and let's create a contract, and we're going to call it to do. And in that, we're going to define our struct. So this is how you can define your struct. You can use the keyword struct, and you can define the name which you want to give to your struct, and this name could be anything. It's totally up to you what kind of data you want to model. So in that, let's define the struct. So it will be a string and text, and it will have this bool complete. So by default the boolean value is going to be false, and if we complete this task, it will turn it to true. So that's the simple struct we have created. Now when you define your struct, you have to define an array. All the data which you're going to create with the struct, that's going to be stored into an array. So let's declare our to do, and will be public and to do. So that's the how you have to declare struct and how you can store the data into an array. Now let's create a function which allow us to create our to do list. So let's create a function. We'll call it create. It will be string, call data, text, and public. So anybody can call this function, and in that we're going to initialize. So generally we have three ways to initialize our struct. So we're going to take each of these so we're going to explore each one of these. So let's come here. The first one we'll have by calling it like a function, and you can take this to do look, and you're going to push the entire data. So we have this to do, text, and the false. So when someone will create, will take the data and will create will turn it to false. Okay, that's the pretty simple things. This is how you can update the data into the struct by using the push method. And there is one more method. The second method we have is by key value mapping. So this is going to be the similar one. All you have to do is to provide the key text, and that's what we have defined in the to do text, and we're passing that. So this is one way you can do by the key value pair as well. And the last one we have is to create like this: initialize an empty struct and then update it. So all you have to do is to create a memory to do. So this is our empty, and here we're going to simply update that. So we'll take this to do, this text, to do dot text equal to text, and the same thing we have to do is for the complete, and by default the boolean value is false. So this is how you can update it, and then we have to push that to do into our to do's. So that's pretty simple thing. Hope it makes sense to all of you guys that how you can update the struct by using these three methods. All you have to keep in mind that we have three ways. One, by simply passing the data using the push method. In that you don't need to pass the key value pair, and the second one we have is the key value pair, and the third one we have is to creating an empty struct, and then we can update one by one. So these are the three methods we have. Now let's come down. Let's check the Solidity automatically create a getter for to do, and to get that you don't need to create a function. So let's create a function. We'll call it get. In that we're going to pass the index, public, view, return, and we want to return the and boolean. So this is the data we want to return from this function, and we'll call it to do storage to do, and in that we're going to pass the index. Pretty simple thing. And then we're going to simply call this return, and we'll pass this data. So in this way we can easily able to access the data into our array, because all the data we have in that array, and we have to pass the index of that. so that will give us the data back. So that's pretty simple. Let's create a, if you want to update that to do, so we can do that. Let's create that function for it. So we'll create a function, we'll call it update text, and that we have to pass the index and the call data public, and we have to simply change the state. So storage to do index, this will give us the particular to do list which I want to update, and in that we're going to simply update the text we want to do it. So that's pretty simple. Hope this makes sense. Now let's come here, let's update completed. So when you will click yes, it will become true. When you click again on that, it will become false. That's the simple logic. So let's call it complete toggle, and we're going to pass this unt index public, and we have to simply change the status. So we'll create a empty array, we'll take that array, that particular struct, and we're going to simply update that to not this. And that's a pretty simple function. So if you call this function on a to do, it will turn it to false if it's true, and if it's false, it will turn it to true. So that's the simple thing it will do forth and back. So hope this makes sense to all of you. This is the entire smart contract we have written on the struct, and now we're going to test this out. Okay, here we have the entire smart contract we have written to understand the struct. You can see we have all the create function, and we have the get, update, and toggle. Now simply deploy the functions. I deploy the contract. I will click on this deploy, and here we have the deploy contract and all the functions. So right now you can see we have this 5 functions, and you can see right now we don't have anything into our array. So if you come here, this is the array we have created. Okay, this one is a, yeah, if I pass 0 index, I won't get anything. I won't get anything because we don't have anything into that. So we have to call this function create. So in that, what we have to do is, let's come here and let's come here. This is the function we are calling. Open this one, and in that we have to simply pass the string. So the data I want to pass is hey, not day, and click on this transaction. If we do call that, the transaction went successful, and now if I call this to do, here you can see I got this hey text, and by default it's false because that's the default behavior of Boolean in Solidity smart contract. It will be false. Now if I want to create one more, I can type something like buddy buddy, and I can click on create, and the transaction went successful. If I want to access that data, I can simply call this one, and this will give me the data. Here you can see we are doing this. So we have used all the 3 methods to create the struct. That's why we are getting this problem. So to fix this, all I can do is simple way. That's pretty simple. Simply comment this. And because we're going to use any one method, not we're going to use all the method to create the same data. So we have uncommented this, delete this one, and now we have to deploy the contract one more time. Here the contract is got deployed, and now we have this method. So we have, first thing we have to create, I call DAULAT download, and I will click on this create. We have created, if we take the 0 index, I will get that, we'll get the data hey text is $, and if I want to go into this, if I pass the index to 0, I'll get this $. But if I want to create one more, I'll say SHOAIB Schwab, and I will click enter. The transaction went successful, and if I call this one, I'll get this Schwab. You can see this time is working. Earlier it was not working because we were using 2 methods to update the same data. That's what's the problem. And if you do the same thing here in the array, it will work in the exact way. We got the swap by. Now what if I want to update this? So here we have this get function. This is the one which is returning the data. So now let's update that. So to update that, we have to pass the index and we have to call the data. So here we have this update text, and what I want to update, so let's expand this one, and here I'm going to pass this buddy buddy, and here I'm going to call it, so buddy is on the index 0. So let's take index 0 and click on this transaction. It's been successful. If I come here and if I call this to do, here I got $. Okay, nothing happened. So let's see what's the problem we are having here. Okay, my bad. It's a 0, and here I have to pass this buddy, buddy buddy. If I click on the transaction went successful. If I click on this to do, I'll get the data buddy. So this one is also working fine. Now let's check this toggle. So for that, I have to provide the index. So let's come here. This is the function we have. Let's close this one. This is the function we have. If I pass this 0, I'll get this data. So right now, if I open the logs, you can see this is the 0 index we have provided, and we have done it. So right now, if I call this 0 index, it will become true, because here we are saying if it's false, then turn it to true. And if I call it one more time, this will become false. You can see it's false. So this also working fine. the to-do list component. So hope this makes sense to all of you guys. Have understood that how you can create struct and how you can update into an array, how you can use this three different method to update the struct. This is the data from you can use to get, this is the function which you can use to get the data from the struct, and this is for updating and this is for changing the state. So hope this makes sense. If you have still any confusion, do let me know in the comment. I would love to help you in that. And let's move to the next video. In that I want to show you one more thing about the so as we have discussed about the enum, that you can create a separate file, separate Solidity file, and that you can define all the enums which you want to use in the smart contract into a different file. That's also possible with the struct. So let me show you the example that how you can create a struct into different file and how you can import into a different contract. So let me provide the general configurations, license identifier, Solidity version, and we're going to create the file which we want to. So here I'm giving this command. In this file, I'm going to create the entire struct which I want to import into different file. So let's come here. Let me create the struct to do. And this is the general convention you have to follow. In that, we don't need to define any contract name because we want to define only the struct which I want to use, which we want to use. And that we have to define the string, text, and we have to define the boolean. This is the struct we have. And now just imagine that I want to use this struct into different contract. So this is how you can do it. Very easy. We have to define the, let's say, import. We have to define the file which we want to use it. And here we're going to create a contract, and in that we're going to simply inherit. So an array of to do struct. We have to create the array because right now in the struct we haven't defined that array. And that is very important that you have to define whenever you define the struct in the contract, because all the struct you're going to create, that's going to be stored into the array. So this is how we have defined the array, and we're going to simply close that. In this way we will have the access of the struct we have defined into this contract, to this contract, and that's pretty simple. So hope this makes sense to all of you guys, that this is how you can create a struct into a different file and how you can import it and how you can use it in your smart contract. And that's the only thing I want to cover in this video, because this is a very simple thing, and I wanted to show you that there is a way you can create a separate file for the struct and you can use it into the smart contract. With that, let's move to the next video. Let's try to understand the data location into the Solidity smart contract. So we have three different type of data location. One is storage, other one is memory, and the third one we have is the call data. So when it's come to the storage, the data we're going to define in the storage, that data is going to be stored on the blockchain. The data you will define in the memory, that data will exist in the functions, and the data you will define as a call data, that data is going to be an argument. So let's follow the general convention. We have to define the Pragma Solidity version. Let's create a contract and we're going to call it data location. In that we're going to define our array. It's going to be a UNT type public array, and we're going to define a mapping address, and we can simply define a struct. In that struct we're going to take a UNT is going to be a foo, sorry, and here we're going to define another mapping which will take our struct, and then we have to define the struct. So that's the pretty simple thing. Hope this makes sense to all of you guys. Now here we can come and create a function we'll call f, and in that we're going to call another function which we're going to call internally. So let's create this function. So we're going to call it, so let's do something with the state variable first, and this data, the state variable we're going to define, this data is going to be stored on the blockchain. So this is the function we're going to create, -f, and in that we have to pass the array and the mapping and the struct, the first struct. Hope this makes sense to all of you. Nothing complicated, very simple. And here we have to do something. So get the struct from a mapping. So to get that, all we have to do is to call the struct, and we're going to call it storage because we are creating a memory. We are creating a copy of the data we have defined as a state variable, and that's how we can do it. We'll call it my struct, and we have to access the struct 1 because we want to access the first element. We're going to simply create a struct in a memory. So we are getting a copy and then we are creating into a memory. So let's come here. We're going to call map. So now we are declaring the struct in the memory. So we have to use the memory keyword, and here we're going to call our struct my struct, and we have to say my struct 0, first one. We'll close that one. Let's come here. Let's create another function which is going to run internally, and in that we have to pass all the variables, array, mapping, and my struct 1. If we come here, we're going to define the UNT storage array. We have to define the mappings, address, storage, and this one is going to be the storage, my storage. It's going to be simple internal function, and here you can type whatever you want to do. Hope this makes sense to all of you guys, that these are the variable we're going to pass into this internal function and our f function will execute. So we'll check. Let's write the other function. We'll create a you can return memory variables. So that's how we can do it very easily. Let's come and create a function. We'll call it g, and then we're going to pass this argument, entire array, memory array, because this is what we want to return. We have to reuse this return, and here we want to return the entire array we have defined. And that's why we are giving this uint type and the memory, because we want to return the data in the memory and we want to do something with the data. We don't want to store on the blockchain, but we want to use that data to perform certain tasks into the smart contract. And that's a very common practice when you will work in the real smart contract. You'll create a copy of the entire storage data and you can perform certain function and you can simply execute it. So that looks fine to me. Let's come here. We can do something with memory array. So that's pretty simple. Now let's talk about the call data. So let's create a function which h, and then we're going to pass this call data array, and we're going to say external, and in that we want to do something. So do something with call data array, and that's pretty much. So this is how you can define the data, the call data, memory, and storage. Storage is very important because when you will write the smart contract, you have to be very precise that what data you want to store on the blockchain, because every single data is worth almost ether. So you have to be very calculated that how much ether you are paying for deploying the contract. So you can learn about the memory, that you can create copy and you can do performance certain tasks using that array. You can do the same thing with the call data, but storage is an important concept. Right now, if it sounds confusing, don't need to worry about it, because when we write the smart contract, when we build the applications like NFT marketplace, which we have already built, you can refer to that project and you can see that how we have defined the memory data for performing and calculating the who are the user had created the NFT. So those kind of logic we have built into the smart contract. So this is the contract for the data location. You can see we have all the variables. So this is the first function, f function, and that we are calling this foo, passing this data. Then we have the other function. This one will run for the call. This one is for the memory, and this one we have for the storage variable. So if you come and if you deploy the contract and if you check, you will have all this access. If you do anything like this, it's when successful. But you can't return any data right now because we have not built any logic. We have built that you can do something with the data. You can do something with the data. So this is how it's worked. That's the only thing you have to keep in mind about the data location in the Solidity smart contract. This is not that important, but when you will write the smart contract, the storage is very important. That when you have to storage, when you have to use the memory. The only thing you have to remember that storage will store the data on the blockchain, and you create a memory because when you want to take the data into the function, not storing on the blockchain, but you want to use it internally in the function to perform certain calculation. That's the only thing you have to keep in mind. Hope this makes sense. If you have still any confusion, and down to leave in the comment section. I'll try to help you in that. With that, let's move to the next video. Function in any programming language is the heart. If you want to do anything in the programming language, in the smart contract, you have to create function to build the logic. And that's what we're going to learn in this video. Function in Solidity smart contract. There are several ways to declare the output. If you want to declare an output, get an output, for that you have to create a functions. So let's follow the general convention. We have to define the Solidity version, and now we have to create a contract. We'll call it function. In that, we're going to create function can return multiple value. Okay, so this function going to return the multiple value for us. So we'll create a function. It will say return many, and in that we have to define, so public, pure, and this will say return, and in that we have to define all the value which we want to return. So uint, we want to define boolean, we can take uint, and we can come here, we can simply call return and we'll pass the value. The only catch here is that you have to specifically tell that what data type you want to have as an output. So here you can see we have taken in a uint, so we are returning 1. If we are returning boolean, so we have defined boolean. We are returning uint, so we are defining uint as a 2. So that's a very important thing which you have to keep in mind. So this is the very first function. Now let's build another one. We'll call it return values by name. You have that option as well. So earlier what we have done, we have returned the value without a name, but you can do with the name as well. So we're going to create a function, we'll call it name, and that we have to do the same thing, public, pure, and it will become returned. And that we have to define the value type and the data type. So uint is going to be x, boolean is going to be b, and uint is going to be y. So this is the name type, I have defined that X is a UNT, B is a Boolean, Y is a UNT. So this is the data type of the value which we want to return from this function. So we're going to simply call it return, and we have to pass the data. So this is the name type which will allow you to return the data. Now let's create another function. We'll call it return values can be assigned to their name. Okay, let's, in the case the return statement can be omitted, so let's create a function for that. We'll call it public pure return, and we want to return this. So we'll say UNTX, we'll call it boolean B and UNTY, and we want to simply return that. So here we can come, we'll call it X is equal to 1, because we haven't defined any variable to the X. So you can also define the variables and then you can return. And because we have already taken this name, so we have this name, so we don't need to define data type here, because here we have already declared that it's a UNT type, and we can simply update the data here before we return from this function. So let's update that. Same thing we have to do for the B, it's true, and Y is going to be 2. And this is the one way to update, and simply destructuring assignment. So hope that makes sense. Now let's destructure the data. So this is how you can do it very easy. So we can create a function that can return multiple values. So we'll say function, and we'll call it destruction assignment. Here we're going to call this public pure, we'll have this return. Inside that we have to define the data type, so UNT boolean, and this is gonna be a UNT, because these are the data type we want to return. And the last one is going to be, let's say, a UNT. We'll make it, let's say, UNT, and we'll make it this. And here we want to deconstruct that. So this is how you can do it. And these all data we have into that. So we'll have this UNTI, boolean B, UNTJ, and we want to get it from here, return many. This is the function we have created on the top, and that we are returning these data, and that's what we are deconstructing here. So deconstruction is also possible. You can create a function, you are getting an output from there, you can deconstruct it into a different function, and you can access that data as well. So that's the exact thing we are doing here, because this is a very simple logic which you will find in most of the JavaScript programs. So it's just a simple JavaScript. Let's go ahead, and we have our deconstruction. Let's come down. We're going to simply value can be left out. So this is how you can do X, Y, and that you can simply update 4, 5, 6. That looks fine to me. Now you can simply return A, I, B, J, X, and Y. That's one way also. So these are the things we are returning in our in the above. So these are the return data type we have defined. Like we have taken I, B, and J, the 3 data type, and here we have defined the other 2, X and Y, and that's what we are returning. So hope this makes sense. Now let's come here. And here is one thing I want to highlight, that sometimes what happened that you cannot use map as a function input. So let me show you what I mean by that. So let's come here. Let's create a function. But you can take it as an array. So let's create a function. And that we're going to say array input. So it will be UNT type array and memory array. You cannot use mapping, but you can use array. Here we have taken a UNT type array, and that's what we're going to simply call it here. So this is the one way you can take data in the form of array to do and perform certain tasks. So this is one way to take the input, but you cannot use mapping. That's the important things you have to keep in mind. Take it array, and this is the one we want to have as an output. So we can say, and we can define the array we want to have as an output. Pretty simple. You can take data output as an array or as an individual, so you have both the option, but you cannot use it as a mapping. That looks fine to me. And let's come here, return the entire array, because that's what we want to return. Here we have taken a UNT type array, public array, and this is what I want to return. And here we have mentioned that we want to have the complete array. So that's the logic here. So make sure to keep these things in mind, that it can only work with array, not with mapping, because mapping is also work like an array. You can have multiple data into that mapping, but you cannot use that as an input as an or as an output. So that looks fine to me. Let's come down. We're going to, and now let's create a contract. And in this I want to teach you that how you can put data into a function with the value pair. So you can assign a key and you can assign a value. That is also possible. So let's come here. We're going to create a contract. We'll call it x and y z, and then we're going to create a function. We'll call some function with many input, and then we're going to define the input type. So UNTX, Y, we have the Z, and we're going to have this address A, boolean B, and we have this string memory C, and we'll have this public pure return, and we want to return this UNT. In that, what I'm going to do is I'll create another function. In this function, we'll call function, and it will be external pure return, and we're going to return a UNT, and in that we have to define a couple of things. So we're going to return this function, the function we have created above. So function with many, and in that we're going to define all the inputs, because this function need an input to execute. So we're going to define without key value pair. So in that we're going to assign the values, not the key, because you have both the option. You can assign the key value or you can assign the value as well, but make sure to follow the exact order we have defined in the function. Here we're going to define the address 0 and this. That's the one way. And now let's declare the function with the key value pair. So we'll come here, we'll create another function, we'll call it function with key value, and the same thing we have to do here. We're going to return a UNT, and this time we're going to call the same function, some input may input, and we're going to assign this value because this is the one we want to return. A, what is A? So we have to define its address. B, what is B? B is a boolean value, true. We can define the C and go so on and so forth. So that's pretty simple thing. You can assign the inputs as a key value pair or without a key value pair, and you can use a output of one function into another function to perform certain tasks. So that's the entire smart contract. Hope this makes sense. If you still any confusion, make sure to rewatch to understand what is happening. So this is the entire function smart contract. You can see all the functions we have declared. We all have here. Now let's simply deploy the contract and let's try to have a look. So deploy, here we have the contract, and here we have all the functions. So first thing we have to do is, here we have this array input. So where we have declared that array input, so the array input we have it's here. Here. This is the array we have, and here we have this array input. So you can declare that. You can call it to something like 1, and you can call this 0, because we don't have anything into this. That's why you can't find anything. The same thing goes from here as well. If you find something, if you put that, you will got nothing because we don't have into an array. Now if you call this array output, you can see this is what you will get. We don't have any data, that's why you get the empty array. If you call this assign, you will get this data because this is the data we are. So here we have this function called this assigned, and in that we are returning this 3 data. You can see this is the one we have updated, and that's what we are returning from these functions. So hope this makes sense. Now we have this decode structure. So if I call this function, you can see this is the data we are getting. So this is the data we had type we have defined. Here we are calling this function return many, this function, and from there we are returning these 3 data, and we are also updating x and y, and that's all the data we are getting here, 1 2 3 4 and 5 6. So hope this makes sense. Now we have this name. If you call this name, here we have this 3 data, and that's what we are assigning here. You can see this is the one we are returning from this function. So 1 true and the 2. If you call it return many, here you will get the same data, return many, and that's what you have here, return many, 1 2 3. So what we have learned in this video, that you can create one function and you can use this function output in different functions, like the way we have used here in custom assignment. That's the one way we can assign and return. You can simply take the data as a key value pair or without a key value pair. So this is the without key value pair, and this is the with key value pair. So A, B, C, that's all we have defined to have an output. So that looks pretty fine to me. Hope this makes sense to all of you guys. If you have still any confusion and doubt, do leave in the comment section. I'll try to help you in that. That's the only thing I want to cover in this video. Hope this makes sense to all of you guys. Still, if you have any confusion and doubt, do leave in the comment section. I'll try to help you in that, and I try to explain one more time. With that, let's move to the next video. So let's try to understand what is event in Solidity and how you can utilize it into a smart contract. And the some major use case we have is that, just imagine that you have an event and if you want to update any data into the blockchain. So you can use this event, and when you use this event to store data on the blockchain, and it's cost you very less as compared to using the actual storage So when you store data as a form of state variable, that will cost you higher amount, but when you use this event to store the data, it will cost you cheaper. So that's what we're going to learn in this, that how you can create event into the Solidity smart contract and how you can define. Let me provide the license identifier Solidity, and let's create a contract. We're going to call it event, and in that we're going to define. So when you define your event, you can pass only 3 indexing. You can have multiple data in the event, but the indexing is going to be only 3, not more than that, and it will allow you to filter the data. So what happens generally in the indexing form, that suppose you have data on the Ethereum blockchain and you want to index based on the address or based on the token ID, something like that. So you can have only 3, not more than that. So let's come here, let's declare an event. We'll call it log, and in that we want to provide the address. We'll call it index, sender, and the string message. So we want to have the data based on the index. So the address is going to be the index for that particular user to get this message. Let's create another empty event. So this is the blank event. We have this event, but we don't have anything into that event. So you can declare an empty event as well. So another logs. Let's come here, let's create a function to test this. So we'll call it public, and in that we have to declare the event. So we'll say emit log, and we have to pass the exact data. So we have to pass the person who's calling this function. So message.sender is going to be the address, and we have to pass our string hello world. So this is how we can update. And let's come here, we're going to say log message.sender hello world, and that's another way. Let's come down here, we're going to simply pass the empty event as well, and that's it. That's the only thing you have to keep in mind. So that's the event contract we have written. We have all the parameters and this function. So let's test this out. So if I come here, if I deploy this event contract, and here you can see we have this one. Here we are getting this only function because that's the function we have it here. Let's click on this, and here you can see we got this entire. But if I open this, entire log, here you can find that here we have this from, which we have called. This is the topic, and this is the event we have. You can see we have all the event. So this is the log we have defined. This is the data, the address, and the string, the address and the string, the define we have defined. So you can define multiple argument here. Here you can see we have these 2 events because we are passing different data in each of this event with the same sender, same person who's calling this function. So that's the entire data you can easily able to get. So this is the first event, this is the second event, and this is the third one, which is an empty, and you can easily able to get this data and fetch the data and display right in your front-end application. So it's a very important things which you have to keep in mind, and this will save a lot of money when you will use, instead of storage data, you can use this event to get the data from the blockchain. So that's the only thing you have to keep in mind. Hope this makes sense to all of you. If you have still any confusion, do leave in the comment section or rewatch the video to understand in a better way. So with that, let's move to the next. Solidity programming language, it supports multiple inheritance. So if you really want to inherit any other contract into your contract, then you have to use the is keyword, which is very important. And if you want to modify any functions, any outcome of that function, you have to use the virtual keyword. And if you want to do the change in the function itself of the parent function, then at that time you have to use the override keyword. I know it sounds abstract, but we're going to have a practical look at how exactly it's worked. Let me provide the general configuration, Solidity version, and now we're going to create a contract. So we'll say let's have a graph. So let's try to understand the entire interface with the help of a graph, that how exactly it's work, because order is very important when you want to inherit any contract into another contract. So order is very important, it's very strict. So let's come here, we'll take a. So this is the A contract, which is a parent contract, and this A will inherit by B and C. Okay, and that B contract is going to inherit by F, D. So now that's how the inheritance works. So you have to follow the proper hierarchy, the way you define the contract in the single contract. Okay, so if you have a contract and that you have a multiple contract, so that's how you can inherit. You have to give a proper reference, otherwise it will throw you an error. So let's come here, inheritance graph. We're going to create our contract. So let's create a first contract, we'll call it A, and in that we're going to create a function, we'll call it foo, public virtual, and it will say string memory, and in that we want to simply return this A. That's a simple function, simple contract which have this foo function, and when you call this function you will get an A. Now we can come down, and here we're going to create another contract, and this contract is going to inherit this A contract. So let me give this comment by using the keyword is. Let's create a contract. We're going to call it B, and we are using this is keyword to inherit our A contract. And this way we can easily able to have the access of the contract A, and the default output of this contract is going to be A, because you can see if you look at the contract A, in that we are returning A. So that's the default output of foo function. Here what we're going to do is we create another function. We'll call it foo public pure virtual override, and this is going to return the string. And here we're going to simply call the B, because here we are using the foo function from a contract A, and we have used the virtual and the override keyword to update the data. So right now if we call a normal foo, we'll get A, but here we are changing the data, so we are returning B from here, and that's how you can do it. So this is the B contract. Let's create another contract C, and we're going to inherit A, and the same thing we're going to do here. So we'll override A to return something else. So virtual override, we have to memory, and we have to simply return this C. So this C contract is going to return C. We are using that A function, foo function, and modifying it and getting our desired result. So this is how inheritance work. And now let's come here. So a few points to keep in mind: that a contract can inherit multiple parents contract. When a function is called, that's define multiple items. Okay, so the parent contract are search for that right to left, and that's how the manner exactly work. The order is very important if you want to inherit the contract. So let me show you the practical demo. So what I'm going to do, I'm going to create a contract. I want to create a contract by D, and I want to inherit, and that's the reason, because it's on the right hand side, the last one. We have the same two function in both the contract, but the C function is getting called because it is the most right side. And that's how the Solidity inheritance work when you want to inherit the functions. So if you are importing multiple contract, then that's how it's worked. The most right parent contract is going to be executed if they have the fourth function name. Okay, that's the things you have to keep in mind. So that's what we have here. Now we're going to create a function. We'll call it foo override VC, and we want to return this. So we are passing the same thing, override B and C, and we're going to simply return this super function in both the way. Now let's come here. Let's create one more contract E. We're going to do the opposite way, because this time we're going to export the output of the B contract, because B is the most right hand side, and the output is going to be this B. Since B is the right most parent contract with the function foo, and here we're going to simply have the same output. We have to pass the same, the way we have inherit the contract, the same we have to provide in the override section, B and C and B, and we want to simply return the data from here. So string memory, and we want to return the super function, and that's the only thing you have to keep in mind. Okay, so let's come here. We're going to create an inheritance must be order from most base like. Swapping the order of A and B will throw a compilation error. We're going to see that what is the error I'm talking about, but I want to give you this note so you guys can keep in your head that there are rules which you have to follow if you want to inherit the contracts. So let me show you. Let me write the code. Let me write a contract F, and we want to inherit A and B in this F contract. So the function we're going to create this foo override, and we want to override A and B return, and we want to return this memory. In that we're going to call this super, and we'll call it foo, and we want to simply return that. So that's the one we have, and that's the entire smart contract we have written. Here we have the entire smart contract for the inheritance. You can see we have A contract, we have B, C, D, E, and F, and we are inheriting one contract from one another. So that's a nested contract. So let's come here. Let's try to deploy. Let's delete me the old one, and here we have this multiple contracts. So if I come here, if I deploy this contract, and here you can see we got this one, and if I click on the foo, I'll get the A. Let's try to deploy the other contract. If I call this B, if I call the deployed, and I'll get the B. So let's close this one, and here I have the B contract. If I call this, I'll get this B. A and B, we have this two contract. But what I want to do is I want to simply inherit in the C as well. So let's come here, and this is the C contract. If I call deploy, and here we have the deployed, and if I come here, so here what I have mentioned that the default output of this A is A, but we are using this override property and creating a virtual, so this one override, to update this C. So if I call this function, I'll get a C. That's what I have mentioned here. We will get a C. Now here what we are doing is that here we are creating this D contract and we are inheriting this B and C. But as because of this C is the most right parent contract, so this function is going to be executed from here and we'll get this C as an output. So let's come here. So what is the name? D. If I come here, if I click on D, if I click on deploy, the contract is deployed, and if I call this foo function, I'll get output FC. So if I click on this C, and you can see this C, because this is the rule we have in the Solidity, because both B and C have the same function, but we are getting this C because this one is the rightmost parent contract. If we take this E contract example, if I deploy that as well, and if I simply deploy this E contract, call this one, I'll get a B, and that's what I have him, because this time the B is the most parent contract on the right hand side. But here if we have this F, and if I call this function, can you guess what will happen? So let's try to check this out. If I come here, if I go to this, if I call this F function deployed, sorry, and here we have the F deployed, and here we have the foo. If you call this time, you get a B. Hope this makes sense to all of you. You guys have understood that why everything's happening, how the inheritance work in multiple contracts. Order is very important, and make sure to rewatch this video if you have still any confusion to understand better that how exactly it's work. With that, let's move to the next video, and if you have still any confusion, end out, do leave in the comment section. I'll try to help you in that. Have a wonderful day. So shadowing is one of the concept in Solidity smart contract. It's allowing you to inherit state variable. So unlike functions, state variables cannot be override by redeclaring in the child contract. So let's see what exactly it is. Here we're going to create a contract A, and in that we're going to declare a state variables, and we're going to assign a value to that. So name is going to be, say, contract A. So this is our state variable, and now we're going to create a function. We'll call it get name, and we want to simply get this state variable. So we'll call it name. That's a pretty simple contract. All it does, it has a state variable, it has a function. So when you call this get name, it will return the state variable, and which is a contract A. That's a pretty simple function. Now here I want to highlight a couple of things. So in the earlier version of Solidity, it was not allowed to inherit the contract like this. This is not the way you have to go. So the exact way is to do like this. So let's come here. Here we're going to create another contract. We'll call it C, and this time we want to inherit contract A, and we're going to simply change the data, override that. So this is how we can do it. This is the correct way to override inherit state variable in the contract A. So what we can do, let's come here, we'll call it constructor, and that we have to pass the name, and we have to simply update that. And that's pretty much. Here we're going to simply get the return is to contract C, and that's pretty much. That's the way you have to simply update the state variable. So here we have the entire smart contract we have written for the getting the notion of the shadowing concept in Solidity. You can see this is the contract, first contract we have, and this is the C contract. Now let's deploy this one. This is the two contract we have. Let's deploy the first one, and if we deploy that, here we get this. If we call this name, we'll get A. If we call this, we'll get the A. Okay. Now the point is, let's come here, and now we have to deploy the contract C. If we deploy the contract C here, in this we have this two functions. So if we call this name, you can see we'll have an output as a C, but if you call this one, it will have an output as a C. So you can inherit the parent contract, and you can simply update the state variables. So here what we have done, here we have declared the state variable in the parent contract, but we haven't declared here in the child contract, the C contract, but we are inheriting this A. With the help of this constructor, we are updating that, and we are getting an output of a C. So that's how the exactly works. So if you want to override the property of a state variable in a parent contract and use a different property in a child contract, that's the way to go. So that's how you can change the state variable. So hope this makes sense to all of you, because this is going to play a huge role when you will work in the actual project, when you're going to communicate with a different contract, but want to have a different values. So that's the important things you have to keep in mind. If it sounds confusing, don't need to worry at all, because we're going to build a project, and on that we're going to explore each one of this. The reason why I'm explaining you this concept, shadowing concept, because you have to know this all things, because when I will use this, I will use it straight away. So on that time you guys not feel like that what I'm talking about. Okay, that's the only reason I'm covering all of these concepts which are there in Solidity. So hope this makes sense. If you are still in confusion, end out, do leave in the comment section. I'll try to help you in that. And with that, let's move to the next. You might have seen super keyword in Solidity smart contract, but what it does and why we use super keyword, what are the functionality we have, and what are the way we can initialize super keyword in the contract. Follow the general convention, provide the license identifier and Solidity version. And now let me create the hierarchy. So super keyword will allow you to inherit the parent contract. So this is how the entire interface tree looks like. So let me call this inheritance tree, and first we have the first contract A, and from this we will have this two contract B and C. So B and C will inherit the A contract, and then we're going to create another contract D, and that D going to inherit B and C and A. So it will inherit all the three contract. So let me show you by the code. So let's create a contract. Let's create a contract. So let's declare an event, and we're going to log that event into our console to see that what data we are getting. So let's declare an event, log. In that we're going to pass this data string, the message. Now let's come down. We're going to create a function. We'll call it foo, and it's going to be a public virtual. And in that we're going to simply emit that event, the event we have created. So in that we're going to pass this data a.foo called. So this is the data. This is the first function we have. Now let's create another function. This will call bar, and it's going to follow the same structure. And in that we're going to emit this event. So this will call it. And now we're going to close this contract. Now what we're going to do, we're going to create another contract by the name B, and this time we're going to inherit the A contract using the is keyword. So I hope you haven't forgot that why we have used is keyword, because we want to inherit the above contract. So let's provide the name of the contract, and now what I'm going to do is let's declare a function. We're going to call the same function name foo. Here we have the foo public virtual override, and here we come, and here we're going to initialize the event. So you have noticed one thing, that here in the B contract we haven't initialized the event because of A we are inheriting. That's why we have the access of the event from the A contract. So let's initialize that event, and in that we're going to call this b.foo call. And this event is coming from the contract A. So that's the things you have to keep in mind. That's pretty simple thing, and we go to call this a.foo. So this is the one way to declare and call the contract A function by the name itself. So you can call it A and you can call the function. So this is the one way to declare the functions. Now let's come here. Let's create another function. We're going to call it bar virtual override. Let's come here. We're going to call this emit log b.bar called. So we're going to call this super. And this time in this function what we have done is still we are calling the contract A, but instead of writing the A we have used the super keyword, and this super keyword will work in exact the same way. Let's close that. So this is the first contract B. It's inheriting the property of A, and we have used the foo function. In that we are calling the contract by the A, by the name, and then we are using the super function, super keyword in the bar function. That's clear. Now let's create another contract. It will call C, and in that we're going to inherit the A property. Pretty simple. We have to do the same thing. Let's create a function virtual override. In that we're going to call this event. Now we have the event. Let's call this function. Same logic we are following, because C is also inheriting the A. And the reason why I'm giving you this multiple example, because you have to understand everything, that no matter what is the hierarchy, what is the tree, it's all important that how you are inheriting the contracts and what is the hierarchy of the contract. So that's what we have here. You can simply inherit that, and you can simply call the other function bar, and you can use this same super keyword. You can log that event and you can call the super bar, and that's pretty much. So that's our C contract. Now let's come here. We're going to create another contract D, and in that we're going to inherit B and C. And in this scenario, D will have the access of all three contracts, B, C, and A. Because B and C is also inheriting A. So in that way, D will have the access of A contract. So let's come here. We're going to create a function called foo virtual. In that we're going to pass this, because we want to override the B and C contract. In that we're going to pass that, and here we're going to call the super.foo. And can you guess from where we are getting the super keyword? I believe that you got it. Super keyword. Let's create another function override. In that we're going to say B and C, and we're going to simply call the super bar. Let's close that one. So that's the pretty much of the contract we have created here. And here you can see I have given this logs. So right now you can see that it seems like complicated thing for all of you guys, but don't need to worry. What we're going to do is when we're going to call each of this function, we have to check the logs that what exactly happening. So here you can see when you will call the this contract, it will inherit the A, B and C. As I told you that it will inherit all the three contract, and it will first call the C and then it will call the A. So that's how it will going to follow, which is not that important. Don't need to worry about it. Now what we can do is, now let's check this entire contract in the remix ID. So this is the contract we have written. This is the A contract, this is the B contract, this is the C contract, and this is the D contract. So let's deploy that. If we click here, we have these 4 different contracts. So let's deploy one by one. First we're going to deploy the A contract. Click on this deploy, and here we have the logs. If you come here, if you click on this A contract, so here we have the A contract. In this we have these 2 functions, foo and bar. So let's click on the bar and let's try to have a look at what data we get in the console. So the transaction went successful. If we come here, click on this, and here you can see this is the log we have. So this is the data we have passed in the foo function. So we have called the bar. Okay, we have called the bar. So in that we have this bar called. You can see this logs we got. If we call this bar, here you got it. You can see this is the another data we got here. So this is how you can access the data from the blockchain with the help of the event. So this is the first contract. Now what I'm going to do is let's deploy the other contract. Click on this, come to the contract B, and in this you will notice one thing, that the contract B is inheriting the property of contract A, just like this event. Okay, so here we have to deploy the contract, and here we got the contract. And if we come here, let's open the logs to see what data we get. If we click on the bar contract, so here you can see we are getting bar dot called. If we open that, here we have the data. So here we have 2 events. This is the bar dot call, this one, and then we have used this super keyword, and we are getting from here. So a dot bar, we have used this super keyword so we can easily able to access this contract A, because here we have specified that we are using the contract A in the contract B. So that's also working fine. Let's come here, let's deploy the contract C, and in the C contract you can see A is inheriting the C, so it will going to behave in the same way the B contract. Let's say check this D contract. So before we do that, okay, let's check the C first, because the D is dependent on A and C. So if we come here, this is the C contract, and if we click on this bar, here the transaction went successful. You can be able to find the logs. If you call the foo, the transaction went successful. Now let's come here, let's deploy this D contract. If we deploy that, the transaction went successful, and here we is the catch. So here we have given the couple of descriptions. So let's do one thing, let's call this foo contract first. If we call the foo contract, and let's try to look what data we get in the. So here you can see, as it mentioned that it's going to call the contract C, and that's what happened here, B dot bar, and then it will have the B dot bar. So first it called the C, because it will start always from the topmost left hand side. First it will have with C, then it will go with B, and that's what we have here, B, and then we have the C. It's called all the contract. If you call the foo contract, it will have the same behavior. So when you want to inherit any other contract, you can use the super keyword, or you can use a direct name. And when you use the super keyword, it's going to take the first contract in the smart contract. Hope you have learned something new in this video. If you're still in confusion and doubt, do leave in the comment section. I'll try to help you with that. Have a wonderful day. Let's learn about visibility in Solidity. What is visibility and where we can use it, and how we can utilize inside the contract, and when we want to inherit any other contract, then how we can define the visibility. And that's going to be the topic of this video. There are 4 types of visibility. Number 1 is public. So any other contract and any other account can call that function or that variable. The second one we have is the private, as the name suggests that it can be only used privately. The third one we have is internal. So it can only work internally, and it can inherit the functions. The last one we have is external. So any external accounts or any external contract can call that function or variables. Let's do the general configurations. Solidity, And now we have to create a contract, so we'll call it base. Inside that, so here I'm giving this comment so you guys can keep in mind that what is private functions are doing. So let's try to see the function. So let's create a function and we're going to call it private function. We're going to call it private because this is how you have to define that what type of function you're going to create. It's a private, or it's a public, or it's external, or it's internal. So this is the place where you have to define the function visibility. It's going to be a pure, it will be return, and it will be returning this memory. So we want to return this string. Inside that, we're going to simply return this string, so private function called. So this is the very first function we have. Now let's create another function, and in this function we're going to test the function we have created, and we're going to call that function. So let's call it public pure return, and we want to simply return this string, and in that we're going to simply call the function, so the function we have created. That's the simple logic. Again, if it sounds complicated, we're going to test this code and I'm going to show you that why it's happening in this way. Now let's talk about the internal function. So here is the command to keep you and remind you that what we are doing here. Let's create a function. We'll call it internal function, internal pure internal pure return, and it's going to return the string memory. In that, we're going to simply call this internal function called. So this is the simple internal function we have created. Now let's come down, let's create another function, and we're going to call it test internal function. It's going to be a public pure virtual returns, and it's going to return this string we have defined. We're going to call the function. It's going to work. Now let's come here. Now let's create the function. We're going to call it public function, public pure return. It's going to return the memory, and that we're going to simply return this string public function called. So this is the public function. Let's come here. Let's create a function. We call it external function. External is going to be pure return. It's going to return the string. So in that, we're going to simply return this external function called. That's the simple function we have written. We have provided all the visibility, external, internal, private, or internal. Everything is looking fine to me. Now let's come here. We're going to, and this is the one note you have to keep in mind. So when you want to call an external function using a public, in that way it's not going to be compiled, it's going to throw an error. So this is the exception it has. It will always throw an error. We're going to declare a couple of state variables, and we can try to access those data. I believe that you guys have already seen that how we are accessing those state variable by assigning a public keyword. And let's come here. We're going to create a string private variable. So it's going to be private, not public. We have to take another variable. It's going to be internal variable. It's going to be another string. It will be say public, and we're going to say public variable. Let's take the state variables. Cannot be extreme. So this is the exception we have, that you can use it private, you can use it internal, you can use it public, but you cannot use as external when you have to define the state variable. So that's the exception we have here. So let's create another contract, and we're going to call it child is base. So we are trying to access the parent contract, which is a base contract, and the contract we are creating is a child. So nothing new to all of you. Let me give this command. You cannot access private variables or state variables. So let's create a function. We're going to call it, let's say, test internal function, public pure override, and we're going to return this string, and that we're going to simply return this internal function which we have declared in that parent contract. And let's close this one, and let's come here. So that looks pretty fine to me. So this is the entire contract we have written for both this base contract and the child contract. And now we're going to test this out, that which function we can easily able to access. So few things you have to keep in mind, that private function, private variables are not accessible in the child contract. So let's test this out. So this is our entire Solidity smart contract we have written. Inside the base contract, we have all these functions we have created. So private, public, internal, public, and this we have public, external, and we have a couple of state variable with different visibility. And this is the child contract, in that we are trying to inherit the parent contract. So let's try to deploy it. If we come here, here you can see we have these two contracts. So first we have to deploy the first one. If we click on this deploy, if we come here, you can see we have all these functions. And if you notice one thing here, that the first function we have is this private. So this one is not displaying, this one is external, this one is public, this one is also a public, and this one is testimonial, and this one is a test private. So okay, so this function is not here because we have assigned the visibility to private, so we cannot have that. This is the private we have and the visibility is the public. So let's test this one out. So test this one out. So this is the contract we have. Let's click on this, and that's the return we can get. You can see this is the return we can get from here. Now we have this public function. So this is the public function we have. If we call that one, this is the exact information we are getting here. Now we have public variable. So this is the variables we have defined. Now this private one, this is what it is. It's a public. So this is the variables. If we click on that, we can get it. But those function declared as a private, you cannot have the access or you cannot get the getter functions. So I hope this thing got clear. Now let's come here. Let me close this one and let's try to deploy the contract child, because this contract inherit the property of the base contract. So let's deploy that one. Our transaction when successful, if we open that, and these are the function we are getting. So if we look at the child contract, and that we have these functions, but here we have a lot of functions because we are inheriting the base contract, and because of that we have access to this data. So this is the contract we have, test internal. So test internal, this is the function. If we call it, you can see you can easily able to get the information, and this function we have here, internal function, and this is coming from here, internal function where it is, and this is the function, and from here we are getting the message. So hope this makes sense to all of you. You guys can understand that how everything's work, how the inheritance work, and how you can easily able to access different data in different contract and assign different visibility. So hope this visibility concept got clear to all of you. If you have still any doubt, in any confusion, do leave in the comment section. I'll try to help you in that. With the time being, so hope everything is got clear to all of you guys. If you have still in doubt, any confusion, do leave in the comment section. I'll try to help you in that. With that, let's move for the next video. There was a debate among the students that interface is a contract or it's just a library. In this video, we're going to learn about interface, that what it is and how you can create and how you can inherit that interface into your smart contract. So there are a couple of facts which you have to know about the interface. Interface cannot have any function implementation. So I will explain what is function implementations. Interface inherit from other interface. So you have one interface, you can inherit the property of other interface into that interface. All declare function must be external, cannot declare a constructor, cannot declare state variable. So these are the couple of property of interface when you want to create. So let's have a practical look. So let's provide the general configuration. We have to provide the Solidity version. Now we have to create a contract, and we're going to call the contract to counter. And in that we're going to define our couple of variables. So it's going to be unt public, and we're going to call count. Let's come down here. We're going to create a function we'll call increment, and it's going to be external. And that we're going to simply call count plus 1. So we want to increment our state variable by 1 every time someone will call the function. It's pretty simple function. Now let's come here. This is the first contract we have, and now we're going to create an interface, because this is what the topic is about, interface. So we have to, if you want to declare interface, you have to use the keyword interface, and we have to give the name. So you can give whatever name you want to your interface, and in that we have to define all the functions. So let's come here. Here we're going to call this function count, and it's going to be external, view, and return. So there are a couple of property of the function which you define in the interface which you have to follow. So first it will take the normal function keyword, then you have to define the name of the function, and it's always going to be an external type. No private, no public, no internal. It's going to be an external type. You can use view and you can use pure. It's totally up to you, and you can return the data from the function or you can't. It's totally your choice, but it will always follow the external. And you cannot declare any variable, you cannot declare any constructor into your interface. So let's declare here. That's the few things you have to keep in mind. Now let's come here, let's create another function. We'll call it increment external, and that's how you can define the interface. Let's create another contract. We'll call it my contract, and that we're going to create another function, and we're going to call this increment functions, and in that we're going to simply take this data address external, and we're going to call the increment interface we have created. In that we're going to pass that count increment. So can you please explain me what is happening here? Write down in the comment sections and just tell me what is happening here. So here what we are doing is we are creating a contract, in that we are creating a function. Inside the function we are taking an address, and that data we are taking, we are passing into our interface, and this is how we got that interface into our my contract, I contract. We are passing the data and we are calling the increment function. So whenever someone will call this function, it will store the data and it will increment that number. That increment function is there. So that's the pretty simple function we have here. Now let's create another function. We'll call it get count, and in that we're going to pass this data. External view return is going to return the unt. We have to return our counter, and we're going to call this count function we have here. Now we're going to take the example of the Uniswap. So I believe that most of you are following the Uniswap decentralized exchange which we are working on. If you haven't followed that, make sure to watch, because that's going to be the huge thing. And I'm going to take the example from there to explain you that how exactly work. So let's come here, let's declare the interface. In that we're going to call this Uniswap v2 factory. So there is a contract is available in the Uniswap documentation, you can check it from there, and that's what I'm going to use it here. So let's come here, we're going to call this function get pairs. It will take the token address A, token address B, and external, and it's going to be view, and it's going to return me the address of the pairs. So this is the very first function. Let's create another interface. We'll call it Uniswap v3 pair. In that we're going to create this function get reserve, external, it will be view, and it will going to return the address, sorry, unt 112 reverse 0, unt 12 reverse 1, the two tokens, and it will have this unt which is a time block stamp, and that's the get reverse function. So I'm not coming up with this because these are there in the Uniswap smart contract, so you can simply refer back there. So that looks fine. Let's create a contract. We'll call it Uniswap example. In that we're going to take the address which is a private type. Factory is going to be this. So this is the address of the Uniswap v2. Again, I'm getting from the Uniswap contract. This is the first address. Let's take the another one which is a private DAI address. This is the DAI address on the mainnet. And let's take another one. This one is the WETH address on the mainnet. And let's come down here, we're going to take this function called get token reserve, external view returns unt, that's the two data we want to return from there. And in that we're going to simply call this add pairs, and we're going to call this Uniswap v2, and that we're going to pass the factory, and we're going to pass the pair, get pair. In that we have to pass the two token address. So let's pass that one. Here we have the two token. Let's call this unt reserve, and we have to pass all this data, and we're going to call this pair get reserve. Then we have to simply return these two, and that's it. I know most of you guys are confused at what I have done, what we have written, but it will make sense. Here we are trying to learn about the interface, that how exactly it works. So this is the entire contract we have built to learn about interface. So this is the first contract. In that we have this variable, we have this increment function. Then we have this interface. Inside the interface we have this to function. Now we have the second contract. In that we have this to function, and this is the interface for Uniswap v3 factory get pair. In that we are passing these two data. Here we have the second interface which is a Uniswap v3 pair. In that we are passing all this data, and this is the contract factory address, and this is the two token address, and this is the get token reserve. So right now I don't have this data, but I want to show you. So let's come here and let's deploy the contract, the first one. So let's deploy that one. If we click on this deploy, here we got it. If you come here, you can call this count. You can see you got this 0. If you call it increment, if you come here, you can see it's working, it's incrementing. So this contract is working fine. So this is how the interface exactly works. This is how you inherit the property. Right now it's not working because we are not providing the valid address, but it will make more sense when we write the smart contract. So make sure to watch the Uniswap smart contract we have written for the decentralized exchange, and that we have inherit this Uniswap smart contract addresses. So make sure to access there to watch that, to have a better understanding that what exactly is happening here. Rewatch the video and trying to understand that how we are inheriting property. The only thing you have to keep in mind that inheritance is not a smart contract, and if you want to inherit, you can define it and you can use it in the contract like this. This is how you can initialize and use it. Let's try to understand the payable keyword in Solidity smart contract. So when you declare payable keyword in any function, you can easily able to receive ether in the contract. Follow the general convention, and now we have to take this pragma Solidity version. Let's create a contract. We'll call it payable. Inside that, we're going to declare a couple of comments. So payable address can receive ether. That's true. We're going to define the address. We're going to make it payable so it can receive fund, and we're going to make it public so we can check what is the address. So here we have taken a variable which is address, payable, public, and honor. Simple variables. Let's come here. So when you declare payable in the constructor, it can also receive ether. And let's come here, declare constructor, will make it payable. And here we're going to define the honor. So honor, and who is the honor? Message.sender, the person who's deploying the contract. So he can receive some ether. So that's the simple constructor we have. Now we're going to create a function that to deposit ether into this contract. Let's create a function, deposit. It will be public payable because we want to pay. And this function will going to create function. We'll call it not payable public. So if you try to send fund with this function, it's going to throw an error because we haven't defined the payable keyword into this. So these are the two functions we have. Let's come here. We're going to give this command. And now we have to build the function for withdrawing the ether. Let's create a function. We'll call it withdraw public, and here we're going to say get the amount of ether stored in this contract. So we have to get it. For getting that, we have to take this unt amount and we have to say address this dot balance. So this will give us the balance of the contract, that what balance we have in the contract. Address this means the contract, or you might have seen address 0, that's also referred to the contract. Send all ether to honor. So we'll call it honor can receive ether since the address of the honor is payable, and that's what we have declared on the top. So let's call bool success. We have to take a boolean value and we have to say success, and that we have to call honor.call value, and we have to take the entire amount which the contract has, and we're going to call this method call. This will send the money back to the honor address. And here we're going to call this require. So we have to check whether the transaction went successful or not. So if boolean is false, then it's mean that the transaction went fail, and if it's true, then it's passed. So we'll fail to send ether, and that's it. Let's come here. Let's create a function to transfer ether from this contract to address from input. Function transfer, in that we're going to take this address payable, and we're going to take this to amount that where we want to transfer. So we have an address and we want to make that address as a payable so it can receive fund, and we are defining the fund, and we are making it public so anybody can call it functions. Simple function. And let's do the same thing. So the same thing we have to do, we have to pass the amount which we are getting, want to transfer, then we have to do the check that whether the transaction went successful or not. And that's the only thing we have to know about this payable keyword in Solidity, that how it's going to receive fund, how it's going to send fund, and how you can send the transaction, the contract balance to your own. So let's check this out. Let's test this out. So this is the entire payable contract we have written, in that we have all these functions and the honor. So this is the honor, this is the constructor, this is the deposit function, this is the not payable function, this is the withdraw function, and this is the transfer function. So what we can do is let's deploy the contract. This is the only contract we have deployed, and here we got the contract instance, and that we have all these functions. So the very first function we have this deploy, and this function will allow us to add ether into this contract. So right now you can see we have this 4. Okay, I don't know from where it came. So let's try to deposit that. Maybe I have predefined the value here, that's why it got added, because we have made our constructor payable. Okay, so this 4 ether came at the time of deployment. By mistake I have added the 4 and it's got deployed. So we have that. Now let's deposit by this function. So I want to add, let's say 5. If I call this transfer, the transfer went successful, and here we have this 9. If you call this payable function, so right now we don't have anything, let's call this 1, and if I call this not payable, it will throw an error because we haven't assigned payable keyword to this function, and that's why it cannot add fund into the contract. So that's also look fine. Now let's check this function, withdraw function. So in the withdraw function we want to take the entire amount. So right now we have this 9, and I'm the owner of the contract, so this address is the owner. So right now we have 87. So if we call this withdraw function, you can see the amount will become 0, and 0, and here you can see this amount got updated 96. So we can easily able to withdraw fund from this. If you want to transfer, you can do the same thing. All you have to do is to provide the amount and the address, and you can easily able to transfer. So that's how the payable concept work. You can easily able to add the fund at the time of at the time of contract deployment, which we have done. You can check the honor, you can do all the things. That's a pretty simple things in the Solidity smart contract. If you want to receive fund in the contract, or you want to make it payable to any function, so you can transfer the fund to anyone else, then you have to define the payable keyword, and that's the only thing you have to keep in mind. So with that, I'm ending this video. Hope you have found this video valuable. If you have still any confusion and doubt, do leave in the comment section. I'll try to help you in that. With that, let's move to the next video. So when you will send Ether in any contract or any wallet address, there are a couple of methods in Solidity which you can use to transfer the fund. And those three methods we have here in the Solidity. The first one we have is transfer, the second one we have is send, and the third one we have call. So let's see in practical each one of these, that how exactly it works. Let's follow the general convention. License identifier, we have the Pragma Solidity version. Let's declare the contract. We'll call it receive Ether. And here we have to build the hierarchy. So let me build that. And these are few points I have written which you have to keep in mind. Which function is called? So we have two functions in Solidity to receive the fund in the contracts. The first one we have is the fallback, and the second one we have is receive. When anybody will send Ether into the contract, if message.sender.data is empty, in that scenario it's going to call this receive function. But when it has some data, it's going to call this fallback function. So when anybody will send any transaction to the normal wallet, it's going to call this function, and that's how you can keep in mind. But when the transaction will have any data, it's going to call these functions, and that's the only thing you have to keep in mind. Now let's declare the function to receive Ether in the contract if the message.sender data is empty. So we'll call it to receive. It's going to be external type, so anybody can send the Ether into the contract, and it will become payable. So if you want to receive fund, you have to make it payable, otherwise it will not receive fund and it will throw an error. So this is the receive function we have. When we have the data, then we have to call this fallback function. Fallback external payable, so it can receive. We're going to create a function we'll call get balance public view return, and it's going to return the UNT, which is the amount in Ether. And here we're going to declare return the balance of the contract. Address.this balance. And let's come here, let's create another contract we'll call send Ether, and in that we're going to create a function we'll call send via transfer method. So as I told you, we have three methods. One, we have the transfer, then we have the send, then we have the call. So this is the transfer method. In that we're going to pass the address, and we have to make it payable, that address, so it can receive fund. In that we're going to pass the address where we want to send the amount, public, payable. And in that we're going to simply, so this method is not recommended to use in your smart contract to transfer the fund. We're going to create that to.transfer. We have to use the keyword transfer, which is inbuilt keyword in the Solidity smart contract. In that we have to simply pass the value, the amount we want to transfer, and that's the function we have. Let's create another function we'll call send via send. So now we're going to use the send method to send the fund into the contract. So we have to define the address payable to public payable. It will always return the boolean value whether the transaction got succeed or fail, and this function is no longer recommended to use to transfer the fund. Let's call this bool send, and then we have to call this to send method, and we have to simply pass the value. If it's when successful, then it will become true. If it's false, then we have to display this error message. Simple function we have here, how to send Ether via send method. Now let's create a third function which is a send via call. It will do the same thing. Add public payables. Now here we have to, so this is the recommended one by most of the advanced developer in the Solidity space. If you want to send the transfer, you have to use the call method. So let's call boolean. It will say send, and then we have to send the byte data memory. We have to call this to call, and we have to simply send the value, and we have to call this empty functions. Then we have to check whether the transaction went successfully or not, and that's it. And that's the thing you have to keep in mind. So this is the recommended method which you can use in your contract to send the transfer of Ether. And hope this makes sense to all of you. These are not that complicated, very simple function we have written, very simple smart contract. So this is the entire contract we have written for receive Ether, and this is the another contract we have for the send Ether. In that we have all these three methods: transfer, send and call, and here we have defined this receive and fallback, and this is for the getting the balance. Let's deploy the contract. This is the only contract we have. First we have to deploy this receive one so it can receive the fund, and here you can see right now we have 0 into this contract. If we call this balance, we'll get the exact amount. Now we have to deploy the other contract to send the ether into that. Let's deploy it. Here we have it succeed, and here we have all this method. So now what we're going to do is, first we're going to send the ether via transfer one, and that we have to pass the address. So we have to pass the address of the contract. We're going to paste it, and we want to specify the amount we want to transfer. So I want to transfer this amount. So let's say I want to send 10 ether, and now I can simply call the functions transaction, and here is the transaction went successful. If I close this one, and if I come to this transaction receive one, here you can see I have the balance 10. If I call this one, I'll get the entire, and this is in the terms of weight. You can see I have 10 ether, so it's working fine. So this function is working fine. Now we have to check the other function. So let me close this one. We have checked this one. Now we have to check this send method, and that I'm going to transfer the fund, let's say close to what amount I can send. I can send 2 ether, and I can call this 2, and the transaction went successfully. You can see this is in terms of weight. Now let's call this one. I'll want to send something like let's send this something. I want to say something, let's say 3, and let's do the transfer. It went successful. If you come back to the receive ether contract, and that you can able to find that this is the amount we have. First we sent 2, then we have sent 3. If we click on this, we'll get the entire amount in terms of weight. So hope this makes sense, that how you can easily able to send transaction into contract. You can do the same thing for the addresses. It will both work in the same way. When the data is empty, it's going to call this receive function, and when there is a data, the data is not empty, it's going to call this fallback. So these are the couple of things which you have to keep in mind. And with that, we are ending this video. Hope you guys have learned something new. If you still have any confusion and doubt, do leave in the comment section. I'll try to help you in that. With that, let's move to the next video. When you use fallback in the contract, and when someone will send the ether into the contract via transfer method or via send method, in that scenario, the minimum gas they have to pay is 2,300. And that's the only thing you have to keep in mind about the fallback. Now let's see in the example that how exactly it's going to work. Now let's follow the general conventions, and we have to provide the Solidity version. Let's create a contract, and we're going to call it fallback. Inside that, we're going to create an event, and we're going to provide a string fun, and we're going to provide a unt gas. This is our event we have now, and fallback function must be declared as external, and that's what we have done here. We have made it public external, so it can receive fund. In that, we're going to define a couple of things. So when you use the send and transfer method, in that scenario, this is the gas fee you pay. And inside the fallback function, we're going to call our event. So we're going to say fallback, and we have to pass the gas, and which we have is gas left. Just simply call this function. Let's create a receive external payable, and that we have to define that logs receive and the gas left, the function we have to call here. And we're going to simply come down. Now let's create a helper function. So we'll say function get balance public view return is going to return the unt, and we have to simply check the balance of the contract. Let's create another contract. We'll call send to fallback. In that, we're going to create a function we'll call say transfer to fallback. In that, we're going to transfer the address. Sorry, we have to provide the address to transfer the fund. Public payable, so it can receive. And then we have to call the transfer method. Now let's create another function. We'll call it fallback. In that, we're going to use this payable. And the same method we have to call boolean send. We have to call this call method, and then we have to simply true the transfer. So I believe this is nothing new to all of you guys. This is what we have followed in the send ether contract, and the same thing we are following here. So that's the entire smart contract we have written. Hope this makes sense to all of you. We have created 2 contracts, and in that we have built this logics. So now let's test this. now let's test this out. So this is the entire smart contract we have written for the fallback. This is the event we have. This is the fallback function. This is the receive function, and here we are checking the balance of the contract. This is the second contract we have. In that we have this 2 function, transfer ether and call ether. These are the 2 methods to transfer the ether. Now let's simply deploy the contract. This is the first contract we're going to deploy, the fallback. And here you can see this is what we have here. Right now we have this 0 balance. If you call this one, we have this 0 balance. Now what I can do is let's deploy the other contract. if we click on the deploy, here you can see we have the contract here. If you open that, we need to pass the address in which we want to transfer the funds. So I simply copy this address and simply paste here, and do the same thing from here as well. And here we have to define the amount which we want to transfer. So I want to go with 5 ether. So let's call this fallback. So this function first, transfer. If we call that one, the transfer went successful. And if we see the logs here, you can see this is the function we have called, and you can see this is the address we have provided, and this is the entire log. You can see this is the receive, and this is the ID, this is the function we have called, and this is the gas, and this is the gas. So this function provided by Solidity. So if you want to check that what is the gas you have paid, you can simply call this function and you can have a log, and that's what we can see it. Let's call the other function. The same thing happened to this. If you come here, click on this, you can see the address of the contract, and you can see the receive and the ID and the amount, the function you have called and the gas you have paid. So this looks pretty fine. This is nothing complicated. It's pretty simple. All we have done, created 2 contracts, and we are logging the data of each of this one. So hope this makes sense to all of you guys. If you still have any confusion, any doubt, do leave in the comment section. And if we come here in the fallback, if you can see here, we have this 5. If we call this get balance, you can see this is the amount we have transferred into the contract. So hope this makes sense to all of you. The only thing you have to keep in mind that you have to check that what amount you are paying as a gas fee. So this is something you knew you have learned. So with that, I'm ending this video. Hope you guys have found this video valuable. If you have still any confusion, any doubt, do leave in the comment section. I'll try to help you in that, and I try to explain in a better way. So with that, let's move to the next video. In the last video, we have learned the fallback keyword in Solidity and what it does when it's come to receiving the fund. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about the call keyword in Solidity, and this is the recommended way to implement when you are transferring fund from one account to other, or from one wallet to another smart contract. Let's follow the general convention. We have to provide the Solidity version. Let's create a contract. We'll call it receiver, and this is going to receive the fund. Inside that, we're going to declare an event. It will say receiver received, and that we have to pass the address of the caller, the worker who is calling this function. Then we have to assign the amount, and it's going to be the message. So 3 data we are passing: address, UNT, and this message. This is our event. Let's create a call of fallback function because we want to receive ether into this contract. Receiver, external payable, so we can receive the fund. In that, we're going to simply emit this event. So this is the event we have created. Now we have to initialize that. So message.sender, we have to pass the amount. Message.value, and that will have the amount, and we can simply pass the message. Fallback was called. So this is the fallback function we have. Now let's come here. Let's create a function we'll call foo. In that, we're going to pass the message. We have to pass the amount, and it's going to be a payable. It's going to return the UNT, and we're going to simply initialize the event. So we already have the event. Now we're going to call this value and the message. That looks fine. Now let's come here. Let's do certain calculation into that. And what we're going to do is we have to simply say x plus 1. So whatever amount, whatever ID it's providing, we're going to simply add on that 1. That's the simple things we are doing. Let's create another contract. In that contract, we're going to call it caller, because this is the contract is going to transfer the fund into that contract. In this, we're going to create an event. We'll call it respond. It will take Boolean success byte data. This is the 2 data it will take. So the one condition, we have the address and we want to call. So we'll create a function. We'll call it test call foo. And that we're going to pass this address, the address where we want to transfer, public payable, and in that we're going to simply, and as you all know that you have to pay gas fee whenever you do any transaction on Ethereum blockchain. And in this, you will also have the option to customize and define that what gas fees you want to pay. If it exists more than that, then you want the transaction get failed. So you have an option that as well. So let's define that. We'll call it Boolean. We'll take the Boolean value. It will be success. It will take the byte, memory, and data, and we'll call this, we have the address, and we're going to call this method call, and that we're going to pass the amount, message.value, and we can define our gas fee. So this is the gas fee, 5,000. We don't want to pay more than that for this transaction. That looks fine. Now let's come here. We're going to call abi.encoded with signature, and that we're going to simply pass this foo string UNT 556, and we're going to call this call foo and this. That's the simple things you have to do. And once we have that one, now we're going to call the event we have created. In that, we're going to simply pass the success and the data. That looks pretty fine to me. That's a simple function we have. So let's come here. We're going to create a function. Test call does not exist. In that, we're going to simply pass the address, payable, and we're going to do the same thing. We're going to take a boolean value. We'll take the byte data, memory data, and that we're going to call this function. And that we have to assign the ABI encoded with signature. We have to assign this data, and we're going to simply initialize the event. And that looks pretty fine. And I believe that you guys have understood that what exactly happening here in the call method. So this is the entire smart contract we have written. The first contract we have is the receiver. Inside that we have this event, we have this fallback, and we have this function. This is the second contract. We have this caller. In that we have this event, and we have these two functions, test call foo, and we have this test call not exist. Now let's deploy the contract and let's have a look. So first we're going to deploy this receiver. And if we come here, you can see right now we don't have anything into this. And if you want to check this function, you can pass the message and you can pass this. So I can pass, I'll say hey, and I can pass 1. If I do the transaction went successful. And if I open the logs, you can see the data which I have got. So this is the UNT I got 2, which I have returned. So it's working fine. These are the two data we have provided. Let's close this one. Let's deploy the other contract, and we're going to deploy that. This is the second contract we have. Inside that, right now we don't have anything into this. And in this contract, we have to pass this data. So we have to pass the data, the address. So simply grab this, and we're going to cause and paste here, and we're going to send that. The transaction went successful. You can see the transaction went successful, and everything looks fine. This is the custom gas fee we have paid, and right now we haven't transferred any funds. So if you come into this contract and still we have this 0, if you want to transfer the fund for that, you can simply come here, increase the fund, and now you can make the transaction. If you call this, it's working fine, and here you can see we have this balance here. It will work in the same way if you come here and paste the address of the contract here, and if you again transfer the fund, and you can call this transfer foo, the transaction went successful and the balance got up. So it's looking absolutely fine. So this is the recommended method which you have to use whenever you want to transfer the fund, this call. And that's the only thing I want to show you, that how you can build a complex model to get the data and transfer the funds into the contract or into the wallet. So hope this makes sense. If you still have any confusion, make sure to analyze the entire code we have written and what's happening. Try to understand what these functions are doing. If you still have any confusion, try to Google it out and try to find out what is happening here. These are very simple one. So with that, I'm ending this video. Hope you have found this video valuable. If you are still confusion and doubt, do leave in the comment section. With that, let's move to the next video. In Solidity, we have a keyword called delegated call. It's a low-level function, and that function is similar to a call which we use to transfer the fund from one account to other. When a contract A execute the delegated call to contract B, in that scenario, B contract will also execute. So with contract A, the storage of the message.sender and the message.value would be accessible. So let's try to have a look what it is and how we can utilize it into our smart contract. Let's provide the general configurations. We have to provide the Solidity version. Let me give this note. Deploy this contract first, and here we're going to create a contract. We'll call it contract B. The state variable will define in the contract B that would be similar to contract A. Only then we can easily able to call the delegated call. So let's define the variables. We'll take this UNT public num. We'll take the address public sender, and we'll take the UNT public value. So these are the three state variables we have, and here we're going to create a function. We'll call it set var. Inside that, we're going to take this UNT public payable, so we can easily able to send that. In that, we're going to take this data. We want to update our number. So this is the first function we have. Inside that, we're going to update the sender, which we have inside this message.sender. And the final one we have is the value. So this will send the amount and update into our state variable. So this is the contract B. Now let's create a contract A, and we have to follow the general convention, because the contract B state variable, whatever we have defined, that's the exact thing we're going to add into a contract A. So let's define the variable num, address, sender, and this is going to be unt value. So same state variable we have here. Now let's create a function we'll call set var address. In that we have to pass the contract we want to call the delegate. So that's going to be the contract address. Then we have to pass the unt, the number, and we have to be public payable. Inside that we're going to boolean success bytes memory data, and we have to simply call the contract. So delegate, and because here we want to refer to the contract B, and we are using this delegated method to execute our contract B. And in that we're going to simply pass this ABI dot encoded with signature, and in that we have to pass the function which we want to execute. So we have to pass this set vares, and we have to pass the amount, and the amount we are getting. Here we can come, and now that's pretty much. So this is the delegate method which we are using to transfer the funds. So hope this makes sense. The reason why I'm showing you this, because this is not that popular in the smart contract using this delegate call. Most of the smart contract you will find in that they use only call method, but I want to show you this keyword exists in the Solidity programming, and you can use this encoded with signature data to call the functions. So that looks pretty fine to me. And now let's test this out. This is the contract we have written to understand the delegated call. This is the B contract, and this is the A contract. So let's deploy that, and here you can see here we have the two contracts. So first let's call this B contract, and if we come here you can see here we have this function. So we have num. If we click on num, we have 0 sender, this is the 0 address, this is the value, and here we can easily able to call this function. So if I want to send any amount, I can simply call 5, and I can simply call this send. The transaction went successful. And if I come here, if I go into the logs, you can find all the data. This is the data we have provided. And now if you call this num, if you call this sender, if you call this value, everything is got updated. But this time we're going to use this contract A, and we're going to deploy this one. If we deploy that, you can see this is the contract, we got it. And from here you can easily able to call the function which we have in the B contract with the help of this delegated call method. If you call this one, you can see we have the same variables, but if we want to call that, we need the address of the contract B. We can simply open this one, and we can simply pass the address, and we can pass the number. So I can pass 6, and if I call this transaction, here you can see the transaction went successful, and you can call this one, you can see the updates, and we have called this function. So if we come here, if we'll open the logs, you can able to find the details. This is what we have provided, and everything's working fine. If you come in the B contract, if you call it, everything's looking fine. So that's how we can access the function of contract B with the help of this delegate method, and we can simply transfer. So the only thing you have to keep in mind that this is the delegate method which allow you to call the function on the base of the encoded with signature, and that's the only thing you have to remember. Pretty simple. Here we are using these functions, and that's what we are getting from here. And that's how you can call different contract with the help of this delegate method. So with that, I'm ending this video. Hope you have learned. If you still have any confusion, do leave in the comment section, and just try to play around with this code and see how the things are working. Okay, so let's move to the next video. When you want to call different contract, you have two ways to call. The first way we have is to call straight away by the name, and the second way we have to call by the low level calls. So let's have a look what I mean by that. Let's provide the general configuration, and we have to provide the Pragma Solidity version. In that, we're going to create a contract. We'll call it callie. So this is the contract we're going to call into a different contract. So let's define a variable. We'll say unt public x, and we have to take this unt public value. So these are the two state variables we have. Now let's create a function. We'll call it set x. In that, we're going to receive the x. It would be public return, and we want to return this unt. Inside that, we're going to take this x, and I'm going to update it to our state variable. That's pretty simple. And we're going to simply return the x, that what we are exactly the value of the x. So that's the simple function. Let's create another function. We'll call it set x and send ether. So we're going to take this UNTX, that what is the X we have, and we're going to make it public, and it will return the two data. It will return the X and it will return the amount. So let's do that. We'll say X is equal to this, the amount we are providing, and it's going to be the value is going to be the message.value. And now we have to simply return X and Y and close this function. So this is the very first contract. Now we're going to create a second contract. In that we're going to call these functions, and we want to understand the ways we can call different contract. So contract, in that we're going to call it callie. So because this is what it's going to call, we come here, we can create a function, we'll call it set X, and in that we're going to receive the address of the contract which we want to call. So I'm going to call it callie, and we're going to provide the address of that contract, and we have to provide the amount, UNTX. Call that UNTX is equal to, we have to call the function we have set X, and we have to pass that X value because that's need to be executed. So we'll get our X value. Now let's create a second function. We'll say function X from address. So in that we're going to pass the address, and we have to pass the X, and we'll make it public. And in that we're going to simply callie this. We'll take the variable callie, and we're going to simply call the contract address. Once we have that, we're going to call this set X, and we're going to pass the value of the X. What is the X we have, and we're going to call that function. Let's come here. We're going to create another function. We'll call it set X and send ether. So we need the address because we want to access the different functions to call into this contract. So we need the address of the contract, and we need the amount. So we'll make it public so we can transfer the ether. And here we're going to call this X, UNT, and the value, and it's coming from this. So message.sender value, and we have the X. So we are deconstructing that and getting in here. So that's the pretty thing. Pretty much you need to know about the calling different contract into another contract. So these are the two contracts we have written, and now we're going to test this out, that how we can call this contract into this contract and to access all the function which it declare. So let's come here, let's deploy the contract. So here you can see the first contract we have to deploy this callie, deploy that one, and here you can see we got deployed, and here you can able to find the value of X and Y, which is currently empty. Now we're going to call the function this set X. I will pass 5 and I will hit enter. The same thing I have to do with this set X and send ether. In that I'm going to simply open that one, and in that I'm going to simply pass, let's say, 5. If I hit the transaction, the logs, let's have a look at the logs. The transaction went successful. If I click on this, I'll 5, and if I call this, I'll get 0, because if I want to send the transaction, I need to make it select the amount we want to transfer and then click on the transfer. If I click the transfer, the transaction went successful. If I check the value, we have this 5 ether in terms of weight. So this one is working fine. Now let's close this contract, and now let's deploy the contract number caller, and let's deploy that one. The contract got deployed. Let's have a look in the console. So this is all the function we have which we declare in here, and now we can easily able to access. So to access the function of these contract, first thing we have to provide the address of the contract. So in that I'm going to provide the address of this contract, and now I can simply call it. So if I paste that one, and here I have to provide the amount, which is a X. If I call that, the transaction went successful. So that looks fine. If you want to do the same thing for the other one, here you have to do the same thing. If you want to send the ether, you can provide this address, you can send that 5, and you can select the amount which you want to transfer from here in terms of ether, and you can make a request. So if you make that, the transaction went successful. It looks fine. If you want to do the same thing for the address, you can do that. Simply pass that, and you can pass the amount, and you can simply do the transaction. So everything's working fine. No more error we have. If you open the logs, you can able to see all the data which you have provided. Okay, so that's how you can call the different contract into another contract. If you open that, if you call this one, you can see you will still have the same variable, because there is no changes you're going to make in the contract B, because you are trying to inherit that contract and you are getting the result in this contract, and you can execute the function the way you want, the data the way you want. So hope this makes sense. If you still have any confusion, try to analyze the code, that what is we had doing here, how we are accessing this contract. Just try to analyze this one. So hope this is making sense to all of you. Still have any confusion, any doubt, do leave in the comment section, and that's the only thing I want to cover. Let's move to the next video. One contract can create another contract, and that's what we're going to learn in this video, that how you can execute a contract and that will generate another contract. and what is the keyword to create a new contract, what was the old method, and in which version this new keyword is introduced. So that's all we're going to learn in this video. So let's provide the general configuration, license identifier, pragma, solidity versions. Let's create a contract. We're going to call it car, and in that we're going to define a couple of variables. So first one is going to be address, string, and we have this address public car add. So these are the three state variables we have here. And now let's create the constructor to update this data. So we'll create constructor, and that we have to pass the address of the owner. We have to pass the string, memory, and the model. So these are the two data we are passing. It's going to be a payable. And in that, what we have to do is we have to set that owner. We have to set the model. And then we have to simply add the address. And the address is going to be this address, which is a contract address. Our address is the contract address. And this is how you can initialize. If you want to know that what is the address of the contract which you are about to deploy, you can do in this way. You can simply add the address and you can provide this. This means the contract address itself. So this is our constructor. Now let's come down. Here we're going to create another contract we'll call car factory. And in that, we have to define an array. We'll say public car. Inside that, we're going to define a function create. In that, we're going to pass the address, owner, string, and model is going to be a public. Inside that, we're going to take the car. So right now we have an array. We're going to we have a contract. We're going to utilize this. We're going to call this car.owner. And in that, we're going to pass this model. So owner and the model, the data we are getting from the user. So that's what we are passing here. We'll create a car.push, and we're going to push the entire data into the array we have created. Let's come here. Let's create a function. We'll call it car and send ether. Function create and send ether. It will take the address of the owner. It will take the string, memory, model, and public payable because we want to send the fund. So we have to use the keyword public, otherwise it will throw an error. Let's come here. We're going to create a car array, and this time we are creating another contract using one contract. So that's why we have to use this new keyword, and this is the keyword is introduced in Solidity 0.8 version. So if you want to generate a new contract from one contract, you have to use this new keyword, and that we are assigning that car and we are sending the value because this is going to be our constructor, and this is the exact value we have assigned in our constructor. So we have to pass the data. We have to pass the owner and the model. So this is the data we are passing in the constructor. Now we have to simply push the data into our array. And that looks fine. Let's create another function. We'll call it create2. So this is one more method which allow you to create a contract. So let's check this one. And that we're going to simply pass the address of the owner. We have to pass the string, model, and we're going to say byte data 32 slot. And that we're going to make it public, and that we're going to simply say car dot, and we're going to use the same thing. New car, we have to provide the slots and owner and the model. So you have noticed one thing, that earlier we have used the value and that we are using the slot. Both exactly work in the same way. In that, we're going to call this car.push, and we're going to simply push the data into our array. Let's create another function. We're going to call this create2 and send ether. Inside that, we have to pass the function address. We have to pass the string, model. We have to pass the byte 32 slot. And we're going to make it public payable so it can transfer the ethers. Let's do the car, and we're going to follow the general configuration. We have to send the value, and we have to send the slot, owner, and model. Then we have to simply push the data. Let's create another function we'll call getCar, and we need to provide the index of the data we want to receive from that array, because we have taken a car array and that we have all the data which we have created using this different method. So we want to find the data for the particular car. So we're going to take this push public value view return, and we want to return the data. So we want to return the address of the owner, and we want to return we have to return the address car, and we want to return the balance, and we simply going to take the car. We'll take the entire array, and in that we're going to pass the index, because every car will have a index, and the data will get back to this. And here we're going to simply return the owner. We're going to call this car.owner, car.model, and car.address, and all these data. So in this way we can easily able to access all the data, because our car object will have the access of each of this data, because of we have used the public keyword. Remember, our state variable is a public keyword, so that's why we can easily able to call it. and this will give us the data, and that looks pretty good. That's the entire code for this testing, that how you can generate one contract from another contract. This is a car factory, this is the car contract, this is the car factory contract, and we have bunch of functions. So these are the two contracts we have written for creating one contract from another contract. So this is the first contract, which is a car contract. We have the state variable and we made it public, so that's why we can see here we can call that functions, so we can easily get the data. This is the first contract and this is the second contract. So let's try to deploy this and let's try to have a look. So what I'm going to do is, here we have this two car, and in that we have to define the constructor. So you can see these are the data we are passing in the constructor. So I want to set address. So I'm going to be the owner of the contract and I want to pass this string. So I'll say hey, and I will say the transaction went successful. The transaction went successful. If you simply come here, and if you see the things, you can click on the owner. So this is the owner. If you call the model, this is the hey model. And if you call this address, so this is the address of the contract. So this is our address. So if I copy and if I paste here, you will see the exact address. So this is the exact address which is got updated to our contract. So if whenever you want to know the contract address, this is how you can utilize it. So this is the first contract we have. Now what I can do, I can simply deploy the contract factory, and in that we don't need to pass anything. So simply click on this deploy, and here we have the deployed contract. If you open that one, in that you will have all these functions. So we have this create to, and send. This is the car. So right now if I pass the 0 index, I won't get anything. I don't get anything. You can see the transaction is reverted because we don't have anything into that. If I pass the again here get, it will not do anything because we don't have anything into that. Now let's click on the create method, and if I come here we need to pass the two data, address and the string. So this is the method we are using. We have to pass the owner and we have to pass the model name. So for the address purpose, I'm going to use the my address. So I will copy that one and I'm going to paste it, and I'm going to say buddy buddy. I can hit on the transaction and the transaction went successful, and if I call this one, I'll get that data. You can see this is the address which I have assigned, used to create the account. So we have that in our, if I click on this, you will get this exact data. You can get the entire data, and that's what we are returning. That's what we are returning because we have access of this state variables, and that's how we can simply call that. So we are getting the entire data, and that's the pretty simple things you have to know. You have to declare the state variable, you can call it here, and you can easily able to get the access of the data. Right now you can see here we have defined the data called byte 32. I don't want to convert, otherwise it will take me a lot of time to convert the data into 32 to byte and simply call this one. The only thing you have to keep in mind that there is a way to create another contract using this new keyword, and you will find this a lot in most of the contract when one contract is dependent on the other contract creation. So this is the things take into an account. This method is an old method, create to, which you will not find in most of the contract to creating a new contract. This method is a very new one. Right now it sounds very complicated. You can see a lot of things are going on, but these are not that important. The only thing you have to focus in this new keyword, that you can utilize it to access the contract which you want to create by the definite value, and that's the only thing you have to keep in mind. So with that, I'm ending this video. Hope this makes sense to all of you. If you still have any confusion, any doubt, do watch the video one more time, and if you still have any confusion, do leave in the comment section. I'll try to help you in that. With that said, let's move to the next video. In Solidity, we have try and catch block to catch an error into our smart contract. So let's try to understand how we can create try and catch in Solidity smart contract. Now we're going to use the external contract to use try and catch block. We'll come here, we'll create a contract called foo. Inside that, we're going to take an address and we're going to create a constructor. In that, we're going to pass the owner address, and here we're going to simply do the check. So we'll say require owner is not equal to the 0 address, means the owner is not should be the contract. It should be the normal wallet added, but it should not be the contract. And here we're going to display the address in message invalid address. That's the first check. Here we're going to pass this assert to compare, and that will say owner is not equal to this, means 0 address. This is not the address we want. This is the second check. Now let's do update the address. So whatever the address we are getting, we need to update it to the owner. That's the simple constructor we have written. Let's come here. We'll create a function called my function. In that, we're going to pass a variable called x. It's a uint type. We'll make it public, pure return, and it's going to return the string. Inside that, we're going to create a required statement, and we have to check that x not equal to 0. We want they should provide any number. It should not be equal to 0. Otherwise, we have to throw this error message. Here we're going to do the return. So we want to return that my function was called. That's the only function it does. What it does, it will take a number. If it's 0, then it will throw the error message. But if it's a valid number, then it will return this string. Let's close that one. Let's come here. Now we're going to create another contract. In that, we're going to test the try and catch block. So this is the simple contract we have written. We have this function, we have the constructor. Now let's create a contract. We'll call bar. Inside that, we're going to take an event. In that, we're going to pass this message. We're going to take another event. In that, we're going to pass this byte data. Now we're going to take the contract foo and we'll say foo. So in this way, we can easily to have the contract which we have defined above. And here we can come. Here we can create a constructor, empty constructor, and in that we're going to pass this. This foo contract is used for example of try and catch with the external call. Inside that, we're going to call the foo, and this is how we can use it. So we'll say new foo. And we have to pass the message.sender because that's what it needs. It's need the address, the person who is calling that. And we're going to make him an owner. So that's the constructor. We are updating our foo owner. We can come here. We'll take this example of try and catch with external calls. In that, we're going to try and catch external is equal to 0. And this is the check we're going to do. If it's going to be 0, then we have to simply fail that. And that's what we're going to log it. Here we're going to define try and catch. But if it's provide the valid number, the function we have in the foo, if they provide the valid number, then we want to simply log this text message. We can call the function, we can say try catch external call. In that, we're going to pass the uint public. Inside that, we're going to take this try foo. This is how we can define. To use the word try, it's similar to JavaScript. We have in try and catch, the same thing we have to do here. Try, then we have to call the contract. In that, we have the function called myfoo. In that, we have to pass the ID. And in that, we're going to return this string result. And here I have defined the variable name. So later I don't need to name it. I can simply pass it. So this is the variable name I have taken, string. And I'm going to initialize the log, the event. And here we're going to attach the catch block. If anything goes wrong, we have to simply get the error message. So internal call failed. Now we have to do a couple of check. First thing, we have to check that the contract creation should be not having this 0 addresses. If we have that one, then we have to display all these error messages. Now let's create the function, and that will say try catch new contract, and that we have to pass the address, and this address should be the valid one. It will say public, and in that we're going to take this try new. That's how we refer our contract, and that we have to pass the owner. That is we are getting, and we have to simply return foo the contract. And here we're going to emit the log. So foo created, and we have to simply catch the error. So this is how we can do it. We can define the error keyword we have in Solidity, and we can define the string, the error message we want to log. And simply come here, we have to simply, we have the error, and this error can be thrown by using this two method. We have revert and required. So let's come here, we're going to say this event, and then we're going to pass the reason, and simply come here, we have to pass the byte data memory and catch failing assert. And that we have to simply event this log error message, and that's looks pretty fine. So this is pretty huge contract. Hope this makes sense. Pretty simple. All we are doing, we are checking for the addresses and doing some transaction into other contract by following general conventions. This is the entire contract we have written. So this is the entire foo contract and bar contract we have written to test this try and catch. Deploy the contract. Here we have the two contract. We have to deploy the foo contract, and that we have to pass the address of the owner. So I'm going to be the owners of the contract. So simply pass the in the constructor and click on deploy, and the transaction went successful. If you see the logs, this is the owner, which is me, and the transaction went successful. If you open that, you can able to find the owner, and here you can call this function. This is the function we have created. So in that, if I provide this 0, you can see this is the error message I will get. So the transaction got reverted, and if you open this log, you can able to find the failed transaction decoded. this is 0, and because of this it's got failed. But if I provide the right number, if I provide 1, the transaction will went success. If I click on the function, here you can see the data got updated, and this is what we are returning here. So this one is looking fine. Now let's come here, let's create a go on the bar contract, and in that we have to simply deploy the contract. The contract got deployed, and let's have a look what we get. Tree function, this is the foo try catch by example. So let's come here, and this is the first contract we have. In that we have to pass the unt. When we pass the unt, we're going to call this foo function, foo.my. So if we come in the foo contract, and this is the function we are calling, in that we are passing this I, and we are having this return. So what will happen here, so we're going to return the result, and we're going to initialize that into our event. But if it's right, then we're going to initialize this result, otherwise it will throw the error. So let's do one thing. If we provide 1, the transaction which went successful, because here we are checking for 1. If it's 1, then it will display the right message. Let's type for this, and the transaction went successful. You can see here, you can come, and here you can see the log. We have my function called, and this is the message we have here. But if I still provide 0 here, the transaction will fail. 0, and this is the message we'll get back here, external call failed, and this is what we have explained here. This is our failed message we'll got, and this is how we catch from this catch block. So that makes sense. Now let's understand this function. So here we have this try and catch, and here we are saying that try catch new contract. So when in this contract, if we pass this address, this is the invalid message we will display, invalid address, because we don't want to have a 0 address. We don't want to have the 0 address. So in that, what I'm going to do is, if I simply grab this entire address, and if I call this function, if I call the owner, you can see the error I will get. So the transaction went successful, and if I open this one, this is the error message I got, invalid address, and that's what we are logging here. If we pass this one, if I copy this, I'll get the byte log, and I can simply pass it here, and I can simply get it. If I click on this, I will get this error message, the transaction went successful, and we are catch this reason that why it's got failed. And here you can able to see is say that this is the address, this is the data, and it's not valid, the byte log. Now if I want to catch the data which is in byte format, and if I simply copy that one, and I'm going to pass this one, I'll get the third reason, the third error message, which is that foo created. This is the foo created. If I pass this one, if I paste here, I can click on this, the transaction went success, and here we can easily able to have the message. So on the base of these condition, you can catch different error. You can see we have 3 blocks, first this and this. So this makes sense, hope, I believe, and that's the only thing you have to know. If you click on this, this is the address of the foo you will get it, and that's the only thing you have to keep in mind. That's the only thing you have to keep in mind. So hope this makes sense, how to use a try and catch block. Here you can see here we have tested for 3 different conditions. You can add in any logic, and that's how you can define. So here we have defined on the base of the contract, and we are validating the contract address, but you can build any statement like transfer fund or any data or any logic. So hope this makes sense. If you still have any confusion and doubt, rewatch the video and do leave in the comment section that what do you have the problem. I'll try to explain that. What is library in Solidity? Most of you guys have found different libraries in different smart contract. If you talk about OpenZeppelin, if you talk about Uniswap, they have libraries in their contract and they're using in their smart contract. Then how we going to create and how we can initialize the library, and that's what we're going to learn in this video. That how you can create a library and how you can use that library in the contract. Let's provide the general configuration. We have to provide the Pragma Solidity version, and now we're going to create a library. So to create a library, you have to use the keyword library, and you can call whatever you want to the name. So I'll call it math because that's what I'm going to do. I'm going to perform certain calculation in the library. So let's create a block. In that, we're going to create a function. We'll call it square. UNT, it will take a Y, it will run internal, pure, return, it's going to return the Z. And that's a very common practice in the library when it's come to Solidity smart contract. You want to perform certain mathematical calculation to prevent any kind of hack. Take this if statement, and in this we'll say that if Y is greater than 3, then we want to do this. In that we're going to say Z is equal to Y. Simple. And we're going to take this X variable and we're going to assign, and we'll take a unt variable x, and we're going to assign the variable to that. We're going to say y divided by that plus 1. We'll run a while loop. We'll say x is smaller than z. In that scenario, we can simply take the z and make it equal to x. Here we're going to define the x, and we're going to assign y divided by x plus x1 by 2. That's the simple library function we have here. Now we're going to write the else block, and that we're going to check for a condition y is not equal to 0. And in that, we're going to update the z value of z, and we're going to perform the certain calculations. So else z, by default, the value of z is going to be 0 because it's a unt type. And this is the simple library we had created. What we are doing, we are assigning a couple of variables, checking for a condition, running a while loop, and making variables so we can utilize it into the contract. So let's come here, let's create a contract, and we're going to use this library in this contract, test math. We'll come here, we're going to take this function, we'll say test square root, and that we're going to pass the unt x public pure return, and it's going to return the unt. Inside that, we're going to return this math dot square, because this is math is the library which we are using, and we are calling this square function, and in that we have to pass the data, which is the x, and this will return the calculation, entire calculation which is happening. That's a very simple function. Let me give this comment: array function to delete element at index and reorganize the array. And we have already talked about the deleting array in Solidity, that when you delete any element into an array, it will leave a blank space. It will make the value of that particular element which you want to delete to 0, and there is no changes in the length, but we want to make the change in the length once we delete any element. And that's what I have mentioned here. This is the problem we have in Solidity when it's come to array deleting an element. So now we're going to create a library. That library will delete the element, and it will also change the length. So if there is a 10 element, if we delete one, the length would be, let's create a library for that. So we'll say library array, and that we're going to create a function. We'll say remove unt, because we have to reset the array, storage area unt index, and public. Can you guess why we have used this storage keyword? Because we are directly manipulating our state variable, and we have to pipe the index. And that we'll say, now we're going to remove the last element. Whichever element we want to delete, we want to shift that element to the last, and we're going to delete it from there. If you still have any confusion about shifting the array, make sure to watch the array section, and that we have talked about in detail, that how you can shift the array and delete it, and you can change the length as well. Here we have it. Now let's come here, we'll say required.length should be greater than 0. If it's not, then we have to throw this error message, can't remove from an empty array. And that we're going to take the array, we're going to pass the index, so we can easily able to identify that which array we want to remove. And here we're going to call this array.length, and we're going to shift that to the end, so we have to subtract that. As you all know, that array start from the 0 index, so that's what we are getting, -1, so we can get the last one. So that's what we are doing here, we are shifting. And then we're going to simply call this pop method to delete the last element. Simple JavaScript. And that's our library. So this is the library we have designed. Now we're going to use it in the contract to delete. So let's create a contract. We're going to say test array, and that we're going to take this using array, because we have to initialize the library by using this using keyword, which is there in the Solidity. And we're going to say the for unt. So we have to define the type, that what type it is. It's a unt. Let's take the unt public array. This is going to be our array. We're going to create a function. We'll say test array remove public. Inside that, we're going to create this for loop. We'll say unt I is 0, then I is greater than 3. Then we have to simply increment that. So we got our loop. Inside that, we're going to simply call this method array dot. In that, we have to simply pass the I, the element inside the array. We can come here. We can simply say array dot remove 1, the method, and we have to simply check for the length, that we have the 2 length or not. Then we have to simply check the data, that what data we have in what location. So check the 1 is 2, and that's it. That's the entire smart contract, that how you can build a library and how you can test it and how you can utilize it. So hope this makes sense to all of you. Now we're going to test this out in the Remix ID. This is the entire smart contract we have written to understand the library concept in Solidity. So this is the first library we have declared. This is the test math contract, and this is the second library in which we are checking for the array length, and this is the last contract, test array, and that we are utilizing the library. So let's deploy the contract. Let's come here. We're going to deploy the first contract, deploy the math contract, do the transaction. It's went, And let's call this first one test math contract, and then we're going to deploy that one. Here we have the contract. Let's come here. If you call this math library, you can see we have nothing here because it's just a library, but we have something in here. Let's close this one. We have something in here. We can simply come here, and here we need to pass a data. So what it takes is take a unt, which is an x, and it will perform all this calculation because we are using this square library. So if we come here, if we pass less 5, if I make a request, the entire calculation will happen and I will get this 2 back. So first it will take this y, then it will check that y is bigger than 3 is not, because we have provided this 2. Provide this 5, yes, it's bigger than y. So if we have provided this 5, yes, it's bigger than 3, then it will execute this, update the value of the z, and thus it will do the calculation, run the while loop, and do the performance of this. And finally, it's going to return that. The default value is going to be 0 of UNT type. And that's what I have mentioned. So it's working fine. You can see we got an output. No matter what you passed, if you pass this 52, if you make a call, and you can see this is the 7 you will get. So this is the square root of that. Square root functions, and that's looking fine to me. Now let's test this out contract. So let's come here. We're gonna come to this. We have to simply, so this is the library we have declared. Let's deploy that one. So we got deployed. Now let's come here. We have to test the array one, and if I come here, right now we don't have anything, so let's test and call this contract. The transaction went successful, and here we have the contract, and then we have these 2 functions. So if we call this test array, so if you come here, you can see this is the array we have declared. Right now we don't have anything into that. If I call that one, I'll get an empty, which is not there, nothing. Now here I have this test array and remove array. So right now you can see that we are updating our array. We have 3 elements into that. So when we call this function, it will run this for loop, and it's going to update our array, this one. So let's call this function, and here you can see the transaction went successful. And if you call this one, you'll get the length. So we have 0, so because initial value is 0. If you pass this 1, you'll get this, the value is 2. So this for loop is working fine, and the transaction went successful because we run the for loop. We add 3 elements into our array. After that we remove the first element, which is a 2. So right now you can see, right now we have, if I pass this 0, call this, I'll get a 0. But if I pass this 1, we are getting this 2. But by default we need to get 1, because here we are calling this remove function. So it's removing the first. When this loop will run, it will start from 0, then it will become 1, then it will become 2. If I call this 2, what I will get? I'll get nothing, because we have only 2 elements. And this remove function is working fine, and we have also confirming here that the length is 2 after deleting. So this library which we have used, we have created this array library, is working fine. It's giving us the actual length of an array after deleting. Hope this makes sense that how the library work. These are the simple library we have created to understand the entire concept of library and removing. So if you still have any confusion, any doubt, make sure to watch this code again, retype, change with the value, and try to understand that what exactly happening and what we are exactly doing. With that said, let's move to the next video. Already we have ABI encoded. Most of the time you will find in different contract that they use ABI encoded to generate data and get data, or get any type of contract. And that's what we're going to learn in this video. Everything about ABI encoded. Let's follow the general configuration. We have to provide the Solidity Pragma version, and that we're going to create an interface. This will say ERC20, IERC20. Inside that, we're going to define a function. We'll say transfer address UNT external, and that's how we define interfaces. I believe you guys haven't forgot in the previous lectures. Now let's declare a contract, and that we're going to take a contract token, and in that we're going to create a function. We'll say transfer. It will take the address and the amount we want to transfer. That's the simple things we have done here. We have created an interface, and we have created a contract token, and now we're going to use the method ABI encoded method to access each one of these interface and the contract. So let's come down, let's create a contract. We'll say ABI encoded. In that we're going to create a function. We'll say test address contract. So in this we have to pass the contract address. We'll call it byte call data external. Inside that we're going to check bool okay. If that's true, then we're going to call the contract and we're going to call the method to transfer the fund. So we'll say data. That's the simple check we are doing here. So what this function is doing, it's first will take the address of the contract, it will take the byte data, and it will simply do the transaction by calling this call method. So that looks fine here. Now let's do the check that whether the transaction went success or not. That's the first function we have. Let's come down. Let's create another function. We'll say encoded with signature. And this is the function you have found in very small number of contract, but they utilize it. Some programmers, some smart contract developer, they use these functions to identify the contract based on this ABI encoders. In that we're going to pass this. So address to and the UNT amount. We have that one. Now we have to make it external, and here we have to say pure return, and we want to return the byte data once the transaction went success. And here we're going to call this typo is not checked. We're going to assign this transfer address and UNT. So when you use this function encoded with signature, this is the way you have to access the functions. We'll say return ABI encoded, and in that we have to simply call the functions. So this time we are targeting the contract. So we have the function, this transfer function in the contract, and that's what we're going to call it here. So transfer the address and the UNT amount 250, and here we're going to provide the to and amount where we want to send and the amount. So that looks fine to me. That's the first function. Let's create another function. We'll say encoded with selector. So there are a couple of methods we have. First we have discussed about the ABI encoded with signature. In that we are calling the contract address, pass a targeting contract, and with that contract we are getting the access of the functions with the help of this ABI encoded signature. In this selector we're going to pass the address to and the amount, then we'll make it external pure, and this will become return, and it will return the byte memory. And here we can come and we can simply do this check. So typo check is not ERC20 interface selectors and true amount. So this time we're going to target the interface. So this is the interface we have declared ERC20, and with this selector method which we have, with this we can easily able to target that interface and we can access the function to do the transaction. So that's the difference between the signature. Signature is basically a contract address, and the selector is the ad interface itself. We can come here, return ABI encoded with selector. In that we have to take the interface, we have to call the method we have already in that, and we're going to call the selectors. In that we have to pass the amount and the to address, and that's the simple function we have here. Let's come down, let's create another function. We'll call it encoded call. It will take the data amount to UNT amount external pure return, and it's going to return the byte memory. We'll pass this. This will not compile. Now let's do the return ABI encoded. We have to take this ERC20. We'll have to pass the function. We have to pass the to and the amount, and that's pretty much. So these are the three methods we have when it's come to encoded ABI encoded data. You can see all the function we have written, all the three selectors we have. So what we have learned about the encoded with signature, and that we pass the address of the contract. Now we have the encoded with selector, in that we pass the interface, and we have encoded call. This is the entire contract we have written for our ABI encoded. This is the first interface, this is the first contract, and this is the second contract ABI encoded. And in that we have this three functions. We have the normal test function. The second one we have with encoded with signature. The second one we have, third one we have it's with selector, and the last one we have call. So let's deploy the contract and let's test this out. Let's come here, click on this, and first we're going to deploy the token contract. Simply call deploy, and the transaction went successful. You can see that we have this. So simply close this for a while. Now come here, we have to deploy this interface. Simply click on this deploy. Okay, so we don't need to deploy that. That looks fine. Now we have to deploy this ABI encoded. Come here and do the transaction. The transaction went successful, and this is the two token we have. So let's come here in the first one. Inside that we need to pass two data. We have to pass the address and we have to pass the amount. So let's come here. This is the two things we have to pass. So I'll come here. I'm going to simply copy this one. I'm going to paste this address here, and I'm going to pass this data 5. I'll make the transaction, and the transaction went successful, and you can check the logs. So that's the successful deployment of this one. Now we have this ABI encoded, and in that we need couple of data. Here we have the 4 functions. So let's test this function first. Encoded with signature. In that we have to pass this to data. We have to pass the address and we have to pass the amount. So the address I want to pass is this, the first contract, and that I'm going to simply call it, open this one, and that I will pass the address and I'm going to pass the amount. So amount is going to be the 5. Hit enter, hit call, and that's looks pretty fine to me. What's happened here? Let's open the log and let's try to understand. This is the 2 data we have passed, and here you can see this is the output we got, our byte data, and that's what we are returning here. So this byte data contain the information we have provided about the addresses and about the amount. So if you decode this one, you can easily able to get the exact data which you have provided, and that's how exactly this encoded with signature work. So if you have a data, you can easily able to convert it into a byte code, and you can easily able to access that, because sometimes you need to convert the data into a byte code to have a memory efficiency. So that looks fine to me. Here you can see the typo check, and that's what we are simply passing here. This is the function we are calling, and you can see this is the output we have got, the entire byte. And let's close this one, and okay, let's close this one. This is the data we have. Now let's come to this selector one, and in that we need to pass the address and the amount. So this time the address I'm going to provide to this one, and I will simply come here, open this and pass the address, and the amount I want to provide is, let's say, 3. Make a call. The transaction went successful. We got this byte. If you look at this, this is the entire data we have in that. If you open the logs, you can able to see that byte, what you have paid exactly. And this time we have used this selector method, and the last one we have is this encoded. So let's close this one, and now let's do this last test. So in that we're going to pass the address. We can pass the address, and we have to assign the amount 8 and make a call, and the transaction went successful. You can see the outputs we got it, and this is the amount we have assigned, 8. You have 8 here. Here we have assigned 3. You have 3 here. Here we have the 5. This is the 5, and this is the address we have assigned. Actually this represent the 4 bytes, and this will contain the information about the account which is calling the address, and here is the address which we have provided. So first I provide this, and the second one I have provided this, and the first one we have provided this, the second one we have provided this data, and the third one we have provided the same account to do the transaction. So hope this makes sense. You can understand that how you can get the data into the bytes and how the data exactly flow. So this 4 represent the address of the wallet which you are using, the data you are providing, and the amount you are sending. So this is how the data is actually get stored on the EVM. So hope this makes sense. Still, if you have any confusion, try to see the code entire, retype the entire code, try to understand the data, what exactly happening, check the different variables, that how it's flowing and why we are doing in such a way. So you will find in most of the contract that this is the method is highly used, not this method, but not this method, but this one is the recommended method in most of the smart contract when it's come to identifying the contract and passing the data and calling the functions. So hope this makes sense. If you still have any confusion, do leave in the comment section and do let me know what is the problem. I'll try to explain that. With that, in the last video, we have learned about the ABI encoded in Solidity. In this video, we're going to learn about the ABI decode. So in ABI encoded, you convert the entire data into bytes, but in this time, we're going to convert the byte data into a readable format. Let's follow the general configuration, and we have to provide the license, identifier, and Solidity version. Now let's come here. Let's create a contract. We'll say ABI decoded, because that's what we're going to do here. And inside that, we're going to declare the struct, and we'll call my struct. And the data we want to take is the string name. We want to take a unt. It's going to be an array 2. 2 data will take into that, and that's the struct we have. Let's create a function. We'll say encoded, and that we have to pass the x, and we have to pass the address. We have to pass the complete array, which is a call data array, and that's going to be a unt type. I believe that these are the similar things we have already done. And let's take a my struct, and we'll call the call data my struct. And now we're going to simply make it external public pure return, and we're going to return this ABI bytes memory. Let's return this ABI encoded, in that we need to pass the entire data. So we have to encode this. So we have to x address array my struct And let's come down, we create another function we'll call decode, and that we need to pass the entire decoded data, so bytes, call data and data. We'll simply come here, we're going to create external, we'll make it pure, we'll make it return, and we're going to simply take a couple of variables, untx, address. We want to return the unt complete array in the memory, and we have to take the struct, memory struct, and that's the data we want to return. And here we're going to do certain things. So we're going to take and we're going to call this, we're going to use the deconstructor method. I believe that you guys are familiar with JavaScript, so we are deconstructing that x address and the array my struct, and this is coming from here because this ABI, the byte data, will have the entire data, and in that we need to pass the data and the unt address, array, and the struct. Looks fine. Let's come here, close this one, and that's the pretty much that's the only thing we have to know. We have written this smart contract, we have this two function, coded and decoded. In Solidity, we have a function called kk256. That's what we're going to learn in this video. But before we start, you have to know a couple of things. When you use this kk256, it will take an input. And the common use case we have of this kk256 is that it will create a dramatic new ID for every single input you provide into the functions. And you can have a common schema model which you have to use to using this functionality of kk256. So I know it sounds abstract, but let's have a look at how we can code into our smart contract to provide the Solidity versions. Let's create a contract. We're going to say hash function. In that we're going to take a function, we'll say hash. In that we're going to pass a couple of variables. So text, we're going to pass the unt num, and we have to pass the address. So these are the three data we need. We make it public, pure, return, and we want to return the byte 32 data. So we're going to provide these three data, and we're going to get back a byte 32 data. So that's what we have here. Let's return this. We're going to use this function kk256, and it's there in the Solidity. And in that we're going to call this ABI encoded method. Then we'll get the data into a byte 32 because that's what we want to have an output. So we'll call it ABI encoded. So it will give us the ABI encoded pack, and in that we're going to pass the data. So we want to encode the text, number, and the address. We want to encode into a byte 32 as an output. So that's the first function we have here. Now let's come here. So this is the simple things you have to keep in mind when you use any example of hash collations. So this is what exactly happened. So let's see in the code. So we'll create a function. We'll call this collation, and that we're going to pass this string is a text, and we're going to pass that another text. These are the two data we are passing into this collation function, and in that we're going to simply call this public pure, and we'll say return, and we want to return the byte 32. Inside that we're going to call this encoded pack, and in that we're going to pass the data. So we have to pass the two data into this, then we'll get an output like this. This is the output we'll get, AABB, and that's called pack, encoded pack. Let's give this comment. But when you will do something like this, like you'll pass this way, you will get the output as this. So it will always work in this exact length which you are providing, and that's also depend on the output. We'll use this return, and we're going to use this kk256. In that we're going to use this encoded packed, and then we have to provide the data. So text, another text, and that's the data we have, and that's what we're going to get into return. Let's create a contract, and that we're going to say guess the magic word, and in this we're going to take this byte 32 public answer, and we're going to take this data. So this is the byte 32, simple byte 32 which I have found on net. That's what I'm using here. Let's create a magic word which is a Solidity. So this is the word we're going to generate from this. Let's create a function. We'll say guess string number word public view return, and that we have to pass the boolean because we want to return a boolean as a true or false. And in that we have to say return kk256 encoded pack, and we have to simply pass the word answer word, and that's equal to answer. So that's the step we are doing. We have this answer we have taken, and we're going to take the string and we try to convert. So the string we're going to generate is the Solidity. So we're going to compare that this answer and the word we are getting from here, both are same or not. This is the entire smart contract we have written for hash generation using kk. So you can see this is the first contract, and that we have this hash function, and that we are passing these three variables, and we are getting an output as a byte 32. This is the second function. We have a collision, and that we are passing this two secs. We are converting into the gigabyte, and we are getting an output. Here we have another contract. In that we are taking this variable byte32 answer, and this byte32 represent a solidity text word, and this is the function we're going to provide the text solidity, and we're going to compare that this byte32 which we generated for solidity and the one it's getting generated by this function are equal or not. So let's deploy the contract. Come here, this is the only function we have. No, we have two contract. We have to deploy the first one. Let's call deployed, and here you can see this is the first deployed contract we have. In that we have these two functions. In that we have to pass the name. I will pass hey, I will pass I'll pass DAULAT dollar. I'll click on this call, and the transaction went successful. You can see this is the byte32 data we have got it. If you open the logs, you can see that same data we have as an output. So this is the data we contain all the two information we have provided. So that looks pretty fine. Now let's call this hash one. This is the function we have checked this. Let's check this hash one. So in that we have to pass the data. So we have to pass the string SHOAIB. We have to pass the number. So the number is going to be 6, and the address we want to provide to the address which I'm calling. And now if I call this, I'll get the byte32 which contain all the information. If you open the logs, you can able to see the inputs which you have provided and the output you got into byte32. So that's the pretty simple things about these two functions. Now let's come here, let's deploy this contract. Guess the magic number. So let's deploy the contract. The contract is got deployed. Let me close this one. Here we have the second contract, and that if I call this answer, you can see this is the output we got, and this is what we have defined, the exact output. And let's compare this output and the output we get from this function is same or not. So in that I'm going to pass this keyword solidity, because that's what we want to compare. If I pass this keyword solidity and we pass this guess, you can see it's true, because this is the byte32 which is for solidity, and the code is got generated, it's solidity. So here we are getting the boolean. If I do some changes here, so if I pass something else, so if I pass DAULAT, if I make a request, I'll get the fail. Let's say false, because the byte32 we are comparing and that the one is getting generated is not equal. So that's how you can use the byte32, and you can compare the data on the base of that. And this is very useful when you will actually send the data on the blockchains in the byte format. It will cost you way less compared to the what amount you have to pay when you will use the exact string variable or a unt variable, something like that. Okay, so hope this makes sense. If you still have any confusion, rewatch the video, try to understand that what function we have created, and do leave in the comment section that what's your query. I'll try to cover that. With that, let's move to the next video.
Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now this particular contract, which is for 7 days, has 400 TBC coin, and this one is a really powerful project if you want to build your custom token and allow user to buy and sell any product using your own token. So this will teach you a lot about that as well. So we have this much token in this 7 days contract, and 20% will get reward. Then we have the 2 user stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is I want to stake 100 token. So let's click on the stake. So first is going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token, so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. All of you, hope you guys are great. So this project will blow your mind. If you really want to learn about DeFi, then this is the project which you have to build. Let me give you a complete overview that what project you're going to build in the coming hours and what it will teach you. So this is the incredible front-end UI part we have designed for this entire staking DApp platform. You can able to see that it had a multiple component, multiple categories, and that's all you can able to find right up here. So you can click here, you can come back here. We have this navigation, different navigation. You can click on the search bar. Here you will have the search bar. You can close it up, you can open it up. And here we have the hero section. We have this buttons, you can come down, and here we have the upcoming project. So you can display whatever project you want to initialize in your staking DApp platform, and that's what you can display here. So we have multiple projects, that's what we are displaying here. and we have the volume. You can able to navigate with this. This also looks pretty good. And here we have some previous projects, so you can display all the project which is closed. That's all you can display here, and you can display the amount of monies they have raised. This is the multi-chain. It's actually features, the highlight section, and this is the team section we have. You can go to the different pages, you can click and you can navigate, you can have a look. And this is the how to participate. This is the apply. So if anybody wants to send any emails, they can do it from here. And here we have the beautiful social icons. You can click and you can come back here. So that's what we have in the home page. If you click on this project, you will come back to the project page, and that's how the entire project would look like. You can see we have a external page. This is the title, then we have this header, and here we are displaying all the projects. So right now on our staking DApp platform, we are allowing user 4 different contract, so they can stake their token and they can earn reward. So each contract will have a different rewards, and that's what we have highlighted here. So you can see the volumes, all of the things you can able to find. You can click on this details and it will take you to the contract detail page, and here they can able to find all the information about the project, that what is the staking amount, what is the reward. That's all they can able to find. So this is the reward, this is the summary. They can claim the token. This is the project summary. They can have a video, so if you want to make a video, you can promote that very easily here. This is the overview of the contract which you will provide. That looks pretty good. So that's the project detail page. Now come back to the staking page, and this one is the most important page of our staking tab. You can see we have a stunning front-end UI. We have everything's working fine. This is the hero section, and if I scroll down, this one is the main part. You can see that here we are providing 4 different categories of contract for staking the token. So we have 7 days, 14 days, 13 days, and 90 days, or you can take it any arbitrary number. It's totally up to you. So you can see that this contract is already live on Polygon test network, so you can able to fetch this data at real time. So right now in the 7 days contract, 400 token in the 7 days, and I have staked 300 token. So you can see 14 days, this all data will change real time. So you can see 14 days, all the data is displaying. This is the 13 days, but I have initialized this 21, so you can give any number. It's totally up to you, and I'll show you every single thing that what you have to do and how you can initialize all of these things. So this all data is dynamic and coming from the contract. Here is the countdown which will tell the user that when this contract is going to be end. So it looks pretty fine. Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now this particular contract, which is for 7 days, has 400 TBC coin, and 20% will get reward. Then we have the 2 users stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is, I want to stake 100 token. So let's click on the stake. So first is going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token, so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. Now reload the browser, and you can see nothing changed. Now you have to simply pass the amount and click on stake. So if you click on that, this time it's going to stake the token into the contract. Here we are calling the stake function. Click on confirm, and here we are making the transaction. So just wait, the transaction is happening. So it will take a little bit time because we are doing on a test network. So you can see it's taking a little bit time, and once the transaction will complete, it will take you back to the analytical page. And here you can see this is the analytical page we have, and here you can able to find all the transaction history you have done and the information and the balance you have. So this is the header section we have, and this is the banner section. You can see this is your address, this is the token you have staked 300, and this is the reward, the last reward calculate time, and this is the stake time, and the reward you have, and the reward you have claimed so far. So I have done all of this, that's why you can see all the data. And this is the short description I have given. You can reload the browser and you can able to find that one. If you come here, you can see here, this is the transaction we have done. This is the 12th transaction, and I have staked 100 token. You can click on this transaction, it will take you to the Polygon, and here you can verify the transaction. You can see what we have done. We have called the function, and we have this much token, and we have transferred the contract. all of things. So this is how you can verify the transaction. Now come back to the staking. So this is how you can done, and here you can see the data is updated. 500 BST we have, and you have stuck 400. Earlier it was 300 and look pretty fine. Now you can see 7 days. Now come back to the 14 days. Right now in 14 days we don't have anything, and this now is looking fine. This is the 14 days. Now this one is 40%, and this is the token. All the data is available. Right now we have nothing for reward because I haven't staked any token. Now let me stake the token. So I want to stake 100. Click on the stake, and it's going to make a transaction. It will first approve the tokens, and yeah, coin. Now we have to just wait, let the transaction get complete. And here we have completed transaction. Reload the browser, and if you come here now, click on that, nothing is there. Now we have to simply stake. Click on this, and we can simply call this one. And now you will see that after transaction, the token, the coin will be displayed here. So it's happening. And here we are back to the analytical, and you can able to find the token you have staked. So you can see this is the 30 number transaction, 100 token we have staked. You can verify that. And here you can see, if you click on this 14, you can see 100 and 100 and this is the balance I have. This is the 40%, and currently we have one user, and this is the token reward we have got initially. So you can click on here, and you can easily able to withdraw the fund, confirm it, and this one is going to make the transaction, and you can easily able to claim the reward from out of this token. Looks pretty good. Just wait, the transaction is happening, and here you will back, and here you can see the transaction is stored here. Claim reward, claim token, and you will have it. And you can easily able to verify the contract. So the data is updated, everything is updated. Looks pretty fine. Now if I want to simply stake more token, or if I want to withdraw, I can do that very easily. So let's withdraw my entire token from this 7 days contract. So I have 400 tokens into this 7 days contract. Let me withdraw that. Click on this withdraw, and now I can withdraw. So what this call will do, it will charge couple of tokens because the date is not completed and I'm withdrawing. So that's why they're going to charge 30% fee for early withdrawal. And here the transaction complete, and you can see this is the amount we have withdrawn. You can verify that. Come back here, and you can see I have nothing. 0 token I have staked. Now the balance is reduced to 400, and the balance is come here. I can easily withdraw the fund here in the 700 days, and if I claim that, you will see that it will be decreased to 0. And here we have claimed the reward, and here we are back. So the transaction completed. We have claimed the token. Come back here, and you can see right now the 7 day has 0 token which I have staked, and the reward is 0. So everything is dynamic, working absolutely fine. Here we have the initialize. So you can initialize the contract. Here we have the profile where you can able to find all the transaction which you have done, and this is the home page. And you can click, will take you to the project detail. This is the staking page, and looks pretty good. And this is the contact. So you can easily able to send email as well. So let me show you. Let's give the name, last name. I'll say Hussein. Let's give the email. Let's give the number, and let's give the message. Hey Daulat, Hussein, and click on send. And if you come back here in the Gmail account, you can able to find the information you have provided. Hussein, Daulat, and the blockchain code. Everything is looking fine. So this one is also working fine. So this is the complete project. You can see everything is working fine. Now let me do one thing. Let me log out from the application, and let me reload the browser. You can see it will automatically pop up the MetaMask, or you can add a click event on the button, then it will open. You can see our notification bar is also working. We're not able to fetch the information from Polygon because we are not connected, and that's why you can see the error message. Now let's pass the credential and click on unlock, and that will fix the issue. So you can see here we are. It's taking a little bit time. Reload the browser, and that will work fine. You can see we got the token. Type the blockchain coder, and you will come to the website, and here you will find all the resources which you need to build the project. So just click on this, come to the AI course section. So this is the course which I have launched, and if you really want to master web development and understand every single fundamental that how application get built in the real world, then this is the project for you. This is the course for you. I want you to come and have a look that what are the modules you're going to build, what are the sections we have divided, what are the technology you're going to learn. We have the front end section, we have the advanced section, and we have the API section. So we are using Redux toolkit, which is the most demandable technology right now in the industry. So I want you to come and have a look at what application you're going to build, and this will teach you a lot of things. And once you master this development part in this particular course, then it would be very easy for you to master the web3 part, because 80% is web2 and 20% is web3. So I want you to come and have a look on this particular course. Now click here and get to the source code. Here you will find all the source code which we have built on our YouTube channel. So you can simply come and have a look. We have tons of project, and I believe that you have built some of the project. If you haven't built this particular one, start building. And we have the real estate marketplace, we have the Uniswap clone, we have the chat application, DApp, we have the NFT marketplace, we have the supply chain. So these are the some of the important projects which you have to include in your portfolio. So let's click here, click on the recent one, and let's filter that one. Click on the recent one, and here you will find the final code and the starter file. So simply click on that, or you can simply search for here. So search for token staking, and you can easily able to filter it. So click on that, it's going to open, and here you will find the final code and the starter file. So just come and have a look at what you will get, and if you take the final code, you will give your valuable contribution to our team. So this is the final code, and let's click on the starter file, and you will get the complete assets, the starter folder structure which we need to build this application. So simply grab the URL. Here we have provided some important resources which you can have a look from your end. Copy the URL, and let's go back here. You can simply resend, and you can watch the complete setup video like this one. That once you will get the final code, that how you have to do the setup, that's what you can find here in this video. So it looks pretty good. Close this one and come back here and create a new folder. So let's rename this folder called staking DApp. Make sure to create your folder and open this folder in your VS Code. So let me open my VS Code, click on this open, go to desktop and select me the folder. So this is the folder which I'm going to open, and now make it full screen. Open up your terminal, and we have to clone the repository. So simply type git clone and just give this dot. It's going to clone the repository in the same directory. So here we have the entire folder and file structure which is already given to you. All you have to do is to write the code. So this is the entire starter file. Let me clear the terminal. Now let me give you a walkthrough that what you will get into the starter file. So first thing we have this delete this one. Now we have this asset. Inside that you will have couple of folder like CSS folder, font folder, images folder, JavaScript folder, and vendor folder. So open this CSS. Inside that you will have couple of modules, because we are using external libraries in our project internally. We are not using CDN, we are using internally libraries. So all the minified version of Java CSS you will find here: bootstrap, icons, magnifieds, carousel, video, responsiveness. That's all you will find here. If you come back to the vendor one, here you will find the library and the coloring, the font style. So this is the CSS which you don't need to worry about it, because in this we're going to focus more on the core functionality. We're not going to build the CSS. And this is the entire CSS file, and this is the font file we have. Inside that we are using couple of custom font. You can go with the default one, but I'll go with the custom fonts. So close this one. This is the entire images. So we have the background, and if you want to change any images, make sure to change it, but you have to give the exact name, because many of you said that my image is not displaying because you have given the different name, and that's why it's not rendering. So give the exact name which is given there, and that would be fine. And here we have the JavaScript folder. In that we have the libraries. So this is the main JavaScript file. You can simply scroll and you can see here you can write the custom pre-roller, main navigation, slider, log stuff. That's all you can do it. And here we have the library. So we have all this library: bootstrap, countdown, gallery, popular, slider. That's all library we have. So this is the vendor. So you might have this is the vendor. So you might have seen the notification that if anything goes wrong into our application, we are showing in the notification bar. So this is what it is. So it will display. You can customize the entire styling and the animation. That's all you can customize from here. and this is the JavaScript which is going to trigger the event whenever anything goes wrong into our contract. Close this one, and that's the entire asset you will get. Now comes the most important part. Close this one, and here we have this JS file. In that, we're going to write the entire logic for our application. So the very first folder we have is this data folder, because in our application we are rendering some of the data, a hard-coded data. So that's what we're going to do it with the help of this data folder. In that, we're going to keep the JSON file, and from there we're going to fetch it. So this is the data which is already provided in form of array. All we have to do is to build the logic, and we have to render these data. This is the product. So this is the product we have, and we have the product data, project details, then project details. So this one is for the blog post, and we have the user transaction, the history, where we are displaying all the user information. So this is the data folder. Now we have this common. So here we're going to declare our state variable. So I believe that you guys know that what is state variable. That's what we have followed in React or in Next.js project, but in this we're going to build a separate file where we're going to define all the state variable, and that's why I have called this common JS. And again, I'm telling you that if it sounds complicated, if you don't know what is state variable, how to manage the state, take that particular course. In that we have built the movie that will teach you everything about the state management. Here we're going to define the common JS, then we have the ether package, then we have the header, then we have the index. In that we will write the entire functionality of our staking. Then we have the initial, which is an optional one, and then we have the web3 library which we are using to interact with our contract and making things possible. So this is the huge piece of code, the entire library we have taken. You can use their CDN, but I would like to go with the library because it's not good to depend on the exceedients, because sometimes what happened that when you try to fetch the JavaScript file with the CDN and the website from where you are fetching, it's slow, it takes time to load the JavaScript. So it's always better that in the production application you have to use the entire library locally, and that's what we are doing here. And that's the entire JS file, and that we're going to do all the work. Here we have the web3. Inside that you will have the entire starter file. So this is the contract folder. Inside that we're going to write all of this contract. So we have this address contract we're going to write the context one, ERC20 initializer log, all of this contract. You can see for building this particular application we have to deal with multiple contract. We have to find the address, we have to build the context, initialize, honor, reentrancy guard, the token, and the staking. Tons of things we have to do. So it's going to be a pretty huge, and that's why I say that DeFi development is quite little complex than the normal NFT one. This is the script which I already given to all of you guys. So that's what we have here, and this is the test which we're not going to do it. And here we have the harded config file. So all the setup is already done. All you have to do is to paste your wallet address. This is the RPC URL, because we're going to deploy the contract to the Polygon. You can take any one, Gorilla, Sofale, it's totally up to you. And if you want to deploy on the mainnet, you can go with that as well. So make sure to do the exact configuration. All you have to do is to pass your private key address here. That will work fine. Now come back to the package JSON file. So these are the two packages we are using for the deployment of our contract. Okay, looks pretty good. And close this one. And now we're going to have these pages in our project. So we're going to have this analytical page. We're going to focus on the contact. We're going to focus on index. Then we have the project, then project details. And we have this register. Then we have the staking one. And here we have this README file, and here you will find some of the important information about the courses. And if you want to take any consultancy, that's all it's giving here, which you can take it. Close this one, and looks pretty good. So that's the entire folder and file structure. I believe that you guys have understood that what you have got in the starter file, and you are at the same stage where I am, because from here we're going to code every single thing together to build this phenomenal DApp. So I want you to be thoroughly focused. Take your time while learning this, while building this particular project. Try to understand every single thing which we're going to do in the smart contract, because once you understand every single thing which we're going to cover in this project, that will give you an amazing idea that how you can build DeFi project. So let's come here. First we're going to start with the contract. So open this one. Open the contract, and now we're going to start working with our address contract of the function. Is the contract or it's an address? So that's the very important contract we have to deal with it. And no matter what project you will find on the Ethereum mainnet or testnet, and in the real world project, you will find that they use particular contract which allow us to find out that who is interacting with the smart contract. So let's build that library. So there is a multiple libraries available which you can use it, but I want to make my library a little custom, and that's why we're going to try it together to build this library, address library. So we have to import the license identifier unlicensed, and we're going to take the Solidity version is going to be 8.9. Make sure to take the exact one. Then we have to call the library because we are building the library, and we're going to call this address. And then we're going to build couple of functions. Actually, a lot of function we have to build. So first thing, come here. We're going to take the function. We're going to call say is contract. So in that we're going to pass the contract, and then it's going to trigger all the function we're going to have inside this library. So we'll say is contract address, the account we have to pass. Then this function will be internal view boolean. So I'm going to write so this function will return whether the address is the contract or a owner address. Then we'll return the code.length. If it's greater than 0, then it will be returned either true or false. That's the simple checks we are doing. Let's come here. Let's write the second function. We'll call it send value. So it will be a payable recipient, and we have to define the amount. It's going to be an internal function. Then we'll say required address. This means the contract address. Its balance should be greater or equal to the amount. Otherwise, we have to throw this error message. Simple function we have here. Then we have to do the transfer of the fund. So recipient call, I'm going to pass the amount. If it returns the true, then we have to say unable to send the value if it's returned false. Otherwise, we have to make the transaction. So what we are doing in this particular function, we are taking the recipient and the amount. We are checking for the balance. So when he tried to call this and withdraw the fund from the contract, his balance is greater than the amount. So that's the first check. After that, we are making the transfer the fund. After that, we are simply transferring the fund to the recipient. If everything goes well, then we have to transfer the fund. Otherwise, we have to throw the error message. So we are done with this second function. Let's write the third one. We'll say function call. We have to target the address. Then we have to provide the bytecode, the data, internal, return, and it's going to return the bytecode memory. And here bytecode is quite convenient to pass the data into the function because it will cost you less gas fee in comparison of the string. So that's what we have here. Now we have to build the logic. So first we'll return this particular function. So we'll say function call. I'm giving the same name you can give it. There is no issue with that. So I'll say target data, and we have to throw this particular message, low level call failed. So this is the error message we want to throw whenever the transaction get failed. Now we have to build this particular function. So we'll say function call, and in that we have to receive the data which we have sent. So first thing, the address is the target. The second thing is the bytecode memory data, and the third thing is the message string error. So these are three information we're going to take inside this function. Then we have to build the logic, internal return, and it's going to return the bytecode. Now we can come here, we return the function call with value, and it will take couple of parameters. It will take the target data and 0 and the message. And again, this function is going to be the internal one. You can build the entire logic in the same function, but that's going to be quite big. So it's always important that you have to break down the entire function into a multiple function. So that would be very easy to read. And that's what exactly we follow in the industry. So that's the thing you have to keep in mind. That's why we have defined so many internal functions. So these are the information we're going to pass it down. And now we have to build this particular function call with value. So come down here, we'll take a function call with value, and inside that we have to receive this three information, address, target. Then we have to take the data, which is the bytecode. Then we have to take the unt value, and we have to take the value, and we call this internal returns, and we're going to return the byte memory. So these are the things we are returning. Now come here, we'll take this return function call with value. So that's the function we have to build. In that we have to pass this information, target data, value, and the error message. Looks pretty good. Come here, and now we have to build this particular function call with value. We have to receive this particular data, so we'll have the address target, we'll have the bytecode data, then we'll have the unt variable, and then we'll have the particular message. Internal returns bytecode memory, and we'll have to simply return this. Then we have to check for the balance, and then we have to throw the error message. We are building this multiple function because some of the function we're going to call it, and some of the function it's better to have there, because we are building the entire library which can deal with the entire addresses. Okay, so that's the entire library I'm building, but we're going to use few of the function, and this is the exact library which we are building. It's fully customizable and you can use it in any project. So this one is designed for the staking, but you can do a little bit modification in terms of value, in terms of messages, in terms of data, and you can use any project. So this one is going to be your forever use contract. Now we have to call our is contract, in that we have to pass the target, means the address, and we'll say address called to be non-contract, and then we have to do the success. Okay, so if the transaction is going to be the success one, then we have to call that, otherwise we have to call this particular verified function verified results. So we're going to simply call this verify call result, and in that we have to simply pass the success, return data, and the error message. Now come here, let's try to build this particular function static call. Okay, and that we have to pass the address, the bytecode, and it's going to be internal view bytecode memory. That's what we're going to return from it. And then we can come here, we'll return this function static call, and we have to pass these data, so the target and the data, and we have to throw the error message, low level failed call. So this is the another function. Now we have to build this particular function static call, and we can take the address target, we'll take the data which is in the byte format, and then we have to take the error message, and we can say internal view return, and we'll say bytecode memory. We have to return this is contract, and we have to return the address which he's going to interact with. We'll say address statics call to none contract, and then we have to simply make the transaction. So if it's returned with this data, then we'll say target.static call data, return verify call result, and we have to pass the 3 information into that, and that's the only thing we have to do. Hope you guys have understood what we are doing. We are following this general pattern, but different for different use case. So once we are checking for the statics, one we are checking for the balance, one we are checking for the user, whether the contract is the address of the contract or is a user address. So that's the result we are building. Just code along with me, everything will make sense when everything will come together and we're going to use in our contract. So it's a library. So let's write the function. So we'll say function delegate calls. It needs couple of information. It needs the address, the bytecode, actually the information, and we're going to return this byte memory. Then we have to simply return the function called delegate calls target data, and we have to display the message, low level delegate call failed. Let's build this particular function delegate calls, and we'll take this address target, we'll take the byte memory data, we'll take the string memory error message, and it's going to be internal return view, and it's going to return this particular message in bytecodes. Let's do the checks. So we'll say contract address, and we'll say delegate call to none contract, and we'll take this data. So we have to make the transaction. So byte memory return target delegate calls, we have to pass the data, and then we have to simply return this particular function verify call result, and that's what we have to simply pass here. So I believe that you guys have understood the pattern, that how you can build the library and how exactly it's work. Okay, just code along with me. Every single thing will make sense when we're going to combine all this contract together and we're going to use it in our application. Let's come here, let's build a function called verify call result. So this is the function we have written internally a lot of times, and now we have to build that one. So let's come here, we have to simply take this boolean success, and we'll take this bytecode memory return data, and we'll take the error message. So these are the things we need. We're going to call it internally pure because this will look up the status of the result and it's going to return this particular memory. So we'll say if success, the transaction is success, then we have to return this return data, else we have to simply come here and we have to say that if return data length is greater than 0, then we'll take this assembly, let return data size is model.return data. So this is the special keyword is available in Solidity to define and target the mloaded return data, and you can build a logic on that, but I would like to go with a simple approach. Just follow along with me. So that's what we have here. Now we'll take this revert and we have to throw this error message. So on Saturday I have uploaded a video in that I've explained that how you can revert and throw the error message in the contract with the parameters. So that's what I'm doing here. We are using this revert and we are defining this add 32 return data and the return size. So that's the information we are trying to throw from this particular revert. Now simply close this if else statement. Now we'll say else revert error message and close this one, close this one, close this one. So this is the entire piece of contract we have written. So this is the very first function we have, in that we are checking that account.code.length is greater than 0, means this will return either true or false. This is the send function, this is the function call, and this is the function call we have built. Inside that we have this function call with value, function call with value, so it's pretty huge function. And here we have the static call, and we have this delegate calls. Then we have the delegate calls here, we are checking for the transfer, then we are verifying the transaction with this multiple condition. So this is the library we have designed for this addresses. I have done a little bit modification from my end, but this is the general convention you will follow when you will look at the contracts in different platform when they use the library. Okay, so this is the entire piece of code we have written, and that's the only thing I want to cover in this video. Hope you guys have understood that how you can design your own library through custom error, and we're going to use it extensively in our project. So simply close this one. Everyone, hope all of you are doing great. So in the last video we have written our library contract for our staking DApp. I hope you guys have followed that. In this particular video we're going to build the contract for our context. Okay, just code along with me, everything will make sense, that how you can write custom contracts and you can use in your project. So here I'm in the context contract. Let me give the license identifier. Then we have to define the Solidity version. Let's come here, let's call it abstract contract context. And then that we have to write two functions which can deal with the manage of our context. So we'll take this function called message sender. It's gonna be return internal view virtual, and we'll take this address. I can see that you can see a lot of new keywords we are using in our contract. I believe that you guys have taken the entire Solidity course, which I have. It has close to 60 to 70 videos where I have covered extensively all of these keywords. So I'm going to use it directly. I'm not going to explain that what exactly it's doing. If you haven't taken the Solidity course, make sure to take that. That will give you a proper idea. But first build this project. In that we have to return this address. So we'll take this return message.sender. So this function will allow us to give us that whoever is calling the function is the message.sender and his address. Then we have to build another function which will be the message data, internal view virtual return, and is going to return the call data, means the message. Simply return that message.data. And that's the simple contract we have. You guys have understood that what we have done here. We have written this two function which will tell us that message.sender and the function of the to call. It will give us the address of the message.sender, and the other function we have is message data, means give us the data in the message.sender when he try to call the function. So that's the entire context. So that's what we have written. Let's write the second one. And now we have to build the ERC20 interface for our contract, which will allow us to transfer the tokens, take the token, and take the token out of the contract. So that's the interface we're going to build. It's a general ERC22 interface. Then we have to give the Solidity version name. Then we can call the interface ERC20, or you can call it whatever. but these are the function need to be there in the interface for making the transaction of the token. So we can come here, we'll take this particular one, we'll take this event transfer, and then we have to take this particular one, address index from address and the value. So these are the things we have to pass in this particular transfer event. We'll take another event, and this will be the approve event address. Then we have to pass the address of the sender and the value. Let's take the third event. So I'm taking these two events only because we have to allow the user to transfer the token, and they can simply approve their token to be spent by the contract token. So that's why I can have these two events. You can have more events because we have a lot of function in the ERC20 interface or the standards. So let's define the function. We'll say balance of, so this will allow us to check the balance of the address. Then we have the another one is for the transfer. It will take the address to and the amount for transfer the fund. Then we have one more function which is called allowance. It will take the address of the owner, sender, and then we have to simply return the UNT variable. Let's write another function. This will call approve. It will take the address of the spender and the amount for approving the contract. Now we can come here, we'll take another function. This will be the transfer from, so from transfer from A to from B. Inside that, we're going to take this address from, and we'll take this address to, and we have to provide the amount we want transfer. It will external return and return the boolean. So that's the entire interface we have written for the, so that's the entire interface. So we have the transfer, approval, this is the first function, balance of, transfer, allowance, approve, and transfer form. So these are the interface we're going to use. There are more, but we are focusing on totally customization and building what we need exactly. And that's the only thing I want to cover in this video. Hope you guys have understood that what logic we have implemented, what context we have built, what interface we have built, which we're going to use in our DApp. So everything will make sense. Just follow along with me and try to follow every single video. In that we are building this different contracts, because all of these contracts are dependent on one another. So you have to know how things works, how you can combine multiple contracts to bring certain functionality into your app. Hey all of you, hope you guys are great. So I hope you guys are enjoying this project. In the last video we have written the contract for our context, and we have written the interface for our ERC20 token. In this video we're going to write the contract for our initializer. It's actually going to be abstraction which we're going to use it in our actual contract to initialize our contract and check whether the contract is initialized or not. So what is the status of the contract? So that's what we're going to write, the abstraction. So just let's code along with me, everything will make sense. So we have to give the license identifier on license, we have to give the Solidity name, version. Then we have to take this import. And can you guess that why we have taken this address contract into this initializer contract? Because we have to identify that whether the staking contract is active or not active. So that's why we need the address. So let's create the initializer abstraction. We'll say contract initializable. So now we're going to take theirs. So we'll take this UNT variable called private initialized. We'll come down and we'll take this boolean value initializing. This will tell us that whether it's initializing or not, and we're going to manage this entire in this particular initializer contract. You can just imagine as a state variable. Now we can come here, we'll take this event initialized, and then we have to pass this the version, or you can give whatever name you want. We can come here, we have to take this modifier initializer. Inside that we have to define the logics. So what we'll do is we'll say boolean if top level call is to true. So here we are taking this particular variable, we're saying boolean is top level call, means our contract, it's called the top contract if it's true. So by default we are setting it to true, and if you look at this particular variable, by default it will be the false, but here we are saying that it's true. We're checking for the true condition, and that's what we are assigning here. Then we'll take this required statement, and then we have to build a logic. We'll say is top level call is true and initialized what it will do, it will allow us to check whether the contract is started or not, because when we'll deploy our contract, the staking contract, then we have to set the status of our contract. We have to activate the contract for receiving funds. So this is the contract which is going to check. So this is the modifier will check whether the contract is activated or not. Then we'll take this initialize variable and we have to increase it to 1. So by default it will be 0, and we're going to simply increase that, and when we have to build this logic. So it will say if top level call initializing true, and then we'll simply execute our further function, and we'll say if top level call initializing equal to false, then we have to emit this particular event initialized 1, and looks pretty good. So this is the modifier we have, the custom modifier. Now let's define a couple of more logic into this modifier. So that's the modifier we have. Hope that's very simple. In simple sense, what it does, it will allow you to check whether the contract is started or not. If it's started, then it will throw the error message, but if it's not started, it will set this particular data and update into our state variable. Let's take another modifier, and reinitializer. So this is the second modifier, which is a reinitializer, and this will be trigger whenever we try to update any information into our main contract. Means it's kind of reinitialization, like you are try to update the pricing of the token staking, or you want to increase the staking quantity. So that's will be come in the reinitializer. So in that we need to pass couple of information like the UNT version, the number. Then we can come here, we'll take this required statement, and the same check we have to do here. This is the version, and we'll say initializable contract is already initialized. So means it's already initialized, and we'll simply do this particular things. So we have to simply update the data to the state variable, and then we have to simply continue. Then we have to call this initializing equal to false, and we have to say that emit is gonna be a version. So this is the second modifier. I hope you guys have understood that what we have done. If it sounds complicated, I do understand that it will be complicated a little bit, because we are dealing with the different contract, and we're trying to manage our entire state of our application with a separate file. So this will be a little complex. Just work along with me, everything will make sense, and we are building all the logics together. Okay, so that's the second modifier we have. Now we come down here, we'll take the another one, we'll say only initializing. So this will be triggered at the time of initializing. So we can come here, we'll take this required statement called initializing, and we'll say initializable contract is not initializing. Okay, now we have to simply execute it. So that's the third modifier we have. We can come here, we can write a function called disable initializer. So this will allow us to update this data, and we can turn it off and we can turn it on. So some of the initializer will be triggered at the time of function call in our main contract, but we will have the separate function in our this particular one, which we can call it to update the data with the help of this particular function disable. Okay, we'll say internal view, and we'll take this return initializable contract is initialized. Then we have to say if initialize is greater than this type max, and again I have covered extensively this types max and UNT8, UNT256, everything is covered in the Solidity course, so you can check there. Okay, so come here, we can take this initialized type UNT max, then we have to simply initialize the event with the exact value, then we have to simply close that one. So this is the entire contract for our initialization. So things are looking pretty fine, we have no issues. This is the first initializer we have, this is the reinitializer, this is the only initializing, and this is the disable initializer, and these are the variables which we are managing. So hope this entire thing makes sense to all of you guys, and that's the only thing I want to cover about this initializer contract. And so that's the only thing I want to cover about this initializer contract. Everything will make sense, just follow along with me in this project, things will be pretty clear to all of you guys, and you guys will know that what you have to do, how this different contract work and interact and manage the state inside the contract. So with that, let's move to the next video. Hey all of you, hope you guys are great. So in the last video we have written the contract for our initializer. So if you haven't watched, make sure to watch it because that one is the most important contract in our staking tab. In this video we're going to build the contract for our ownable. So let's write it down. So we have to define our license identifier. Then we have to define the Solidity version. We can come down, we have to import the contract. So we need to import our context contract, and that's what we're going to use to check the context of our stage. So we can come here, we have to define the abstract contract, and we're going to call it ownable, and we're going to own couple of property from our context. So this is what you have to do. I hope you guys have used OpenZip library and other different contract. So that's what we are doing exactly here. We have built our own contract, the libraries, and that's what we are using in this particular context. So we can come here, we'll take this address private owner, and we have to define this particular event ownership transfer address, and we have the index, the new owner. So these are the two things we are passing. Then we can come here, we'll take the constructor. Inside that we have to transfer the ownership, the message.sender, because that's the function we have in our context. So that from there we are getting it. So this is our constructor. Now we can come here, we have to take this modifier, we'll say only owner, and we'll check owner. So this is the function we're going to call it, and then we have to simply close that modifier. Looks pretty good. Now we can come here, we have to take a function called owner public view virtual returns. It will return the address, then we'll say return owner. So it will say that which is the owner of the contract, like who is the owner of the contract, it is going to return, and we're going to simply close that one. And now we can simply come down here, we'll take another function, we'll call check owner internal view virtual, and it's going to return the owners, and we have to do the check. So whatever the owner is equal to the message.sender, means the one is going to be defined in the state variable, and the second one will come from the function call. So that's, we try to match it up, and then we have to throw this error message, caller is not the owner, because when we initialize our contract, it's going to be the fix the owner at that particular time, and we have to manage that in the state. So when someone try to withdraw the fund from the contract but he's not the owner, then we have to throw this particular error message, check owner. So that's what we have here. Now we can simply come down here, we'll create a function called renounce ownership. We'll say public view only owner, and then we have to call this transfer ownership address to the 0 address, and then we can simply come here, we'll say transfer ownership, and we have to pass the address, and it will be only called by the owner. Then we'll build this condition that new owner is not equal to the 0 address, otherwise we have to throw this error message. Then we have to simply transfer ownership to the new owner, and looks pretty good. Basics function we have. Now we can come here, we have to build a function called transfer ownership. This is going to be run internally because we have used this one internally. In that we're going to pass the address of the new owner virtual, and it's going to return a couple of things. So it will return the address, old owner, and here we have to do the comparison. So we'll say old owner equal to the owner, because we have to update that one, and we'll say owner equal to the new owner, and we'll simply initialize this particular event with all the data we have defined above. Looks pretty good, and that's the simple contract which will tell you that who is the owner of the contract, and that's what we are inheriting. So this is the internal library we have built, and that's what we are utilizing here. Hope things are making sense to all of you guys, that how things are coming together and how we are utilizing this all. So we have different contract for different purposes. So come here. So that's the only thing I want to talk about in this video. Hope you guys have understood that how you can write the contract for ownable And this is the most common contract you will find in other popular libraries. If you talk about third wave, if you talk about the open zeppelin, this is the exact contract you will find when it's come to identifying the ownership and transferring that all. In the next video we're going to talk about the reentrancy guard, so make sure to watch that part as well, because there we're going to, because in that video we're going to build a smart contract which will trigger and prevent any kind of reentrancing attack. So let's move to that video. Hey all of you, hope you guys are great. So I believe that you guys are enjoying this particular project, token staking DApp, and in the last video we have built our ownable contract which will allow us to identify that who is the owner of the contract. In this video we're going to build a smart contract for reentrancy guard. This one is most common threat in the blockchain space in the smart contract, and we're going to solve this particular issue with the help of reentrancy smart contract. Let's define the Solidity version, and we can build our abstract. So we'll say contract and we're going to call it reentrancy guard, and in that we have to build the entire logic for our logic for the reentrancy guard. So we're going to take a couple of things. So we'll take a variable called private const non enter 1. So those who have called the function for the very first time, that's what we call 1, and those who have called this function twice, means it's calling in the loop, then we're going to simply update it to 2, and this will allow us to prevent our contract from reentrancy. Let's build the logic. We can come here, we'll take a unity variable called private status, and we can take a constructor. Inside that we have to take the status equal to non-enter. So we have to simply update the status number to non-enter, means 1 by default. But we can come here, we can define our modifier. It will say non-reentrant. Inside that we have to come down here, we have to take the required statement and we have to simply check for the condition, and then we have to throw this particular error message. Reentrancy guard reentrance call, means those who will try to call the function twice, this is the error message, we're going to throw it out, we're going to update that. Then we'll take this status and we'll say entered. If this statement is fulfilled, then we have to simply update the status, and then we have to simply continue on. Then we'll take the status and we'll say non-enter and close this one. So this is the reentrancy guard, pretty simple smart contract we have. So what we are doing, we are taking this toState variable, then we are simply updating the status of the non-entry, then we are checking in this particular modifier that if the statements get fulfilled, then we have to simply update it in the first function call, but if it's not, then we have to simply keep it to the non-enter. That's what we have here, and this is the simple modifier we have, pretty simple one. So now come here, now we have to simply write. So that's the only thing I want to cover in this video. Hope you guys have understood that what logic we have implemented and how you can prevent reentrancy attacks. So this is the approach you have to take when you are building in a DeFi project, because when there is a transfer of tokens and staking of fund in the contract, this is the most secure way which you can take to prevent your contract from getting hacked or getting attacked by the reentrancy. So that's the approach you have to take. With that, let's move to the next video. All of you, welcome back once again. I hope you guys are enjoying this token staking DApp project. In this video we're going to write our custom ERC20 token without using any external library. So far you guys have used open zeppelin for building your ERC20 token, but in this we're going to build our own ERC20 token with more feature which we can use to fetch the data and display in the front end as per the user holding, as per the user transfer of the tokens. So that's the custom token we're going to design in this particular video. You have both the option. You can go with the normal ERC20 token approach with the using the library of open zeppelin, but I want to make it custom token from my own because I want to add more feature to it so we can perform more action in our DApp. So let's provide the license identifier, then let's write the contract. We'll say contract the blockchain coder. So this is the name of the contract I'm giving. You can give your name. Let's define a couple of variables. So we'll take a string public name. So this is the name I have given to my token. This is the symbol BTC. Let's give the string which is going to be the standard, You can define any standard. This is the general standard which you have to follow when it's come to building any token. So if you look at the documentation of the Ethereum and the ERC20 token, these are the couple things you need to have. So this is the version of the standard I'm defining for my token. Now we'll take this total supply, we'll take the owner of the contract, and we'll take the public user ID. Then we'll take this unt variable, we'll take a constant, and we have to say initial supply to be 10,000, and it's going to be an 18 decimal point. Okay, so this is the supply which I want to trigger to my token. And we can take the address public holders token, so in that we're going to keep all the addresses of the user who will have our token, so we can display in our front end. Then we'll take this particular event, we'll say transfer from to and the value. Then we have to define or approve. Inside that we'll take the address owner and who we want to approve, the spender, and the amount we want to approve them to spend the token. So this is the event, second event we have. Now we can come here and we have to define a couple of mapping, because we have to keep the track of the transfer of the tokens and who is holding how much token. So again, we can display in our front end. So we'll take the mapping, we'll say address is greater than the token holder info, and this is the struct we have to build. So we'll build this token holder info, we'll take the unt token id, we'll take the address from, we'll take the address to, we'll take the unt total token, we'll take the boolean token holder, and these are the information we are doing. So whenever someone will transfer any token from the contract, means I'm the owner and I'm transferring any token to anyone, so every time this id will increase. So first we'll start with 1 2 3, and that's how we'll assign the id. And with this boolean value we are checking that whether he is a holder of the token or not. Okay, now we have defined the second mapping, which is the address and unt, the balance of the user in the contract of the token. Then we'll take this mapping called mapping address, and it's going to return this unt variable. Then we can come here, we'll take the constructor, and now we have to simply update the couple of data. So we'll come here, we'll take update the owner. So we'll say message.sender, means those who uploading the contract. So sorry, the person who is uploading the contract is the owner of the contract. Then we can come here, we'll have to update his balance to the initial supply, because he's going to be the owner of all the token. And we'll take this total supply equal to the initial supply, and that looks pretty fine. That's the simple constructor we have. You can take it as an input at the time of deployment, but I will go with this hardcode data because this is the data I want to assign. Now we have to write a couple of functions. So first function is increment, I call it in, you can call it increment, and this will allow us to update our id. Okay, so we'll say user id plus plus, so this is the variable we have taken, and it will increase. Then we can come here, we'll take a function called transfer, and then we have to pass the address value, and that we have to simply call as public, return the boolean. And first we have to check for a condition. We'll say required balance is the message or sender is greater than the value, means when he try to withdraw or transfer the fund, he has to have at least that amount of fund, otherwise we can throw an error message. Then we have to call this increment whenever the transfers take place, and then we have to simply minus the actual fund from his address to, and we have to update to the caller one, sorry, the person we are transferring to, and then we have to simply update the entire information into a struct. We'll say storage token holder info, and we have to pass the address, and that way we can map it, and then we have to simply update the entire information to, from, and we have the token, then we have the token holder info, it's going to be a true because he will hold a couple of token, and we have to update the user id. So these are the information we are updating. Come down here, we'll take this token holder, and we have to push the address because we are keeping the address in an array, so of all the users. So that looks pretty good. Now we can initialize our event, transfer event, pass the address and the value. Then we have to simply return this true after the successful transfer. Hope you guys have understood that what we have done. That's a very simple logic we have implemented. Now let's move to the second function. So we'll say function approve. It will take the address, then the value. Public. It will return the boolean if the approve is successful. Then we have to allow this message spender, and we have to map it. Okay, we are calling this allowance method.sender to spender and the value. These are the information we are getting. Then we have to initialize our event, and that way we can approve and we'll return this true. That's a pretty simple one. Then we can take this function transfer from. We have to take this couple of things. We'll take the address from to, and we have to take the value, and it's going to be return the boolean success. We'll take this required value should be less than the balance of the from, means there. And then we have to do another check. The balance should be less or equal to the allowance balance sender. Then we have to simply take the balance of, and we have to subtract from the transfer, and we have to simply update to whom we are transferring. So that's how we can update the balance and deduct the balance. Now we have to simply call this allowance, and we have to refer to the balance so we can deduct from his, because we have approved that person to transfer the fund on behalf of us. So we have to make the connection, and then we have to deduct the fund from this person who have approved, and then we have to call this particular transfer event, and we have to return this true. You can define custom message, but I'm going to return this true or false. Let's come here. We have to take this function called get token holder data. So this will give us the information about all the user have to done the transfer or holding tokens. It will take the address. We'll say public view, and we're going to return the, let's say, unt. It will return the address, all the data we want to return, and address, unt, boolean. So these are the information we have here. Let's close that down. Come here, let's work on the logic. So first we have to return the token holder info. We have to pass the address, the id, and that address to, and then the from, then the token value information we have to withdraw, total token, and then the status. Okay, so these are the data we are passing. Pretty good. Now close this one. So this will give us the information about the individual if you pass the address, and what is the status of him in the contract, id, token, and whether he is the holder or not. Then we can take this get token holder, and it will return the address and it will return the entire array of the token holders, all the user. And that's the custom token we have written. Hope things are entire making sense to all of you guys, that what we have done. Don't need to worry, everything will make sense when we'll try to bring all the functionality together. So this is the transfer one. That one is a pretty huge one. Then we have the approve, then we have the transfer from, and we are building all the logic. This is the data for getting the data from the contract, and this is the holders, token holders. That's pretty huge. So that's the only thing I want to cover about this custom ERC20 token with the custom logic we have implemented for fetching the information. And I believe that you guys have understood that how you can write that without using any external library. In the next video, we're going to work on the token staking contract, and this one is the main contract, because whatever contract we have built internal contract, and we're going to use those contract as a library in our main contract in the token staking, and that's what we're going to work in the next video. So make sure to watch that video. That will make you more sense, and it will teach you a lot of new things that how you can build the actual real world contract. So let's move to that. Hey, all of you, hope you guys are great. So I believe that you guys are enjoying this token staking DApp project. And in the last video, we have written our custom ERC20 token with extra features. So if you haven't watched that video, make sure to watch it. That will give you a better idea that how you can build your own custom token with more data. In this video, we will write our contract for token staking, and this one is the most important contract in our staking DApp, which going to provide all the feature of staking, reward and withdrawal, everything we're going to do in this particular contract. And all the contract we have built previously, that's all we're going to utilize in this token staking contract. So make sure to watch this one. So here I have opened the token staking file, and in this we're going to write our token staking contract. So let's provide the license identifier. Let's declare the Solidity version, and now we have to import couple of files. So all the contract we have built, that's all we're going to utilize it right now. So first we have to import our honorable contract. The second import we have to do our reentrancy guard. The third import we have to do our initializer, which will allow us to check whether the contract is initialized or not. The fourth contract we have to import is the ERC20 interface, which will allow us to transfer the fund staking. That's all we're going to do. So these are the four contract we are using. Now we have to write the contract. So we'll call it contract token staking. You can give any name you want. And now we have to inherit all this contract into our contract. So this is the is keyword. Again, I believe that you guys have followed the complete Solidity course, and that I have explained every single thing about all the keywords and which I'm using here. So let's import the honorable, then we have to import the reentrancy guard, then we have to import the initializer, and that's all we have here. We have the abstraction, so we have inherit the abstraction. Now we can come here, we have to take the struct to store the user details. So let's define that one. We'll say struct user, and we can provide couple of information. We'll provide the UNT, like stake amount, then we can provide the reward amount, then we have to provide the last staking time, so when they have staked the token last, and we have to provide the reward calculation time, so when the last we have calculated the reward. Then we have to take this reward claim so far, so what amount of reward he or she has taken out of it. So this is the entire user struct we have. You can define more data, but these are the basic information we try to keep in the contract. And now we have to define that what amount of token we allow user to stake in the contract, or what is the minimum staking or what is the maximum staking. So let's define the minimum staking 20. Minimum staking is going to be any number, it's totally up to you. Then we have to define the maximum staking. So maximum staking token limit for program. I'm just giving this comment so you guys can keep in mind that what variable we have taken for what. So because this one is the most important and the biggest contract we're going to create in the staking DApp, so that's why I'm providing this comment. So you guys can refresh, you can come back and you can watch, and you guys can identify that what variable defining for what. Let's come here, we have to take this another one. We'll say staking end date. Then we can come down, we have to take the staking start date, so when it will start. Now we can come down, we have to take another one, which is the token staking, okay, total one. Then we can take this total users who stake the tokens, and we have to take this stake days. So what is the period, and this stake day will define that for how long you allow user to stake their token. Then we can take this early unstake fee. So this will be in terms of percentage, because if the users try to withdraw the fund without a token without the completion of the time, they have to pay certain fee for that. Then we'll take this boolean is taking pause, so it will return either true or false, means, and this particular boolean will tell us that what is the status of the contract, it's active or not active. Then we can come here, we have to define the token contract address. So we'll take the address, we'll call it private, and we'll define the token address. And this variable we're going to update at the time of initializer contract. So we're going to have a function in the contract which will initialize our contract. You can initialize at the time of contract deployment, but I try to keep it separate function for that. So Everything will make sense, just follow along with me. Then we can take this, like the percentage of reward you want to provide, it's going to be unt variable app rate. Then we can take this public const percentage denominator is going to be this 10,000, and the second one will have this app rate change to 10. So this number is totally up to you, that what reward you want to provide to the user, but this is the common denominator I have found in most of the contract when I was doing my research. So I would like to go with the same approach here. This one is the standard one in most of the staking contract. Now we can come here, we'll take this user address user. Now we have to build the mapping user private users. Now we can come here, we have to trigger the event stake event. So when the user will stake the token, we have to call this event. Then we have the unstake event address user and the amount, how much token they have unstake, means withdrawn. Then we'll have another one called early unstake fee. If they try to withdraw the staking without completion of the time, we have to initialize that as well. Then we have this particular claim reward. Then we can come here, we have to build the modifier. So we'll say when treasury has balance, it will take this amount, and in that we have to build certain conditions. So we'll say required, we'll say we have to take the token. So here we are using the ERC20 interface. In that we have to pass the token address, and we have to check the balance. It should be greater than 0, greater than the amount he tried to withdraw from the fund. If it has, then we have to allow them to withdraw, otherwise we have to throw this error message. So what we are doing here, we are using the ERC20 interface, we are passing the token address, and then we are checking the balance of the user, and then if it has, then we have to make the transaction, otherwise we have to throw this error message, insufficient fund in treasury. Then we have to close this modifier and we have to continue ahead. So this is the first modifier we have. Come here, let's build a function call. So this is the very first function we're going to call after we deploy the contract, and this will allow us to initialize, means start our contract. So user can come and deposit the token. So it's going to take couple of data. So it will take the address of the owner, then it will take the token address, app rate. It's going to take the minimum staking amount, then we'll take the maximum staking amount. It will take the UNT stake start date, and we have to provide the end date. And then we'll take this stake days, and we'll take the UNT early staking fees percentage, and we're going to simply call our initializer. So we are calling this initializer method we have, and in that we have to simply pass the data. So we're going to create this function called token staking in change, and in that we have to simply pass all of the data. We have to pass the owner, we have to pass the token address, we have to pass the rate, we have to pass the minimum staking, pass the maximum staking, or we can pass the staking start date, end date, and the maximum stake days, and the early percentage fee. Make sure you have to follow the same order which we have followed. And here you have two options. You can define the owner of the contract at the time of contract deployment, or you can define the owner of the contract at the time of initializer. You have both the option, but for the safer side I would like to go with the separate. So that's the one we have here. Let's close that one, close that one, and now we have to build the function. So let's come here, we have to build the function called token staking int unchained. So this is the internal function we have defined in the initializer, and that's what we have to do. So we have to receive all of the data we have defined above. So we need the address, the token address, the minimum token app rate, then minimum staking amount, then we have the maximum token limit, we have the start date, we have the end date, we have the stake days, and the early percentage fee. So all of this data we have received, and now we have to simply call the only initializing. So this is the method we are calling in the initializer abstraction. And then we have to simply check for a condition, means app rate should be greater than this value. You can define any value, but I would like to go with this one. And otherwise we have to throw this error message if it's less than that. So app rate should be less than this. Okay, app rate should be less than this, otherwise we have to throw this error message. Then we have to do the second check. Staking days should be greater than 0, so we have to allow user to stake the token for a couple of days. We don't want to set it to 0 days, so that's what we have to set here. State days must be none 0. Then we can do the third check. We'll say token address is not equal to the 0 address, so means we don't want the contract, we don't want the 0 address, otherwise we have to throw this error message. Token address cannot be 0 address. Then we can do the fourth check. We'll say start date, it should be less than the end date, and that's obvious. So start date must be less than the end date. We can come here, we have to simply take this to transfer ownership. So this is the method we have, and that we're going to simply pass the owner. It will transfer the ownership of this particular contract. Then we take the token address to be the token address. We have to simply update our state variable. Then we'll take the app rate and simply update all of the data, minimum staking amount, and do the same thing for the max. Then we have the start date and update that one. Then we have to update the end date, then the stake day, and early unstake percentage fee. So here we have updated all the state variable we have taken. So hope you guys have understood that what logic we have implemented, how we are calling the transfer ownership functions, and how we are managing the entire state. And I believe that you guys are good in the state management, and if you really want to learn about the state management, then this is the course which I have on the channel. Take it, you will learn every single thing which you have to know as a web developer, and that will help you a lot in your web3 development. So this is the course which is absolutely must for you to learn about the state management and what are the tools and technology is the most demandable right now which you can learn to build your app. Okay, so make sure to check, and that you will have the complete idea. Now we can take the create a view methods. So now whatever function we're going to write it will allow us to check all the data from our staking contract so we can display in our front end. So that's why I've called this view method start. Let's come here. So I'm going to make this comment so you guys can refer that what function is for what. So let's call the function minimum staking amount. So this will allow us to get the minimum staking amount. It will be external view return, and it's going to return the amount, which is a UNT variable. So we'll take this return and we have to simply return the minimum amount. This is the first function. Let's write the second one. So function get max staking limit, and the same we have to return the UNT, and we'll say return max staking token limit. So this is the maximum. Now we have to write the other one, date external view, it will return the UNT, and we have to return the start day of the token. Close this one. Stake end date, and this will return the end date of our staking contract. So we'll take a function, we'll say get total stake tokens external view return, and it's going to return the UNT, and we'll simply return our the token stake total stake token, that how many token user have staked so far in the contract. We'll say function get total user view return, and return the UNT, return the total user which we have in the contract. Get stake days view return, and return the UNT. So how many days we have to stake our token. So this is our function. Early unstake per fee, which will allow us to display in our front end that if they try to withdraw the fund without completion of the time, we have to charge certain fee, and that's the fee we are going to display. Now we have to write the function for staking. So we'll say get status staking state, and it's going to return the boolean. So we have the data, that's what we can simply pass it here. So function get ap percentage, in that we have to simply do a couple of things. So we'll simply return the app rate, and that's the only thing. Now we have to write the function which allows us to get the estimated reward of a user. So in that we have to simply call this function, and it will return the estimated fund which a user will get. So this is the check we are doing. We are calling this internal function, in that we are passing this message or sender, and then we are simply returning his reward. Very simple logic. So what we are doing here, we are calling this particular method, and we are checking for the funds. We are going to create this particular function called get user estimated reward, which will execute internally, and is going to return this particular amount of the user he will earn the reward. Create a function called get withdrawal amount. So the rewards which user can withdraw, so we'll have to simply return this. So we're going to use this ERC20 interface. We have to pass the address so we can check the balance he or she has, and then we have to simply subtract the fund. So total staking, so total stake token, because this will keep the track that how many token user have stake in our staking contract, and when the user will try to withdraw, this is will display, and will simply reduce that one. These are the simple function we are building for getting the information from the contract. So we'll create a function we'll call get user, and in that we have to pass the user address. So it will give us all the details. So user memory, and then we have to simply return the user address, not the address. We'll pass the user address, and we'll return the entire information about the user. Let's create a function we'll call its staking holder. So this function will allow us to give us true or false. So this particular function will allow us to check whether a particular address is a token holder or not. If it is a holder, then it will return true, but if it's not, then it will return false. We have to pass the address, then we're going to call external viewer is going to return the boolean, and here we have to do the check. So we'll take this return, and we'll try to check, compare it with this. Means if he has any fund in the staking contract, means he's the user, otherwise he's not the holder, and we have to return false. So this is the entire function we have written for the view method, so we can get the information from our contract, so we can display into our front end. This is the simple function we have written by one line, or you can take the entire information in a single function, but this is the approach which I would like to take, because we can call this function in multiple places in our contract, and we don't need to deal with all the data in the contract. Now we can come here, and we can start working on a owner method. So this particular function we're going to create right now, it's going to be controlled by the owner of the contract. So those are the methods we're going to create right now, like updating all the information in the state variable in the contract by the owner. Okay, he has the permission to do that, not the individual. So the very first function we have to create is update minimum staking, and that we have to pass the new amount, and we have to simply update it, and we're going to call this only owner modifier, because we allow only owner to call this function. And then we have to simply update that minimum staking amount to our new amount. Now we have to simply create a function which allows us to update the maximum amount. Again, it will take the new amount, and then we have to simply update that new amount. So this function will allow us to stake the end date. So we'll create a function we'll call update staking end date, and we have to pass the new date, and we have to simply update our state variable. Pretty good. Now we have to write a function for update unstake fee percentage, early unstake fee percentage, new percentage, and we have to do exactly the same thing. We have to simply update the new state variable. That's good. So this function allow the owner of the staking contract to stake the token on behalf of any users. So let's create a function called stake for user. We have to pass these two information, amount and the address. And then we have to simply update that, and make sure to call this none reentrant. Okay, so no one can manipulate this to call the function. Then we have to simply update that. We call this staking, and we have to pass the amount and the user. So this will automatically trigger, and we're going to create this staking token function now, because this one is the most important function which allow the user to stake the token. So now we have to write the function which allow us to active and deactivate our contract for token staking. That's a very simple function. We'll say function toggle staking status, and it will only call by owner, and we have to simply update that one. So we'll say is pos to this means true, or they can be false. And now we have to write the function so the owner of the contract, staking contract, can withdraw the fund from the contract, because sometimes what will happen, that user will stake the token in the contract, but if they withdraw the fund without completing the period, the time staking time, the owner of the contract will charging certain amount as form of token. So we need to have a function in the contract so the user can withdraw the tokens from the contract to his wallet address. So let's create a function. We'll say withdrawal. We have to give the amount, and it can only call by the owner, and we have to check for the non-reentrancy. Then we have to check for a condition. We'll call this dot get withdrawal amount, and we have to check for the amount token staking not enough withdrawal. Okay, so we have to check for a condition. Then we have to call the ERC20, and we have to call the transfer method, so transfer the fund. And that's a pretty simple function we have here. Okay, so this is the end of the owner method, and now we can start working on the user method. So user can stake the token, and they can withdraw the fund, they can claim the reward. So many methods we have built, so many functions we have built, and now the comes for the users. So the very first function we have to create for the user to stake token. and let's create a function called stake, and in that we have to pass the amount. So they can only pass the amount and they can stake. So it's going to be external known reentrancy. We'll call stake token. This is the internal function we're going to create, and that we have to pass the amount and the message.sender. Then we're going to call this particular function called staking token, and this will be the internal function. So this function is getting called by the owner when the owner of the contract is staking on behalf of someone else, and when the user is staking the contract, we're going to call this particular function as well, because this particular function is entirely reliable for staking the token in the contract. Let's take this two information, amount and the address. It's going to be a private function. We have to check for a condition. The pause condition means the contract is still taking the token. That's the first check. Then we have to take a current time, and we have to call this particular function which we're going to create a short while ago. This will give us the time when we are calling this particular function, means when we are staking the token. Then we'll take this second check, current time is greater than the start date, otherwise we have to throw this error message. Okay, I believe that you guys can understand that what we are doing here. These are the simple check we are doing. Then we have to do the second check. We have to check for the end time. It should be less than the current time, otherwise we have to throw this error message. We don't want that the end time is over and then the user is still staking the token. Then we have to do the third check. We have to say that staking total token and with the amount. If it's more than the maximum, then we don't allow them to stake. So it should be less than the max token limit. Now we have to do the fourth check. We have to take the amount. It should be greater than 0. Otherwise we don't want to allow the user to call this contract. Then we have to do the sixth check. In that we have to check for a condition that amount should be greater or equal to the minimum. Obviously, because you don't allow user to stake 0 token, or minimum is 10 but they are trying to stake 1, so we don't allow them to do that. Otherwise we have to throw our error message, token staking stake amount must greater than minimum amount allowed. So this is the condition we have. Now we can come here. Here we have to do a couple of check. So we'll say if user dot stake amount is not equal to 0. In this if statement, what we are doing, we are checking that if the user is already stake any token in the contract, means he has some contract and he tried to stake the token second time. So that's the case. In that scenario we have to calculate his reward, and in that we have to simply pass this user. Else he's tried to stake the token freshly, so in that we'll call this latest reward calculate, and we're going to pass this current time. So this will give us the time when this particular reward is getting calculated and is going to update in the state variable of the user. Then we'll simply update the user. Okay, now we have to simply take the user stake amount and we have to increment that. Then we'll take the user latest stake time, we have to update that as well. Then we have to update the total stake token in the contract. Then we have to check for the required condition. We'll check that ERC20 taking the interface, then we are taking the token address transfer, and we are simply transferring the token from the user address to the contract address, and we are passing the amount. Simple. Otherwise we have to throw this error message, failed to transfer tokens. Hope you guys are understood that what we are doing exactly here in this particular function. Okay, these are the simple logic we have implemented. Then we have to start the the event, stake event. So this is the entire function we have for the stake, which going to be run internally. And now we have to work on the second function called and now we have to write the function which allow user to withdraw their token from the contract. We have written the staking one, and now we have to write the withdraw the token. So we'll call it function call unstake. It will take the amount external non-reentrancy, and when trajectory has balance, means when he try to withdraw the fund, we have to check at least he has some amount in the contract or not. That's why we are calling this modifier. And at the end we're going to return the fund he want to withdraw. We'll call this address user. We have to identify the address. Then we'll say required amount not equal to 0, otherwise we have to throw this error message, because if he doesn't have any fund, then he can't allow to withdraw the fund. Okay, that's a simple logic. Then we have to do the second check. We'll say is staking holder is true, so it will return whether it's true or false. Otherwise we have to throw this error message, not a stakeholder. The third check we have to do is that we have to check for his amount, the amount he tried to withdraw he has or not. Otherwise we have to throw this particular error message, not enough stake to unstake. Then we have to simply calculate the user reward, and now we have to calculate the reward which user have earned so far after staking the token. So we'll say calculate reward, and this is the function we're going to create internally. Just wait. In that we have to pass the user address, and it will give us the balance of the reward. We'll take a uint variable and we'll say fee early unstake. So we have to take the fee, because if we try to withdraw the fund without completing the period, we have to take our commission. So we can come here, we'll take a if get current time is less or equal to the user last stake time plus 7 the days plus day, since he tried to withdraw the fund before completing the entire time. If that's the case, we have to call this staking amount, and we have to simply multiply with our percentage. So this is the denominator we have defined, and we'll initialize this event. In that we have to pass this amount and close this one. This is the simple check we are doing. We are simply confirming the time, the current time, and the exact time of period. So this one is the simple if statement we have built. First we're trying to get the current timing when the user tried to withdraw the token, and we are checking the time which is assigned for the contract to be hold the token. If the current time is less than this one, the exact period, then we have to take our commission, and that's what we are doing exactly here. Then we'll take a uint variable, say amount to unstake. We'll pass the amount, and we're going to simply subtract the fee because we have to charge that one. And that's the subtracted amount we have to simply transfer. We'll subtract from his balance, and we'll also subtract from the total token staking. And here we're going to say if user stake amount is equal to 0, means he has nothing, then we have to delete the user, because obviously if he has no token hold in the contract, we don't want to show that we have one user who stake the token, because there is no token in the contract. So how it would be possible that we have one user who stake the token? So we have to simply delete that particular user, so it will be 0. Total user minus 1, we have to delete that one. We have to decrease it exactly, okay? Because whenever someone will store their token, it will go up 1 2 3, but whenever someone will withdraw, it will come down. Now we can simply check this require statement, and we have to make the condition. Now we have to check for this require statement. So we'll say ERC20 token. We are taking our interface, then we have to pass the token address, and we have to simply transfer the token to the user. Otherwise we have to throw this error message if anything goes wrong. And then we have to initialize our unstake event, and that's the entire contract we have for the withdrawal, the unstake token. So hope this entire thing makes sense. This is the simple logic we have built. First, we are identifying the user who tried to withdraw the fund. Then second, we are checking his balance. Third, we are checking the time period that when he tried to withdraw the fund, it's in early or he has completed the entire period of the contract. If so, then we are simply, if we try to withdraw the fund before the time periods end, we are charging our commission, and when we are updating the simple state variable. That's the simple logic, and at the end we are simply transferring the fund. And now we have to write the function which allow user to claim the reward. So let's write it. We'll say function claim reward external non-reentrancy, and we'll say when treasury has balance, because these are the two must function we have to use. It's going to return the reward amount for the user. We'll calculate, we're going to create this particular function internally, calculate reward. We'll pass the message.sender. Here we have to take a variable called reward amount, and we'll take this user message standard reward. Then we have to check for a condition reward amount greater than 0. We'll say total staking no reward to be claimed. Then we'll call the second one, because if he has something, then we have to use the interface to transfer the reward to his wallet address. So we'll take this token address, we'll call this transfer method, and we'll pass the user and the reward amount. Otherwise we have to throw this error message if anything goes wrong. Then we have to take the user message.sender reward and set the reward value to 0 in the user struct. And we have to take this message under the reward claim, that how much reward he has claimed so far. So we have to simply pass that amount, and we can initialize our event reward claim reward event. And that's the simple function we have. So first we are checking for it, then we are transferring the reward, then third we are simply updating the user struct, and at the end we are simply starting the event. That's a simple function. So this is the end of the user function which user can call in the front end part. Now we have to build the internal function which we're going to call it internally for calculating of the times and reward. So now we have to create a function which allow us to calculate the user reward. So we'll say function, and it's an internal function. We'll say calculate reward. We have to pass the address of the user, and it's going to simply calculate the reward, and it's going to provide us. So we'll say unt variable unt user reward, and it will say current time, and we're going to simply call this get user estimated reward function, and that we have to simply pass the user address. Then we can simply come here, we'll take this user, because we have to make the reference to the user struct, and there we have to simply update the user reward balance. Then we have to take this user last reward calculation time, we have to update that as well. So this is the calculate reward function we have. We are calling this particular function get user estimated reward. It will give us the reward and the time, and that's what we are simply updating it. Now we can come here, and now we have to write this particular function get user estimated reward, and that we have to pass. We'll say function get user estimated reward, and we have to pass the user address, private view return, and it's going to return the unt variable. We'll say this unt user reward. Then we have to take this user timestamp, and we can get it from the user struct, the last time the reward got calculated. Then we can take this user current time, and we can get it with this function which we're going to create in a while, get current time. Then we have to take if current time is greater than the user last take time plus the days. If this statement is true, then we have to take this current time, and we have to take this stake time and the day. We have to simply update that current time to the stake time. Then we'll take this total stake time to the current time, and we're going to simply subtract with the timestamp which we are getting from the last one. So that's how we can calculate the difference. Then we'll take this user reward, and we'll say total stake time multiply by user stake amount multiply by the app rate, means the 20%, and we'll say to 365 days. Okay, hope this is clear to all of you, because this is the logic we have built, because we are going with the 20% app rate. So you can define this app rate to any number, but it would be in percentage, so 20%, 40%, 60%. So that's a simple calculation we are doing. We are taking the total stake time, we are multiplying with the stake amount, then we are multiplying with the total app rate, and then we are dividing with the total days, and this will be in the denominator. So this is the denominator we have defined above, and this is the simple calculation. Then we have to do the second check. We'll take this return, then we have to simply return the user reward and the current time, and that's the simple function which will allow us to calculate the fund. So the entire logic is happening. We are simply calculating the reward, and then we are checking for the current timestamp, and then that's what we are returning here. And now we have to write the last function in our smart contract which will allow us to get the current time. So we'll say function get current time, and we'll say internal view return. It's going to return the UND. So all we have to do is to return that. So we'll say block.timestamp, and that's it. So this will give us the current time of the function calls which we can use in our other function. So this is the entire smart contract we have written. Hope you guys have got an idea. So this is the address contract we have completed. This is the context. This is the ERC20 interface. This is the ownable. We have reentrancy guard. We have the token, our custom token, and this is the staking contract. This is pretty huge. So I believe that you guys have understood every single logic we have implemented here. So try to understand that what we have done exactly here. You guys have understood every single thing we have covered in the smart contract section. So we have written tons of contract and we have utilized in our staking contract. So try to rewatch the video to understand every single thing that what logic we have implemented. If you have stuck anywhere, try to rewatch to find it out. And with that, we are done with this entire smart contract. In the next video, we're going to start building our context. We're going to build our state management. We're going to build all the logic for our application to be working. After that, we're going to work on the front end side. So let's move to the next video, and that we're going to build our logic for application to interact with our contract. Hey all of you, hope you guys are great. So finally we have completed all our smart contract. In this video we're going to work on our context management, and we're going to write all the functionality which allow us to interact with our smart contract and which allow us to stake the token. Okay, so here I have opened the project, and here you will find all the folder and file structure. So come back to this JS file folder. Inside that you will have all these files and this folder. So in this video we're going to work on our header JS file. There we're going to define all the global variable which we're going to use in our multiple file. So it's kind of state management we are doing here. Okay, and that's what we're going to work in our header JS file. So let's start writing the code in our header JS file and define all the global variable. So we'll take a variable called network ID. By default we are going with the polygon. The second one is going to be the selected contract. So we have 4 different contract, and user can select any one of the contract. So that's the variable we have to take. Then we have to take the selected contract network name, and that we have to define all the variables. So first we have to define the network name, which is going to be the polygon. So if you can pick any network like mainnet or Ethereum, Solana, you can take any network. Here we have to provide the explorer URL, so they can click and they can go to there and they can verify. Then we can define the staking contract, and this one is staking. In that we have to define the 4 different contract, so user can pick. So let's come here. We'll say this is the main network which I have defined. I'll simply write it down. Now we'll have the 7 days contract, and this name, the name I'm giving here, 7 days, 19 days, these are the most important one, because on the base of this user will select the contract. Okay, so make sure to give the exact name, and this is the exact name we have to pass on the function. So just code along with me, everything will make sense. So we'll take an object, it will have the address, and we have to do for the other different staking period 10 days. Then we'll have the 30 days, 32 days. And with last one we'll have this 90 days. And these are the contract which I have already deployed on the Polygon. So if you will get the final code, you will find that these are the contract which is deployed and which I'm using on. So that's why I'm using the same addresses here. But we're going to deploy the contract together, don't need to worry about that. So this is the entire staking one, and here we have to define the ABI. So all the contract will have the same ABI because we have to redeploy the same contract with the different initialization. So later, once we deploy the contract, we'll get the ABI, and that's the ABI we're going to paste inside this. So this is the staking one. Now we have to do for the token. Same thing we have. So now we have to do the same thing for the token. So we'll take the token, we'll take the symbol, we'll take the address. You can have multiple token, but I will go with a single one. Then we'll have the ABI of the token. These are the global variable we have defined for our token and for our different contracts. Now let's take a couple of more variables. So let's take the countdown global, which we're going to use. So let's call it countdown global, and we'll use this variable to check the time period so we can display our countdown time. Now the second one will be the wallet connection. So we'll take this let web3, then we'll take the contract for the token, then we'll take the contract call, and by default we're going to reload the 7 days contract. So whenever the user will come to our application, we're going to call this 7 days staking contract, but as a global variable we're going to go with the 7 days. Now we can come here, we'll take this current address, means once the user will connect, we're going to simply update that address to the global variable so we can use in our different application in different places in our application. Then we'll take this web3, and we have to simply provide the RPC URL of a polygon, which we're going to use it to fetch the information. Now let's create the instant of the notified, and again we are using this particular library to display our error message. So let's configure that notify, and in that we have to send a couple of things. So duration, we have to send the position x right, y bottom, and again you can check their documentation, but I'm going to use it straight away. And that's pretty much. Hope this entire thing makes sense to all of you guys. This is the most important file because all the update of the state variable we're going to do it here, and based on this data we're going to call the contract, and we'll allow the user to call the contract and reload the information. So this is the most important things which you have to keep in mind. So this is the entire staking contract and the token contract. This is the countdown, and these are the state variables we have. In this common.js file, we're going to write all the functionality which allow us to communicate with providers. So we have to trigger MetaMask, we have to find out that which network we are connected with, and we have to look at for the event. So if users change his or her account, then we have to listen for that, and we have to fetch the relevant information. So all the basic functionality we're going to write here in the common.js. So make sure to open this one and let's start working on it. So let's write the very first function. It's going to be an async function, and we'll say common provider. So what in this function we'll do, we'll try to fetch that what provider we are using. So right now we have multiple providers like MetaMask, we have a web3 wallets, and different type of wallets we have. So we have to fetch that which provider we are using to make the interaction with the blockchain. So in that we have to pass the provider, and first we have to build this if statement. So we'll say if provider is equal to the MetaMask. Okay, so I'll totally focus on the MetaMask, but you can definitely focus on other wallet, but I would recommend to go with the MetaMask, and after that you can do the modification. So we'll say if provider equal to the MetaMask, then we have to say if window.ethereum, because if we install the MetaMask, there is a Ethereum object in our window, because Ethereum wallet, the MetaMask wallet will inject this Ethereum object. So we'll say window.ethereum and window.ethereum.provider. So we'll have this particular data in that, and we'll take this variable called MetaMask provider equal to window.ethereum.provider, and we have to call this find method. In that we have to pass the provider. We'll say provider is MetaMask, then we'll simply close it down. So that's a very simple function we are doing. We are simply connecting the provider, and we are checking for that is that MetaMask is or not. Okay, all of this data you will find in this window Ethereum object. So that's the data I'm just simply taking here. So now I'll say if MetaMask provider window.ethereum provider equal to the MetaMask provider, then I'll take this return, and I'm going to call this particular method. So this is the function which I'm going to call, and it's an internal function. We'll say common injected connections, and in that we have to pass the provider, and we'll pass the provider. So MetaMask provider which we have taken, and this is the provider which we have got from the function. Okay, so that's what we have here. Now we'll say else. If it's not there, then we have to say console.log metamask wallet not found. Means the metamask wallet is not there, the user have not installed that one. So in such scenario, we would recommend the user to install the metamask. So we can do that very easily. We'll come here and we'll say window.open, and we're going to provide this metamask extension location, so user can go there and they can download it. That's the simple logic. Come here. Now we have to simply return false, and then we have to simply close that one. Come here. We'll take if window.ethereum, then return await, and we're going to call this common injected connections, and that we're going to pass window Ethereum and the provider. Else we have to console log out this particular one, metamask wallet not found. Then we'll take this try and catch block. We'll say window open, and we have to open that so the user can click on the button and it will go to the there. So we have to check for the multiple conditions. First we have checked based on the metamask, and the second check we are doing based on the Ethereum object, and we'll call this focus. Then we'll catch an error if anything goes wrong into that. So first thing we have to say return false, and we have to simply close that one. So this is the very first function we have written, which allow us to find out that which network we are connected, which wallet we are using. We are focusing totally on the metamask, but you can go with any other wallet. The process is exactly the same. So we're done with the very first function. Let's move to the next one, and this time we're going to build this particular function, common injected connect. This is the internal function we have used in the provider, default provider, and in that we have to simply pass the provider and the provider name. Then come here, call this await provider.enable. Then we can come here, we'll say take this set web3 event, and in that we have to simply pass the provider. And again, this is the internal function we're going to create, so we are just using right now. Come here, we'll take this web3 and we'll say new web3, and we'll pass the provider. We'll say get connected chain ID from Ethereum node. So we have the entire object in our web3 model, and from there we are getting the chain ID. So let's take this let current network ID. We'll say await web3.ethereum chain. This will give us the chain network ID, and then we'll say current network ID equal to the current network ID, and we have to convert into a string. Then we'll take this console log, so we can check in our terminal, in our browser console. Let's come here, let's look for the account. So we'll say window.ethereum.account, and this will give us the account, an array of account. So we'll take this one account, and we have to get the very first account. So we'll take it like it. Come here, we'll take this current address. We have this first account, and we have to convert into a lowercase. So the address will have an uppercase or lowercase, and we are simply converting the very first account into a lowercase, and we are setting that to our global variable. So I hope you guys have watched the last video, the header part, in that we have defined couple of global variables, and there we are updating it. So that's what we have. Let's say if current network ID is not equal to the network ID, in that context we have to throw our error message. So now we have to call our error component, and we have to simply pass the error message. So please connect wallet on network, and we'll pass the network name. So like it will automatically fetch the network which we are connected. So this one is the dynamic one. No matter in which network you deploy your contract, it will automatically fetch the name of that network, and it will display in the error message. Close this one. Now come here, we have to return this false. Just simply close this one. Come down, we have to take this contract, and now we have to take the variable we have defined for our token contract, and that's what we're going to use it here. So we'll say new web3.ether contract, and in that we have to simply pass the network, the ABI, and we have to pass the address of the token, and that way we can able to fetch the contract, the contract, okay, the token contract. So once we have the token contract, we can simply return this true, and that's the only thing we have to do here. So hope things are making sense to all of you guys. Whatever we have covered in these two functions. Now we can simply come here, let's write the third function, and in that we're going to build this particular function, set web3 event. So this is the function we have used internally in the injected. In that we have to simply pass the provider, and here we have to build the logic. We'll say provider on change. So in this particular function we're going to listen for all the events. So when the user will change his account address in the MetaMask, we have to listen for the events, and when he log out or when he transfer any fund, we have to listen for all those things. So we'll pass this account chain, and we'll pass the account, then we'll call log out the account address. We'll say if account dot length means, then we have to simply call this logout, else we can simply say current address equal to the first account. Simple. And we're going to take our contract. So this is the variable which I'm going to take, and we're going to simply call this get selected tab. This will give us the contract, and this particular function is reliable to let our application know that which contract we are interacting with. Okay, so we'll call this particular function, and we're going to simply close that one. Now come here, let's subscribe to chain ID. Okay, chain. Come here, we'll take the provider and we'll call this method on changed, and we'll pass the chain ID. Then we'll take the console logout, the chain ID, then we can log out simply from the application, because whenever the user will change we have to log out the user. So that's the chain. Now we can take the another one, we'll call it subscribe to session connection. We'll take the provider, we'll call on connect. In that we have to simply console log out the connect, and we have to call this logout. So this is the third method we have. Now we can come here, we'll take the fourth one, we'll call subscribe to session disconnect. We'll take the provider on disconnect, and we'll pass two arguments, code and reason. Inside that we're going to take this console code and reason, and then we'll take this local storage, and we're going to simply clear that one. We're going to remove everything from our local storage, and we'll call this logout, and that's the web3 function we have is ready. Hope you guys are following that what I have covered so far, whatever I have explained, everything is making sense to all of you guys. Okay, we're just building basic functionality which allow us to interact with the MetaMask and look for the chain event which user is doing for changing the network or changing the ID, all of things. Okay, so let's come down and let's work on the other function. And this time we're going to call this particular logout, and in this it's a pretty simple function. All we have to do is we have to simply reload the browser. So this is the logout function we have used, and that's what we are building. Let's come here. Now we have to work on the add decimal, and this function is really very important for us to use in our project, because we have to just convert the user amount into ether. Okay, because you know that the transaction take place in terms of way, so we have to add 18 decimal points. So that's the function we have to write. So we'll call add decimal, and actually I found this particular function in the GitHub repository, but it was in the TypeScript, so I converted into a JavaScript. So in that we have to pass two arguments, num1 and n-decimal. We'll take a variable called na_num, and we're going to simply split it out by comma dot. We'll say if a_num1, if a_num length greater than the decimal, then we have to simply pass this slice to 0 and the number of decimal. Okay, if it's not making any sense, if you are confused, just follow along with me. It's simple function which allow us to convert the ether into way. So that's what we are doing here. Just follow along with me. Then we're going to simply return this, and we're going to simply add all of this, and we're going to replace this with this. Come here. Now we have to return this a_num0 plus 0, and we have to repeat end. So that's our add decimal function. Hope you guys have understood that what we have done. It's a simple JavaScript. All we are doing that we are identifying the number, and we are splitting it by the comma. Then we are making some logic and doing some calculation and providing some methods on that based on the length. Pretty simple. Okay, so again I don't go into deep. just simply type this one, and this is the very common function you will find in most of the application which convert in like number into way and ethers. Okay, so this is the function we have at decimal. Now come here. Now we have to create another function we'll call format ether error message. So in this we're going to build all the logic. So you can see that our notification pop-up shows the error which is occurring in our application. So here we're going to build the entire model, and we're going to pass this message to our notification bar, so user can know in the front end that this is the error happened in the function call. So let's do that. So in this particular function we're going to pass the error object. So we'll come here, we'll take this try and catch block, we'll take this variable and we'll say eForm error.message index of this, and we'll have this e2 and last index of. Then we'll take the var m1 error message index of token staking. Then we'll take the fourth variable em2 error message index of erc20. Then we'll take this var em4 error message index of internal json rpc error. So these are the variables we have taken. Now we can come here, we'll take this if error from is not equal to -1 and error2 is not equal to -1 error m1. So we have to set the same variable. If this is the condition, in that context we have to take this variable, we'll say error message stem, we have to convert into a json, we'll say parse, and we have to pass the message. We'll call this particular method which is there in the error object sub star, and we'll pass our informations error from error2. Then we'll take a variable, we'll say message, and we have to simply build this particular if else statement to display different messages. And by the way, this all information is there in the error object when you will try to filter the data. I'm not going to getting into that details. That's a simple logic, simple JavaScript. Now we have to take if em not equal to this, then we have to return the token staking, the first index message, else we'll return the split erc21. So you can see that we have two different contracts, one for the staking, and that staking contract has a multiple variation, like for 7 days, 30 days, whatever days you want to set. But we have two different contract for the token staking, and for the erc20 token we have only one contract. You can add multiple the way we have done for the other staking contract, but I will go with the simple approach, and I want you to go with the simple approach. So this is the one logic we have. Now we have to simply say else return error message, and we can simply catch this error if anything goes wrong in between that. So we're going to simply log out that, and we're going to simply return this something went wrong, and simply close this one. So this is the entire error function we have, which allow us to find out that which error causing in bit particular contract, whether it's a contract or whether it's a ERC20 token. So again, don't need to worry about that, because this is the general convention message which I found in the library, and again I have converted into JavaScript from TypeScript. So now we have to work on this particular function get selected tab, because we have 4 different tabs for 4 different contracts. Okay, so we have to select that which tab, which contract user is interacting, whether he's interacting with the 7 days or 30 days or 90 days. So in that we will pass this s class, actually it's a object name, and we can come here, we'll say console dog the class, then we have to return the class, else we're going to go with the default contract which is a 7 days. Okay, if user have not selected any tab, that means we'll go with the 7 days staking, but if he has selected any, and that's the variable we're going to set it, and that's the only thing we have to do here for this particular function get selected tab. Now let's write the other function for get contract object, and this will give us the contract object based on the name. So we can come here, we can take this return new web3.contract, and in that we have to pass the ABI and the address. So we'll say select contract network ID staking ABI, and here we have to provide the dynamic address, and that way we can easily able to find that which contract we are interacting with. Everything will make sense, just follow along with me. And that's the function we have done with get contract object. Now looks pretty good, and this is the entire function we have written. It's a pretty huge one. You can see we have so many things is going on, but if you look at, these are the very simple JavaScript we have written for fetching the information, for building the connection. So this is the very first function we have, common provider director. This will trigger to find out that which provider we are using in our application. Simply close this one, and that's the one we have. Now we have this common injected provider. In this we're going to calling in this we're going to simply pass this variable, and we're going to simply make the connection with the blockchain. And that's what you can see here. That's what we are doing here. We are looking for all the events which is taking place in the chain. Now we have this set web3 event. So simply we are setting up the account, and we are finding the contract which the user is trying to interact at the initial, when the application will reload. So that's the one we have. This is the logout function. You can see these are the multiple functions we have included into this chain, connect, disconnect. So these are the functions we have included. This is the logout one, and this one is the decimal one. So close this one, and here we have the format ether message here, and here we have the get selected tab. By default we are going with the 7 days, but if user can select any contract, and that's the logic we have built here. Simply close this one, and this is the function for getting the contract object, and this will be the setup. So all we have to do is to call this get contract object function into our smart contract function, and we'll have the object of the contract, that which contract is user is interacting with. So it's a kind of context management we are doing. So in React we have a state management, just like that we have here in the context management we are doing. So this is the entire function we have written in the common.js. Hope you guys have found everything clear here. Now we can move to the next one. So click here. Now we can simply go back to the other function. All of you, hope you guys are great and you guys are enjoying this project. In the last video we have completed our common.js functionality. So we have built all the functionality which allow us to communicate with our providers, the blockchains, and listening for different events. We have written some important function for managing the errors. So if you guys haven't watched that video, I'll link in the I button or in the description so you guys can watch that. In this video, we're going to start working on our smart contract functionality. So we have written the smart contract. Now is the time to build the function which allows us to interact with the front end and where we can call the smart contract. Here we are in the index file, and by default we're going to call two functions. The first function will reload the entire information, entire data about the smart contract, and it will display in the front end, and we're going to call the MetaMask. So the MetaMask pop-up will pop up so the user can connect their wallet. So let's call this function call, and first function we're going to build is this one, load initial data. In that we have to simply pass the contract. So we have different contracts. So what contract data you want to load? So I will go with the 7 days contract, but this one is dynamic. User can select and they can change it. So I'll pass the name, which is the 7 days, and this is how we're going to load the data. So all we have to do is to change this particular string. So it is 7 days, means 7 days contract we are looking for. If we go to the 90 days, we'll pass this 90 days. If we go to the any other contract name, so that's the name we're going to simply update, and it will give us the information. Let's call the second function. We'll call it connect me, and in that we're going to simply pass this particular provider, and it will trigger the MetaMask. Now we can simply call him here. We'll call this connect wallet, and we're going to create one function which allow the user to connect based on the click event of the button, but that one is totally optional. I'll go with a simple approach. Now we can come here. We'll create the very first function called open tab, and in that we have to pass this event and name, and here we have to simply update that which contract user tried to interact with. So we'll take this console.log, and we have to look for the name which you can easily able to find in the terminal, which we're going to look at. Now I'm going to simply take this particular contract call, because this is our global variable which we have defined in our header file, and we have to simply update the contract name the user tried to interact with. Then we'll take this get selected tab, and in that we have to simply pass the name. So this will also update our global variable of the user interaction and the selected tab. And we'll simply call this particular function load initial data. So this function is absolutely ready. we're going to pass. So in this function, what we are doing, we are updating our global state and we are updating our initial load data function, which will give us the relevant data of the contract. So this is the very first function. Now we have to write the second function, and this one is going to be a quite big one. So we'll call this async function and we'll say load initial data, and that we have to pass this s class, and this is the name of the contract. And first thing, we have to console log out this s class. Then we can simply take this try and catch block because we have to catch an error if anything goes wrong. Then we'll take this clear interval because we are displaying our counter time on, and I want to remove that one. So that's what we have to clear here. We'll pass this countdown global because this is the global variable we have here, and we have to simply pass the global variable. Now we can come here, we can take this let contract object, and we can get that very easily. We have to simply call this new web3 main, and we have to pass the relevant information about the contract. So this is the dynamic contract, we're going to use it. So we'll say selected contract chain ID staking, and we have to have the API because all the contract will have the same API. The only changes we have to do in the address of the contract. Now we have to get the address. We'll say selected contract network, and we'll take the staking, but here we have to provide the class, and we'll say address. So in that way we'll have the address of the contract which user try to interact with. Now we can come here. So we got the contract object. Now we can build and we can simply fetch all the information from the contract. So we'll take this ID element. So we're going to target all the element based on the ID. So we'll say let total user await contract object, and we have to call the function get total user. It will give us the data. Now we have to simply take the data of the percentage, which we can get app, and we're going to simply call it. Then we have to get the user. We'll say let user detail await. We'll say get user. We have to pass the current address. We can come here. We'll take this const user, and here we have to simply update all the information. So we'll take this last reward calculation time, and the data is available here in the user detail. In that way we have to simply update all the time. So we'll say user details stake time, reward amount, user detail reward amount. We have reward claimed so far, user detail reward claimed so far. Now we have this stake amount, user detail stake amount. We'll come here, we'll take the address, and we have the address of the user. So we can simply take this in this particular object, and now we have to store this one. So we'll take this local storage, and we're going to simply store in the local storage so we can display in the front end part. You can use the backend API, but I'm not going to use that one because again it's going to be a centralized. I just want to make it 100% decentralized. So all the information we're going to store about the user in their local system. So let's stay there. Now we can come here, we'll say let user detail balance, let user detail balance, user detail stake amount, and we have to convert it into a way. Now we'll take this document.get element by ID. So this is the ID we have to assign in our HTML. So let's target that. We'll say total locked user token, and we have to simply update the information, the amount. Okay, so make sure to give the exact ID name which I'm giving here because this is the exact ID we're going to give in our HTML, so the data will display in the front end. So that's the first thing we have targeted. Now let's take the element ID. Now we'll document.get element by ID, and the ID we have to target is number of stakers value, and we have to simply update in our HTML. Now we have to get the document.get element by ID, and we have to get the percentage app value feature, and we have to simply update that one. So we have updated all this in the HTML. Now let me give this comment. Now we have to target the element based on the classes. So we'll say let total locked token, and we have to call our contract to find out. So we'll call this particular function get total stake token. Then once we have the data, we have to call this particular one unstaking fee, which we can get from the contract. Let's call the function early unstake fee percentage and call. So this will give us Now let's come here, let's target the element. So we'll say document dot get element by id, we'll call total locked token value, and we have to simply update the data in the element. We'll say total locked token and we have to convert it into ether, and we have to it will display the token name. So we can come here. Now we have to get this document dot query selector all, and we have to get this one unstake fee value. We'll take this for each because we have 4 different component and we have to display the same value in 4 different component. That's why we have taken this query selector all, and that we're going to take this function. We'll say element, and then we have to simply update the inner HTML data with the data. And here we are going with the percentage, and here we are going with the percentage. So that's what we have here, and simply updating. Now we'll target the let minimum staking. So let's get that from the contract, minimum staking amount, and call the function. Let's call the convert it into a number. Then we can simply take this one is going to be a dynamic one. So if user has the token, then we can display the balance. Otherwise we allow them to go to the specific place and they can buy the token. So if you have a pre-sales token page, so we can redirect them to there and they can buy it. So let's build that logic. So we'll say if minimum staking, then we'll say minimum a the amount, and we have to simply convert it to the string. So we can display that, and we'll display the token symbol, means he has something. Else we can allow the user none, or you can display a particular message where a user can go and buy. But for the timing, let's go like this. Then we can come here, we'll take this document dot query selector all, and we have to target the element, and we have to simply update that. So we'll run a for each because we have to display in 4 different components. So we'll say a function, we'll take the element, and we're going to simply target the inner HTML, and we have to simply update the data. So that's it. Then we have to target the document dot query selector all, we'll take the max one. So we have to do the exact thing for the max, and we're going to simply say delete inner HTML, and we have to simply provide this hardcore data, or you can take this data from the contract, but just keep it for the timing because this is the data, this is the exact amount I allow user to store in the contract. So we are going with this, and we can display the token symbol. Close this one. Now we can close this one. Come here, we'll take this variable is taking pause. So now we have to focus on the status, so whether the contract is allowing user to stake token or not. So that's the status we have to display in the front end. So we'll say is taking pause, we have to call the contract function. We'll say staking status, this will give us the data. We'll say let staking status pause text, so we have to display different status. Okay, so we'll say let start date await, and we have to get that, which is really very easy. Now we can come here, we'll say start date, we have to convert it into a number, and we have to simply multiply with this 1000, so we can convert it into a second. Now we can take this end date, and we have to do the exactly the same thing. So let's call the function. Once we have the end date, now we have to simply convert into a number, and we have to multiply with 1000. So we have start days, we have end date, and here we're going to build the logic. So we'll say take a variable called let stake days, so what days they are interacting with. Okay, so stake days. So now we have to get the stake days of the contract. So we have to call the contract called stake date, and we'll take a variable called let day, and we have to simply use the math, and we have to simply convert it into a timestamp. Then we'll take this let display date. Inside that we'll take this day is greater than 0, then we have to display day, plus if its days is equal to 1, then we have to display days as days. That's a simple JavaScript. Now let's come here, We'll take the document dot query selector all. We have to target that, and we have to simply update the text. We'll say display date. So this will display our time. Close that one. Now come here. We'll take a variable called reward balance. So how much balance is rewarded so far after staking certain token. We have to call the contract function. We'll say get user estimated reward. Call the function, and in that we have to pass the address of the user. We have to take the element and we have to simply display the balance of the user. We'll pass that. Okay, so we are converting into ether. So that looks pretty good, and we have to display the token name. Now we'll take this user token balance. So let's write that function for that. So we'll take this balance main user. We'll take the current address. And the reason why I'm building this particular logic, because sometime what happened that maybe the user is not connected with the MetaMask, so we don't have his address. So on the base of that, we don't want to have any error in our application. So that's why we are making this dynamic one. So if user has address, then it's going to be called this particular function. Otherwise, it's going to be skip. Okay. So we'll say if there is a account address exists, means user is connected, then we have to simply call this function, the contract token function, and we have to call the balance of, and we have to pass the address of the user. So in that way we'll have the balance. Otherwise we don't need to call anything. So simple logic. Come here, we have to take the balance and we have to convert into a number, and then we have to simply update into our HTML. We'll target the document get element by ID, and we have to simply target the element, and we have to simply update the inner HTML with the user balance. Simple function. Hope whatever I have covered so far, everything's making sense. And then come here, take a variable called current date, and we're going to use this JavaScript method new date, and we have to pass this particular function get time, because we have to get that one. We can come here, we'll take this one. If is staking paused, means the staking is paused, then we'll say is staking pause equal to pause, else if current time is less than the staking date, then we'll say is staking text equal to locked, because we have to check for multiple time period, for pause, for lock, for duration. On the base of that we have to display the status of the contract. So we'll say else if current date greater than the end date, means is staking is ended. And the last one is going to be the is staking is none of these, then means it's active. So this is the if else statement, and we are simply updating the data. Now we have to call the DOM element, and we have to simply update the text. So we'll say get selected all, we have to target the active stated staking, and we have to update the data. So we'll take this element, we'll call the element in our HTML, and we have to simply update the data in our HTML. That's it. Pretty simple. Okay, I hope you guys are familiar with JavaScript. So that's why I'm going a little faster, because these are the basic JavaScript we are doing here. Come here, we'll say if current date greater than the start date and current date is less than the end date, then we'll say const element, we'll say document dot get element by ID, and we have to get the countdown timer, because we have to display the timer. And we'll take the variable, we'll take this get generate countdown, and this is the function we're going to create, and in that we have to pass the two things, element and the end date. Then we can take this document dot get element by ID, and we have to get the countdown title value. Once we have the value, now we have to simply update that into the front end. So we'll say staking ends. Close this one. Come here, we'll say if current date less than the start date, that means element get element by ID, and we will say that countdown title value, we'll say generate countdown time, and we have to pass the element and the end date. Multiple conditions. Now we're going to take this document get element by id, and we have to simply update the data. So we'll say title inner html is going to be the staking started in. Okay, different stated for the countdown, one for end and the other one for is starting. Now we can come here, we'll take this document dot query selector all, and we have to target this app value, and we have to run a for each to update all the elements. So we'll take the element dot inner html, and we're going to simply call this particular percentage value. Looks pretty good. Come down here. Now we have to write the catch block if anything goes wrong. So we'll say error. First thing we have to do is console log of the error. Second thing is we're going to call our error component, notify error, and we'll display the message. So we'll say unable to fetch data from the network name, please refresh this page. So this is the first error message. Close this one, and that's the entire function we have written for reload initial data. So whatever we have done so far, I hope everything is making sense to all of you guys. These are the very simple function we have written. It's allow us to fetch the information from the contract, and we are simply feeding those data in our HTML. So that's the first function. Let's move on. Now we're going to write the second function called generate countdown. Okay, so let's build the logic for this one. We have to receive two data, element and the claim date. Then we'll say clear interval, in that we have to pass the global countdown logo, countdown global, and we have to clear that one. Now we have to set counting down. We'll take a variable countdown date, and we'll call this new date. In that we have to pass the claim date, and it will give us the time. So again, these are the JavaScript method which I'm using here. We have the once we have the countdown date, then we can build this one and update. We'll say update countdown every 1 second. So we'll say this countdown global, and we're going to simply call this set interval, and we'll pass a function because set interval take a callback function. And inside that we're going to simply take the today date and time. We'll take a variable call now, and we'll call this particular method. This will give us the current date and time. It's a huge string. So once we have the date, we'll take this find distance between now and the actual time, which is in the future. Okay, because we are allowing user to stake the token for a particular period. Okay, so obviously it's going to be in the future. So now we have to find the distance between them. So we'll take this variable called distance countdown date minus now, and this will give us a distance. So once we have the distance, we'll call this time calculation for days, hours, minutes and seconds. Then we'll take a var, we'll say days. We have to use this math property, and we have to pass the distance multiply by 1000, and we have to complete just convert this entire thing into days. We'll take this hour, this one is the day, and this one is the hour. So let's do the same thing, provide all this, and we have to multiply by 100, and then we have to simply provide this 60. So this is the hour. Now we have to do for the minutes, take the math distance, convert it, then we have to do 60, then we have to take the second, math floor distance 60, and this. So this will give us the second. Looks pretty good. So we have all the information, like we have days, hour, minute and second, and now we can feed this data into our component. So we'll say display the result in the element. Now we can say element inner HTML, and we have to simply pass the data. So we'll say days plus days, hours, minutes and second. So we are simply updating in our HTML. Right now we can see that we are taking this particular element dynamically into this particular function, or you can go with the hard code one, both will work fine, but I would like to make things more dynamic. Okay, and this is the another way which you can add to update the data, but this one has a different element. So that's the display one. Now let's write the another function. We'll say finish, write some text. So once the time period is over, we have to display certain text. So let's do that. We'll say if distance is less than 0, then we have to simply update the text. So we'll clear this particular interval, the global countdown, and then we have to simply pass this particular message. Refresh page means the time is over, and close this function, and we have to call this particular function every single second. So that's why we have given this 1000, and that's it. So this is the entire function for our countdown. Hope everything's making sense to all of you guys, and you guys have understood that what we have done and what logic we have tried to implement here. So let's move ahead further. These are the basic function we have written. Now let's write the another function, which is going to be async function, and this function will call connect me, and this will allow us to connect from the MetaMask. So in that we have to pass the provider, the name, and we'll say take this try and catch. We'll say let common response, we'll call this await common provider director, and we have to simply pass the provider. So this is the function we are using, which we have defined in our common JS file. So we are simply passing that provider in the folder, and it's going to set the entire variable. So once we have that variable, then we have to simply console log out, and we can say if common response is not there, then we can take this console.log please connect, means the user is not connected, and else let the contract which we want to interact with, in that we have to simply call this get selected tab, and by default we are calling this 7 days contract. Okay, so that's why we don't need to pass any data into this, and we have to simply console log out the entire contract object. And now we have to catch an error if anything goes wrong. We have to pass that into a notification, the error message, and that's the connect me function for the MetaMask. So far things are clear. Let's move ahead. Now we have to write a async function, and this function will call stake token. So this one is the actual function we are writing for interacting with our smart contracts. So whatever we have done, these are the basic functionality we have written, and now we're going to write the staking contract function. So we generally going to have two approaches to write the staking token functionality. One, you can write the entire function in the same function, but it's going to be a little bigger, so it's always better that you have to make two separate function. One function is going to be the internal function, and the one function is we going to use it for calling in the front end. Things will make sense, just follow along with me. So this is the name of the function we have given. Now let's build the logic. So we can come here, we'll take this try and catch block, because if anything goes wrong we have to catch that. We'll say let token, okay, so the amount of token which user wants to stake, so we have to get that value. So we can get it very easily. We'll say document dot get element by id, and we'll have this particular element, the input field will have this id, and from there we can get the value. So we have the token value. Now we have to take this if, means we have to throw an error message if the user called the function without providing any token amount. So we have to throw the error message. So we'll say return this. You can return error message as well. Now come here. So now we have to check that the token which user have provided is a number or not. That's the first check. Then we have to check that if it is equal to 0, and the third check we have to do is that we have to check that if that is less than 0. So these are the three check we have to do, and we have to simply console log out invalid token amount, and we have to return. So far so good. Let's move ahead. Now we can take this token and we have to convert it into a number, so we can pass into our functions, because we can pass as it is string because we have defined number in our contract. So we can take this let token to transfer. We'll take this decimal function because we have to convert that into a way. So we'll say add decimal, we'll pass the token and the 18 decimal points. It could be 16, it could be 8, it's totally up to you that what token you want to use it, because this function we have built add decimal, it will work fine for all the different tokens. So we'll have the token to transfer value in way. Now we can pass it. So we can come here, we'll take this console.log token transfer, and this is the amount we want to transfer. We'll take a variable called balance user. We'll take the balance main user, and we'll have to take await contract token, and we have to simply check for the balance of the user, whether he or she has the balance or not, which amount he want to stake. So that's the check we have to do. So once we check that he has that balance, then we can simply take the balance of the user and we have to convert it into a number, and we have to convert this into a way. Then we can console log out in the console. So that's pretty simple. Now we can come here. Now we're going to take this if statements. We'll say if balance main user is less than the number of token, then we have to throw this error message, and we're going to display that you can come to this place and you can buy that one. So let's throw that error message. We'll say that insufficient token on, we can define the network name, please buy some token, or you can provide any link so they can go there and they can buy that one. But just try to keep it like it for a time being. Okay, so now we can come here. We have to return this one and close this if statement. Let's take a variable called class, and we have to get the contract. So we'll say get selected tab, and in that we have to pass this particular variable contract call, and this one is the global variable we have defined our header. So by default this is what we're going to do it, and in this we have to pass the contract name which user try to interact with. So in that way we'll have the entire object. Now we can simply console log out and we can check in the terminal, which we're going to do it. Now we can take a variable called balance main allowance. We'll call the contract token contract, and we have to call this method allowance, and in that we have to pass the current address, and we have to pass the address of the token, address of the contract, staking contract, because the staking contract has the permission to make the staking and make things works. So we have to allow the staking contract. Now we have to call the function. So let's come here. We'll say if number means the main balance allowance is less than the token transfer, we can call this approved token spend, and in that we have to pass the transfer amount, and we have to pass the contract which user try to interact. If the token is not approved, if the main allowance balance is less than the token transfer, else we have to simply call the stake function. We'll call say stake token main function, and in that we have to pass the token transfer and the class, the contract. And that's the very simple logic we have built in this if else statement. What we have done that first we are checking for the allowance balance, that how much allowance the staking contract has. If he has less than the transfer token, then we have to first call this approve token spend and first approve the token and then stake. But if he has the enough approval, then we can simply call the stake token function, and that's what we have done. Now let's go ahead and we have to simply close this function. We'll call the notify dismiss, and we're going to simply call the error message. And by the way, if you want to learn more about this notified error, make sure to check the library. They have explained every single thing, that how you can use their library to display the error. I'm just using all the method they have. So this is the stake function we have, and now we have to build the internal function. So let's come here. We'll take a async function, and first we have to work on the approved token. So we'll say approved token spend. We have to take the minimum, the amount. It's coming in the term of way, and we have the contract. Let's take a, now we have to estimate the gas amount, because here we are using our native token for making the staking process, not any native change token. So we have to calculate the gas amount for that. So let's take a global variable. We'll say let estimate, and we can calculate that. That's a very easy. We have to take a try and catch gas estimation, and we'll say await contract token contract, and in that we have a function. So we'll say approve, and that we have to simply pass the two information. So we have to pass the address, and we have to pass the amount. So this will give us the estimation, and on that we have to call this particular function guess estimated gas, and we have to define the address, which address of the user who will pay for the gas. So we'll say from current address. Okay, so what I'm doing here, we are trying to estimate the gas cost for making this transactions. We are passing these two variable in our approve function, and we are calling this particular method get estimate gas, and we are defining the address who will pay the gas amount. So in this way we'll have the estimation of the gas, that how much it's going to cost for making this transaction. So this is the estimation we got for the gas. If anything goes wrong, we have to throw the error message. We'll say notify, and we'll have the error message, and we'll simply return that one. So this is for the estimation, and now we have to call actual function. So let's call that one. So we'll say on contract token, because token we have to transfer into the contract. So we'll say method, and we have to call this particular function approve. We have to pass the same data, we have to pass the address of the contract, and we have to pass the amount, and we have to simply define the gas amount from, and we have to define the estimated gas. And on this we can call multiple functions. So we'll call this on change, and we can simply log out the hash of the transaction hash, so you can check. So that's the on change. Now let's cut one more time, and this time we'll say receipt, and we can simply console log out the receipt. We'll take this stake token main function, we're going to simply call it. Again, this is the function we're going to build in a while. So first it will approve, then it's going to trigger this one, and everything will make sense. And then we have to pass the amount for transfer, because the staking is already done. Now we can simply catch error if anything goes wrong. Console log out, and we have to throw the error message, return, and close this one. So this is the approve function for our token. Now we have to work on the stake token main, which will actually stake our token into our staking contract. So first we have approve, then we have to stake. Let's work on the function. We'll say function stake main token, and that we're going to receive the amount and the class. So we'll take this let gas estimation, we have to calculate the gas amount. So let's get the contract. So we'll say contract staking, and we have to call this function get contract object, and all we have to do is to pass the name, and it will give us the object of the contract. Once we have the contract, we can take this try and catch block, and we have to estimate the gas cost. So we'll call this staking contract, and we'll have to pass the staking amount, because that's what it need in our smart contract. And we have to call this gas estimation, and then we have to pass the account, and we have to close this one. So in that way we'll have our gas estimation, and now we have to simply catch error if anything goes wrong. Now we can call our notification, and we can display our error message into that, return that one. So that's the one. And now we have to actually interact with our staking contract. So let's call the contract, and in that we have to call the stake function. We have to pass the amount, we have to provide this send method, and we have to pass the user, and we have to pass the gas estimation, and we have to look for a chain event. So we'll say on recipient. So in this we'll have the entire data. Now we're going to store a couple of data into a local storage. So we'll come here, we'll console log out the entire recipient. Now we'll take a variable called recipient object, and in that we can build the entire object, which we're going to store in our local storage in form of array. So we can fetch that, and we can display into the front end. So let's come here, we'll have this token, we'll take the amount, then we'll take the from, then we'll take the to, then we'll take the block hash, which is available in recipient block hash, then we'll take this block number, then we'll take the accumulative gas used, then we'll take the effective gas price, then we'll take the gas used. You can store as many data as you want, There is tons of data available in the recipient, but we're going to receive this data and we're going to store in our local storage. So let's go ahead, let's take the status, and we can take the transaction hash, and we can take the type, and that's the entire object for the recipient object. Now we have to take this data, we'll take an array because the user can take the token multiple times. So we cannot go with the one data, we have to display arrays of data. So we'll say transaction, we'll take a transaction history, an empty array, and all we have to do is we have to take a variable called const all user transaction, and we'll call this local storage. First we have to get that data, because when the user will call this function, first we have to get and then we have to push. So we'll call this particular variable local storage get item transaction. Now we'll say if all user transaction, we'll call this transaction history equal to the JSON parse. We'll say local storage get item and we have to pass the transaction history. Then we'll take this transaction history and we have to push that object. Then we'll take this local storage dot set item and we have to give the transaction and we have to simply push the data, the transaction history, and looks pretty good. So this is what we are doing. First we are getting, then we are pushing, and else we can simply display the transaction history and the recipient object, and we'll set this to the local storage transaction, and we have our transaction history. Okay, close this one, and that's the only thing we have to do here for setting the data after a successful stake. Now we'll take this console and we'll simply console log out all the transactions so you can see and we have to simply redirect the user to the analytical page. So let's build the URL analytical and close this one, and we have to look for the on change and we can simply log the hash of the transaction so we can see that whether our transaction is successful or not. And come here, we can call error if anything goes wrong, console log out the error, and we have to display the error notification, the error message, and return this. Close this one and close this one. So this is the entire function for stake. Hope things are making sense to all of you, that what logic we are following. Okay, let's move ahead. Now we will take a function. This time we're going to call unstake token. So we have written for the approval, we have written for the stake. Now we have to write a function for withdrawal of the token. Okay, if user decides to withdraw the fund from the contract, they can do that. So let's build that functionality. So we'll say unstake token. We'll take this try and catch block. We'll say let, we have to get the token, that how much he or she wants to withdraw from the front end. Once we have that, we have to do the couple of check. We'll take this if it's there, otherwise we have to simply return it. Then we can come here and then we have to check for the number, multiple condition, it's a number or its value is equal to 0 or its value is less than 0. Then we have to display our notification mirror message, invalid token error message, and then we have to notification error message, and then we have to return. So this is the if statement we have. Now we'll take the number token and we have to convert into a number, and we have to use the same logic which we have done above. So we're going to simply call this decimal and we have to convert it. Then we'll take this less, the contract, which contract user trying to interact with. We'll call this get selected tab and we'll pass the global contract, so global variable. Then we can take this let contract staking and we have to get the contract object. We have that. Once we have that, we have to fetch the balance of the user, and we're going to simply call this method get user address, and then we have to call the, so once we have the entire information about the user, we can simply get the balance of the user. That's how we can get it, and we have to convert it. Once we have the balance of the user, now we'll check for a condition. We'll say balance user is less than the token amount. Obviously, if this statement is false, then we have to throw this error message. We'll say insufficient stake token, and we have to give the network name. So that's the if statement we have, and we have to simply return it. Let's come here. But if he has the token, then we'll go on and we're going to call this particular function unstaken main, unstake token main. So this is the internal function we're going to create, and in that we have to pass the token amount and the contract and the class, and we have to simply catch error if anything goes wrong and display the error message. We have to dismiss first, and then we can display the error message and close that one, close this one. So this is the unstake token function we have, and now we have to build this particular function unstake token main, where we're going to build all the logic. So let's go ahead. We'll take a async function unstake token main. In that we have to receive the amount, we have to receive the contract, and we have to receive the class. Then we'll take a variable called gas estimation, because we have to calculate that how much gas fee we're going to pay for this transaction. We'll take a try and catch block gas. We're going to simply call the function. So this is the function we're going to call in the contract unstake, and then we have to pass the amount. Then we have to call this estimation gas. We pass the user address, and it will give us the estimation gas amount. We have to close this one, and we have to catch an error if anything goes wrong into that. Looks fine, and we have to display our notification error message. Now we have to interact with the contract and make this entire unstaking and transfer the token from the contract to the user. So we'll call the contract, call the method, and we have to call this unstake, and that we have to pass the amount. Then we have to set the gas estimation. So we'll take the user, and then we have to set the gas estimation. Close that one, and here we're going to get the recipient, and again this data we're going to store into the local storage, because this is the recipient data we have, where we have all the data. So let's take a variable called recipient object, and we're going to push this particular data into the array we have in the local storage. So let's build that cut quickly. So we'll take the token amount, we'll take the from, we'll take the to, and we'll take the balance block hash. We'll take the block number, we'll take the cumulative gas used, and we'll take the effective gas price. We'll take the gas use, we'll take the gas status, and we'll take the transaction hash, and we'll take the type. Simply close this one. So this is the entire recipient object, and now we have to do the same thing. So let's do it very quickly. First we have to get the transaction history, then we'll say all transaction we have to get from the local storage. Once we has from the local storage, we'll have to check for the if else state condition. We'll say that if there is a all user transaction, in that context we have to simply take those data. We have to get all the data from the local storage, and then we have to take the history, and then we have to simply push that into the transaction object, and then we have to set that to our local storage. Okay, we have set that local storage. Else we'll say transaction history, and we're going to simply push this object into our local storage straight away. We'll take the local storage set item, and we'll give the name transaction history, and we have to set our transaction history. Simple. Hope you guys can understand that what we are doing here. So if there is a data in our local storage with this transaction history, so then we are fetching those data, and then we are updating. But if we don't have that one, we are straight away updating that. So that's the logic. Looks pretty good. Close this one. Now we have to take this window and we have to simply reload the browser, or we can redirect to the user to the activity page. And let's close that one. And we can look for the transaction hash. So simply log out that data to the console so the user can check that. And we have to catch an error if anything goes wrong. So looks pretty good. And we can simply console log out. We can simply throw the error message, and at the end we have to return. So this is the unstaking, and now we have to build the internal function. So we'll say function claim token, and this function will allow user to claim the reward which they have earned after staking the token. So let's write that function. So we can take this try and catch. We'll take this contract. Once we have that one, we have to simply pass that to the contract object, and it will give us the entire contract object. So we got the name, then we are passing that name to the get contract object, and it will return the entire object of the contract. And now we can make the connection. We'll take this variable called reward balance, and we have to get the balance of the user from the contract. So get user estimated reward function we have, and that's we have to simply pass the address, and it will give us the balance of the user. So we'll have the reward balance. We have to convert it into a number. Once we convert that into a number, we can simply console log out. After that, we'll take this if reward balance means there is not enough balance, there is no reward, and that we can display the error message that there is no error, and we can display our insufficient reward token to claim, and we can simply return that one. But else he has something, then we can simply allow him to claim the reward, and we can simply pass the in this function claim token main, which we're going to create, and again it's an internal function. So in that we have to pass the contract and the class, and we have to catch if anything goes wrong. Let's console log out the error, and we can use the dismiss notification, and we can display the error message in our notification bar. Close this one. So this is the claim reward. Okay, we are done with this function. Let's come down, and now we have to create this internal function claim token main. So let's call a async function, and we have to give the name, and we have to receive the contract, and we have to receive the name. Then we can come here, we'll say we have to estimate the gas cost. Then we'll take this try and catch. We have to follow the same pattern. So estimation gas, we're going to take the contract, we're going to call the function claim reward, and we have to pass the account, and we have to catch console log out the gas, and we have to catch the error if anything goes wrong. So once we have the gas cost, and return that one. So once we have the gas cost, now we can simply call the function. So come here, we have to call the contract method. Now we can call the function. So let's call the claim reward, call the send. We have to pass the user address and the gas cost, and we have to call this on change recipient, and in that we'll have all the data once the transaction will go successfully. So we'll console log out the entire recipients, and now we're going to simply set the object. Okay, so we'll take this recipient object, and now we have to simply update the data into our local storage. So let's quickly take that one. The same thing we have to do here. Let me type it very quickly. So the entire object is ready. Now we can come here, we'll take a variable called transaction, an array, and the same thing we have to do. So we'll take this all user transaction. We have to get the data from the local storage first. We have to check for the length. If it's there, then we have to simply convert that into the local JSON. get that all, and then we have to simply push into an array, and then we have to simply set into our local storage. Simply set that, close this one. But if we don't have anything, then we can simply straight away push that into our local storage and set that. So local storage, set items, transaction, and we can pass the transaction history in stringify, and that's pretty cool. Once everything's done successfully, we have to redirect the user to the activity page, the profile page, and there you can find all the data. And now we can simply console log out the transaction hash, and that's the only thing we have to do here. So we have to catch an error. If anything goes wrong, console log out the error, then we can simply pass the error message to the notification component, and it will pop up in our front end. And that's the entire function we have written to this huge index file. Some of the functions are quite repetitive in nature, but I believe that you guys have got an idea that how you can build this entire logic and what we are doing exactly here. So we are fetching the information from the contract and we are passing into the component. First, for making the transaction with the smart contract, first we need the gas estimations, gas cost, and then we are calling this method. If you don't do that, if you call the method straight away, you're going to have an error because your contract will ask for a gas estimation and you will get that error. So it's always better that you have to calculate the gas cost which you go to pay for the transaction. So things looks pretty good. So we have this tree function, then we have this open tab which update the context, then we have our loading data function, then we have the counter, then we have the connect me, then we have the stake token, approve token spend, main, unstake token main, claim, and claim token main. So this is the function we have written. It's pretty huge, and now we are done with that. So we are done with this common JS, we are done with this header, we are done with this index. So in the entire thing is pretty awesome. And now what we're going to do is, and this is, we don't need this one, initial one, just leave that one. So we have done with this common JS, we have done with this header, and we have done with this index. So we have done with all the three important files which allow us to connect with our smart contract, and that looks pretty good. I'll close this one, and now we're going to start working, and this is the data folder we have. So right now we're not going to work on it. First we'll work on the staking file. We're going to build all the logics and connect to the front end. After that we're going to work on the other pages. So now we're going to start working on the staking page. So this is what we're going to work next. So let's move to that. Great. So finally, in the last video, we have done with the entire JavaScript, all the logic for connecting, managing the states. So all the functionality we have written. In this video, we're going to start working on our front end part. So first we'll start working on the staking page, and after that we're going to move on all the other pages. So here I've opened the project, and make sure to open that one. And you can see this is the data folder we have, and this is the entire JS folder. Let's come down here. Here we have this staking, and that's what we're going to work on it. So let's come up here. Things are looking pretty fine to me, and this is what we're going to work. So first thing, you have to install this particular extension, live server. Okay, simply search live server, and as you can see that I have already installed this particular server. You can click and you can see I have already installed this. So make sure to install that one and restart your VS Code, then it will become active. You can read that what it does. So come back here in the file, click on this, and this is how it's look right now. And here you will have a button, go live. So when you will install the live server, you will have the similar button. Simply click on that and it will open the application in your browser. So it's going to open the application in my default browser. I'm using Mac, so it's going to open in the Safari, but I would like to use the Chrome. So I will simply copy the URL, come back in the Chrome, and I'm going to simply paste here, and that's it. Hit enter. You can see we are connected and everything's working fine. Now we have to make it side by side so we can see that what we are working on. So I believe that you guys have got the starter file, okay, and I have already provided you all the CSS. All we have to do is to write the HTML and all the styling will take place. Okay, so let's start working on it. So here we are. First What I will do is I'm going to simply change the title. So I'll say the blockchain coder, and you can see the title is changed. We'll say ERC20 token staking DApp, and here the title is changed. Now we have to work on the icon, the favicon icon. So what we can do, we'll take this link and we have to get the asset. So we'll go back to the images. Inside the images we have this favicon icon, and we have to say icon, so our icon will display. Here we have. Now we can come here, we have to connect our CSS file. So we'll say, so first we have to remove this, we have to get into the asset folder, and we have this one. So this is the CSS we have attached for the notification. So I believe that you guys have followed the starter file, and that I've explained that what are the folders and files you will get. So that's what I'm simply connecting. So first notification. Now we have to actually replace this one, and here we have to define the type. So we'll say text/css. So this is the second CSS file, and now we have to connect our CSS file, the main one, and this will also come from the starter file. So here we have all the CSS file. So we're going to import this particular one, style CSS, and here you can see the color is changed. Looks pretty good. Now our CSS is connected. Now we can start working on the body. So bring this down, and first we're going to work on our loader. So whenever you will reload the page, we're going to display our loader, and I hope you guys have seen the preview. So that's what we're going to build. So let's call it loader, and copy and paste here, and then that we're going to define our loader. So let's come here, let's take a div. It will have a class, it will have an ID, and it will call game on. You can call game on preloader. We'll have a class called game on preloader. Inside that we're going to take a div. It will have a class called preloader animation. Inside that we're going to take a div. It will have a class spinner. We'll come down and we'll take a p tag, and it will have a class called f. So font width 5, and we'll say text center, text uppercase, and inside that we have to call this loader. So you can see our loader is displaying because we have already built all the CSS. I hope you guys know what is CSS class model. So if you use Tailwind CSS, this is what we do. We use the classes and the styling take place. Okay, so here we have the loader, which is absolutely working fine. Now what we can do is, let's come here. Here we want to take a couple of divs. So let's take a div. It will have a class called loader animation. Inside that we'll take a div. It will have a class called row. Height is going to be 100 viewport, and it will have a div. It will have a class called column3 single loader, and we'll have a padding 0. So let's take that one. Inside that we'll take a div. It will have a class called loader pg, stand for background. Simply replicate couple of times. So copy that one, and let's give me this particular text and grab this one. So simply copy this one and replicate couple of times. So paste 4 times. So we have this 4 div, and all things are looking pretty fine. We don't need to do anything. So this is the entire loader we have for the animation. So that looks pretty good. Let's have a look one more time. Everything's good. So this one is the entire preloader. Close this one. So we are done with this entire preloader. So that's the only thing we have to write. Now what we can do is, let's connect the JavaScript file, because right now you can see that our loader is keep loading, but this is not the behavior we want in our application. So when we reload the browser, only that time this loader will display. After 1 second or 2 seconds, it's going to be turned off. So what we can do is, let's come here, let's call all the script. So already I have provided all the scripts to all of you guys. So let's call that one by one. So we'll take a script, we'll go into the asset folder, and we have this JS vendor, and inside that we have to go into the JS, then we have to go to the vendor, and inside that we have all the CSS files. So we have to import one by one. So JavaScript file, let's import one by one. Copy this one, paste couple of time, and simply change this asset JavaScript vendor, and we have to pick this time proper. Then we have to remove this one. This time we have to pick Bootstrap. This time we have to pick the all minify.js and remove this one. And this time we're going to take this one gallery. Remove this one. We'll take the slider, replicate it one more time. Okay, let's come here. This time we're going to import this countdown. I hope you guys can hear the noise of a baby crying. She's my niece. She's crying and she wants to go out, so just ignore that. Now we have to call the other file, so we're going to call this sluffer, and we have all this JavaScript, so looks pretty good. Let's JS remove this part, and this time we have to install the main file, main JavaScript, and we'll simply remove this one, and it's going to have the JavaScript notify, and we're going to take this notification and save it. And once you will save, you will find the loader is gone. But if you reload the page, you will see our loader is displaying, means our JavaScript is working, and we have connected our JavaScript with our application. And let me give this comment, and down below this web3 functions script, so below this we're going to attach all the script we have written, but for the time being let's keep it like it. Let's work on the HTML, and after that, once we write the entire HTML, then definitely we're going to connect it. So we have this preloader. Now we have to work on this main component. So let's come here. Let's give this comment main start, and this one is main end. Inside that we're going to take a div. It will have a class called main, and inside that we're going to break down the entire application into a small component. So we'll have a header, then footer, then the main section, the banner section. So the all section we're going to define inside this. So let's create a header section, copy that one, bring it down, and let's call it end of header. Inside that we'll take a header tag. It will have a ID called header. Inside that we're going to take this nav. It will have a data OS attribute, so we can open and we can close, and this one is for the zoom out, and it will have a data OS delay, and this will be 800 for the animations. And now we'll take a class called navbar. We'll say game on navbar, and we'll take this navbar expand. So this is the entire header class we have assigned in the navbar. Looks good. Now let's come here. Let's take a div. It will have a class called container header. Inside that we'll take an anchor, and we're going to redirect to the HTML page, and we'll take a class. We'll say navbar brand. Inside that we'll take an image. We have to provide our image, the logo. Go to the logo folder, and we have to pick the logo, and you can define that all text. So we'll say brand logo. Here we have the logo. Looks pretty good. Let's come here. We'll take a div. It will have a class called margin left auto, and we'll take this, save it, and come here. We'll take a UL. It will have a class called navbar nav. It will have the items, and it will have a max auto. Then we'll take this li. It will have a class called navbar nav item and active. Inside that we'll take this anchor. We'll redirect to the index page, and we'll have a class called nav link active, and inside that we have to display our menus. So this one is the home one. So simply save it. Looks pretty good. Now what we can do is just do the inspect element, and let's see why our things are not displaying, the menus are not displaying. Okay, let's try to make it big. I guess because of the responsiveness, because that's the class we have attached. So what we can do is let's try to work on this list item. So we'll simply copy this one, the entire li. So simply copy this one and replicate couple of times. Okay, now we have to simply change this state. So first thing we have to change this one is the active going to be on the first one, and we have to remove from all the other ones. So select all of this, Control D or Command D, it will select and remove that one. So we have to remove all the active classes, but we have to keep in the home one. And here we have to change the page, so this will become the project 2, and this will say project page, and this will become our staking one and staking page. Let's come here, we have to call contact, and this will be called register, and we'll say initialize, and now we have to redirect to the analytical, and this will say profile. We have this extra, remove that one. Looks pretty good. We have all the menu, so let me make it on the big screen, and you can see here we have the menu. As I told you that because of the responsive classes we have attached, it's not going to display in the mobile phone, because we're going to create a different component which we're going to display in the mobile devices. So you can see we have the, everything is looking pretty good. So let's make it big, and this looks pretty good. Everything is working fine. We have all the menu navigation. Close this one. We'll take another UL. It will have a class called nav bar, and it will have the icon class. Inside that we'll take a li. It will have a class called nav item. Inside that we'll take an anchor tag, and we don't want to redirect to anywhere, but we have to assign a class called nav link. It will have the data attribute, we'll say toggle, and it will have this model, and it will have the data called target, and we have to target the search component. Okay, the search model we're going to open. So that's our anchor. Looks pretty good. Inside that we can display our icon, so we'll take a class, we'll use this icon magnifier, so the search icon we have to display, and we have our icon. So looks pretty good. Now we can come back here. So this is the one we have, so let's give this one nav bar toggle, give the comment, and we can come here, we can simply display our menu. So we can say nav bar toggle, and here we have. So simply copy this one, and that's what we have to paste here, and we have to change the icon, so we'll say toggle, and here we have to change the target to menu, and we have to change the icon. So this time we have to display the icon menu, and we'll say margin 0, so you can see our icon is displaying. So this is the menu icon we have. Looks pretty good. Now come here, we'll take a nav bar action button, so we have to display the button. Come here, we'll take a UL, it will have a class called nav bar nav action, and inside that we'll take a li, and inside that it will have a class called nav item. It will have a margin 2 pixels, and we have to display our anchor. So just ignore this noise, we have to remove it. Let's have a class called button margin left large auto, and we'll take this button bordered white. So you can see that's the button we have. Inside that we have to display our icon, the wallet icon, so we'll say icon wallet, and we'll have the margin right medium 2 pixels, and inside that we have to display our text. So here we have the button. Okay, we have something wrong here, it's displaying the text, but it has to hide the text in the small screen, so we have to see what's the went wrong. So this looks pretty good. We have all the classes, this one is also good. So you can see I paused the video for a while, and I found that I made a silly mistake. I put that text inside the icon, so that was the problem I had. So make sure to, you have to simply provide the same classes and simply cut and paste out of the icons, and everything is looking pretty fine. So this is the entire header component is ready for the mobile screen, but we have to build a component where we can display the mobile. So right now if you click, nothing will happen because we have to write for the mobile. So what I can do is, so come back here and let's call model responsive menu r start. This one is going to be for the mobile device, and this one is the end. If you click, nothing will happen, but we have to open the model. So we'll take a div, it will have an ID called menu, it will have a class called model, fade, and we'll say padding 0. Inside that we'll take a div. It will have a class called model dialog, and it will say dialog animate. Inside that we'll take a div. It will have a class called model content, and it will have a class height 100 pixels. Then we'll take a div. It will have a class called model header, and it will have a data attribute, so we'll say dismiss, and we have to pass the model. Inside that we have to display our menu, and we have to display our icon. So let's have a class called far times circle and icon, so it will display our close icon. Right now it will not display, so save it, and looks pretty good. Let's come here. We'll take a div. It will have a class called menu model body. Inside that we'll take a div. It will have a class called row width is 100, and we'll say class items padding 0 column 12 text center, and that looks pretty good. So this is the entire model component we have. So save it, and if you click on that, you can see our model, the mobile navigation is displaying our cross icons. Everything is looking pretty fine. So this is the model icon, and now we have to work on the search model. So we can simply format this. Let's come here, and here we have to build the component. We'll say model search area start, comment this one, copy and paste here, and this will be the end. We'll take a div. It will have a id called search. It will have a class called model fade padding 0. Inside that we'll have a div. It will have a class called model dialog, and we'll say model animate. Inside that we'll have a div. It will have a class called model content, and height is going to be 100 viewport, and we'll have a class called model header. It will have a data attribute, so we'll say data miss, and we have to close that one, which is the model. And inside that we'll take a search, and we have to display our icon, so it will have a class called far time circle. So the close icon, it will have a class icon close. So if you click, you can see we have this drop down search component. Looks pretty good. Now we have to write the code for the body, so we can come here. Well, target the div. We'll say class model body. Inside that we'll take a form element, remove this action. We'll have a class called row. Inside that we'll have a div. It will have a class called column 12 align self container, center. Inside that we'll take a div. It will have a class called row. Inside that we'll have a div. It will have a class called column 12 padding 3, and we'll have the header, which is a class called search title margin top 0 and margin bottom 3, and in that we have to simply type this particular text. What are you looking for? If you click, and here we have that one. Pretty good. Come here, we'll take a p tag, and we'll take this dummy text, so it's quite big, so let's remove a couple of. Now this one is look good. Now we can come here, and we'll take a div. It will have a class called row. Inside that we'll have a div. It will have a class called class column 12. We'll have this input group margin top medium 4. Inside that we'll take this input type text. We'll take the placeholder. We'll say enter your keyword, and we'll simply come here. We have to take a div. It will have a class called row. Inside that we'll take a div. It will have a class called column 12, and we'll say input group align self center, and that we have the button. So we'll take a class. We'll say button bordered white, and we'll take the margin top 3 pixels, and in that we have to display our text search. So if you click here, we have the button. Okay, something's wrong. It has to come from the side, but it's coming from the top. So maybe I've done something wrong. Let me have a look one more time. So this is the entire search component. We can fix that very easily. Let's check on the big screen. So let's take this one. This is the problem I have, but this style is also looking good, but this is not what we have in the design. So this is the problem I had. So right now, if you click, this is the problem I have, and this is the problem I have because I have provided this particular class. So simply remove this one. It will be dialog animate, not model animate. So if you save it, and now our entire component will taking the full width and working absolutely fine. So we are done with the menu, we are done with the search components, both are working absolutely fine. Now we can start working on the footer component. So let's build that component. We'll say footer start. And the reason why we are working on all of these components, because these are the components we're going to use on other pages. So once we build the entire layout, we're going to simply copy paste this entire code in different pages and we'll have the styling. So copy that one and paste here, end. Inside that, we'll take this footer tag. It will have a class called footer area. Inside that, we'll take a div. It will have a class called container. Inside that, we'll take a div. It will have a class called row. Justify content center. Inside that, we'll take a div. It will have a class called column 12, and we'll have the column medium 8, and we'll take this text center. We'll take this, simply comment this one, and now we have to display the icons, the items. So we'll take this footer items. Inside that, we'll take the logo, because that's what we have to display. So come here, we'll take a simply take a href. In that, we have to redirect to the home page, and it will have a class called nav brand. In that, we have to take the image. So we have the image in the logo folder, save it, and here you can see we have the image in the center. So looks pretty good. Now we can simply come down and we can display our social icons. Come here, we'll take a div. It will have a class called social icon, deflex, justify content center, and we'll have margin y. Then we'll come here inside the div. We'll take a anchor, and we don't need to redirect, so you can simply provide where you want to redirect to the user. So it will have a class called Facebook, and we'll have the target blank, so it will open in the new page. Inside that, we have to display our icon, so we have to display the Facebook icon. So we'll say icon social Facebook, simply replicate it one time and save it. So you can see here we have the Facebook icon. Simply copy this one and replicate couple of times, because we have to display the different icons. So simply copy this one and paste couple of times, and simply change the classes. So this is the one we have. They will say Twitter. This will be the Twitter and Twitter. So okay, I think I missed something, so not a big deal. So this one is the Twitter, so we can simply call this Twitter, and we can call this LinkedIn, and LinkedIn, select this one and say LinkedIn. Here we have that. Now we have to work on the other icon. So this one is the Facebook, select this one, and we'll say Reddit. Okay, there is a spelling mistake in the Reddit, so it's E, not A. Sorry, my bad. Reddit. Now we have the two, so this one is going to be our V, and simply paste right up here. And the last one is going to be YouTube, save it. So we have all of this icon and looks pretty good. So this is the entire footer icons have. Now we can come down and we can work on the footer menu. So we'll take a UL. It will have a class called list inline. It will have a li, and we'll have the class called list inline item. We'll have a anchor. We don't want to redirect, and we have to display our feature. So it will call features. So this is the first menu. Now we have to simply replicate this li couple of times. So simply select that one and replicate couple of times. And now we have to simply change the name. So this one is going to be roadmap. This will be the how it works. This will be called blog, and the last one will have the privacy policy. So this is the entire menu, and that looks pretty good. Okay, Now we can come here, we can display our copyright section, and we can come here, we'll take a div, it will have a class, we'll say copyright area padding y. Inside that we'll take this copyright icon, and we have to display the here the blockchain coder all right reserve by, and we have to display. So what I will do, I'm going to redirect the user to the blockchain coder website. So this is the URL. I hope you guys are familiar with this. So the blockchaincoder.com and slash resources. So at this location you will find the source code, so take it, or the starter file if you haven't downloaded that. And I want to open in the new page, and inside that we're going to display this particular test. You can see it's looking pretty fine. So this is the copyright section. Now we can display the button, so the user can click and it will take them to up. So the anchor, so come here, we'll take this called scroll to top, and here we'll simply attach that. We'll take a div, it will have a class called scroll to top, and it will have an ID called scroll to top. Inside that we'll take this anchor and we'll say header, it will have a class called smooth anchor, and we'll display our anchor icon. So fade far arrow up. So this is the icon, and that's the entire footer component we have. So looks pretty good. Let's see in the big screen, and here we have the entire footer. Looks absolutely good. All the animations, menu, colors are looking fine. Here we have redirect to the blockchain coder, and you can simply come here and you can get the starter file if you want, and you have to take the starter file if you want to code along with me. And here we have this. Looks pretty good. All these components are looking fine. So here we are. Now things are getting good. You can see the loader animation is also working fine. So now what we can do is, now we have to work on the call to action component. So let's format this one, and let's say CTA area or action start, copy that one and paste here, end. So we have to work on the call to action. So we'll take a section, it will have a class called CTA area, will have a padding 0. Inside that we'll take a div, it will have a class called container. Inside that we'll take a div, it will have a class called row. Inside that we'll take a div, it will have a class called column 12 card. Inside that we'll take a div, it will have a class called row align item center and justify content center. So that's the div I have. Inside that we're going to take this div, it will have a class called column 12, and we'll take this column medium 5 and text center. Inside that we'll take the image and we have to display the image. So we'll go into this and we'll display this call to action thumbnail. If you save, and here you can see we have the image looking absolutely fine. Now we can simply come here, we'll take a div, it will have a class called column 12, column medium 6, margin top 4 pixels, and we'll have the margin medium 0. Inside that we'll take the h2, it will have a class called margin 0. We'll say apply for IGO or staking. So I'll go with the IGO. This looks pretty good. So we have our, now we have to take a p tag, and in that we're going to display this text message, get access to huge set of tools to stake your ERC token and earn reward. You can type any message depending on your offer. So it looks pretty good. We can come here, we'll take an anchor, and it will not going to redirect to anywhere. And here we'll have a class called button boarded, and it will have the active state. It will have the inline block, and we can display our text. So it will have an icon, the rocket icon. So it will have a class called icon rocket margin 2 pixels from the right side, and we can say apply now, save it, and here we have that one. Looks pretty good. So this is the text. Now what we can do is come here, we have to take an anchor and we'll say class CT link, so the user can click and they can redirect. So you can see it's looking pretty fine on the white screen, and we have all the things looking absolutely great. So come back here. So everything is working fine. Our call to action component is looking good. Now we have to work on the actual component, means the main one. So we have done with the header, we have done with the CTS, and now we're gonna work on the main section, the banners, the breadcrumb sections. So we'll say start, copy, and that's we're gonna paste it. And so let's take a section. It will have a class called breadcrumb area. We'll have a overlay dark and deflex, and we'll have a align item center. So we'll have nice cap, and we can display our content in that. Open this section. We'll have a div. It will have a class called container. Inside that, we'll take a div. It will have a class called row. In that, we'll take a div. It will have a class called column 12. Inside that, we'll take a div. It will have a class called breadcrumb content and text center. In that, we'll take this h2. It will have a class called margin 0, and in that we'll display our staking page title. Then we'll take this ol. It will have a class, and we'll say breadcrumb deflex justify content. We'll take this li, and we'll display the icon, breadcrumb icon. So we'll say breadcrumb item, and we'll have this anchor. We add to the page, home page. So simply copy and replicate, and here we have to simply take this one, provide this one, and we'll say this staking, and we have to replicate one more time, and this will be the staking same, and we'll have this active. Looks pretty good. So our breadcrumb section is also looking fine. Let's have a look on the big screen. You can see this is how it will look on the desktop, and things are looking good. So we have built the entire structure. The main component we have included. You can click, you can open that one, and you can go to the different pages. Now what we can do is, we are done with this entire layout structure. Now we're going to simply copy and paste in all the other pages. So let's do that. So everything is looking good. Now we can simply select all, copy that one, and paste in the analytical. Do the same thing in the content, index, project detail, register, and close all the open tab. So the layout is done. Now you can come back to the browser and you can have a look. So if you click on this project, you can see we are on the project page. All we have to do is to change this text. Here we are in the staking, we are in the contract, initials, and the pool, and all the open component, and it's 100% responsive for all the devices. Looks pretty good. Wonderful. Click and it will come up. So we are done with the basic functionality. You can see we have written the entire architecture, built the entire component, and it looks pretty good to me. So everything's working fine. Now we're going to start working on the staking page first, and we have to connect all the functionality we have built so we can stake the token and earn reward, all of those things. So first start working on the staking page, then we'll work on the other pages. So let me bring this side, and looks pretty good. Come here, and here we are in the staking page. So this is the entire the loader we have. This is the main, this is the header component, the breadcrumb component, the CTA, the footer, and the models for menu and for the search. So we have to come back down below the breadcrumb, and here we have to build the main component, staking component start. Comment this one, copy, and paste here. This will be end. Okay, now we'll take a section. It will have a class called staking area, and inside that we'll take a div. It will have a class called container. Inside that we'll take a div. It will have a class called row. Inside that we'll take a div. It will have a class called column 12, column medium 7 will have a div. It will have a class called margin 0. Inside that, let's remove this one and say add class card and non-over, and it will be the staking card and single staking. Save it. Inside that we'll take a h3. It will have a class called margin 0, and that will display our text. So we'll say participate IGO stake. Okay, so the text is not reflecting. Why? Reload the browser. Okay, let's work on it. We'll take a span. It will have a class called balance, and we have to display the user balance. So we'll take this hardcore data USDT, and we'll come down. We'll take this tab start. So we're going to work on the tab component. So what we can do is, so why this text is not displaying, let's take this UL. It will have a class nav tabs, and it will have the staking tab border 0, and margin Y is 3 and margin medium 4. So okay, I do understand why it's happening. So right now you can see that we are in the analytical page, and we are working on the staking page. So we have to go back to the staking page, and here you will find that it's working, because earlier we were in the analytical page. That's why we are not able to find this one. So styling is taking place, and we have the data. Now we can simply open this one, and we'll take a ID. We'll say my tab, and we have to define the role. So tab list, come here, inside that we'll take a li, and we'll have a class called nav item. It will have the role. So we'll say presentation, we'll have an anchor, and we don't want to redirect anywhere else. So we'll take a class. It will have a tab link. It will have active. So this is the default tab. We're going to open it, and it will have an ID. We'll say tab 1. Altogether we're going to have 4 tabs. So this is the tab 1 ID. We have to assign the data attribute. So we'll say data toggle to tab, and we'll take this href, and by default we're going to take tab 1. We have to open. So this one is the most important thing. Okay, don't try to make mistakes. Try to provide the exact value. So we can open different component, and we can call different contract, so user can stake the token in different contracts. So these are the important tags that are very, so these are the tags are very important, and you have to provide the exact one. So come here, we'll have to define the role. So we'll say tab, and we'll take this one. So we have to define the ADL, and we'll say content is gonna be tab 1. ADL selected. By default it will be true, and the name is going to be the 7 days, and it will have a on click function, and we have to call the function we have built. So we'll say open tab, and that we have to pass the event and the name 7 days. So on the base of this we can identify that which contract we have to call. So this is the function we have built. I hope you guys haven't forgot that. In that we'll say 7 days. So this is the first tab. This is the one. Come here, and if you come back to the common.js, so this is the function we have called. Come here in the index, and this is the function we are calling. So that's the simple thing. Now what we can do is we can simply copy this one and replicate 3 times. So paste 1 2 3. So we have this 4 buttons. All we have to do is to change the name. So this one is the first one, and now we have to work on the second one. So here we have to change the 1 to 2. So this will be 2, this will be 2, and this will be 2, and we'll have the 7 days to be the 10 days, and this will be the 10 days. It's 10 days, and this we have to remove this active class, and this is good, and we have to simply turn this false, not true, and that's the only thing we have to do. Looks pretty good. Do the same thing for the third one. So this will be the 3. So select this, and we'll say 3. Okay, so this one is the 3 one. This will be the false, and we have to change the name. So this will be the 32 days and 2 days. It's totally up to you that how long you want your user to be stake their token. You can define your own, but I'm going with this normal one. So this is the third one. Now we have to work on the fourth one. Remove this one, and this will be the 4. Select and change 4, and this will be the 90 days. 90 days, and change this to 90, and this will be the false. So we have these 4 different tab. You can simply click and you can see the over effect and click event is also working in place. Close this one, and this is the entire tab section we have. Now we have to go ahead. So we have work on this, bring it down. Now we have to work on the body, and we have to display 4 different components. So what we can do is, we'll take a div. It will have a class called tab content, margin top, medium 3 pixels. Will have an id called my tab content. It will have a div. It will have a class called tab pen fade, and we'll have the show and the active. By default, we're going to open the very first component, the 7 days one inside, and it will have the id called tab 1. It will have the role, and we'll say tab panel. It will have the area label, and we'll say tab 1. Save it. Inside the div, we have to take a div. It will have a class called staking tab content. Inside that, we'll take a div. It will have a class called info box deflex justify content between. In that, we'll take a div. It will have a class called info left. Inside that, we'll take a ul. It will have a class called li list unlisted. Inside that, we'll have our li, and we'll take the strong tag. Inside that, we'll display the title log period, and here we'll display the actual data. So right now we are going with this hard code, but we're going to display with the dynamic one. So make sure to give the exact class name, because this is the class name we have provided in our JavaScript file, and we're going to populate the data in this particular element span. So log period value. So this one is the thing you have to keep in mind. So this is the first one we have. Now we have to simply copy and replicate couple of times. So we can take the strong tag, and you can give this extended locked on registration, and here you can say yes. You can see that's how you can do it. Simply copy and replicate couple of times. Now we have to simply change the test, and we have to assign the IDs. So let's remove this one. We'll say early unstake fee, and we'll take a span. It will have a ID, class, and we'll say early unstake fee value. Make sure to give the exact class, and here we have to provide the amount. So right now we are going with this hardcode data, but we're going to update this data with the function. Now we have to display the minimum staking amount. We'll take a span. It will have a class called minimum staking amount, and we'll say 0. We'll go to the maximum one. So the maximum staking amount, remove this one, and we'll take this span, remove this one. We'll say maximum staking amount, and by default we'll go with the 100 just for demo data. Simply copy that one, paste here, and replace this one. So this will be our stake status, and by default we'll say unlocked, and change the class name. So active status staking, and we have this extra one, so simply change this one. We'll say additional reward, and we are not providing any additional reward. So what we can do, simply remove the span, and we can display the none. Save it. Now simply copy this one and come back here and paste. Now we have to display the text. So we'll say this app rate, so the percentage value, and simply come here and take a div. It will have a class called info right deflex, and we'll have the flex column. We'll take a span. It will have a class called app value, and we have to display the percentage they will get as a reward. We'll take a div and we'll have this particular APY, and things looks good. So this is the component which is working absolutely fine. So looks good. Now here we are. Simply close this one. This is the entire component, and open this one, and this is the one. So this is the one component, and we have to have a 4 component together. So this is the one component we have. Looks good. So simply copy this one, and we have to replicate 4 times because we have 4 tabs, and paste here, and we have to remove this one classes show and active, and we have to change this tab 1 to 2. Okay, let's come up here, just change this to 2, and that's the only changes you have to do here. The rest would be fine. Simply copy and paste here, and this will be the 3. So select this one, and this will be 3. Copy this one and paste here, and the last one we have is the 4. So simply change this to 4, save it, and looks good. Save it, and that's the entire 4 component we have. Let's see on the big screen. Okay, everything is working fine. We can toggle in different tabs, so looks good. Now simply close this one, and now we have to work on the other components, the input field. So let's take a div. It will have a class called input box. It will have margin y 4 pixels. It will have a pay, and it will have a ID user token balance. So we'll display that, like what is the balance of his token which he want to stake. So that's the balance we will display. So we'll say balance, and we'll say 0 as a default value. Come here, we'll take a div. It will have a class called in. We'll have the ID. We'll say staking button block show hide. Now we have to assign the classes input area. We'll take this flex column, and with the flex medium row, and we'll have the margin bottom 3 pixels. Save it, open this div, and inside that we'll take a div. It will have a class called input text. It will have a input, so we'll type text and placeholder. Then we'll have a ID. We'll say amount total stake new, and we'll have this anchor. We'll say max. Remove this anchor and save it. Looks good. You can see our input field is looking pretty fine. Now we have to display the button. So we'll take a span. It will have a class called button. We'll say input button, and we'll take this margin top 2 pixels, margin top medium 0, and we'll have the margin L medium 3 pixels, and it will have an on click function, and we have to call the stake function. So this is the function we have in our file, index file. So save it, come back here, and you can see this is the entire load initial data we have, and this is all the function we have created in the index file. Close all of these functions. Pretty good. And this is the function we are calling, and this will allow us to stake our token. Simply copy, and that's what we have to pass, and looks pretty good. Here we have to call this stake. So our button is ready. Now we can simply take a div. It will have a class, work on the other input field. We'll say input area deflex flex column flex medium row, and we'll have the medium 3 pixels. Inside that we have to take our input. It will have the placeholder, so that amount, and we'll have ID. So we have to get the amount from this input field. So we'll say unstake value, and we'll say max. Save it, and we have to display the button. So what we can do is we can come here. We'll take a div. Let's assign a class, and we'll say text input text. Cut this one and wrap this entire and we'll have this styling. Now we can take this button one, take this span and copy and paste here. So paste here, so we have the button and we have to simply change the text to withdraw. So that's the withdraw, and this is the function we have to call. Okay, so the two input fields are ready, and now we have to write one more for the getting the reward. So close this one, copy this one and paste here. And here we have to do a couple of changes. So we have to change the IDs and the function name and the name of the button. So it looks pretty good to me. Now we can simply remove this margin bottom, and things are looking good. Now we have to replace this ID. We'll say user reward balance value, and we have to call the function. So come here and we have to get the function called claim token, copy, and that's what we have to paste. And we'll say reward, save it. And that's all the input we have, and looks pretty good. And we have attached the functionality as well. Now we can simply come here and we can display some dummy text. We'll take this detail, and in that we're going to take this span. It will have the Lawrence span, so you can see we have this text, remove some extra text, and we can take this span and we can have a class called margin top 3 pixels. Inside that we'll take this strong tag, and in that we'll display our app rate is dynamic. You can display any text, but this is what I have in the design. Save it, and this is the entire component for the right side, for the left side. Now we have to work on the right side, so let's call it sidebar. Cut there. Now we can come here, we'll take a div. It will have a class called column 12, column medium 5 pixels. Well, come here, we'll take a div. It will have a class called staking item. We'll take the medium margin top 4%, margin top medium 0, and we'll have the card. So simply comment this one and come here, we'll take a div. It will have a class called card none over, and we'll have the staking card. Inside that we'll take the h3 and we'll take the ID. We'll say total lock token value, and we'll have a class. Let's add a class called margin 0, and we have to display this hardcode token data. Things are looking fine. Now we can take a p tag and it will display the total value lock, so in the contract. And here we have to simply close this one, copy this card, and we have to replicate 5 times. So we have this one. Now let's assign a margin top because they are stacked to each other. So we'll say this, remove this one. We'll say margin y 4 pixels. Copy this one, and the same thing we have to do in this particular card as well. So we'll have some space. Looks good. Now we have to change the text and the ID. So this will be the your lock token, and we have to, this is the value we have given, and this is the replace the ID. So we'll say total locked user token. Let's replace the text. We'll say percentage, and by default we'll say 20%, and we have to replace the ID. So the ID will be app value feature, and the last one we have is this number of stakers, and we have to replace the ID. We'll say number of staker value, change this to 34, and we need one more for the timer, the countdown timer. Simply copy and paste here, and this will say time left, hurry. We have to replace the ID, so we'll say countdown title value. We'll take this countdown time value. Inside that we'll take a span, and we'll take a ID, and we'll display this countdown title value. So this will be the time of our contract. So let's give this hardcode data. You can see the data is displaying. Let's provide a real data to check how it looks when we have the time. So this is how it's going to be looking, pretty fine. And let's assign a margin from top. So you can see things looks pretty good. We have the binary, this is the tab, different tabs we have, looks pretty good. We have different input fields, and search bar is also working fine. We can go into the different pages and looks pretty good. So with that, we are done with the entire staking page. In the next video, we're going to test all the functionality we have built, and we're going to make some live transactions. So let's move to that. Great, welcome back once again. In the last video, we have built all the important component, and also we have completed our entire staking page. In this video, we're going to deploy the contract and we're going to attach the functionality. The functionality is already attached. All we have to do is to test that. So here I have opened the project. You can see this is what we have worked in the last video. We have simply copy and pasted all the component we have built in all the pages. Come back to the browser, and here I have started the application. You can go to the different pages, project. All you have to do is to change this breadcrumb titles, staking, and here we have built. That's what we have built. We have the contact, we have the initialize, we have the profile. So now we're going to work on the initialize. So all this component styling, you can click and you can come up here. The search bar is working fine. You can come back to the code, and now we have to simply deploy the contract. So let's close this one, come back into the web3 folder. I have already provided this. Open that one, and here we have written all the smart contract. So we don't need to take this log contract, so simply delete this one. I was testing for something, so I have this one, and we have this initializable, onable, all the contract, and here we have the remix, which I have explained that why I have created this file in the final code. Okay, so all of this contract we have, and this one is the optional one. If you want to deploy your contract using remix id, you can definitely copy the entire smart contract in one single file, and you can call the function. So I will show you the both way. I'll show you the both way, that how you can deploy the contract using hardhat, or how you can use the remix id and deploy all the contract together. I'll show you the both way. So all of this thing, all the function we have here looks pretty good. And what we can do is come back here in the open the new tab and come back to the blockchain coder. And if you come back to the source code section, if you go to this video, if you click on that, in this video I have explained that how you can deploy the entire smart contract in with the help of remix id. So make sure to watch this video if you have any confusion about this remix.sol file. So let's close this one, and now we can open our terminal, and we have to install all the dependency we need. Have to install the hardhat. So let's get into the folder. So we'll go into the web3 folder. So let's say cd web3, and we have to close this one, open package.json file, and these are the two packages we need. So simply install that one, npm I, and it's going to install the packages. So here the installation is happening really quickly, so just give a moment. And here we have installed all the packages. We have only two packages. Now we have the node modules, which you don't need to worry about it. So come back, bring this down, and we have this one. Now come back to the script folder, and here we have the deploy script. So in the starter file, you will get this particular script file. So what I will do is, so you can see that we are deploying our staking contract, but I also want to deploy my token contract as well. So what I can see, this is the token staking contract we are targeting here. And if you come back here, we have to deploy the token as well. So this is the two contract I have to deploy. So I'll come back here, and let's copy that one. Let's call this staking contract. Let's format this one. Come here, let's call this one token contract. Copy this one and paste here, and we can come here, we'll say contract address, copy and paste here, and this will be the token. So we are done with the setup. All we have to do is to pass the name of the token contract. So come back here in the contract, come back into the token, simply copy the name of the contract. So copy the name, come back here and paste here. Simply copy, and we have to rename this one. So I'll select this one, I will make it small t, not capital T, and simply grab that one, and we have to call it here so we can get the token address. And this is what you have to do exactly. So close this one, and now we are ready to deploy our contract. So close this one. Now come back to the hardhead config file, and here we have to do the important configuration. So I have already done all the configuration. So once you will get the starter file, all of this configuration it will be there. All you have to do is to paste the private key of your wallet. So all the configuration I have done, all the optimization for the smart contract is done. All you have to do is to paste your private key of your wallet. So what I will do, come open the browser, come back to the application, click on the MetaMask, log into the application, MetaMask, click on the MetaMask, come here, click on this account, click on this three dots and click on this account details, and here you have to simply pass your private key and copy this, and that's what you have to paste in your config file. So here we have the private key of our wallet, and here we are simply calling that account to the network. So come back to the browser, and before you make the transaction and deploy your contract, you have to have a Metacoin, because we are going deploying our contract to the Polygon. So you have to have a faucet which you can use to deploy. So to get that, you can simply come here and simply look for the Polygon faucet. Click on that, click on the very first link, and from here you can get it. Or there is a multiple provider, so you can simply paste your wallet address, and it will throw error when I will try to transfer, because I have already done in the morning. So if I click on that, click on confirm, the transaction is failed because I have already done in the morning, and I already have enough Medi which I can use to transfer and deploy our contract. So make sure to have the faucet in your MetaMask wallet, and now we can deploy that one. So come here. So come back to the hardhead config file. So if you have any error related to the hardhead, the documentation is absolutely amazing. Hardhead have explained every single thing which you have to do for the deployment. So open this one, come back to the hardhead, and this is the place where you can find all the solution about your deployment error if you are deploying your contract with the hardhead. So you can come here. Here we have written the test. So this is the first command we have to write. Simply copy that one. Then we have to, if you want to deploy the contract locally, this is the command you have to type, and if you want to deploy to any network, this is the script we have. Simply copy that one, come back here, split the terminal, and first we have to pass our npx hardhead node, hit enter, and that will start your local blockchain, and it will give you 20 plus accounts. So you can use this account to test your contract locally, and each account contain 1000 ethers, 10,000 ether. And now we have to call the deploy script. So you can come back here. So this is the script we have to call now, which will deploy our token. So we are using Polygon, we are not using localhost. Simply grab that one, come and paste here, and we have to change the name, provide the name of the network. So go back here, and we have to simply delete this your network, and we'll select the Polygon Mumbai. If you want to deploy to Ethereum, you have to provide the Ethereum or Solana, whatever network you want to pick, and simply come here and hit enter, and it first will compile our contract. And here we got this particular error message, and I know why it's happened. So let's come up here, and this particular error is happening in our remix.sol contract, because what we have done is we have multiple contract in the same file. So when you try to compile that contract using hardhead, it will throw you an error. So what we can do is we can simply delete this remix file. So simply clear the terminal and delete this artifact, delete this cache, because whenever you will compile and deploy a contract, the hardhead will create the artifact, and in that we'll have the ABI of our contracts, and we need those ABI. So what we can do is, here we can see, here we have the remix. This is the entire contract we have, and because of this I was getting an error. So I will simply delete this one. But later we need, if we want to deploy our contract using remix ID, then we have to simply pass the entire contract in single file like this, and we have to simply deploy. So remove this file for time being. Looks pretty good. Close this one, and now we can start. Let's stop this internal blockchain and let's restart one more time. So here we have it started, and whether you start or not, it will work fine. So let's first pick the network. It will compile our all 8 contract. You can see it's taking a little bit time, means it's compiling, and it will deploy, and it will give us the address of both the contracts. So here we got the address of the staking contract, and we have the address of the token contract. So we need these addresses. So simply copy this address, come back here in the JS folder, and we have to go into the header. So this is the common JS file, not in the common header. And here we have to pass the contract addresses. So this is the exact thing you have to do. If you want to provide 4 different contract or more than that, simply deploy the same contract multiple time and paste the address here. So I'm going to simply paste the address in the 7 days. So remove this one, and this is the newly deployed contract address. I'll say new, and we have the token contract. Simply grab that one, copy and close this one, and we have to pass our token address, paste. So this is the token address. So we have the new. So far so good. Now what we can do, you can even test this deployment. Come back here in the polyscan and let's check that our contract is deployed or not. In the polyscan Mumbai, click on that, paste your address, hit enter, and you can see our contract is deployed 1 minute ago. Same thing for the token contract. Copy, come here and paste here, and the contract is deployed. You can see it's deployed successfully. So things are looking pretty fine, and you can see we have deployed our token and contract, and we have pasted their address in the header file as well. Make sure you have to do the same thing. Now close this one, and now we have to get the API of the contracts. So let me make it big and close this one. Come back to the artifact folder. Inside the artifact you have this contract, and in that you will find all the contracts API. So we need the 2 API, staking contract API and the token API. So open this one, and this is the entire API of our contract, and we need this one. This is the API. Simply copy this one, and that's what we have to pass in our header. So come here, and here we have this one. Open this one, close this one, and here we have to pass the API. Simply paste here, come up here, and looks fine. So this API can be used in all the different contract because we are not making any changes. So the API would be the same. So this is the API of our staking contract. Now we have to get the token contract API. Simply get that one. So open that one. This is the API. Simply grab that one, come back here in the header, and that's what we have to pass here, paste here. So this is the API. So this is the exact setup you have to do. Again, I'm telling you, this is the exact setup you have to do. Close this one, and close this one, come back here, close this one. Now we have to open this particular file. So you can see that we have all of this file, common JS header and this index, and that's file we have to connect here in the staking. So we have to simply go all the way down, and the order is very important. Let me tell you what I mean by the order. So this is the staking area, and we have already connected all the functionality. Everything is already connected. Close this one and bring all the way down. So this is the entire JS file for all the animation and for the stylings and all. And we can come here in the Web3 section, and this is the exact order you have to follow. If you don't follow this particular order, your application, your functionality is not going to work. So first we have to provide this library, because library will be on the top, so its variables will be available in the global object. So the way you will define the JavaScript file, it will be available like that. So first we'll define our library. So I'll simply copy this one and paste here, and I'm going to remove this entire one. So first we have to get into the JS folder, and from there we have to get the Web3 library first. So again, I'm telling you, you have to follow this particular order. First Web3 library, then the header, then the common, and then we have the index.js file. So this is the order you have to follow. Simply copy that one, paste here 4 times, and now we have to follow this order. So the second will come the header, because in header we have the global objects, the global variable we have defined. This is the file. So first library, then the header, then we have to define the common JS file, because in that we have the common files, the functionality which will trigger the provider. Okay, looks fine. Now we have to provide this index which has all the function, because this index file is dependent on all the other files we have in the project, and this will work fine. If you save it, come back to the browser, it will automatically trigger the MetaMask. If you reload that one, and again it's taking a bit time, and I'm already connected with the application. So if I log out, it will trigger the MetaMask, and here you can see the MetaMask triggered. Our notification bar is also working fine. We can display the error message that we are not connected, and the error message is displaying. You can simply type the password and click on unlock, and here we are in the application. And right now you can see we are trying to fetch the information about this particular contract, but we haven't initialized the contract. So you can see it has the demo data. If you reload the browser, you can see it's fetching the information from the contract, and it has 0 0 0, everything 0, because we haven't initialized the contract. So as I told you that once you deploy the contract, after that we have to initialize the contract, and we have to pass all the information like amount, the maximum token, minimum token, what is the unstaking fee, all this data we have to provide. So we have to initialize our contract. So you can see everything is working fine. We are fetching the information and displaying in our component. So far everything is good, we have no issues, and you can see we can easily able to fetch the balance of the token, and we are displaying here. And this is the countdown timer, which is a hardcode data because we don't have the data that. So looks good to me, and that's pretty impressive. Let's have a one more look. And here we have the balance. You can see this is the token I have in this particular. If I open the MetaMask, let's come back here in my header file, and I have this token. Simply copy that one, and I'm going to import this token in my MetaMask. Click on this, come back to the import token, paste here, and click on this. It will take the symbols, and now I have to define the 18 decimal points. So 18, click on add token and import token, and here you will find the token we have imported just now. So this much balance I have, and you can pick any one. And if you come here, change the address, and you do the browser, you will see there is no fund. We are listening for all the events, and everything is 0, and we don't have any token. So let's come back to the account one back and reload the page, and you will find that here we have the amount of the token, and right now we have 0 reward. So things look pretty fine, and you can see we have all this different contract. So if you come back to the 10 days, so here I'm using the old contract, and you will find their information as well. So this is the 32 days, and this is the 90 days contract which I showed you in the explanation video. In that I use the old contract. In that I show you that how you can deposit the stake, how to stake the token, how you can reward that one. So all the data you will find, and it's displaying perfectly fine in our front end. So this is the actual 7 days contract we have here. Now we have to initialize that contract. So come back here. So what I will do is, I'm not going to create a front end where we can add this initialization function, because that's unnecessary work. So what I will do is, if you come back here in the initialization, you can do one thing. You can create a form. You can take the input field, and you can pass all of the data, and you can create it right up here. But I'm not going to do it, because again I have to write the form, and that's not necessary. So we can use the remix ID for the initialization. Okay, so come here, go back to the fallback, and I'm going to simply remove this one. Come back here, and now we have to simply get all the contracts. Open this one, and now we have to create a, let's create a file called remix.sol, and in that we have to pass all the contract. So you can simply copy, and you can pass here. This is the address contract. Just format that one, and this is what we have to do for all the contracts. Simply grab that one and paste here, because this time we are using remix ID for deployment, so it is absolutely fine. This is the interface. Get that one and paste here. Close that one. Now we have to do the same thing with the initializable contract. No, not like that. Simply we have to get the only abstraction one. Copy this one, get the abstraction and paste here, and we have to get the Solidity Pragma version as well. So come here, grab this part and paste here. So that looks fine. Now we have to work on the reentrancy. So we have the ownable, simply take that one and copy and paste here. Now we have to get the version, and that's what I'm going to simply paste here on top. Then we have to take this reentrancy guard class contract, get that one and paste here and close this one. Now we have to get the token staking contract, so simply get that one, copy and paste here. That's a huge contract, so let's scroll all the way up, and here we are. Now we have to close this one, and we have to get the version of the Solidity. Get this Pragma Solidity and paste here, save it. Looks pretty good. The entire contract we have pasted. So we have the initializer, reentrancy guard, context, ownable. We are simply taking the ERC20 interface. We have the staking contract, and I also have imported the token we have. Looks pretty good. And this is what you have to do. Simply select all of this and copy, and that's what we have to paste here in the remix ID. You can see our contract compiled successfully. We have no issues in that. Things looks pretty fine. You can check everything from your end. No issues we have. Again, if you are getting any error, make sure to rewatch the video, try to understand that what we have done. If you have missed something, because of that you are getting the error. But in my case, don't have any error right now. Now we have to simply use injected provider, because we have to deploy to the Polygon, and here it will fetch the balance and the address. So now here we have multiple contract, but the only contract we have to deploy is the staking token. Deploy. Let's bring this up and click on this deploy. And here we are deploying our contract to the Polygon, and once it will deploy, it will give us the instant of our contract. You can see it's deploying, and here the contract is deployed. And here you can see, simply copy the address first, come back in the VS Code, go back to the header and come back to the JS, and here you can see. So again we have deployed the contract one more time. So this is the 7 days, and this is the new contract which I have deployed. So what I will do is I'll simply provide this one. So the recent deployed contract here, I will simply take this one, the 7 days, and paste here, and I will simply paste this one here, because by default we're going to trigger the 7 days. So that's why I'm keeping the new contract deployed on top, because that's what we're going to initialize in our remix ID. So simply remove this one. So we have deployed 2 contracts. We have deployed the contract 2 times, but we're going to initialize the 7th one. If you come here we have the entire function we have defined in our contract. You can see, you can check all of the things. So the honor, you can check the percentage, and all of the data you can check. But we have to call this function initializer, because this will update the entire data in the smart contract, that what is the minimum, what is the maximum, what is the percentage ratio, what is the unstaking fees, what is the duration, all the data we have to provide here, the token and the honor. So we have a lot of data to be provided. Percentage, minimum, staking. So first we have to provide the address of the honor. So you can give anybody's address, but I'm going to be honor of the contract. So I'll provide my address. Okay, let's open that one. Let's pass the address. Now we have to pass the address of the token which we allow user to stake. So come here, and this is the token address. Copy that one and paste here. Now we have to provide the percentage. So what percentage reward they will get. So I'll go with the 20%. You can pick anyone. So for 7 days I'll provide 20%. Now I have to provide the minimum staking. So I'll provide that I'll allow user to stake at least 1 token. Okay, so we'll say 1, and after that you have to provide 18.0, because it's in way. So we have to provide 18.0. After 1 we have to provide 18.0. So this is the 18.0. So minimum, the maximum token we allow them to stake is 5,000, because we have created total 10,000 token, but we'll allow them to stake 5,000, not more than that. So 5,000, and now we have to provide 18.0. So provided 18. So minimum staking is 1 and the maximum staking is 5,000. Now we have to provide the start date. So I want to start the contract as soon as I deploy, as soon as I initialize the contract. So that's why I will give 0. You can fix a specific time that you want to initialize the contract after 1 day when you are calling this function. But I want to initialize as soon as I call the function. So now we have to come back here and we have to search for this timestamp. In this particular contract, I will allow the user to stake the token for 7 days. So this is the month of July. So we have 31 days in July and today is 26 by the time I'm recording this video. So I'll take this 8 because I want to stake for 7 days. So I have 6 days in July and 1 day in August. So what I can do is I can simply provide the 7 days time in future. So I'll take this 8 and here I'm going to decrease this one to 1. So simply decrease all the way to 1 and 1. So 7 days we got it. 7 days in future. Click on this convert and this is the timestamp we got. Simply copy that one and that's what we have to pass in our contract. Come here and simply pass here in the end date, end staking time, and here you have to define the days, so 7 days, and here you have to define the unstaking fee percent. Just imagine that someone staked their token and they want to withdraw the token without completing this time frame, the 7 days time phrase. If they complete after 2 days or 3 days, we have to charge certain percentage. So it's totally up to you. I'll charge 30% and click on this transaction. And here you can see it's going to call our MetaMask and we are calling this initialize function. Click on confirm and let's have a look. So just a moment. Once the transaction is get completed, all the data you will find in our application. So things looks pretty good. Now you don't need to do anything in here. Now come back to the application and here we are in the register page. Click on this staking and it will update all the data. So just wait, the data will come soon. So right now you can see all the data is updated. So we have the 7 days staking period, 20% reward, and we have the unstaking fees. Minimum take staking is 1 and the maximum, this is the hard-coded data I have given. You can simply fetch the actual data from the contract. So you can come back to the contract and what I will do, I will go back to the index one, come back to the function, not this function. Let's come up here. We have to go into the load initial data and here we are calling this. So here we are making the token. So I'm going with this hard code, but you can fetch the information. So what I will do, I'll simply do one thing. I'll simply provide 5,000 and I hope you guys know how to fetch the data because we have done tons of time and I don't want to write again any code in here. So just go with this and here you can see the token is updated and we have all the information and the state is active, means the user can stake the token and this is the balance which is displaying and this is the time. So 5 days 18 hours 27 minutes and 11 seconds is left. After this, the staking contract will not able to take any token. Reload the page and you will find all the information is coming from the contract and this is the previous contract we have deployed. We have nothing in here, it's totally blank. This is the 32 days. So this is the old contract I'm using, which I used in the demo one. You can see I have staked some token in that and displaying fine. Now come back to the 7 days and now we can test all the functionality we have included. So first we're going to stake the token. So first let me do one thing. Let me log out from the application to see everything is working fine. The notification bar is also looking absolutely great and things are looking pretty fine to me. No issues we have. This is the demo data because we are not connected. If you reload that one and it's not fetching the data. First we have to log into the application and here we are in the application. Simply reload the browser and here it will fetch the information from the contract. If you want that user can have the data from the contract without connecting their wallet, you can attach that as well, but I will leave that on you guys. So looks pretty fine and everything is working absolutely great. And now we can stake some token in our contract. So let's come back here and this is the initialize function which is working fine and now we have to call this function stake token. Come here, and we can stake the token. So let's do the inspect element and let me show you that how it's going to look. So if you come back here in the application, right now you will find in the local storage I'm storing some other information. So what I will do, I'll simply remove that one. So we have built the logic that after a successful stake, the staking information we are storing in our local storage, so you can able to find here. So what I can do is, now let's call the stake function. Let's stake 100 token. Click on stake. It's going to open the MetaMask. Yes, it's working absolutely fine. We have the functions. Approve. First we have to approve, and it's going to call the approve function. After the approve, we have to call the stake. So just wait, it's approving, and boom, it's approved successfully. So our token is approved successfully, and now we can simply stake that one. So like you can see, we have approved that one. Now we can simply pass the amount. So reload the browser and simply pass the stake amount. So first it's calling this checking. So if you call without approve, so if you don't pass anything and simply call the function, it's going to throw nothing, but you can display the error message. Now we have to stake the token. Simply pass 100, click on stake, and it's going to open the MetaMask, and we are staking the contract. So first we have to approve the token to be spent in the staking contract. So first it will call the approve function, then it will call the stake function. So here you can see it's calling the function, and it will take place. Just a moment. Once the transaction will complete, it will redirect to the analytical page. And here we are back to the analytical page. You can see here we are redirect to the analytical page, and you will find that we have successfully staken 100 token into this particular contract. You have stored 100%, and we have one staker, and this is our reward we are got, because we are providing high reward at the initial for the very first time. And you can see the balance of the token decreased to this. If you check the inspect element, go to the local storage, you will find that here we have stored all the information. We have stored the information about the user, we have stored the information about the transaction they have done. So if you click on the user, here you will find the information. So this is the amount they have staked, 100 token, the reward, time calculations, all of things. If you come back to the transaction, this is all the data we have stored, and you can display this data in the front end. So it looks pretty good. So we have staked the token. Now what we can do, let's withdraw the token, 50 token. Click on this withdraw, and here we have the withdraw. Call this unstake function, click on confirm. It's going to call the function unstake, and once the transaction will complete, it will redirect to the analytical page, and here we are, the transaction is completed successfully. Now here we have the 50 token in the contract and 50 token, and here you got the token back in your address. But here we have charged the fee 30% because you have taken your token back before completing the 7 days period. It's pretty fine. Now let's do the inspect element. In that we'll have the information about the transaction we have done just now. So we have this two array. This is the first one, and this is the second one for the 50, and you can see the information there. Close this one, and now we have to claim this reward. Click on this claim reward. It will call this functions, click on confirm, and it will give you the reward. So just wait, and here you have successfully claimed your reward. It's fetching the balance. You can see here we have updated the balance, and right now you have this much. If every single thing is working fine, we can fetch the information about to the 7 days. And now let's try to withdraw the other 50%. So let's come back to the 7 days, and let's try to withdraw the other 50 token. So let's do the inspect element, and in that you will find that we have this 3 array of the transaction we have done. So let's try to withdraw the other 50. So I'll take the 50, withdraw, and it's going to make the transaction. Let's call confirm, and just click on the MetaMask to see. So here we are calling the function. Just a moment, it will happen very quickly. So once the transaction will complete, you will have a 0 token stake. So come back here, and you can see we have 0 token and no user, and we have this much reward. You can claim the reward, and you can make it 0. So click on confirm, and Just a moment. Click on the MetaMask, and here the transaction completed. And the reward is 0 and all the token you got back. And the same thing you have to do for other contracts. So simply deploy the contract one by one, set the initializer value, and user are ready to deploy our token. So it looks pretty good. I hope it works exactly the way I showed you here, and everything's working absolutely fine. We have no issues in the functionality. Simply close all of these things. So all you have to do is to simply deploy the contract and paste their address. This is the exact ABI because we are not doing any changes in the contract. But if you do any changes in the contract, make sure to paste the API, relevant API. Close this one, and close this one. So we are done with this entire web3 file and the contract deployment. Now we have to work on the data. So right now we have data in the local storage and we have to display in the user profile in the analytical section. So it looks pretty good. Come here. These are all looking good. We have no issues so far. Things are absolutely perfect. So what we can do is click on the profile, and that's what we have to work now. So come back here in the VS Code, come back to the analytical, and here we're going to simply just display all the historical data, all the transaction data, all the user information. That's all we're going to work on it. So we have already done the hard work. We have already built the components. All we have to do is to build one or two components and the page would be ready. So this is the analytical section. Copy, paste here, and this will be the analytical. So looks good. Come back here. Now bring it here, and now we can start working on the component. Every single thing is working fine. Come here and let's format all of these components. So this is the bread component, and now we have to work on the middle section. So let's format this one, and the rest would be fine. We don't need to do anything in here. So come here and we'll work on the middle section. So we'll take this project area section. We can comment this, copy and paste here. This will be the end section. Come here, take a section. It will have a class called project area. We'll say explore area. It will have a div. It will have a class called container. Inside that we'll have a div. It will have a class called raw. Justify content center. Inside that we'll take a div. It will have a class called column 12, column middle 8, and we'll have the column large 7. Inside that we'll take a div. It will have a class called intro text center. Inside that we'll take a div. It will have a class called intro content. Inside that we'll take a span. It will have a class called intro text. Inside that we'll take the transaction, save it, and looks pretty fine. Now come here, we'll take this h3. We'll have a class called margin top 3 pixels and margin bottom 0. Your profile, that looks good. Now we can come here, take a div. It will have a class called contract user. Inside that we'll have a div. It will have a class called contract user profile. In that we'll take an image and we have to display the avatar. Looks good. Now we'll come here, we'll take a div. It will have a class called contract user profile info. Inside that we'll take a p. It will have the strong tag and we'll say address. Come here, we'll take a span. It will have a class called contract space. It will have the strong tag, and in that we'll display the address. So replicate this couple of times, and now we have to pass the actual data which we want to display in these spam. So right now we are just saying address, but we have to display the actual data. So come here, let's do the inspect element. Go back to the local storage because we already have the data there. Bring it here. This not this one. We have to go to the user and we have to get all of this values. Copy and paste here. Do the same thing for this. Copy, paste. This is the reward. Copy, paste, claim reward, paste, and we have the stake amount, paste here. So we got all of this. Now simply close that one. That's how it will look on the phone. So this is the entire profile section where we are displaying all the analytics of the user. Now we can come here, we'll take a P. It will have a class called contract para, and you can display some dummy text. So I'll just reduce a couple of things. Let's good. Now come here, we'll take a div. It will have a class called row. It will have a class called explore items, and we'll say inner data user transaction, and this is what we use to inject the data with the help of JavaScript. So we have this data user transaction. Come here in this we'll take a div. It will have a class called column 12, column medium 6, call large 4, and we'll have the item, we'll have the explore item. Inside that we'll take a, let's assign our data groups ongoing, and this will be the ended. Open this one. We'll take a div. It will have a class called card. It will have the project card. Inside that we'll take a div. It will have a class called medium. It will have the anchor, and we'll take this project details. Inside that we'll have an image. We'll say assets, image, content, and we have to go to the thumb. So it's quite big. We have to add the classes. So let's add the class. We'll take this card image top avatar max large, so looks good. Come back here, we'll take a div. It will have a class called medium body large 4, and we'll have our anchor project details, and we'll take the h4. It will have a class called margin 0, and we'll display this hardcode data. We can simply come here, we can take this div. It will have a class, and we'll say down times. It will take this h1. It will have a class my 2. Then we'll take this transaction, and the number is going to be 1. So that looks pretty good. Come down, we'll take a div. It will have a class called countdown deflex. We'll take this data, and we want to assign 2022 6, and we'll have this 30. So looks good. Come here, we'll take a div. It will have a class called card body. Inside that we'll take a div. It will have a class called items. Then we'll take a div. It will have a class called single item. Inside that we'll take a span. It will say amount. We'll take another span, and we'll display the value. So that's how it will look. Simply copy this one and replicate couple of times. So this will be the gas, this will be the status. Let's change this value to something, and this one is something. So status is going to be true. So that looks good. We have the data. You can display as many data as you want, but I'm going with this 3 data because all the data we have available in our local storage in an array. So come close this one. Come here, we'll take a div. It will have a class called project footer. It will have a deflex, align item center, margin top 4, margin bottom 5. We'll have some space. Come down, we'll take an anchor. We'll take this Let's build this URL because we have to redirect the user to the Polygon so they can verify the transaction. So this is the link, and all we have to do is to send the transaction hash. So simply provide this one and we'll say transaction hash. We're going to feed this data dynamically. So let's give this double quotes, looks pretty good. Now come here, we can say this transaction. So here we have, okay, I made some things. Okay, come here, let's provide the classes. We'll say button, we'll take the button border white and button smaller. So we have this one. It's pretty fine. Now you can see, you can click and you can redirect to the Polygon. So our router is also working fine, and that looks good to me. Close this one, and now we have to display the social icon. So we'll take a div, it will have a class. We'll say social share margin left auto, and that will take a UL. It will have a deflex list unlisted. Inside that will take a li. It will have an anchor, and we have to display our icon, the social icon. So we'll take this first icon is going to be our Twitter icon. Then simply replicate this couple of times. So we have to display 4 different icons. So this will be the, let's say, Telegram. Now this will be the global, and this will be our Discord. So looks good. We have this 4 different icons, and all the icons are looking absolutely amazing. So beautiful. You can see we are saving, we are having this reloader is also looking fine. Now come here, we'll take a div, it will have a class called blockchain icon. We'll take an image, and we have to display the network icon. So we'll display Ethereum by hard coded, but we're going to make it dynamic. Looks good. And this is the entire code we have to write here in the analytical page. We have run with all the components. All we have to do is to populate the data with the help of JavaScript. So we have this analytical component, we have this card which is ready, and this one is looking good. Now all of things are looking absolutely amazing. So we have built the entire skeleton. So let's have a one more look. Body, this is the transaction component, and let's call this target blank. So if you click, it will come back to the new page. So it looks good. Let's do the inspect element, and let's go back to the application, and here we have all the data. Now we have to get this data, and we have to simply render in the front end. So close this one, and things looking good. We don't need to do anything in here, everything's fine. This is the staking, is also looking absolutely great. Now we have to work on the JavaScript. So here we are in the file, make it big, come here, and now we have to go into the JavaScript folder, click on this data. Inside the data we have this user transaction file, click on that, and here we have to write all the logic for getting the data from the local storage and injecting in our front end. So that's what we're going to do it. So first we have to take a variable called user transaction, and we'll say JSON pass, and that we have to target the local storage get items, and we have to give the key pair. So we'll say transaction. So this is the one key pair we have. Simply come here, we'll take a user data, we'll say JSON parse, and we have to get the user data from there, and we have to provide the key pair which is a user capital. So we are getting the data from the local storage. Now we have to simply render it. Now we have to write the function which allow us to convert the timestamp into time. So let's call it generate countdown. Inside that we'll take a variable called now, and we'll use the JavaScript date method, get date. Once we have the date, now we have to take the minutes, we'll take the math floor, and we have to simply make this calculation. So we'll take the now, then we have to simply percentage, and we have to simply stay. So this will give us the minute. Now we have to get the second, we have to do the same thing. We have minute, we have second. Let's come here, we have to simply return the time, and build that one. So minute, second, and that's the function we have ready. Now come here, we'll take a variable, and now we have to get the elements in which we have to inject the data. So we'll target that contract transaction list. We'll say document dot query selector, and we have to pass the class. So data user transaction. So this is the class we have given. So if you come back here, copy this one, come back to the analytical, and simply try to find it out. So here you can see we are simply injecting this injecting the component inside this div. So come here, so we have got this one. Now we have to get the user one. So we'll say user profile document dot query selector, and we have to get the user. So we'll say dot contain contract user. So we got the user, we got the transaction. Now we have to build the logic. So we'll take this variable called user transaction history, and we have all the data here. User transaction, we're going to simply loop over it, map. So we'll say transaction and index, and we have to return the entire HTML. So we'll take this return, we'll take this template literal, and in that we have to write the entire HTML, and which we have already written. So all we have to do is come back here in the analytical page. So things looks pretty good. Come here in the analytical page, and here we have that entire HTML. So this is the entire component we need. This is the one we need. So simply close this one and copy, comment this one, copy and paste here. Now we have to simply feed the data in this particular HTML. So we want to make the image dynamically. So we'll say I+1. Then we have to display the number. So we'll change this as well. Then we have to display the amount. So we'll do one thing. Take this dynamic data. We'll say transaction dot token, and we have to convert it in Ether. So we'll have to multiply with 18, and otherwise it will be amount, and otherwise it will be claim token. So I hope you guys understood that why I built this logic. Means we claim the reward, then we have to display this particular message. So that's the dynamic block we have, and here we have to display the value. So we'll display the transaction dot the token, and we have to convert it into a Ether in a decimal point, otherwise none. Let's display the gas cost. We have the gas used. This is the status, transaction dot status, looking fine. And this transaction we have already built. We don't need to do anything in here, and we are not connected our JavaScript file, so we have to connect that one. So let's connect that first. Come back here in the staking file, and we have to simply grab this one, and that's what we have to paste here. And I hope this time everything would be great. Now what we have to do is, so we have connected this entire file. Now we have to connect the actual file, user transaction file. So we'll say data, and we'll take this one, and we'll simply remove this one. Go back to the data. Inside the data we have this user transaction, and we don't need these two, so simply remove that one, remove this one. So our file is connected, and if you come back here, you can see our pop-up message is displaying because we are trying to fetch the information and it's giving us this error message. So simply comment this one, and now this error notification is gone and looks fine. Now our dynamic component is ready, and we have to simply call that one. So we'll call this contract transaction list in a HTML, and we'll pass the dynamic component user transaction history, and this will actually display our data in the front end. Reload the browser. Okay, something's wrong because we have the data here. If you come back to the console, and here you can see we are getting this error message, cannot set properties of undefined. Don't need to worry about that. And if you do the inspect element, come back here in the source code, and here we are getting this error message. If you come here, so we are trying to fetch the balance, and because of that we are getting an error. So things are looking pretty good, but this is the one which causing the issue. So let's do the inspect elements one more time. Here we have the entire data. So for the time being, I'm stopping this video. In the next video, we'll try to fix this out, that why our data is not displaying. And we are almost done with this project. So we have only one page to work on, that is the front end, but all the logic is working absolutely fine. So with that, let's move to the next video. We're not rendering in our analytical page, so I did couple of changes and everything is working fine. So you can see here I have fetch all the information from our local storage about the users, addresses, reward, staking tokens. That's all the data is displaying here, and here we are rendering the data from our local storage. So if I open my inspect element, if I go to the applications, here you will find that right now we have close to 6 arrays of transaction, and that's what you will find here. Here I have the user information, and that's what we are fetching. So in the last video I made a spelling mistake. Because of that I was not able to render the component. In this video I'm going to show you that what are the fix you have to do. So come here, and this is the analytical page. You can see this is the entire analytical page we have. So let me show you. So first thing is, this is our preloader component. So I'm going to simply close this one, and this is the main. So this is the header. Everything's good in the header section, and this is the analytical. We don't need to do any changes in here. And here we have the transaction. Again, we don't need to do any changes in here, but here you can see that. So let me open this one. Let's close this one, and here you can see that. So this is the div. This is the entire demo content we have added in the last video. So all you have to do is that whatever data we have defined in the span, simply take this div and you have to add this particular class, and whatever content we have, simply copy this one, or you can just simply comment this. Okay, so this is the one thing you have to do. I'll show you the JavaScript file, just wait. So this is the one thing you have to do. Make sure you have to give the exact class name. Close this one, and here we have this another div. In this we are rendering our entire cart component, and we have already written all of this code in the last video. Hope you guys have written that. So make sure to give this exact. I made a spelling mistake here, and because of that I was not able to get it. So this is the thing we have to do. So in this we're going to populate the data dynamically with the JavaScript, and here we're going to render our array of cards dynamically. So this is the entire HTML, and I have done one more thing. So if I scroll all the way down here, you will find that. So this is the model we have, and this is the navigation menu, and here I have connected the JavaScript file. So you can see this is the 3 script. The header, we have our web3 package, then we have the header, then we have a common function, then we have the index, and here we are also importing our JSON data user transfer. So this is the file in which we are targeting this particular page. So make sure you have to do all of this import, and these are the import is similar. We are simply removing the notification JavaScript file from here. So that's the thing you have to do here in this analytical page. Now we can come back here in our JavaScript file. So simply click on this, and we can simply come back here in this data. Inside the data we have this user transaction, and here I have done all of the things. So let me simply close this one, and you can see everything's working fine. So this is first we are getting the information from our local storage. So we are getting that. Then we are simply console logger. So you can simply check. So if I show you the browser, so if I let me minimize this one, if I show you the browser, and you can see if you come back to the search console, if you reload that, just forget about this particular error. Don't think about it, but just focus on the data. So we have this 6 array, and we have this 6 or your user information, the account addresses you will have, and here we have the user information which we are rendering here. So that's why I have told many times that you guys have to good with the JavaScript. So you guys can do these things very easily, because we are not using any framework. So first we are getting the data from the local storage, and then this is the timer countdown, so which we have built in the last video, but we are not using. Okay, so again it's an unnecessary too many work, but I've keep it here. If you want to display the timer, you can display that. So here you can see here we have targeted both the element. So again let me make a bigger screen. Let me open this one. So I have targeted the both div. If I come back here, so first let me provide this, otherwise it will be go off, and you can see here. So first we are targeting this contract user. If you come here, that's what I have target here, contract user. So make sure to target that one. If you come back here, close this one, and here I have taken this particular div, and that's what I have target here. This is what I have target. So we got the component, and here we are building the logic. So first we are using the entire array. So this is the array we have. We are running a loop on it, and this is the entire HTML we have taken. So whatever HTML we have written here in this card component, I've simply copied this entire HTML till this here, and I'm simply passing the data. So that's the exact HTML I have written here. So I'm simply passing the changing the simply taking the, this is the hard-coded image, but we are making dynamic images. So that's the thing we have done. And here we have the transaction number, and here we have built a simple logic. So here we have to display the two title, whether it's account or claim token. So if user will make any transaction with the token, like withdrawal of the token or staking of the token, then we have to display this particular title. But if user claim reward, then we have to display this claim. And here we are displaying the token, otherwise we have to display nothing. Then we are displaying the guest, then we are displaying the status, and here we are allowing the user to click and go to the polycase scan so they can verify the transaction. And that's the only thing I have done here. That's the only thing for the entire card component, and this is the exactly thing you have to do. So let me close this one. So this is the card component, and the same thing I have done with the profile. So I have taken this one, and this data, the user data is already available in the form of object. So we don't need to make a loop on it. So we are getting the data in the form of object, and that's what we are simply feeding. So we are taking a variable called user profile HTML, and this is the entire HTML. So if you come back here, and if I come all the way up, if I simply close this one, if I open this container, and this is the entire HTML I have simply copy, and that's what I have paste here. Paste all of this, and simply passing the user name, address, then we are passing his stake amount, then the last calculation time, the last stake time, the reward, and the reward calculation for sale, and this is the entire. So once you're done with this too, so once you do all the things, and here we are simply injecting that. So make sure you have to give the exact name. So here we have called user profile. This is what we have called. So first we have target that, and we have called user profile. You have to call user profile, call inner HTML, and you have to pass the component. So this is the dynamic component we have built, and that's what we are passing for the user, and the same thing we are doing for the card. So this will inject our data dynamically. So hope you guys have got an idea that what you have to do. The only thing you have to do is to come here and check the spelling, because I made a spelling mistake, because of that it was not working. So this is the thing you have to do. Comment this, and you have to inject it with JavaScript. The same thing you have to do with here with the card, and everything would be working fine. So if I minimize that one and come back to the browser, you can see every single thing is working fine, and we have all the different images, the different transaction we have done, claim reward or amount, all the things are working absolutely fine. Looks pretty fine. So I hope you guys have got an idea that what are the things you have to do. And now we have to start working on the home page, and this one is going to be the last page which we're going to work on it. So everything is working fine. We have the staking where we are fetching the tokens, the contract, the initializer. We have the profile where we have all the information. So let's move to the home page. Hey all of you, welcome back once again. In the last video, we have successfully completed our entire analytical page. In this video, we're going to work on our home page. So this one is going to be the last video, okay? We're not going to work on the other pages because it's going to be unnecessary working on the front end part, HTML, CSS and JavaScript. So you will not learn anything about the blockchain. So I'll try to stick this one video, and that we're going to simply wrap up, and we're going to build the only one page. That is one is the home page. So here I have opened the project side by side, and this is what we're going to work on it. So this is the entire setup we have done. Close this one, and we have already have all of this component. So close this one, and this is the loader we have, and this is the main component. So this is the header we're going to have it, but we're not going to have this breadcrumb. So we're going to simply remove this one. And we're going to have two components. We're going to have the hero component, and we're going to have the card components. So only these two components I'm going to build. And by the way, if you want to get the complete application with all the pages with those components, then definitely check out the final code in that I have provided that one. So you can take the final code, and in that you will have all the pages, and all the data will work fine from the JSON file. But in this, I'm going to build on this two component, hero component, and we're going to build the card component. Come here, we'll take a hero section, and that's what we're going to work on it. So this one is the start, simply copy and paste here, and this one is the end one. So let's close all of these components, and let's start working on it. So here you can see everything is working fine. So we can come here. Here is the hero section. We'll take a let's take a section. It will have a class. We'll call it header section. Inside that we'll take a div, it will have a class called container. Inside that we'll take another div, it will have a class called row, align item center, justify contain center. Inside that we'll take a div, it will have a class called hero content. Inside that we'll take a div, it will have a class called intro text center, margin 5. And we'll take this span, it will have a class called intro text. Inside that we'll take this game on. You can see this is the title. Now we can bring down, we'll take h1 and it will have a class called margin top 4 pixels, and inside that we'll display our text. So we'll say next generation web 3.0 IGO, let's token staking DApp. Looks pretty good. We'll come down, we'll take a paragraph, and inside that we can take our text. So let's come here, we'll take a full scale blockchain gaming ecosystem for IGO and token staking. So it looks pretty good. Now we can come here, we'll take a div, it will have a class called button group. Inside that we'll take this 2 buttons. So we'll take this explore, it will have a class called button bordered, and we'll have this active smooth scroll anchor, and we'll simply come here, we'll take the icon, and inside that we have to display our rocket icon. It will have a class called margin left 2 pixels, and we'll type our text explore ICO, or you can say ICO. Now this is the one button, simply copy and paste here, and this one is the second button. Simply change the icon to note and change the text, so this will be apply now. So this is the entire hero component we have. Everything's looking pretty fine. Let's open in the big screen, full screen, and here you can see it looks absolutely great, but there is some problem in the button. I think we have missed something for the button, so let's try to bring in the middle. So come here, let's try to examine that what went wrong. This is the hero content. We have to take a div, it will have a class column 12, column bottom 6, column large 9, and we'll have a text center. We'll cut this one and we're going to bring all the way down here, and this will fix the issue. Now it looks perfect. We can remove this extra IGO. So let's open this one, remove this one, and this one is perfect. So this is the hero component. Now we have to work on the card component, and this one is the final component we have to work. So everything's working fine and we are done with the hero section. Simply format this one and let's work on the card component, the project area. So project section, start, simply copy this one and paste here, and this one is the end one. Looks pretty good. We'll take a scan section. Inside that we'll have a ID, it will say explore, it will have a class called project area, and that will take a div, it will have a class called container. Inside that we'll take a div, it will have a class called row. Inside that we'll take a div, it will have a class called column 12. Inside that we'll take a div, it will have a class called intro, deflex, and justify content between, and it will have a align item and margin 0. Inside that we'll take a div, it will have a class called intro content. Inside that we'll take a spam, it will have a class called intro text, and that will say project. Looks pretty good. You can see this is the text which is displaying. Now we can take a h3 and we'll say margin top 3 pixels, margin bottom 0, and we'll say upcoming IGO or token. That looks pretty good. Now we can simply come here, we'll take a div, it will have a class called intro button. We'll take this anchor and we'll say project page, then we'll assign the class button container button, and we'll display our text view more. So this one is looking fine. So this is the card titles. Now we have to work on the actual card, and this one is going to be actually a slider. So we'll come here and close this one. Let's take a div, it will have a class called, it's going to be a slider, so we'll say project slider. Inside that we'll take a div, it will have a class called swiper container slider medium items. Inside that, we'll take a div. It will have a class called swiper wrapper. It will have the container list. Inside that, we'll take a div. It will have a class called swiper slide item, and inside that, we'll take a div. It will have a class called card project card. Inside that, we'll take a div. It will have a class called media. Inside that, we have to take the anchor and we have to redirect to the project detail page. Inside that, we'll take the image, asset, image, contain, and we're going to take the first image. Now we have to add the class, so we'll say card image top avatar max large. So this looks pretty good. Now we can simply come here, we'll take a div. It will have a class called medium media body and margin left 4 pixels. Inside that, we'll take an anchor, redirect to the project detail page, and we'll have a text called margin 0. Then we'll say metaverse. You can see our slider is already working place. That's pretty good. Now we'll take a div. It will have a class countdown deflex. Inside that, we'll add the data and it will be the date. So we'll say 2022 6:30, and we can, that's the looking fine. Now I can simply cut this one and just paste here, so that looks good. So this is the title we have. Now we have to come here, we'll take a div. It will have a class called card body. Inside that, we'll take a div. It will have a class called items. Inside that, we'll take a div. It will have a class called single item. Inside that, we'll take a spam. It will have a text, we'll say total raise. Inside that, we'll take the amount. So we're going with the hardcode data, but you can feed that dynamically, which we have done in the last video. So that looks good, but the alignment is not good, so I done something wrong. So let's come here. This is the entire media component. Okay, I made a mistake, so simply cut this one, cut and paste here, so it will be inside the media component. And you can see now designing is taking place. Now all we have to do is simply copy this one, single item, and replicate 3 times. So replicate 3 times and change the title. So this will be the value. You can display 4.5 million. This will be our min allowance, means the located token, and it could be this amount. So that's the perfect, the card body. Now we have to work on the progress bar. So we can simply do one thing. We can come here, we'll take a div. It will have a class item progress. Inside that, we'll take a div. It will have a class called progress. It will have the margin top 4, and we'll take margin top medium 5. It will have a div. It will have a class called progress bar, and it will have the role, and that will be the progress bar with a space. And we have to assign the style. Width is going to be, let's say, 25%. And we can come here, we'll take the Arial, value now is 25. Then we have to take this minimum. So Arial minimum value 0, and the max one is going to be 25 or 100, you can type. So that's what we have, and here we can pass the 25%, the text 20% or 25%. You can type whatever you want. Now we can come here, we'll take a div. It will have a class called progress scale, and it will have a deflex, justify, contain between, and margin top 3 pixels. Inside that, we have to take this particular information. So we'll say this much token is allotted. So far none have taken any token. Simply replicate, and here we'll say the actual value, the token use case. You can display your token data. So this is the one. Now we can come here, we can take a div. It will have a class called project footer deflex, and we'll have a align item center, margin top 4, margin top medium 5 pixels. Inside that, we have to take the anchor and we have to display the redirect to the detail page, and it will have a button white and button small. So there is it. Now we have to display our text, so we'll say participation. Looks pretty good. So that's the button we have. Now we can come here, we'll take a div. It will have a class called social share. It will have margin left, auto, and inside that we'll take a UL. It will have a class called deflex, align list, unlisted. Inside that we'll take a li. It will have an anchor, and we don't want to read icon anywhere, and we have to display our icon. So first icon will display the Twitter. And by the way, the Twitter is no longer Twitter. The icon is changed. It's X. So for the time we have to use it. So simply replicate it 5 times. Change this to Telegram. This will be our global, and this will be our Discord, and the last one is going to be YouTube. So we have all the icon, and that's pretty good. Now we can come here and we can display the icon, so the network native token. So we can take a div. It will have a class called blockchain icon. We'll take an image and it will have this assets image, and we have to pick the Ethereum. You can pick any network depending on the token you have deployed. So looks good. So this is the card component, and we can come here and we can simply take a div. It will have a class, and this will call swiper pagination, and the user can click and they can swipe through that. So you can see our slider is absolutely working fine, and with that we're done with this entire component. And again, I'm telling you that if you guys really want the complete project with all the pages with working, so make sure to check the final code. So that looks pretty good. Now we can come here, we can take this single card, and you can simply display as many as you want. So simply copy that one and replicate couple of times. So you will have a multiple card, you can see. Close this one, or you can easily able to populate this data with the help of JavaScript. That's what I have done in the final code. So looks good, and here we are done with this entire home page. So this is our slider working absolutely fine. You can easily able to just populate the data with the JavaScript file, with the smart contract, whatever you want. Things looks pretty good. Come here, and here we have the analytical, and this is what we have covered in the last video. So right now you can see we are getting all of this data into our analytical field. You can do the same thing for the home section as well. You can do the same thing. So simply do one thing, simply come here. Looks pretty good. So that's the entire project. So I'm really excited. I hope you guys have followed this far. It was really huge. We have to work so many things. We have to build the smart contract, front end part, connecting, so many things we have done. Everything's working fine. You can see we are here in the staking page, and it will automatically pop up our MetaMask, and we are connected with the application, and here we are fetching the information. So if you reload that, you will have all the information. So right now we haven't staked any token into this, so we can stake that very easily. So let's take let's take 10 token. So click on stake. First we'll call the approve function in the contract, and after the approve we have to call the stake function. So you can see here it's making the transaction. Again, everything is working fine. If you have encountered any error, make sure to rewatch the video and try to understand the smart contract. That's why I have divided all the contract into a small parts, so you guys can focus more. Don't try to rush, try to understand that what logic I have implemented, because once you will understand, you can easily able to do all the modification in the contract as per your requirements. So you can see we can easily able to make the transactions. Right now we have stake 10 token. If you come back to analysis, so that's awesome. Looks pretty good. Close all of this, and you can come back here, the blockchain coder. You can click on the source section. You can come here, and this is the project. You can click and you can watch this, because once you will get the final code, you have to follow the exact step which I have explained in this video. Okay, you can simply get that one. So that looks pretty fine. So with that, we are done with this entire project. We have designed the entire architecture of our application. We have built different contract, and we have used those contract internally, checking for different conditions. So make sure to try to understand whatever logic we have implemented if you really want to become a master in DeFi developer. Okay, because this type of contract we're going to build a lot, and we're going to build more project like DeFi one. So you have to know that how everything's work. That's the only thing I'm going to cover, and I want you to watch this particular video which I'm going to add. Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now this particular contract, which is for 7 days, has 400 TBC coin. And this one is a really powerful project if you want to build your custom token and allow user to buy and sell any product using your own token. So this will teach you a lot about that as well. So we have this much token in this 7 days contract, and 20% will get reward. Then we have the 2 users stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is I want to stake 100 token. So let's click on the stake. So first is going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. All of you, hope you guys are great. So this project will blow your mind. If you really want to learn about DeFi, then this is the project which you have to build. Let me give you a complete overview that what project you're going to build in the coming hours and what it will teach you. So this is the incredible front-end UI part we have designed for this entire staking DApp platform. You can able to see that it had a multiple component, multiple categories, and that's all you can able to find right up here. So you can click here, you can come back here. We have this navigation, different navigation. You can click on the search bar. Here you will have the search bar. You can close it up, you can open it up. And here we have the hero section. We have these buttons, you can come down, and here we have the upcoming project. So you can display whatever project you want to initialize in your staking DApp platform, and that's what you can display here. So we have multiple projects, that's what we are displaying here. And we have the volume, you can able to navigate with this. This also looks pretty good. And here we have the previous project, so you can display all the project which is closed. That's all you can display here, and you can display the amount of monies they have raised. This is the multi-chain. It's actually features, the highlight section, and this is the team section we have. You can go to the different pages. You can click and you can navigate. You can have a look. And this is the how to participate. This is the apply. So if anybody wants to send any emails, they can do it from here. And here we have the beautiful social icons. You can click and you can come back here. So that's what we have in the home page. If you click on this project, you will come back to the project page, and that's how the entire project would look like. You can see we have a external page. This is the title, then we have this header, and here we are displaying all the projects. So right now on our staking DApp platform, we are allowing user 4 different contracts so they can stake their token and they can earn reward. So each contract will have a different rewards, and that's what we have highlighted here. So you can see the volumes, all of the things you can able to find. You can click on this details and it will take you to the contract detail page, and here they can able to find all the information about the project, that what is the staking amount, what is the reward. That's all they can able to find. So this is the reward, this is the summary. They can claim the token. This is the project summary. They can have a video, so if you want to make a video, you can promote that very easily here. This is the overview of the contract which you will provide. That looks pretty good. So that's the project detail page. Now come back to the staking page, and this one is the most important page of our staking tab. You can see we have a stunning front-end UI. We have everything's working fine. This is the hero section, and if I scroll down, this one is the main part. You can see that here we are providing 4 different categories of contract for staking the token. So we have 7 days, 14 days, 13 days, and 90 days, or you can take it any arbitrary number. It's totally up to you. So you can see that this contract is already live on Polygon test network, so you can able to fetch this data at real time. So right now in the 7 days contract, 400 token in the 7 days, and I have staked 300 token. So you can see 14 days, this all data will change real time. So you can see 14 days, all the data is displaying. This is the 13 days, but I have initialized this 21, so you can give any number. It's totally up to you, and I'll show you every single thing that what you have to do and how you can initialize all of these things. So this all data is dynamic and coming from the contract. Here is the countdown which will tell the user that when this contract is going to be end. So it looks pretty fine. Now what I will do is, let me show you that how you can stake the token in this particular contract. So right now this particular contract, which is for 7 days, has 400 TBC coin. And this one is a really powerful project if you want to build your custom token and allow user to buy and sell any product using your own token. So this will teach you a lot about that as well. So we have this much token in this 7 days contract, and 20% will get reward. Then we have the 2 users stake, and this is the ending date of the 7 days token. And you can see that I have already staked token, and this much I got the reward. So I have staked 300 token and I got this reward. Now what I want to do is I want to stake 100 token. So let's click on the stake. So first it's going to call the approve contract function we have in the contract. So first we have to approve the staking contract to take our token. Click on confirm, and it's going to make a transaction, and it will allow our staking contract to take our token so we can stake and we can earn the reward. So you can see it's calling the contract, and here the transaction went through. Now reload the browser, and you can see nothing changed. Now you have to simply pass the amount and click on stake. So if you click on that, this time it's going to stake the token into the contract. Here we are calling the stake function. Click on confirm, and here we are making the transaction. So just wait, the transaction is happening. So it will take a little bit time because we are doing on a test network. So you can see it's taking a little bit time, and once the transaction will complete, it will take you back to the analytical page. And here you can see this is the analytical page we have, and here you can able to find all the transaction history you have done and the information and the balance you have. So this is the header section we have, and this is the banner section. You can see this is your address, this is the token you have staked 300, and this is the reward, the last reward calculate time, and this is the stake time and the reward you have and the reward you have claimed so far. So I have done all of this, that's why you can see all the data. And this is the short description I have given. You can reload the browser and you can able to find that one. If you come here, you can see here, this is the transaction we have done. This is the 12th transaction, and I have staked 100 token. You can click on this transaction, it will take you to the Polygon, and here you can verify the transaction. You can see what we have done. We have called the function, and we have this much token, and we have transferred the contract, all of things. So this is how you can verify the transaction. Now come back to the staking. So this is how you can done, and here you can see the data is updated. 500 BST we have, and you have stuck 400. Earlier it was 300, and look pretty fine. Now you can see 7 days. Now come back to the 14 days. Right now in 14 days we don't have anything, and this now is looking fine. This is the 14 days. Now this one is 40%, and this is the token. All the data is available. Right now we have nothing for reward because I haven't staked any token. Now let me stake the token. So I want to stake 100. Click on the stake, and it's going to make a transaction. It will first approve the tokens, and yeah, coin. Now we have to just wait, let the transaction get complete. And here we have completed transaction. Reload the browser, and if you come here now, click on that, nothing is there. Now we have to simply stake. Click on this, and we can simply call this one. And now you will see that after transaction, the token, the coin will be displayed here. So it's happening. And here we are back to the analytical, and you can able to find the token you have staked. So you can see this is the 30 number transaction, 100 token we have staked. You can verify that. And here you can see, if you click on this 14, you can see 100 and 100 and this is the balance I have. This is the 40%, and currently we have one user, and this is the token reward we have got initially. So you can click on here, and you can easily able to withdraw the fund, confirm it, and this one is going to make the transaction, and you can easily able to claim the reward from out of this token. Looks pretty good. Just wait, the transaction is happening, and here you will back, and here you can see the transaction is stored here. Claim reward, claim token, and you will have it. And you can easily able to verify the contract. So the data is updated, everything is updated. Looks pretty fine. Now if I want to simply stake more token, or if I want to withdraw, I can do that very easily. So let's withdraw my entire token from this 7 days contract. So I have 400 tokens into the 7 days contract. Let me withdraw that. Click on this withdraw, and now I can withdraw. So what this call will do, it will charge couple of tokens because the date is not completed and I'm withdrawing. So that's why they're going to charge 30% fee for early withdrawal. And here the transaction complete, and you can see this is the amount we have withdrawn. You can verify that. Come back here, and you can see I have nothing 40 token I have staked. Now the balance is reduced to 400 and the balance is come here. I can easily able to withdraw the fund here in the 700 days, and if I claim that, you will see that it will be decreased to 0. And here we have claimed the reward. And here we are back. So the transaction completed, we have claimed the token. Come back here and you can see right now the 7 day has 0 token which I have stake and the reward is 0. So everything is dynamic, working absolutely fine. Here we have the initialize. So from you can initialize the contract. Here we have the profile where you can able to find all the transaction which you have done, and this is the home page. And you can click, will take you to the project detail. This is the staking page, looks pretty good. And this is the contact. So you can easily able to send email as well. So let me show you. Let's give the name, last name. I'll say Hussein. Let's give the email. Let's give the number, and let's give the message. Hey Daulat, Hussein, and click on send. And if you come back here in the Gmail account, you can able to find the information you have provided. Hussein, Daulat, and the blockchain code. Everything is looking fine. So this one is also working fine. So this is the complete project. You can see everything is working fine. Now let me do one thing. Let me log out from the application and let me reload the browser. You can see it will automatically pop up the MetaMask, or you can add a click event on the button, then it will open. You can see our notification bar is also working. We're not able to fetch the information from Polygon because we are not connected, and that's why you can see the error message. Now let's pass the credential and click on unlock, and that will fix the issue. So you can see here we are, it's taking a little bit time. Reload the browser and that will work fine. You can see we got the token and the price and everything all. So hope this entire thing makes sense to all of you guys. Now let me show you the code, that what you're going to code along with me in this particular project. So if I come back my VS code, you can see this is the entire code we have for this particular project. We are not using any framework. We are using pure HTML, CSS and JavaScript. We're not using React, we are not using TypeScript, we are not using Next.js, we are using only HTML, CSS and JavaScript, because most of you are beginner, most of you try to learn about the development of DApp without using any framework. So I thought let's build a project without using any framework. Okay, so that's what I will here. So this is the entire piece of code. Again, let me tell you that how you can get the starter file and how you can get the complete code if you want to take that. So come back to the blockchain coder. And this is the place where you can find all the project we have built on our channel, including the source code, and recently we have launched our course. That's also you can find. Click on this source code and you will come back to the source code section. Here you will find all the project we have built and their final source code. We have tons of project. So this is one is the code is listed. Click on this get, or you can see all of these 4 projects are absolutely amazing. So you can click here and you can get it, or you can come here, you can click on this recent and it will filter the data and you can get it from here, or you can simply type the name of the project, staking token, and it will give you that. So click on that, it will take you to this page. From here you can able to get the starter file and the final code. The code you have seen just now, that's what you will get in the final code. So again, if you take the source code, that will give a very valuable contribution to our team, so we can bring this kind of free courses for all of you guys to teach you that how you can build amazing application. So your contribution always welcome and means a lot for us. So you can get the starter file and you can buy the code here. So what I will do, once you get the source code, this is what exactly you will get. This is what exactly you will get. And you will not get this final code as well. You will get something else. I'll tell you what you will get. So you can see this is the entire folder and file structure we have here. So this is the first folder, we have assets. In that you will find all the assets, including CSS, fonts, images, JavaScript, and external library we are using in the project. So if I open the CSS file, in that you will find all the CSS, custom CSS we have designed and the plugin. So this is all minified version of CSS you will have. Again, you don't need to do any changes in here unless or until you know how the CSS work. So we have all the CSS file and we have this vendor, and that we have the minified version of the CSS. So all this library we are using, like bootstrap, animations, gallery, so slider, so all of these packages we are using, that's all you will find here. So this is the CSS file, this is the font. Again, don't need to worry about that. We are using some custom form in our application. This is the images. Again, one thing I want to highlight, that if you want to change any image in the application, so you can change the name, but you have to give the exact name which the image you're going to replace. So you can see this is the background, and if I want to remove this particular image, I have to give the exact name. So in that way you will not mess. This is the content. In that we'll have all of these images we are using in the project. MetaMask, Solana, thumbnail for the transactions. This is the wallet one we have. Looks pretty fine. Close this one, and this is the background. This is the logo. So if you want to put your own logo, you can put that, but make sure to give the exact name. This is the fav icon. So all the assets you will find right up here. This is the fav icon we have. So close this one, and this is the JavaScript file. So we have external library. So let me show you what I mean by that. If I open this folder, in that you will find all of the libraries we are using. What I have done, I have downloaded the entire library locally in my system. Or you can use their CDN, but because sometimes what will happen that if you use CDN, maybe those who are providing you the CDN for having the functionality which you want in your application, maybe the website is slow. So when the CDN provider website is slow, in that way the application will take a lot of time for loading. So it's always better that you have to download the entire library and use it locally. So here we have this entire library which I'm using locally. Bootstrap we have, Countdown, we have Gallery, we have jQuery, and that looks pretty good. Now we have the proper, then we have the shuffler, and we have the slider. So don't need to worry about that. These all libraries we have used for building our sliders, animations, all of the things. So don't need to worry about that, and you will get this exactly. If you come back to the main, here we have written some custom JavaScript for all the things. Again, you will get this as well in the final code, so you don't worry about it. So this is the entire JavaScript we have, and here we have some more. So you have seen that we are using a notification bar whenever anything error is happening in our application, the notification pop-up. So that's what we have here. So we have this custom CSS for that. You can do the modification if you don't like the color, and here we have the JavaScript. Again, don't need to do any changes in the JavaScript and in the CSS file. All you can do is you can replace the images. So that's the assets folder. Close this one, and here we have the main JavaScript file, which is not inside the asset but outside the asset folder. This one is the most important folder, and that we have built all the logic for interaction with the contract, fetching the data, making token swap, staking, all of the things. It's not swap, like it's staking. So first we have this data folder, because you can see that we are displaying some demo data, or we are using our application as a reusable component. So that's what you can find here. So let me show you what I mean by that. So the very first JS file, we have this product.js, and here we have defined all the contracts. Just imagine that you have multiple contract, multiple staking contract, and you want to provide the information about that to the user. So all you can do is you can define all of the contract information right up here in the JSON file, and that will reflect in the front end. So that's what I have done. You can do that in either way. You can store the information in the contract, and you can fetch the information from there, and you can display it. But I don't want to create and allow user to pay unnecessary gas fee, because these are going to be the static information. So I would prefer to go in this way, and I want to go in this way because when you will store all of this information in the contract, you have to pay higher amount of money, and that's totally unnecessary. So that's one we have here, the product JSON file, and this is the home data. So here we are simply rendering the data in our home page. So this is the entire JSX file, this is the user information, this is the footer menu. So all of the things we're going to code along with me. Okay, so this part, the folder and file we have in this JS folder, that's all we're going to code together. So you will have a better understanding that what we are building. Actually, we're going to code this entire application together from scratch. I'm not going to just simply copy and paste the code. I'm going to code it along with you so you guys can follow me. So this is the entire home data file we have, and all of the data which you can see, that's coming from there, that file. Like once you will build, this will not only teach you that how to be interacting with the smart contract, but it will also teach you that how you can build custom logic and use a reusable component model in your application. You have heard about reusable component model in Next.js or React, but you can also do that with the help of JavaScript here in this HTA here in the DApp. So that looks pretty good. Now we have this project data, so you can also display the information about the projects. You can see we have all of this information. We're going to write it together, don't need to worry about that. And here we have the project detail page where we are populating with the help of JavaScript. So we're not manipulating the data with the, we don't have the static data in the project detail page. We are manipulating the data based on the project here on the base of the dynamic data. Okay, So that will make sense a lot. And here we have the entire transaction components. So we are rendering all the transaction which user are doing, we are fetching, and then we are rendering on our page. So that's also we're going to code it together. Don't need to worry about that. Now this is the data, and here we have the main function for interactions. So the very first page you will find is common JS. If you open that, here you will find the most common use function we are using in our project in multiple pages, like connecting with the MetaMask, interacting with the blockchains, fetching our state variables, passing the information about the contract, which contract we are interacting with into our context. That's all information we are doing here. So you can see this is the functions we have written. That's pretty huge. And again, we're going to code it together, and that will teach you every single thing. Okay, so don't need to worry about that. This is the ether package. So again, I'm not using the CDN, I'm using the entire library which I have downloaded locally in my system, and that's what I have here. So we're going to use this ether package as well. Then we're going to use this header. So here there is the most important part. You can see these are the 4 contracts which I have deployed on Polygon test network, and we have the addresses. So if you don't like this particular contract, all you have to do is to deploy the contract and you have to paste the address, and it will work absolutely fine. Again, I will teach you everything. Okay, again, you will find everything well explained when we'll start working on the project. And this is the index page. Here we have built all the function which allow us to bring all the functionality to our DApp. You can see it's pretty huge. Then we have this initializer, so you can easily able to initialize the contract. So once you deploy the contract, you have to initialize the contract with all the data. Then the contract will work and allow user to stake. So you can do it from here, but I'll try to keep it simple. Then we have this web3.js. So this is the entire library we are using again. So this is the entire library. So that's the most important folder in our project. So close this one. Hope you guys have got an idea that what you will get in the asset file, what you will get in the JS files. And now we have a couple of more folders and files. Let me explain that as well. So once you will get the final code, in that will not provide you this working functions of the DApp, but you will also get this complete template. So I'll show you, just focus along with me. So here we have this particular folder called web3. In that we have all the contracts. So we have this artifact, caches, and we are using Hardhat for deployment of our contract. You can use remix ID, but we are using with Hardhat. So this is the artifact we have. And again, we're going to write this entire contract together. So you will understand that what logic we are building, how we are writing the contract, how the contract is interacting with the artifact interface, owner. So we have all of this contract. This is the address contract we have. I'll explain in detail that what this contract does. We have this context, we have the IERC20, we have the initializer, we have the lock, then we have this is the entire one, we have the honor, we have this guard class for the reentrancy attack on a contract, and this is the custom ERC20 token which I have created. We are not using any external library for our smart contract development, and that's what I find best about this project, because every single thing we're going to write it together. You can use the external library to build a DApp, but that will not teach you anything, and you cannot able to modify and fulfill the requirement of your clients. If a clients come up to you and he tells you that I want this particular feature in my contract, this particular pricing strategy I want, so in that way you're not able to provide that because you have used the external library. But if you follow this particular project, it will teach you everything that how you can customize it as per the client requirement. So this is the entire token we have built. This is called TBC, the blockchain coders. That's what I have called. You can see this is the entire one with all the data we have designed, and we're going to code it along with me. Don't need to worry about that. And this is the main contract, the staking one. You can see it's pretty huge. We have a lot of functions, a lot of things are going on. You can see how easily we have staked the contract, but it's not that simple. There is a tons of things is happening, tons of calculation is happening inside the contract, and then we are allowing user to do that. So that's the entire contract folder. This is a script. So we're going to deploy the 2 contract, staking and the token. And this is the staking. That's what we'll deploy, and we'll deploy this, the blockchain coder, the token, ERC20 token, so the user can stoke the token. And that's what we're going to do it. Close this one, and here we have this one. So again, this is the entire test. We're not going to write the test, so I will simply remove that one. And this is the get ignore. This is the Hardhat config file. So this is the exact configuration you have to do. All you have to do is that you have to provide the private key, and I have already done the configuration. Simply copy the private key and paste here, and you can deploy the contract very easily. So we're going to deploy that to the we're going to deploy to the, so we are deploying the contract to the Polygon Mumbai. You can simply pass the RPC URL of the network and you can deploy it to any network, Mainnet, Testnet, or Solana, wherever you want. You can do that very easily. These are the two packages we need, that's must. And this is some information you will have. Close this one, and that's what we have into our web3 folder. And here we have all the pages. So right now you can see whatever you have seen in the demo, that's all the code we have here. Looks pretty good. So all the thing is there which you can able to modify and have a look. This is the contact, this is the harded config file. So again, I have provided twice, so I will simply remove that in the final code, so you won't have this one. And here you can see this is the HTML home page. This is the home page we have, all the code. You can simply edit it if edit any text you don't like it, or images you don't like it. This is the project page. You can simply edit the text. You can project detail page. You can edit the data, which I will tell you. And here we have the register page. And here we have the staking page, where we have built all the functions to stake the token and all of the things. So don't need to worry about that, because every single page we're going to code together and we're going to write every single thing from scratch. That will teach you everything. Now let me show you that what you will have into this particular staking template. And that will have a lot of pages. You can see that. And this one is absolutely gold mine. So now before I show you, let me show you that how you can deploy the contract and how you can initialize the contract and how you can attach the particular contract which you have deployed into this particular application. So you guys can follow that. So what I will do is, first thing I have to do is I have to get into this web3 folder, because there I have the contract, so I have to deploy that one. So right now you can see we have all of this contract, and I want to deploy this particular contract, staking contract, and the our token. If you come back here in the header, and here we have to provide the information. So you can see we have the ABI of the staking contract. So if you not make any changes in our contract, then you can use the same ABI. But if you are changing anything in the staking contract, then once you deploy the contract, you have to simply copy the ABI and you have to paste here. So this is the ABI for the token, and this ABI is not the regular ABI like you will find in OpenZeppelin, because we have built our custom ERC20 token. So that particular token will have a different ABI. So you can see we have the token address, because this token address will let the user to deposit, because you have to define, like you can have one token or you can have multiple token. So here I'm going with the one simple token for deploying in multiple contract. So you can see we have all the addresses of different contract, but all the contract has the same ABI because we have the same functionality. So this is the old one, all the contract which I have deployed. Now I'm going to deploy that one. So let's come here, let's deploy it for fresh. So come back in Web3, and first thing we have to install the hard hat. So we'll say np, we'll go back to the Web3 folder, and now we have to install the packages which we have here. So come back to the package JSON file. Here we have this hard hat, and here you have to paste the private key before you deploy that. So you can see I will simply copy the private key, and that's what I'm going to paste here. Okay, where it gone? So what I will do, I'll simply copy that one and well back here and paste here. So this is the private key of my wallet, and to get the private key is very easy. All you have to do is come back MetaMask, click on this three dot, go to the account details, and simply click here and pass your credential, and you will get the private key. Okay, so come back here in the code, and that's what you have to provide. So you have the private key. Now we have to install all these two packages. So let's install that very quickly. So npm install, hit enter, and this is going to install the packages. So make sure you have to be in Web3 folder and then install the package, because that's where we have the packages and file. So this will take a little bit time, and you can see in my case it's happened very quickly. So I'll bring this down. So we have installed the packages, don't need to worry about that. Now everything's set. Now we have to deploy the contract. So we're going to deploy this staking contract. So this is the contract we're going to deploy, and we're going to deploy this token contract, these two contract. Our staking contract is using all the other contract like address, honor. So our staking contract is dependent on that. If you not provide that, our contract is not going to work. So here we are in the deploy script, and now what I will do is, here we have this particular one. So simply come up here and simply grab this particular contract address. I don't want to make any spelling mistake, because that's a really very irritating problem. So save it. Now simply grab this one, come here, and let me give this comment, staking contract. Simply copy this one and paste here. This will call the token, and here we have to give the contract name. So copy that one and paste here, and we have to change the name. So change it, make it small, and we have to copy that one and paste here as well. So we are deploying this two contract. So far so good. Hope you guys have no issues. Now we can deploy the contract. So that looks pretty good to me. I have no issues in that. Make sure that you have to be in the web3 folder. Now we have to run this particular command, npx hard run script, means we are into the script folder /deploy -network Polygon. You can give any network, Robston, Gorilla, Mumbai, Ethereum, you can use anyone. Just give the name and provide the RPC URL in the hard config file, and it will deploy the contract. And make sure to have a balance in your MetaMask account. So you can see it's compiled successfully, and it's compiled. I'll bring it up. It's taking a little bit time because the contract is really huge. So here we got the staking contract, but our token contract is taking a little bit time. So you have multiple way to deploy the contract, and you can see I waited for quite long. What I'm going to do is I'm going to stop this one, and I'm going to use a remix ID for deployment. I don't know why it's taking so much time. So what I will do, I'll simply clear my terminal, and I'll come here, and I have to do a little bit modification in the contract if I want to use the remix ID for the deployments. It's not a modification. I have to keep all the contract in one single file. So what I will do, I'll come here. I have all of these contract in different files, but I have to bring it in one single file. So come here, click on this contract. And by the way, whatever update we are doing here, which you can see, once you will get the final code, and that all of this update is going to be already done. Okay, so you don't need to do any one of these things. Obviously you have to change the contract addresses, or if you modify the stake contract, then you have to provide the ABI of that particular contract. Otherwise everything would be fine. If you all you have to do is to pass the token address and the contract address. Let's create a file into this contract, and I'll call it remix.sol. In that I have to simply bring all the contract together. So what I will do, I have already done that. You can see here we are in remix ID. I'm simply copy that one, and I'm going to simply paste here. And you will have this particular file where you will have all the contract together. So you can see we have the library, address library, and we have the abstraction for initialable, then we have the reentrancy guard, then we have the context, we have the ownable, then we have the ERC20 phase, then we have the staking contract, and we have the token contract. So all the contracts are in one file. Let me rearrange this so it will look pretty good. Let's bring this together, bring it here, and looks pretty good. You can see all the contract in one single file. Simply copy that one and paste here. So when you will get the final code, this is, you already will have the code in the remix ID. All you have to do is to copy and paste here. I have already done that. Let me rearrange this. I don't know why it's came back to the normal. Let me rearrange that one, close all this opening one, and looks pretty good. Now we can simply deploy the contract. You can see everything's working fine. We have no issues in our code, and now we are ready for the deployment. So click on this, and first we have to pick the network where you want to deploy. So we want to go to the MetaMask, injected MetaMask, and you can see here we have the MetaMask. It's fetching our balance, and we are connected with our MetaMask. I already have this much fund in this particular account, and if you really want to deploy the contract, you have to have a couple test fund in the contract, which I have explained n number of time. I would suggest you to watch the NFT marketplace, where we have deployed the NFT marketplace on the internet, and we have deployed the contract as well. So in that I've explained everything, that how you can do the basic configuration and get the token. Looks pretty good. Now what I can do is, now I have to deploy the contract. So I come here you will find all the contract we have defined in this remix ID, but the one we have to deploy is this, the blockchain coder, the token, and the staking contract. So first we're going to deploy this staking contract. You can click and you can simply change the contract which you want to deploy. So I'll deploy this one, staking contract. Click on this deploy, and it's going to make the transaction. So just wait. We are doing with the Polygon. You can see deployment, click on confirm, and here it's going to make the transaction. So it's pending because we are doing on the actual network, test network, and the contract is deployed successfully. We have no issues. And here we got the instead of the contract and the address. You can open that. You can able to find all the functions we have included in this staking contract. You can simply copy the address, you can come here and you can hit enter, and you can see the contract is successfully deployed to the Polygon Mumbai, and you can find the transaction details. Come back here. Now we are done with the staking contract deployment. Now we have to deploy the token. So I can come here, click on this, the blockchain coder, and now we have to deploy this particular contract. So click on this deploy. It's going to make the transaction, and here we have the MetaMask contract deployment. Click on this deployment, and it's going to deploy our contract for the token. Looks pretty good. And here the contract is deployed. You can copy the address, you can come back to the Polygon, and you can check whether the contract is deployed. Click on this, and you can see it's taking a little bit time. Simply refresh the browser. You can see it's happened very quickly in my end, but if it's take more time in your end, just wait for our time being. You can see that our token is also deployed and our staking contract is also deployed. Now you have this two data. You have the address of the staking contract and you have the address of the token, and that's what you need. So what I will do is I'll come back here and come back to the remix ID, and now the very first function we have to call in our staking contract, because we have to tell our staking contract that what contract it has to take, what pricing, what durations, everything, all the information we have to give. So if you come back here, let me bring this down, and here we have this particular function in our staking contract. Click on that. So the very first function you have to call to start this staking contract is this initialize, and in that you have to pass all the information. You can do it very easily at the time of deployment. All you have to do is to provide the hardcode data at the time of deployment, and that will also work fine, but I would like to go in this way. It's totally up to you. So if you open that, in that you have to provide all of this information. So first you have to provide the who is the owner of the contract. So here you have the option to define the owner of the contract. It's not the person who's deployed the contract. You can also give anybody's address as an owner. So just imagine that someone hired to build this particular dApp, and you are building this and deploying the contract, but the person who have given you the contract, he wants you to be the owner of the staking contract. So that's how you can define it. You will build it, you will deploy that, but you're going to take his address and you can assign it so he become the owner. So that's one. Let me pass the address. So this is the owner of the contract. Now we have to pass the address of the token, which will allow user to stake. And this one is very important. You have to provide that particular token address which you can allow user to stake, because if someone's try to stake different token, it's not going to work. So we have already deployed the contract. So this is the token. I'll simply copy the address because this token I want to allow them. Simply paste here, looks fine. And now we have to provide the rate, that what amount of reward they will get. So RPM rate, if you come back here, go back to the staking, you can see this is the rate we have. We have different rate for different time period, 20%, 40%, 60%, 80%, is totally up to you, that what rate you want to provide it. Okay, you can see this data is dynamic, and here you have to provide the rate. So we're going to go with 20%, and that's what you have to pass. And now we have to define that what amount of token you can allow the user to stake in the contract. So what is the minimum, what is the maximum? So the minimum I want to assign, you can go with the 0, and 0 is not the ideal, because why you allow user to call the contract with a 0 token? They have to stake at least something if they are calling the particular contract function. So I want them to stake 1 token minimum. They have to stake 1, and here you have to provide 18.0 because it's in the way. If you give 1, it's not going to work. So you have to give 18.0. So 1, and you have to give 18.0, so it will be the 1 ether, because here we are using 18 decimal points. So we have 1 is the minimum token they have to stake, and the max I want them to stake 5,000, depending that what is the supply of your token which you are providing. So in my case, the token which I have deployed, it has a 10,000 supply, and I allow user to stake only 5,000 token into this. This number can be anything. Okay, so again I have to convert it into a way, 18 decimal points. So after 5,000 I have to give 18.0. You can calculate it because this one is very important. If you're deploying to the mainnet and you don't have that much token and you are assigning in the contract, then your entire contract will be gone. Looks pretty good. And here we have to provide the start date and end date. So I want this contract to be get start as soon as I call this function. So for that I will give this 0, or you can specify any particular date. Means if you want to start this contract after a day or a 2 day or any particular day, make sure to provide that day into a second. I'll show you how you can convert that. So I'll start this particular contract as soon as I call this function. And if I come back here, you can see this is the website which I use very frequently, because we have to pass the date into a seconds. Okay, so what I can see is, you can see we are in the 7th month. So this is the current date at the time of I'm recording this video, 7th month. Today is 10th, and you can pick the date. You can see right now we have this 14 days, 7 days time. So what I will do is, I want them to stake their token. This token period will be for the 7 days. So right now today is 10, so I'll say 7. You can simply call 7, means at 17. So when the date is 17, this contract will not allow user to stake the token. So this is the ending period. Now click on this convert, and it will give you the second timestamp, and that's what you have to provide in the contract, because this date in future. So that's the thing you have to keep in mind. So that's the timestamp you have to provide, end time, and here you have to define the day. So it's 7, so that's what we have to specify. And here we have to provide the amount. So just imagine that if someone's stake their token and the time period is for 7 days, but they have decided to withdraw the token before the time period ends. So in that case, we have to charge certain fee, because they are not fulfilling the requirement for getting the reward. So we're going to take a couple of tokens from their tokens. We're going to charge commission for that. So the commission is totally up to you. I would say that, like here we can see that in 7 days we are charging commission 30%. You can take any number, you can charge 100%, it's totally up to you, but no one's going to stake the token in your contract. So like I can come here and I'm going to charge 30%. Let's say 30%. And then you have to click on this transaction. So once you will click provide all of this data, make sure to double check all of these things. Okay, timestamp, date, percentage, and then click on this transaction. So once you call this function, it's going to trigger your smart contract with all the data. You can see initialize function we are calling. Click on confirm, and it's going to make the transaction, and it will start the smart contract. And this is the exact thing you have to do for all the contracts, like for different days. So 7 days, 14 days, and like 16 days or 90 days, no matter how many days you are providing to stake. Because like if you are allowing them to 7 days staking, so this is one contract. If you allow them to for 14 days, that's a different contract, and you have to do the exact thing. So you have to deploy multiple contracts for that. If you reload, come back here, you can see, reload the browser, you can see this is the function we have called just now in 30 seconds ago, and our contract is successfully initialized. Now what you have to do is, if you want to use the contract we have deployed in our application, that's also very easy, because we have the address of the token. So you can see you can able to check all the data we have defined. Rate, maximum, this is the minimum, this is the staking date, this is the ending, this is the stake, all the things which you can able to find, like it's on and on. This one is for the users, all of the things which you can call. And that's what we are calling and fetching the data in our front end. So looks pretty fine. Now come back to the project, and if you want to use that particular contract and the token we have deployed in the project and allow user to work straight away, then that's pretty easy. All you have to do is come back here. You can see right now we are working on the 700, say 7 days contract, and this one is the previous one, but I'm going to use the contract we have just now deployed and the token we have just deployed. We're going to use those two contracts in this particular 7 days one. So come back here, close this one. Now come back to the header, and here we have to provide the address. So you can see here we have all the addresses of the contract. So this is the entire ABI. Again, I'm telling you that if you are making any changes in the staking contract, you have to provide the ABI of that particular contract. But if you're using the same contract without any changes, you can go with the same ABI. And I believe that you can easily able to get the ABI, which I have covered tons of time in my project, because all the contract will have the same features, same things. So we don't do any changes in the ABI. Then this one ABI can be handled easily, all of this one. So we have all this 4 different contract we have here. Now I'm going to simply paste the address of the contract we have deployed just now. So this is the ABI we have, and let's close this one and come back here. Okay, this is the ABI. So once you deploy with the hard hat, you can see it will generate the ABI, and you can get it from here as well. Simply copy that one, and that's what you can simply paste here. Let's come back here, and where it is, come back here, initialize hard hat. Okay, here, and you can simply paste here. You can do the same thing for the token, because One thing I want to highlight is that this token we have built, it's a custom token. It's not like a regular token like OpenZeppelin. So you have to provide the ABI of the token of the custom token, not the ABI of the OpenZeppelin. Looks pretty good. Okay, this is the ABI of our custom token. Now we have to provide the addresses. Looks good. Now I'll simply come here in Web3, and we can see this is the custom token we have, and this is the one we have used. Now close this one and come back to the header, and now we have to pass the data in the API. So these are the two things you have to keep in mind. Again, I'm telling you, that's why I'm showing you again this thing, that's what you have to keep in mind. Now we have to paste the address. So come back here in the remix ID, we have deployed the contract, and here we have the staking contract address. That's what I'm going to take it. Simply copy that one, come back here and paste here. So this is the newly deployed contract address, and this one is the old one. So come back here, and now if you use this particular token, it's not going to work with our new contract, but it will work with all these 3 other contract. But if I change this particular token as well, then other 3 contract will not work, but it will work with the first one, because we have initialize different token in other contracts on another contract. Now get me this token and paste here. So we have changed the token and the contract. If you want to use the 4 different token for 4 different contract, all you have to do is to do the same thing exactly we have done with the contract. But I will go with this easy and simplest way, and that's what we follow in the real world app. We don't allow them to have multiple token for staking, because that will not scale your application. We go with a simple one token, and we'll allow multiple contract to stake and earn reward. So that's the setup we have done. Everything is looking fine. So it will work with only first contract, because other 3 contracts are the old one and it has a different contract. So looks pretty good. And by the way, if you want to test the transaction which I have done, you can simply copy the old contract address and you can paste it, and you can have the data of the old contract which are deployed, and do the same thing for the other tokens, the token as well. So now what I will do is now come back to the application. If I reload the browser, come back here in the home page, everything's working fine. You can see we have no issues. So I will come here in the remix ID. I'm going to stop the application from running, and let me close this terminal. Let me close this one. So we have done all the setups. Close this one, and now we have to start the application. So we are not using any hard add. We are not using Next.js, React, TypeScript. So we can type npm run dev to start the application. This time we're going to use live server. So come back to the extension. So this is the page, this is the home page I just want to start. So what I will do is I'll come back here in the I will come back to the in the extension. I'll type live server, and this server will allow you to open up your application. So I believe that you guys already know about this, and you guys already have in your application in your VS Code. So if you don't have, make sure to install it. I have already done that. You can see it's looking fine. You can click and you can have a look on this. So close this one, and now once you successfully install, make sure to open the file which you want to open. This is the home page, and here you will have a button called go live once you will install the live server. So once you install the live server, I want you to restart your VS Code, because it will take a little bit time to add this in the terminal. So you can see I have a go live. I can click on that and it will open the application and the browser. So simply copy that one, close this one, come back here in the Chrome browser, because I like to use Chrome browser and I don't want to use any other browser. So I will simply paste here and hit enter. That will open the application. You can see every single thing is working fine. We have no issues in that. If you click on that, we are already connected with the application. Looks pretty good. Fetching all the balance. Let me log out and reload the browser. It will open the, it's not opening. Okay, I think I have not attached the function here in the index page. So what I will do, I'll come back here in the code, and you can see I have not attached the script for connecting with the MetaMask. So to do that, very easy. All we have to do is that you can see here we have this index file, and in that we have the current wallet function which we are not calling. So what I can do is come back here in the, this is the home page, and here we have to pass the script. So what I will do here, I have already attached the functionality in the staking file, because that's where I was testing. So we need all these 4 files, all these 4 files. So let's paste that. As you can see, as soon as we paste it, it will open the MetaMask and it will call the function. All we have to do is to pass the pass the password and click on unlock, and here we have log into the application. Looks pretty good. So you can see it looks pretty good. You can log out and it will automatically open the MetaMask because we are calling the function straight away in the page reload, or you can easily able to do the modification on the click button, which I have covered tons of time, but I will go with this approach because our contract is dependent on the address of the user for fetching his balance. So I'll go with this. You come back to the project and you can see everything is working fine, no issues we have. You can go to the details. This is the staking, and here you can see that this now we are using the new contract we have just created. We have 0 token into this our contract, you can see. So we have 0 tokens stored in the contract, all the data is fetching, and the current balance of the token I have is this. You can see this much token we have initialized, and that's what I have here. So this much balance I have in my token, and now I can easily able to call the function. You can see all the function we are calling: 7 days, yes, 3%, 1, then the total value active, and the time and date. And these are the old contract. In this, we're going to stake the token, it's not going to work. And that's the thing you have to keep in mind, because many of you say that I'm getting this error or that error. If you really want to use the same token in other three contract, you have to redeploy the contracts and give the token addresses, then it will take the token, otherwise it will not take the tokens. So it looks pretty good. Now what I can do is I'll take this 7 days staking contract, and I'm going to stake the token. So first I will pass that 100 token I want to stake, click on the stake, and it's going to call the approve function in our contract, and it will approve the token. You can do one thing, you can create a separate input field for the approve and the stake, but I'm going with the same one. You can do the modification from your end. Okay, it's approving and look fine. Just wait, the transaction is happening in the background, and once the transaction will complete, you can see the token is approved, and now you can simply reload and you can call the function again, and this time the token will stake in the contract. You can see MetaMask open, calling the stake function, and here we have making the transaction, and here we are redirect to the analytical page, and this is the token, this is the amount of token you have stake, and the gas amount which you have paid, and the status is true. There is tons of information about the contract user. That's what we are not displaying here, but you can display. That's all I will cover in the project. Don't need to worry about that what data you will have. So you can click and you can easily able to verify the transaction. It's taking a little bit time because we recently have done the transaction. Come back here, and you can see this is the 7 days token. We have the token amount we have in our balance is less. Earlier we have 10,000, but now 100 is less. You can see your lock token and the reward, and that looks good. You can see everything is working fine. Now let me attach all these function for opening the MetaMask and fetching the data in all the pages. So again, I'm telling you that when you will get the final code, and that these things are already done, I will give you the updated code, so you can simply download it, or all you have to do is to deploy the contract and add the contract addresses, token addresses, and it will work fine. So simply let me copy this one. Okay, what's happening, come back to the here, and here we have already attached in the registration. Come back to the project 2, and here we have to paste it. This 3 function we have to paste. Go to the project detail page and do the same thing there as well. Paste here and come back to the index we have done. Come back to the contact, paste here, come back to the analytical, and we have to do the same thing here as well. Looks pretty good, and I think I'm missing something. So we have this. Actually, we need all these 4, not only 3. We need the Web3 library as well. So come back here in the product detail and paste here Web3 library, product page as well, contact, and we have the analytical. In this way, like all the function is attached in all the pages, and it will trigger. So looks pretty fine, and now you will have no issues. Projects, taking, now we have this profile. You can have all this data. Looks pretty good. And come back here, looks pretty good. We have the index, header. All you have to do is to replace the addresses, and that will work fine. Again, I'm telling you, if you do any modification in the contract, in the staking contract, in the token contract, make sure to provide the relevant API of the contract and addresses. Okay, looks good. All this are fine, no issues we have here. So close this one, and things are looking good. And now let me show you the real goal, the most complete template for staking DApp. So if I open this, in this you will find that we have all of these files which we have created only for this project. So you can see we have this all. Now what I will do, I'll come back here in the index file, and first I have to stop the previous live server, and I have to initialize this particular page. So here I've started, copy this URL, come back to the Chrome browser and paste it right up here. So this is the complete template, in that we have not attached any functionality, but we have provided all the templates for this particular dApp, including all the pages. So if you want to add more features, you can do it very easily. So this is the home page. It has the exact interface like the previous one, but it has a couple of more pages. Come back to the project, in that you will find that we have, say, like close to 5 different type of project page. So if you click on the very first one, this is how the first one would look like with the pagination. This is how the second would look like in the card, and we have the third one. This is how they look like with the slider, card slider. And we have the fourth one is this looks pretty good without pagination, and we have this product detail page. It is exactly you have seen. And now we have this staking page in 2 different format as well. So first one we have like this style, which you guys have seen, which we have used. And again, I'm telling you that we haven't attached any functionality in this. All you have to do is to attach the functionality and it is ready. Everything I will cover extensively. And this template will be the bonus for those who will buy the source code and give us the valuable contribution. I hope you guys love this project. So that looks good. Now come back to the second style tab. This is how the second tab will look like. Okay, looks good. Come back to the farming. That's how it will look. Quite similar one. We have this one, all the trading, all this latest transaction or coins you can display. We have a couple of inner pages, and we have the current wallet pages, like you can assign multiple wallet option for the users. We have the help center and like all the information you can display about the project which you have initialized, the pricing and all. And here we have the contract. Looks good. And we have other pages which you guys can see from your end. And here we have the contact page, which you guys have already seen. It's working 100% fine. And here we have the sidebar, no issues, everything's looking fine. Here we have navigating to different pages, looks good. Let's check the responsiveness, and you can see search bar is working fine. We have this, looks pretty good. And we have this wallet option as well. And don't need to worry about that. We're going to build every single thing together, whatever I have shown you in the first part. And this one is the additional one, in case if you guys want to launch your application and have the complete template, then you guys can take it. So if you really want to get the source code, come back to the blockchain coder. Here you will find all the project source code which we have taken, and you can start working straight away. So this is the one. You can simply filter from here, or you can click on this and you can come here. And I want you to download the startup file right now, because in that you will have all the assets, all the libraries already there, all the folder file structure is already defined. All we're going to do is we're going to take this particular startup file and we're going to start coding straight away. So make sure to get the startup file, and if you want the complete code, you can simply get it from here. But get the complete startup file right now so we can start working together, where we're going to write all the functionality together. Okay, or you can click on this and you can watch this particular video whenever you will come and have any confusion. So you can come and watch right up here. So it looks pretty good. Everything is working fine to me. And recently I have launched my course. This is the complete course where I have teach you every single thing about the state management and the real world application, how it's built. So I want you to come and have a look at this. This particular application is powered by AI. There you will learn all of this technology, and that will teach you every single thing which you have to know about the web development and how you can take that skill into the Web3 space. So this will teach you everything. So let me close this one. And so that looks pretty good. And that's the only thing I want to cover in this video. I hope you guys have got an idea that what you're going to build and how you can get the assets. So I hope you guys will have a lot of fun. Very soon I'm going to publish the videos on this project, because the videos is almost ready. We have 10% left and the 80% videos are ready, and it's also recorded and it's in the editing phase. So within the week, like after a week, we'll start posting the videos, and so you guys can follow that. So hope you guys have enjoyed this entire project. If you guys have any question, any doubt, do let me know in the comment section. I'll try to help you in that. With that, I'm ending this video. Have a wonderful day. Bye bye.